Hey everybody, welcome to Percona Live Online. Thank you for attending. We're really excited about having you here this year. This is our first 24-hour around the clock, around the world conference. And because of the world we live in, we've had to move online, but we're hoping that you can stick with us for as much as this is possible. And if you could stay for the all 24 hours, that would be awesome too, but we're looking forward to having a really fun day with you. So before we pass it over to Peter to begin our show, want to do a few housekeeping things for everybody. So real quick, so the first thing to talk about is, this is Percona Live, just like we've had before, just remote, right? And we are live on YouTube, Twitch, and Facebook right now. So we're streaming to all these different platforms. Okay, so you can watch us in a multitude of locations. Check the Twitter feed for any important updates. This is live, so anything can happen, right? People can pop in by accident. You can have internet issues. Be mindful that, as we go through this, there could be hiccups, and we'll resolve them quickly. We've gone through a lot of work to make sure we minimize those. We have an official Slack channel. So if you're not on Slack, please, jump over there. You can do Q&A. We'll be asking questions in between sessions. We'll also be giving away a few prizes here and there. So jump on over to Slack and you can chat with us there. Also, this is live, right? So there are some pre-recorded versions of this in case there is an issue. So be mindful that, we might have to switch to a pre-recorded talk, and we will make the recordings available as soon as possible after the conference. All right, and go ahead and tag us with Percona Live on all the social platforms. Really appreciate you doing that. And finally, I want to say thank you to the hosts. So right now, I'm DJ Jazzy Matt, your host for the keynotes, but we'll be passing this along to other hosts that have volunteered to help us at different times during the day. So when you see them online, if you have questions during their time, feel free to ask them. And that is our opening. So this has been quite a week, right? And so, and it's an exciting week. Not only is it Percona Live online, it's the 25th birthday of MySQL. This is the 8th Percona Live online conference. And it's been 1 week since my data has been leaked on the internet. So I'm quite happy. Now, Peter, would you please come on up and we'll pass the screen share over to you. Peter, welcome. And Peter's on mute still, so I don't know if he's on mute. It's one of those live things.
Myself.
There you go.
Okay, you see my screen. That's fantastic. Huh. Okay, that's funny. There seems to be delay reaction on muting and muted. Well, anyway, let's get started. Of course, I am missing out on my walking up to a big stage in the Star Wars Imperial March music Matt likes to put for me, but well, we do with what we've got. So welcome everybody. Good morning, good afternoon, good night. I have seen on Percona Slack there have been so many people saying hi to each other from so many different countries all around the world, which is pretty cool. Well, I will talk to you about the state of open source databases today. And I decided to take a little bit different path today and look at the history of open source software, which I think the open source databases are really impacted and influenced a lot by. So if you think about the early days of computing, think about like really early days, 2050s or something, then you would have software and hardware were bundled together. And even though we did not have a term open source at those days, the software source was actually open. And one of the big reasons for that was their copyrights of a software was not a thing, because the software was not really a thing before that. And we know always the laws tend to move slower and or only kind of catch up with technological development. So in the early days, we would have software code, which is the source code was shipped with early software, and early adopters, a lot of them were different universities and so on, would modify the code to fix the bugs and add functionality we need. Well, kind of like advanced open source users do those days. And the changes were openly shared with the academic principles. Now, if you look to late 60s and the early 70s, software was becoming a thing, right? And the computing was growing to be significant industry. The IBM was controlling the vast majority of what was the mainframe market at that time. And in US, there was a lawsuit, antitrust lawsuit against the IBM. So they partly because of that split unbundled software from hardware. Also, Congress acts and makes software copyrightable items, which really creates this multi-billion-dollar separate software industry, right, which is distinct from a hardware industry. And software becomes the major class of intellectual property. And from really those 70s, we see vast majority of software is really being proprietary. Now, when you go to the 80s and 90s, I would call that an era of romantic open source software, right? Because a lot of software in that time was started by hobbyists and really was created to scratch their own itch, right? Or as Linus Torvalds would write in his book, why he created Linux, just for fun, not to become a billionaire, as the later open source creators would pursue, right? And you see on this picture Richard Stallman, which is kind of wearing Percona logo as his hat. I mean, I'm not quite sure why he's doing that, but I thought that's fun picture anyway. When it comes to 2000s, 2000s was really the dramatic decade for open source software. I think especially because the dot-com crash in early 2000s, a lot of companies needed ways to build their solutions very efficiently, and Linux, Apache, MySQL, a lot of other open source really allowed them to do just that, right? And if you look at the companies born in 2020s, a lot of large internet companies, Facebooks, Twitters, Yahoo's, right? A lot of them would build all the massive infrastructure based on the open source and its core, right? Because of that, open source was also noticed by the dominant companies at the time, like Microsoft, with Steve Ballmer famously referencing to Linux as a cancer at that time. That is also the decade where we would see some significant business outcomes for open source software. Before 2000s, we only had the Red Hat, which went IPO in the late 1990s. In 2000, though, we also have a MySQL who was sold for $1 billion to Sun. And I know now many open source companies have valuations in billions of dollars, but at that time, that was really a big deal. What is also happening in 2000s for open source software is many businesses started to recognize the value of open source software. And we can see increasing amount of companies, large enterprises, starting to adopt the open source first mentality. And that can be seen across large enterprises, and especially, I think, by a lot of governments, because that can help them to also avoid reliance on the companies from other countries, right, which can be potentially challenges. If you look at their businesses, though, a lot of values of the open source software is connected to one thing. It lowers lower costs, short term and long term, right? And you should understand that from a business standpoint, that is the main conversation that you would want to have, because businesses may be talking about how they are all here for world peace, eternal love, having trees grown greener, but in reality, for majority of companies, especially public ones, that is the cost, and something which helps them to succeed in the market is driving their decision. Open source offers direct lower cost in many cases. It also is preferred by developers in many cases, and that's over years becomes easier to find developers which are proficient in open source technologies compared to some exotic proprietary software, which also gets to offer companies better productivity and faster innovation on the given host. And what is also very important is avoiding software vendor lock-in. I think a lot of businesses, they found what they can achieve the most efficiency when they're not locked into just one solution. In hardware, that was achieved relatively easy, right? Like you can get, let's say, server from HP, IBM, Dell, right? They're all speaking 2000, and they're all pretty much the same, right? But that's not, didn't apply to the software, right? If you are using Microsoft SQL Server, you can't move to Oracle easily, and vice versa, right? While with open source software, you can finally break or at least reduce that software vendor lock-in. Now, what also happened in 2000s is what we see open source understood as a great way to start a business and make money. A new generation of open source companies is started with a business idea first. The founders would be actually starting those new companies to make money, not just for fun or to scratch their own itch. A lot of those companies would be venture funded as a result, and because of that, we also need to provide high returns and fast. Because if somebody, venture companies, gives you money, they are not looking for you to grow 5% over the next 50 years, right? That's not how the game is played. Now, that means also for those businesses, the classical business schools approach of growing a business would be applied. Right, one is you want to make sure what your marketing is focused on the message which is appealed to the time. And we know open source is a fantastic message with a lot of enterprises pursuing that open source first mentality, right? But then at the same time, you would be thinking how you can build monopoly and avoid commoditization, increase the stickiness. So once people start using your software, and what is more important, your the business proposition, they can't leave, and also somehow build anti-competitive modes, so nobody can really really compete with you. Now, what I think is interesting in this case, if you really look at those approaches to business values, many of them kind of go in a conflict with the early stage of romantic open source, right? And open source software values and ideas about, you know, sharing and let other people to innovate on your software, because, hey, that actually can create a competition for you. With that, we can see a lot of business models where evolving from open source to what I would call not quite open source, right? Something which is often marketed as an open source, but not really so. And those models would be open core, open source eventually, such as BSL license, shared source licenses, right, like SSPL, and also open source compatible software, which is especially used by a lot of cloud vendors when you can say, hey, look at that. We have a software which is, of course, proprietary, but actually it is compatible with open source software. You can move from open source software to our solution. Well, you probably would have a very hard time to moving back, but we don't talk about that. Now, with that not quite open source, I think for open source community and the market, that's brought both positives and negatives. On the good side, there is a lot more investments and higher pace of innovation in the software around open source community. On the negative side, though, is this software doesn't provide you all the value of a truly open source software, and really market became quite much more complicated, right? I mean, it really becomes very complicated to understand which software gives you all the values you would expect from open source software and which doesn't. Now, when we move to 2010s, we see the rise of a cloud. And indeed, their cloud like AWS was started in a previous decade, but I think it's 2010s when the cloud was impacting, especially open source databases specifically. The cloud and open source, I think that really brings a lot of challenges and opportunities for open source software, and especially for companies which are looking to build business around the open source. One thing I think what cloud did is what it really hijacked the GPL license. If you look before the cloud, before software as a service, the deployment model, the software vendors who did not want others to build or commercial software on their solutions, right? They can just use GPL. For example, MySQL did that, and they, in the early days, had a very successful dual license business model where companies who would want to build commercial solutions could do that. The cloud changed that. Now, AWS probably makes more money on MySQL than Oracle does, right? And they can just use the GPL software and don't have to pay Oracle anything. I don't know about the details of their commercial relationship, but there is no requirement to do that. Another interesting thing which happened with cloud services is the opposite of what happened in the early 70s, and we have software and the hardware cost are being bundled together, right? So what that means now, if you are looking to spin up, let's say, your computer instance in the cloud, you will get a per hour fee. If you are spinning up your database instance, like Amazon Aurora or Google Cloud SQL, you also get a fee, which will not bundle software, which will bundle the cost of usage of the hardware and the software together. And that means for the open source can no more benefit of a zero price effect, right? And this is a very important psychological thing which was driving adoption of open source, I think, right? Because in the past, I would have to buy the server separately, right? And then I have a choice. Either I go and pay hundreds of thousands of dollars, right, or tens of thousands of dollars to license Oracle to run on that server, or I go ahead and download Postgres and use it for free, right? That is a very, very powerful. That is not the case anymore, right? It just becomes a case of a difference in the price, which is may not be very well seasoned, understood by people. Also, cloud databases, of course, make it much easier to use than do-it-yourself database solution. Now, another thing which I think has been happening in the market is what this not fully open source software models, they are actually quite accepted on the marketplace right? More than I would be expecting. And I think that is very important for us as an open source database community to really educate folks in the market about the difference of the open source and a software which is marketed using the open source term, but not being open source, not providing the true values of open source software. Okay, now let's move to 2020s. And as 2020s just started, I don't have a history, right? And frankly, none of us really knows what is going to happen in this decade completely. But we can see how it is starting. One is we can see what, especially for commercial open source software, where companies who really is focused on monetizing open source, that has been fantastic year, right? I mean, I just looked up a couple of days ago the current valuations for many companies, and you can see there are quite a few companies which have $1 billion plus valuation on the market, right? Or in private, right? So, and these are not even all $1 billion plus companies. What we can see is also, I think, because of success of MongoDB, Elastic, and some other open source companies, we see a lot of investment and a lot of innovation in open source database space. This is just selection of a few database technologies which have started over the last few years, right? And we can see a lot of interesting innovation going on out there, both in terms of design, like distributed databases, as well as in terms of a different database schemas, right? It's not only relational databases. We have a multimodal cloud graph databases, time series focused, and so on and so forth. Now, we also, as we all know, we have a pandemic upon us, right? And while it is, of course, incredibly tragic, I think that can have a positive effect to the adoption of open source software, right? Because of a couple of things, a lot of people are pushed to the accelerated to a different digital transformation, be in education or being have to deliver more services online than before, and also needs to either do that at a lower cost or really to need to cut cost in the company, right, due to the economy slowdown. Now, another thing which goes about the database specifically is we have moved to a database as a service as a preferred way to consume open source database software and non-open source as well. And that is very interesting because that really allows the development team to use multiple database technologies, much better matching them to application needs, because we don't really need to install and maintain them, which is hard. On the other side, database as a server, I think, is very commonly marketed by cloud vendors as a fully managed, and they tend to be over-marketed. We hear again and again saying, hey, you know what, we thought it's fully managed database. Because of that, we don't get any DBAs or other database experts on the team. But you know what? This fully managed still needs to be configured for security. Somebody still needs to advise us on a schema, help us to design the queries, and so on and so forth, right? And I think what that is, it comes to this very interesting case where developers choose and use those databases, service databases, without supervision of folks who really understand the databases. And that can cause to a variety of bad outcomes, ranging from security leaks to very inefficient delivery of the database services. Now, if you look at the cloud user in generally, and then look at that again from an open source prism, you can think about the cloud in two ways: either as a commodity, similar to the electricity, right, where you can really swap one cloud for another very easily, or think about highly differentiated clouds, where you have a proprietary solutions, right? Maybe better performance or better usability, right? But they can with a huge vendor lock-in. In my experience, what enterprises do not really want to be hostage. Not again. Many of them, especially in the database space, played this game with Oracle, and they didn't like it. Many of them still do not like it, right? Because they are trying to figure out how they can now get rid of those relationship, right? And move to something more sustainable, but that is quite hard. I think where we are moving through is what we can call a multiverse. And Matt Yonkovit, who speaks after me, will talk more about that. But this is basically, we are increasingly seeing multiple database technologies are run in multiple environments, hybrid cloud, multi-cloud, and so on and so forth. Now, what is interesting is what that is recognized by many cloud vendors as well, right? We are seeing many proprietary solutions available, such as Google Anthos, VMware, ABS Outposts, and so on and so forth. But at the same time, we are seeing the open source is stepping up, and the Kubernetes is also emerged as a leading open source API for those hybrid and public cloud. Now, what is interesting is you do not really get to choose Kubernetes, right, or those proprietary solutions. In many cases, you mix and match those. Like, for example, you would see a proprietary solution to used to simplify the Kubernetes management, right, such as OpenShift by Red Hat and many others. And also, because of Kubernetes is so ubiquitous, majority of those multi-cloud, hybrid cloud platforms, they also support that Kubernetes as an API. How does that apply to the open source databases, right? And what I think we should be focusing on with those developments. One is adapt for cloud native deployment and multi-cloud and hybrid cloud deployments. Many are doing that. A lot of the new generation databases are even built initially to support Kubernetes or add an app, right? So that's already done. And a third item, I think, is what we really need to be thinking about, how to provide simplicity compatible to the integrated database as a service solutions. Because while Kubernetes is wonderful, changing 50 YAML files to deploy your resource on Kubernetes is not the same with a couple of clicks how it takes you to get their Amazon Aurora, let's say, deployed on Amazon, which will back itself up, provide you some level of high availability, and so on and so forth. Now, as we are looking at database as a service, I think what the database as a service, as a way to consume the database software, is really a winning model for vast majority of their use cases, because that is just so much better, so much easier for developers. And what you want to think in this case is, okay, if that is your choice, if that is what your developers are going to prefer, how do you do that while still keep of most of the value what open source software provide, most of its freedom? And that is a complicated question, and I do not think there is a solution right now on the market which can really came to provide that. Now, let me finish up by saying what Percona is doing in this way. We are really embracing the cloud native and multi-cloud approach through Kubernetes. We have released operators for X-Ray cluster for MySQL and also for Percona server for MongoDB, right? And we are also working through usability, work with our Percona monitoring and management, right, to really help you to reduce the friction and run the open source databases successfully in those cloud environments and on-prem. With that, that is the end of the informational part of my keynote, but I want to finish up with two announcements. One is we have kicked off an open source data management survey. Please take a time, maybe while you're listening to one of the keynotes on the talks, and fill out this survey. We are sharing all results of this survey publicly under Creative Commons license. And that will really help us to help you, because we can really understand where we should focus our limited resources developing open source software. And finally, I want to say a happy birthday, happy quarantine birthday to the MySQL, which is turning 25 years old this year. I remember when MySQL was turning 20 years, we had a cake to cut at one of Percona Live events. Unfortunately, it is not happening this year because of the quarantine and we're all online, but still I'm wishing a very happy birthday to MySQL. Great job, MySQL team. Thank you. Take it away, Matt.
Thank you, Peter. And I appreciate, you being able to go through that. And we'll get you a cake. I promise we'll get you a cake when this is all over, and we'll live stream the cutting of the cake. So just for you. But if there are questions, feel free to put them in the general chat. Because of timing, we're going to move on to the next talk. So I'll introduce the next speaker. The next speaker is me. Thank you, everyone. Appreciate that. So I wanted to continue with what Peter was talking about and talk a little bit about the crazy world that we are in right now. And this just isn't, COVID-19 and, the fun around that. But we're seeing trends and we're seeing things that are disrupting and breaking the database infrastructure, for many of us. And I want to talk through that. So first, a small disclaimer. I'm going to talk about our 2020 open source survey. I'm going to preview some of the results. All right. Peter had talked a little bit about this. This is an ongoing survey. We're approaching 600 respondents right now. We anticipate more, but 600 is enough to start analyzing the results and seeing where the trends are going. And some of them are very interesting. So we wanted to share that. So you've probably heard all of these words before, and this is my, overhyped word cloud, if you will. And so we've got, the machine learning, the automation, the cloud native, the DevOps, all these different words. And you're going to hear these over and over in the next couple of years, and you're probably going to get sick of them if you're not sick of them already. But I'm going to throw in a few of these here and there, but I'm going to try and minimize the buzzwords here, but realize these will be occurring over and over. So I want to start with probably the biggest trend that I'm concerned about or that I'm seeing, and it's he who controls the application controls the stack, right? And so hopefully people get the reference with the picture. If you do, put it in Slack. But those who are building it are not the ones managing it, and those who are building it are the ones who are deciding what to put in it. So when we go back a year and we ran a survey of our user base, and we saw that the majority of people choosing database technology is outside the database or the infrastructure side. Management's not choosing it, DBAs aren't choosing it, application architects and developers are choosing it. And we extended that and we looked this year to see what that was. And the increase is moving more towards the architects and the app architects, and the developers are still pretty strong. But the DBAs are more and more inheriting the technology and the databases that that they've gotten from the development stack, right? So someone develops this, and all of a sudden now you have to support it, and there are going to be consequences, whether they're good or bad. The law of unintended consequences here is, as we start to make these decisions, as we start to shift that balance, and as we start to make those decisions elsewhere, things happen. Now, I like to call this the technology inheritance problem. Okay, so in years past, when I started as a DBA, it seems like forever ago, I started in an Oracle shop, and I'm guessing that a lot of you have started in an Oracle or a SQL Server, or a DB2 or Sybase even. Maybe there's some Sybase folks out there, and all of your applications use that technology. And as a shop, you worked with the developers to figure out how to get their apps, to work right. Well, now it's the app teams are going off, they're developing they're choosing some technologies, they're choosing where to go, how to install, and then they throw it over the wall a lot of times to the DBA team or to the infrastructure team. And so now we have this inheritance problem where you've got a team of people who are not necessarily skilled at managing those technologies, all of a sudden being responsible for new technologies. And, we see this over and over again where people inherit, whether it's, Postgres. Oh, I've never done Postgres. So now I'm an Oracle DBA moving to Postgres, or I'm a MySQL DBA who has to learn Postgres, or, I'm moving to some other technology. And it happens over and over again. Now, this is leading to this multiverse of technologies, because instead of, saying we're going to run on AWS and we're going to consolidate on a single database or a set of databases, you're running on multiple databases. You're running in multiple locations. You're running, multi-skilled people, because you're no longer, an expert Oracle DBA. You're a DBA of everything. And it's leading to these multi-database environments. And when we look at our survey from last year, this is a graphic that we used before, but we saw last year that 92% of companies are already running more than one database. And 89% have more than an open source database. So the multiverse for a database perspective is already there. It already exists. And so now we just need to know how to deal with it and how to deal with the consequences of this type of environment. And we've led to this environment where, we've got more data and more databases than ever before, right? And so, I don't know about you, but we've seen more and more people with lots and lots of databases. When we compare 2019 to where we are today in our 2020 survey, okay, the number of companies that reported having between 100 and 1,000 databases grew by 40%. Okay, think about that. So, I worked for, a company that was owned by GE. Okay, and so GE has lots of databases. I don't think we had 1,000 databases. And so now 1,000 database, 100 to 1,000 database environments are growing up. And it's because every application wants their own database. Every little tiny application microservice gets it. But you think that's startling. Those with reporting over 1,000 databases grew by more than 50%. So the fact of the matter is now we've got environments that have thousands of databases that have to be managed and supported. And that means that the care and feeding of each individual database is very difficult, and you have to look at them as a whole. And some of this is, coming from new technologies like machine learning or AI. I like to consider, a lot of these applications that require quote unquote machine learning as kind of Pac-Man, right? And the data is the pellets. You just want more and more and more, and you just keep on consuming them. And, there's this insatiable need for more data to make better decisions. And I don't see that changing, especially in this new environment that we're in. Now, when we talk about not only like the number of instances, we talk about the sizes of these instances. The database footprints of databases continues to grow. Only 3.5% shrunk, whereas 14% stayed the same. And the vast majority, 80%, saw growth, and almost 39% saw large or massive growth in the size of their environment. And so again, you need to store data for longer. You have more uses for data. You want more data to make better decisions. And so this is causing not only more instances of databases to be run, but more data to be stored. So we're seeing this explosive growth in terms of the amount of stuff that we have to manage. And this also leads to this, multi-cloud space now, right? I mentioned that, right? Some of this is on purpose. Some of this is not on purpose, right? These are headlines from just the last month, okay? And so you look at the headlines for the last month, multi-cloud is a growing trend. Why? A couple reasons. One is, shadow IT. I mentioned you're kind of inheriting somebody, decided to run an Azure, another person decided to run an AWS. Now you have to deal with both. That happens. But a lot of this is more purposeful now. And we're seeing more and more people choose this to protect themselves from outages, to protect themselves from issues, performance issues, things like that. And so this growth of the cloud, so now we've got thousands of databases, we've got bigger databases, and now we've got multiple places they're running. I mean, it just gets bigger and bigger and bigger. And when we look at our data last year versus this year, 30% reported that they were running a multi-cloud environment. This year, it's 39%. I mean, it's no wonder when you go back to those headlines, you see that some of the cloud providers are now taking notice and they're investing in tools to let you run their platform across other, competitors' platforms. And so, and that also exists in the hybrid space as well. So hybrid continues to grow, not as fast as the multi-cloud. So 41% were hybrid in 2019, 2020, 44%. So again, complexity is getting more and more prevalent. So we're seeing more databases, more data, more providers, more locations, more hybrid installations. And so what are the consequences of this? Well, there's some more and some less takeaways, right? So it means for a lot of us who have to work on these systems, we have less expertise in any one of them because we don't have the time to not only enhance our skills, but to enhance the systems that we're supporting and ensure that they're properly managed and set up. We have less time per application. We just have less time available. But that leads to some more problems, right? More mistakes happening, more automation that's cascading problems, more outages, more security issues, more complexity, more cost, right? And more help is needed. We're feeling more and more overwhelmed. And so, you have this problem that's starting to exist, and, there's always an answer for it, and everybody's really good at that. So how does the industry as a whole respond? And I'm going to go to one of the, the best actors in the history of acting to pull a quote, and that is, of course, Bill Murray. And in Ghostbusters, he said how crazy the times were, and it's human sacrifice, dogs and cats living together, mass hysteria. And what's interesting is all of these problems that I mentioned, it's sort of a human sacrifice thing that people are looking at to solve it. And that human sacrifice is this debate between, do we need to automate more? How much do we need to automate? How much do we not need people, right? How much do we need to focus on, the automation of things and the AI versus, bringing in experts? And, Peter had mentioned that a lot of, when we talk about databases as a service, it's about the automation, and it's about like, oh, it's fully managed. You don't need a DBA anymore. And cloud providers have been very good about publishing things where they say you still need database resources, you still need experts, you still need people who know what they're doing. But I think people ignore it. And so, this is not a new trend, though. If you think about it, this goes back to, all business, right? There's always been a drive to do more with less. Right. And when you talk about automation, you talk about things that, scale, system scale, people don't thinking it's prevalent in most businesses. And so this goes back to the time of Henry Ford and the assembly line, trying to optimize how you do things so you don't have to have as many hands on, the tools and building the things that you need. And I don't want to say automation is bad because it's not. It's actually good. Blind automation is bad. But the skills and the tools required to manage this properly change drastically. And automating bad things just equals more bad things. And that is a critical thing to remember, because as we go out and we automate, if we don't have the skill set to know how to manage or automate properly, that's going to bite us, right? That's going to cause us issues. And so we need to understand that we need to ensure that we still have the tools and the skill set to properly address these problems as they occur. Otherwise, we just make more problems. And let's talk about database as a service, because database as a service is probably one of the best inventions that has happened in the last 10 years to databases. Now, it is great because it enables developers to move quicker. It overcomes all kinds of skill gaps, right? So for years, it was really difficult to find MySQL DBAs. It was really difficult to find Postgres DBAs. It was really difficult to find MongoDBs. It still is. So building the tools to help people start and enhance their systems sooner rather than later is good. Speeding releases, making it easier for folks. It's great. It is awesome. Okay. But it doesn't eliminate that need for understanding and the tools to help make that better, right? We need better, smarter, tools. So this is where I mentioned that false sense of safety, right? What does fully managed mean to you? What does fully managed, mean to, the vast majority of people? Because it means different things, and we have to be careful, because a lot of the fully managed things that we do, even if it isn't like public cloud or private cloud, even if it's the things that we automate ourselves, we have to understand that, there still needs to be some thought process and expertise put into it. So I asked, as part of our open source survey this year, what keeps people up at night, right? And so, when we talk about keeping people up at night, from a technology perspective, these are the 5 top things. Okay, downtime, unforeseen emergencies that just pop up, security issues, bad performance, query issues, staffing issues, lack of resources, right? So those are the top 5 things that everyone has responded that keep them up at night. Now, when we look at like a shared responsibility model, and we look at databases as service, we look at other places, you have to realize that like a lot of these are shared responsibilities or you fully own, right? Downtime was the number one thing. Yes, there is some great tools out there to prevent and eliminate downtime, but you need to know how to deploy them. Otherwise, they don't work. There's a reason that you see like, outages that happen in, one cloud provider all of a sudden take down applications, even though they might have a whole bunch of HA set up. They just didn't set it up right. Maybe they didn't understand the nuances and where the issues were. Unforeseen emergencies, who knows what those are, but they come up, right? You never know. It could be application code. It could be, something happened to your data. Who knows? But anything beyond the infrastructure is the responsibility of us as a group to manage. And when we talk about security, it is totally a shared responsibility. And performance, query tuning, lack of expertise, those are completely on you as the user. And, those are the things that you have to realize, like, hey, as we look at this automation and this great, automated space, what is our responsibility versus what can we outsource to, a provider? Now, it's interesting because we also asked how many of these events did you have any of these happen in the last 12 months? And, we asked, did you have performance problems? Did you have unplanned downtime? Did you have bad code? Did you have overworked staff? Did you have security issues? And when we look, problems happen everywhere, whether you're in the cloud or not, right? So, when we asked, how many people had performance issues in, 62% in the cloud said I had performance issues. 54% not in the cloud said I had performance issues. Bad code, guess what? You roll bad code into production, whether you're in the cloud or not. But what's interesting here is I want to point out, look at the overworked staff. Okay, 26% say they're overworked. And when we compare this to cloud instances where you're running non-databases as service and databases as service, look at the difference, right? There's a 10% jump in the overworked staff when you talk databases as service. Why is this? My speculation is when we move to a database as service, we move those resources to do other things. And when database problems occur, they've got 17 other jobs to work on. And so it becomes very difficult to jump in and fix those performance issues or make sure that, the security is set up correctly, right? And one of the survey respondents responded to our survey. They put in the comment, there is no perfect database server. All of them have weird issues. And that is totally true. And just because you start to outsource components doesn't mean you have to not care about these things. Obviously, if people are still having performance issues, unplanned downtime, overworked staff, security, bad, code rolled into production, if you're still having those in, like a cloud, system and a non-cloud system, you're still having them in production, obviously we haven't fixed the problem. We're still having the things that keep us up at night. And so how do we fix those? That's important. And when you look at, those outages, it's no surprise, right? These are headlines from last month. And outages, right? Whether it's, big cloud providers, application providers, they still happen. This is not new. This happened a year ago. This is my slide from Percona Live a year ago. And when we look at security issues, they still have issues as well. This is a year ago. This is now. Now, I like to always point out this one. GDPR compliant site leaks data and passwords. That one is, kind of, interesting. But, just today, okay, this is a quote from today from CISO magazine. okay? And they talk about like, unprotected databases have been a severe issue for several organizations with hundreds of millions of confidential data exposed. And they point out an Elastic breach that had over 5 billion records. And why? These are simple things. Most of these outages, most of these breaches are because we didn't set a password. A password, okay? Easy things, easy things. These are things that, any of us as experts and, database, pride ourselves on our database knowledge should know to set a password. But it doesn't occur to a large majority of those who are now using this technology. And if you look at, this study by Verizon, and this was just released as well, okay? The fastest growing data breach cause is misconfigurations. It's not setting the passwords. It's making, forgetting to, set encryption. It's doing these common things that occur. And, the report actually goes on to say errors continue to be a significant factor in breaches. They're primarily made up of misconfiguration of cloud databases. This is from Verizon's report where they studied all the database breaches in the last year, right? So this is getting worse, not better. Now, they think it's getting worse because people are now reporting it and they weren't before, but I think it's also because we're storing more and more data. Now, we mentioned, some of the performance issues and some of the other things that are occurring. Now, one of this is, changing how we think about how to scale. Okay, a lot of people say performance tuning keeps them up at night, but how many people choose to, scale their database is via credit card, right? And so when we asked, okay, from a spend perspective, are you spending at plan, below plan, above plan? Overall, whether you're in the cloud or not, about 24% showed that they were above plan. Now, as we move more towards the database as a service side and the cloud side, it gets up to like 33%. So more and more people are spending more than they plan to when they get in here. And this is the one that's more telling for me, right? We asked, how often have you had to upgrade your database instances to something bigger? And, so 11% said 0 time. Almost 20% had to upgrade 10 times or more. Now, every instance upgrade tends to be a 2x price increase. Now, that's a pretty big increase. And most of these can be avoided by fixing those performance problems. And it gets back to us thinking about, like, hey, from a database perspective, do we want to tune? If we don't tune, how do we scale? And if we're not fixing those performance issues, we're going to fix them by paying more. And that's what a lot of people end up doing. So when we talk unexpected costs, okay, here's an interesting number, right? Non-public cloud users had an 8% reported unexpected cost. Public cloud users said 10%. Database as a service, 19% said that their costs were unexpected. Now, when we talk about humans versus sponge or humans versus, like the computer, humans versus the computer in this automation and, how much do we want to just, set it and forget it? The answer is not either one of these. It's the combination, right? Database as a service is great, but how do we make it more efficient? How do we make a better database as a service? How do we, fix this so it is no longer just a robot? It's the cyborg, awesome sauce, thing that can combine both our human knowledge and, the machine. How do we get better tools? How do we get better database as a service? And so we need that. We need better automation. We need smarter tools. We need better education, better security, right? Better performance. We need to make us all more efficient and be able to solve these problems that come up. It's very, very important. Now, the other part of, Bill Murray's quote was, cats and dogs living together. And we're one step away from that, right? So we've got the human sacrifice thing down. So, we're close. We're getting better. But there's still some issues we need to overcome. So what do we do about it? So what's next? Where do we go, right? So better tooling and software to start with. That's an important thing because as these environments get bigger and as they spread out, it's going to be important for us to have tools to help manage those tens of thousands of instances. And so we need to work across those cloud providers. We need that view into the thousands of instances. We need tools that are going to help us keep our data safe, right? And we need database software that scales up and down easily with the demand that we have. And we need our software to still be open, portable, and extensible, right? So this is where, we've started to work on our software, and where our vision for Percona monitoring and management is, right? We want a simplified management system where we can take that complexity and give you the ability to reduce the complexity with it, right? And so there's a lot of, different things that we pull together around performance and security and scalability in PMM. Now, when we talk about security, I have a selfish goal myself, okay? I don't know about you guys, but my data gets breached quite a bit. And I do not need any more credit monitoring. I don't know. How many people here have gotten free credit monitoring lately? I seem to have a lot. I am actually really good with free credit monitoring until the year 2082. I think my daughter will be good with free credit monitoring with what I've gotten as well. So I do not need or want any more free credit monitoring from these database breaches. I really don't. But the problem is these database breaches continue to happen, right? Over and over again over the last year. My data has been leaked so many times. So I have a solution, all right? So, I'm going to give you the simple solution, and then I'm going to give you some tools to help with this. So the simple solution that I have is I think I can solve more than 50% of the data breaches that exist right now, okay? And I'm going to give you the secret sauce. And what's more, I can do it in one line code, one line, all right? And that one line is this. It is set your password. It is the change password command for MongoDB. Mongo and Elastic are the two most breached databases out there. Most of them breach because nobody set a password. Okay, so if everyone in the world does this, I will not get any more, well, at least 50% of the free credit monitoring that I have would go away. And I would really appreciate that, right? So changing your password is critical to ensuring that, you keep your data safe. It's like step one, right? There's all these other steps that have to happen after that. But if you don't even do that, you're worried about the wrong things. You're leaving the front door open while you're in the back, building the fence and a wall to keep people out the back. And so you got to fix that first. And so I went to our, product team and our engineering team, and I implored them. I go, please, please help us. Help stop leaking my data, right? So hashtag keep Matt's data safe. So I asked them to do this. And so in Percona Monitoring and Management 2.6, we've included the first version of our security threat tool. All right. So it gives some basic checks for the most common issues, like I didn't set a password, like I'm out of date on my software, right? And we're going to be implementing more checks over the coming months, because here's the thing. These might be easy for a lot of us, but those who are out there who are actually deploying and setting these systems up, it doesn't occur to them. So we need to help protect this environment and protect the data that's out there. Okay. Now, I mentioned that MongoDB is also one of the areas where we're seeing a lot of data breaches. And so we're starting with our first release, first release of our Percona distribution for MongoDB. And so what we've done is we've taken our MongoDB tools, we've taken Percona server for MongoDB, and we've taken other open source components. We bundled them together so they work together and they can be installed easily across multiple environments. And we bake those into this distribution. We also take all the best of the open source components and bundle it into one there. And we're also offering now managed services for MongoDB in case you just want someone else to manage it for you. And this is kind of like the human robot mixed with the Kung Fu grip. We also have distributions for MySQL, Mongo, and Postgres coming up, MySQL coming up. And PXE 8 has come up, and it's the world's highest, most trusted high availability solution for MySQL. If you're not familiar with how we built Percona server for MySQL, we take on all of those features and fixes and bundle it on top of MySQL community to make it truly an enterprise ready system. And so helping you to scale and simplify, we've got PXE 8 that we mentioned. So, and we have Kubernetes operators for that. We have our Postgres distribution version 12. And then we're going to be launching more performance enhancements and security things. We're also announcing today a partnership with Linode, where we're going to be bringing the best of Linode and Percona together to bring a enhanced database as a service. I invited Blair to give a quick introduction. Blair, if you want to come off mute.
All right, great. Matt, can you hear me?
I can hear you just fine.
Oh, fantastic. Well, great. I'm proud to be here at Percona Live Online. As Matt said, I'm Blair Lyon. I'm the Vice President of Marketing here at Linode. Since 2003, Linode has been helping our clients accelerate innovation by making cloud computing simple, affordable, and accessible for all. And now with nearly 1 million worldwide customers and 11 global data centers, Linode is leading a growing category of what we call alternative cloud providers. And key to being a true alternative to the big guys is providing a best-of-breed enterprise solutions, and database as a service is no exception. We are excited to combine forces with Percona to build a better DBaaS, using enhanced versions of MySQL that includes not only high availability features, but also security and performance enhancements. We essentially combine Percona PMM with a deep integration of PXC, deployed on our new managed Kubernetes offering. Our goal, click button, get high availability, high performance, and scalable DBaaS cluster. Best of all, customers will enjoy the core benefits of Linode, predictable flat rate pricing across all our data centers, award-winning, no-tiered, 100% human support for free, and 50% cost savings over AWS, GCP, and Azure without sacrificing performance. Stay tuned for more on a better DBaaS solution powered by Percona and Linode coming later this year. And thanks, Matt and the Percona team, for having me on. Back to you.
Thanks, Blair. Appreciate it. And so finally, I want to recap with what Peter said. If you haven't filled out our open source management survey, we really appreciate it. And so that is our talk. And I'm going to bring on our favorite Oracle employee, which is LaFred, who we all know and love and has been working, in the MySQL space for years and years. Fred, are you on?
Yes.
Ah, wonderful, Fred. I love the hat.
I know there was a trend, right?
I feel so jealous. You must send me one.
I didn't want to leave you alone.
Okay. Fred, feel free to share your screen and go from there.
Do you see it?
I do.
Perfect. So good morning, good afternoon, good evening, good night, depends where you are, right, in the world so far. So welcome to the MySQL State of the Dolphin. The first slide, if you're familiar with the event, you should have seen this several times in the past, but there was some new people, so I will let show just a few seconds. And as there are new people, just briefly who I am. So my name is Frédéric Descamps. I'm known as LaFred. I'm a MySQL evangelist working with MySQL for a long time. So I think the first version I installed was 3.23. I'm DevOps believer. I'm from Belgium. And I have a blog which is quite popular and gives a lot of information about MySQL. So MySQL 8 is out for 2 years now, right? It was GA for 2 years. And my plan now is to say, where are we now? And explain a bit what we have done in MySQL 8. So first, as you can see from DB Engine, we are still the most popular open source database. So we are very proud of that, and we try to keep that way. And we also got to the DBMS of the year. So we really appreciate that, and we are very proud of it. So if we check the Stack Overflow survey, we can see that also, and this is something really make us very happy, is that MySQL is still the most popular database for the developers. And all what we do is also focus on that because we want to keep that leadership, right? And as Peter mentioned it, so we are doing this for a long time now, right? And this is now, this month, the 25th anniversary of MySQL. So we are also very, very happy about this achievement and this anniversary. Let's hope we will have 25 extra ones also, right? And so when we came GA with the MySQL 8, as you can see there, it came in April 2018. The first thing that people said, and not even us from MySQL, was that was a giant leap for SQL. So if I take here like a tweet and the information comes from Modern SQL, right? They said, and they grant us for making MySQL 8 more, supporting more the standards and the SQL standard. And this is something we really focus on. And there were some, and we agree that in the previous version, there was some missing points, and still there are, and we are working on that to fix all this gap. And as you can see, so we're very happy when it came out 2 years ago in GA. And what happened in these 2 years, you can see in this slide, not made by the slide made by me, but all the points there are from Marcus Whelan from Modern SQL, right? And you can see that MySQL, with MySQL 8, tries to support more and more all this SQL standard and previous standard, but also the new ones and the recent. So as there are a lot of people not knowing or never attended Percona Live in the past, I was asking earlier on the Slack, I wanted to give a small overview of something we did in MySQL 8 that sometimes people are not aware of. When I go discussing around the world, seeing students, and they say, oh, when will MySQL support that? We do. For example, common table expression and recursive common table expression. This is part of MySQL 8. So in MySQL 8, if you didn't know, we support this with the with keyword, we support that. Same for lateral. Lateral was requested. True that before MySQL 8, we were not supporting it. And when MySQL 8 came GA, it was not yet there. And as you can see in 8.014, we brought that to the community with MySQL 8 now supports lateral. Same for the Windows function. A lot of people were asking about Windows function when they are very complicated queries, and they were missing that. And in MySQL 8 comes with the Windows function. You can see here an example with Belgium, where I come from, and it's very, very popular and very powerful. But I can see still now that a lot of people, even if they use MySQL 8, are not aware of MySQL supporting this. In the community Slack, we see a lot of questions that we can fix easily using Windows function, for example. And as I said earlier, we also support the SQL standards, SQL 92, but also, if I remember correctly, the JSON table, it's an SQL standard 2016, and MySQL 8 supports that too, right? You can have now a document, a JSON document, because maybe you know, but JSON documents is the JSON, it's a native data type in MySQL now, in MySQL 8, and also in MySQL 7, but we use it a lot in MySQL 8. So we have this full JSON data type natively, and it's possible to use the JSON table function to deal with that JSON document as it was a relational table, right? And as we talk about the JSON, I wanted to also highlight that MySQL 8 is also a document store. So we can do SQL with relational table, foreign keys, all we do usually, but we can also do NoSQL now in MySQL. So we can store no documents and have a collection without any schema, and all that using the XDev API. That means that you can use the X protocol that is default in MySQL 8. So users now and developers can query the data without knowing even SQL. So we support this CRUD operation for the collections. So this is our example. So we can add documents. We just do collection add. we can look into, so read data with the find method, we can modify, we can remove, so we can do create, read, update, delete, which are the CRUD operation. So this is very important for us. And when I show this to students, for example, they are so amazed about that because they really like, and in fact, they don't like SQL. I love SQL, and I think SQL, it's powerful, and we still need it. But to start with, a lot of people are afraid to store their data because they don't know SQL. So now it's possible to use MySQL without one single line of SQL. If you want, you can also mix SQL and NoSQL in the same connection of MySQL, but I have plenty of slides, or I can answer a question on that later if you want, but it's not the key of this session. So MySQL support JSON and CRUD operations. So here it's an example. So what you can see is that it's very easy to query documents without knowing SQL. And these data are just JSON documents in the database. So as I like to say, and we see a lot of time, no SQL plus SQL, it's MySQL, right? So other than SQL standard, other than document store with NoSQL, JSON, MySQL 8 brought something very important for us, and we restarted to refactoring the optimizer, for example. So we did a lot of work there, and we have now a new iterator executor. So this new iterator executor, it's modular, it's very easy to extend from our developers. Each of these iterator can encapsulate each other and only one operation, and then you can put them, you can connect them one by one, and it's very easy to improve and to extend the possibilities. So this is something very, very hot for us, and that we worked a lot on that. The optimizer team worked a lot on this to bring that. And thanks to that, what happened is that it gave us a lot of new possibilities with the optimizer. And one of them, so the first one that finally the user could see, was the new format of the explain. So now when you do explain format 3, so you know that there was explain without any format, there was explain with the JSON format, and now there is format 3. So with the format 3, you have this output, which is very common in other relational database and very popular. So we have that now in MySQL. So we can see at each step what we are doing and what's our estimation. Next to that, when we had the format 3, because of the new iterator executor, we could add other stuff. And what we added in MySQL 8, it's something that a lot of people were also asking for, is the explain analyze. So now we can have instrumentation and execution of the query at the same time and analyze that. So we can see what the optimizer estimates for cost, but also what are the real costs, or what are the real statistics of it for all part of the query. So this helps a lot when you need to do query optimization, and it is something very, very needed, but also not known a lot yet from people. We see still people using MySQL 8, and they don't run the explain analyze even when it's available. And we always tell them, please run that. It gives us a lot of information. So this is an example of explain analyze. So we can see here, compared to the explain tree, that we have more information. And here is the actual time that, for example, we get the first row and the time to get all the rows. So we can see where we are spending time, how many rows were read, and how many times. So the loop happened for this. So this is very, very detailed information that is very useful when you do query optimization. So other than the explain, this new iterator brings us something also very popular and very quick. And I know there are some sessions, there will be one session during the conference about that, is the hash join. So usually hash join is faster than the nested loop. and for large result set. And the implementation of the Hash join in MySQL 8, it's an hybrid implementation, meaning that we're going to use memory as when it's possible. And if it is not possible to use memory to execute all the hash join, we will split to disk what is necessary. So this is about the implementation, so which is different than others. And also now, the first time when it came out, it was not for all type of join. With 8.0.20, it's hash join are available for all the type of join. So inner join, equi-join, outer join, semi-join, and anti-join. Therefore, because we support all of them, we're going to replace, it's replacing the block nested loop in the query plans. So you won't see a block nested loop anymore in the query plans now, because hash join will be used. So if we check the performance on the data using hash join compared to block nested loop, so when there is no indexes, because of course indexes are also very good for performance when you can create them and when you can have them. But in case you need to do some queries where the index are not possible to be used, you can see that the hash join is much faster than a block nested loop. So this is why we have implemented that. So this is almost what I will say about Optimizer. There is a lot of extra feature. If you want to know more about MySQL 8, please check previous session of MySQL 8. There is one from Geir at FOSDEM that is that shows a lot more about implementation in the optimizer and what happened, what's new in MySQL 8. And now I will, because I have a few amount of time, of course, I want to show also what we did, some latest change that we did in InnoDB and binary logs, for example, in 8.0.20, related to performance and scalability. So if you are following the evolution of MySQL and MySQL 8, you should know that in 8.0.20, we have a new double write buffer. So when this is an example, when we are an IO bound system, very IO bound, this is very important to know that this is an IO bound system, you can see that MySQL 8, thanks to the new double write buffer, will perform much better than 5.7. And as this is a slide from Dimitri, we should not forget Dimitri's flame, right? They are not exactly the same, but he likes that. So this is something that we are very happy, and you will see in the future, we will, there is a lot of improvement in InnoDB, new stuff we are doing to improve it more and more. But this one gives already fix a lot of issues. Other thing we are very, very happy and very proud in 8.0.20 is the new binlog compression. So a lot of users were waiting for it, asking for it. So now it is. So thank you for Jesper, because he wrote a blog post about it, and I took the image from his blog post. So you can see here, or you can save a lot of size. You can save network about how we, about the binlog compression. Binlog compression happens in transactions, so we compress the full transaction, and you can specify a different type of compression. So this is also something very new and very powerful and very useful for people. Something that is not in 8.0.20, but I want to highlight because this is one of my favorite feature, and I think this was a game changer, and it is a game changer. But not everybody knows about it yet. And when I see questions in forum and stuff, I still have a lot of questions related to that. And people are not using it that much because they don't know it. But when they know it, they cannot go away of it because it's wonderful. And this is the MySQL clone. So MySQL clone, it's something very, very powerful. It allows you to populate new instances. So that can be a master and replicas, or can be part of InnoDB cluster in a group replication, a new member. You can provision data very quickly just from the SQL layer. So this is something very, very powerful. And it's well integrated in MySQL shell too. So here, for example, this is an output in the MySQL shell. So this is very, very fast. I know Simon might make some blog post about testing it. So I invite you to have a look to see some numbers there if you are looking for that. But MySQL clone is very, very nice, and you should use it. And now the transition, it's easy with what Matt said earlier. Matt was saying about, we need to make stuff easy also and automate a lot, right? And this is where MySQL 8 is also focusing a lot of energy. So the MySQL team are working a lot to make this database architecture much easier and much easy to deploy, because we have seen so many deployments that are crazy, but really crazy, and sometimes not needed. So when I talk about this easy solution, the first one that comes in mind of people that follows me will be InnoDB cluster. And of course, InnoDB cluster, it's one product that gives you HA and scaling features, so you can scale your reads very easily with it, and it's all integrated. So this is how a cluster looks like. So you have applications, you have server routers, then you have your cluster of a server, of MySQL server with the group application, and all it's orchestrated by the shell. So it gives you MySQL service HA, completely available. It has fault tolerance, automatic failover. It can be active-active, so multi-primary, but some limits apply there. So watch out to read what are the limits if you plan to use it. It has also, you can, all the membership management can be automatic. So in case one node has a network issue, it can be removed from the cluster, or you can do that manually from the shell if you want. There is conflict detection, and this solution is the only one that in MySQL that really prevents you from data loss. So if data is your concern, you should go for MySQL InnoDB cluster. And of course, it's GPL. So we're very happy about that too. Other than that, and this is maybe not well known because it's quite new, it's from 8.19, it's the MySQL InnoDB Replica-Set. So this is also completely integrated with the MySQL router. It's also all orchestrable by the MySQL shell, and it uses the clone plugin to do the provisioning automatically, all that. So it's exactly the same as InnoDB cluster to set up, and I will show you that. But it is different because this one uses asynchronous replication, so it can give you read scale out, but it's not automated. Not everything is automated. There is no, let's say, primary choose when one has an issue. All that has to be manual, because as you can see here, we don't need 3 nodes at least, but 2 can be enough. And you don't need to rely on a very good network. If you have some flaky network, this solution is for you because it uses asynchronous replication. So these 2 solutions, the goals of them was to have one product, which is MySQL, and all these components are tested together. They are all integrated components. They are SysQA together. They are developed together, and deliver all together. And the most important for us, it's easy to use. So you have only one client, which is the MySQL shell, to orchestrate all that and to integrate all of that. And also sometimes it's very important is to have homogeneous servers. So you can have different servers on different OS to use your architecture. Also, something new that a lot of people doesn't know yet, it's that since 8.19, all these 2 solutions support GNSSRV with our connectors. So it's very, you can use this service discovery, and then no need to change anything. It's very, very easy and to deploy that. So I said it's easy to deploy. So here is the difference between the InnoDB cluster and the Replica-Set, for example. So you connect to one server and you just do, okay, I want to create a cluster, or you want to create a Replica-Set. Then you say, oh, I want to add a machine. I need to configure it. And because MySQL add 8 at set persist to change the configuration and persist configuration. And the shell is using all that. You can do, I want to configure an instance for a cluster, or I want to configure a Replica-Set instance for replica sets. You can add then the machine to your cluster or to your Replica-Set by using add instance. And then to bootstrap a router, it's very easy. You just do bootstrap your router and connect it to one of the machine. And it's very, very easy. So as you can see, the MySQL shell, it's the center or the heart of many of our product of MySQL. You can use the admin API with it for deploying a cluster or replica set. You can use the Dev API with it in JSON or in Python to do document store or to do whatever you want, because the MySQL shell is very extensible. So you can extend without limit what you can do with the shell. If you can write JavaScript or Python, you can do whatever you want. So this is an example, for example, of a plugin I wrote. And if you're interested in many plugins to create your own or to just test them, here it's a repository where you can find plugins. And finally, I wanted to also the new, what you call that, transition with what Peter was saying earlier about all these licenses, right? So MySQL did all that for 25 years without changing the license, and the license for us is GPL. So MySQL is GPL, and I hear a lot of time everywhere that it's not true. This is not the case. MySQL is GPL. So the MySQL server is GPL. The MySQL router is GPL. The MySQL shell is GPL. The clone plugin, this awesome product, is GPL. The workbench is GPL. All that is GPL, and we accept contribution. And as a session cannot happen without numbers, I want to show you also some very numbers. I'm very proud as a community manager of it. And so MySQL 8 is also 264 contributions so far. It is 58 contributors that are not our employees, so external contributors. And the top 3 contributors so far are Facebook, are Daniel Van Ede, and Arenas. So big applause. I don't know if you can applaud from in front of your screen, but I do. So thank you very much. But I don't only want to thank these 3 top contributors, but I want to thank you all of them. So this is the 58 contributors for MySQL. So kudos to you guys. Thank you very much. And you did a very good job promoting and helping MySQL. So you can join the MySQL community Slack. You go on my blog and you will find how to join it. There is a lot of people there answering a lot of questions. Sometimes developers are there. MySQL team is there. So, and a lot of other DBA. So if you have questions, this is the right place to be. Like I said, MySQL 8 is great and you need to go there. And now the DBA certification is also available to be taken in the Oracle University. So you can do this DBA exam, and the developer exam will be also soon available. We are finishing it. So I think I'm still in time. So thank you very much. One word is that MySQL 5.6 will be end of line soon. So it's time to upgrade. And if you need to upgrade to MySQL 8 because MySQL 8 is great. So thank you very much, Matt. I'm done. 2 minutes in advance.
Lovely, Fred. Thank you. Thank you very much. And there was actually a couple questions. We've got a couple minutes. So Simon wanted to know, is cloning still same version only?
So let me stop. Yes, I think so. There is, to be honest, there is no technical limits on that, right? It's just, yeah, it was like that. And we need to, I think one version up should be okay, but currently it doesn't allow it. But it's a work in progress.
Okay. All right. Well, thank you, Fred, and thank everybody at MySQL from all of us here for 25 great years of really helping promote open source software and open source databases. It's been a great ride, and we all appreciate everything that you've done.
I'm not able to stop my share.
All right, stop your share then.
I'm not able to it. I click on it, but
oh well, you're stop sharing. So it's just
okay.
So thank you, Fred. So moving on to our next speaker, Matt Asay from AWS is here, and he's going to talk to us more about open source licensing. And he's going to talk about getting beyond zero sum in open source. So Matt, are you there?
I am.
Ah, lovely. Wonderful.
Okay. Can I go?
You can go. You're up.
Awesome. Awesome. And it feels kind of awesome to follow after MySQL. Very grateful for the work that they've done for 25 years. It's kind of amazing. And I'm going to talk a little bit about that. So I want to talk about, mine's going to be less technical, less product oriented or project oriented, and more about how we as an industry or how we as a community of communities get away from thinking about open source zero sum games. And I'll explain what I mean by that. I'm not going to talk about AWS per se, but I'm going to talk about industry trends and where we all fit in this. So without further ado, and let's get started. So to get started, I need to give a very brief history of open source. And incidentally, you'll see obligatory ski pictures as I go because I love to ski. And yes, I am still skiing, socially distant skiing in Utah. But I think it's useful to get a little bit of background on open source, how we've gotten to this point. I promise it won't be boring. And if it is boring, I promise it will be short. The first place to start with is long before there was the open source as a term, as a phrase, which of course was coined in February 1998, there was the concept of open source. It was very much alive. And if you think back, and this is a picture of Grace Hopper, if you think back to the 60s, 70s, the idea of open source was very much alive. And it was that, but at that time, it was that the companies like IBM would sell hardware and the software was more or less given away. And I don't want to say that it was an afterthought or that it was unimportant. It's just not what was sold. And especially in academics, it was very much the case that one university, one researcher would take the software, make tweaks to suit her needs, and then share it. And that was the norm. It wasn't an aberration. That was how software was distributed and used. Fast forward a few years to 98, and that spirit of sharing that was coined as open source. Throughout all that time, this concept of developers sharing with each other has persisted. And just want to make sure that I forgot to start my timer. So keep that in mind, but I want to make it a little bit more personal. And to make it more personal, I want to talk about 3 developers and 3 projects over the last few decades that have arisen. And the first one is SolveSpace, and the maintainer, her name is White Quark. I don't actually know her name, but she goes by White Quark online. It's licensed under GPL v3. SolveSpace is parametric 3D CAD or computer assisted drawing. Basically, it's the software that you would use if you had a 3D printer and you wanted to build something. You might use this 3D CAD program, SolveSpace, or another one before to design and to tune your machine to know what to build. For White Quark, when I asked her, I interviewed her recently, and I asked her, what got you into this? She said, well, I build very boring, these are her words, very boring technical parts. And why? Because making physical things is cool. I know most of us are probably on the software side. She's as much on the software side as she is on the hardware side. And when she started in roughly around 2014, she started looking for again, a 3D CAD program that she could use. But she was constrained by a few different criteria. One was not that it had to be open source. She actually didn't care. She says she's not a purist. But she needed something that was relatively cheap. She needed something that ran on Linux. And she needed something, and this is where we get out of my pay grade, that did parametric modeling and NURBS Booleans. The important thing here is that this narrowed the field considerably. She evaluated a few different options and ultimately settled on SolveSpace. The problem was, as she said, it was a legacy code base that was extremely challenging to work with for anyone who wasn't its original author, as I quickly realized by discovering that many of my earliest obvious looking changes were in fact unsound. So what would any serious open source developer do with this? They did what she did. She started to contribute. She contributed first just trying to make the infrastructure or the scaffolding of SolveSpace more sound. It got to the point where she was valued so highly that she was made the maintainer of the project by the original founder and maintainer of the project. She continues to maintain it to this day. But again, a good example of how open source can work. She wanted something solved. She had an itch to scratch, as it were. She got involved. She started to contribute. And today is the lead designer or the lead maintainer. In fact, one thing about Whitequark that I find particularly inspiring is she cared so much about it. She recognized that they needed a graphic design person to work on the project. They didn't have one. And so she actually took on contract work so that she could pay somebody to do this work. Kind of amazing, going above and beyond. Now, SolveSpace is a relatively small project. Compare that with Drupal and founder Dries Buytaert. And Drupal's slightly bigger. Last year, in 2019, Drupal had roughly 10,000 individual contributors, which is sort of mind-blowing if you think about it. These contributors might include, and do include, developers at Pfizer, for example. Pfizer contributes millions of dollars of engineering time each year so that they could build, for example, a workflow engine that benefits everyone who uses Drupal, including their top competitor, Johnson & Johnson, or one of their top competitors. The spirit of open source. Now, when I interviewed Dries for this, he told me that it wasn't always this way. It's this huge community now, but it wasn't always that way. It started with Dries wanting to build, as he calls it, a very little website, so that he was at I think at the University of Antwerp in Belgium, and was just crazed with this idea of the internet and building websites. But he didn't have an internet connection, or at least not a fast one. His friend, however, did have an ADSL connection, which today would be very slow, but at the time was quite fast, could handle up to 10 users. But there was a requirement that they couldn't share, that he was not allowed to share that connection. So what did he do? Well, they immediately started trying to figure out how to share that connection. Dries became an early contributor to the Linux kernel on the wireless LAN stuff, and they figured out how to share it. And he built this website that allowed users of this ADSL connection to coordinate how they were going to do it, and eventually became coordinate when they're going to go to McDonald's or meet up at the pub. But it started with this very little act of sharing, and eventually got to the point where Dries says, hey, you know, people were lobbing in all these support requests saying, hey, it would be great if Drupal, as it came to be called, could do X, Y, or Z. And he said, well, maybe you should contribute that. He said he bent over backwards, wrapping, as he said, a warm blanket around these contributors to enable them to give back to Drupal. The super interesting thing about Drupal in all this, to this day, so 7 years, he kind of worked on this as a labor of love, nights and weekends as he finished his PhD, came to this decision point where he had to decide, what am I going to do with my life? He said the easy choice would have been to stay in academia, decided instead to start a company, Acquia, with Jay Batson, And now, today, Acquia is one of the primary contributors to Drupal. And if you think about the way that we think of commercial open source today, you say, oh, they must contribute most of Drupal. In fact, they contribute less than 5% of Drupal, to the point that he says, now Dries thinks about commercial and open source very differently from many today. He says, with so many of the open source companies, they're very insecure. They want to be in control. The thought of not having absolute control over the product, the roadmap, etc., is, quote, foreign to them. It's the craziest thing in their minds. So Dries has decided to do open source in a very different way, which I would argue is the original way of sharing. And the benefit to everyone is that this Drupal community of 10,000 or so contributors is that's filled with all sorts of companies and people who benefit from Drupal. All right, last one, Redis and Salvatore Sanfilippo, who incidentally looks like he should be like a GQ model or something. Should have had Salvatore on here, and everyone would like looking at him a lot more than they like looking at me. Salvatore's story is also super interesting because he wasn't trying to start a company. There is a fantastic company now backing Redis called Redis Labs, but that wasn't where he started. He started just needing a database that would scale to meet his meet an analytics application within his company, meet his needs for that. MySQL met the needs, but was too expensive for him to scale. So based on his needs, he said it just wasn't cost effective for him to use MySQL. So instead, he started developing this in-memory database, which the database experts at the time said, this is crazy. Why would you put that in memory? And there were a number of other things where, again, the database experts, who weren't wrong for the state of where databases were at the time, but they were wrong for where databases were going. Salvatore, in his, quote, ignorance, persisted and created one of the top today, one of the most popular databases on the planet. If you look at DB engines, I think it's maybe ranked number 7 right now, but at any rate, super popular. One of the things that's really worked for Salvatore and Redis is that he doesn't try to guide how people use Redis. I asked him, well, what's the best thing? What are the best use cases for Redis? And his response was, what Redis is good for is not my choice. It's the application developer that knows best. This has enabled a vibrant community to grow up around Redis. And he says it's important because different users bring different experiences, want to solve different problems. And so they bring that expertise and those needs to Redis and make it better. He said, having said that, you tend to only get serious contributions, his words, only from folks that are paid to write such contributions most of the time. Turns out it's hard to develop a database if you really need to be able to invest a lot of time in it. So those who offer the quote unquote best contributions tend to be paid to do that. But he says the Redis core is definitely a collaboration between many individuals. So of course, during this time of peace, love, and Redis, Drupal, and Solve Space, other forces have been at work in software. To the left is Bill Gates' famous 1976 open letter to the hobbyists, where he says, most of you steal your code, you prevent great software from being written, pay up, was kind of the thrust of what he says. But this isn't to say that Bill Gates started this trouble in paradise, or this idea of selling software licenses and turning software into property. Remember, back in the 60s, 70s, software wasn't sold, the hardware was sold, and software was mostly given away. Throughout this time, through 1976, and then on to 98, and then on to today, lots of sharing and collaboration has happened. But this idea of locking down software and it being a scarce resource started to arise. To the point in 2005, I joined a company, Alfresco, great company, But this was the rise of the open core movement, where open source software companies, in order to, I don't want to put a pejorative slant on it, but compel users to become customers, kept some software back and said, hey, you know what, for example, if you want to use this core of the software, it's great, works great. But if you need advanced security, you have to buy the enterprise version. If you have more than 100 users, you need to buy this enterprise version. So it's this infiltration of open source with the old model of proprietary software, to the point that more recently, in the last few years, some of these companies just gave up on open source altogether and started using licenses that weren't OSI approved, weren't open source licenses. This isn't to cast aspersions on anyone, but it is to bring up something, one of my favorite things, Pi. When I bring up this history and I bring up this proprietization of open source, because I think we're missing something fundamentally important in all of this, and that is Pi. It's not really about the number of pies. This is, I like to make Pi, and I made for my team one year a number of different pies, but it's not really about the number of pies. It's about how big you make the pie. So let's do some Pi related math. For those watching at home, which is all of you, check me on my math, because I was a literature major, so my math is not always great. But Gartner's done this math and said, this was 2 years ago, or about a year ago, really. Gartner said that open source is roughly 10% of the now $46 billion database market. Pretty good, right? At one time it was 0%, so it's pretty good. But it's still a small fraction of the database market. Let's broaden beyond databases and talk to the global IT market. That's a $3.9 trillion market. Awesome. Cloud spending within that is roughly 266 billion. Now, again, I'm a literature major. I also went to law school, did a master's in international relations, none of which qualifies me to do this math, but you can check my math. I think what this means, if you look at these numbers, I think what it means is that we spend a lot of time arguing over 6% of the total IT market. We spend a lot of time pointing fingers at cloud vendors, or it's not just the cloud, but we spend a lot of times pointing fingers at these different vendors saying, you're taking from me, but we're talking about 6%. We're talking about almost a rounding error of the overall IT market. And maybe more importantly, as we carve up this little tiny pie, we're thinking about it, I think, wrong. So MySQL preceded me in this, now Oracle, of course, but Martin Mikos, former CEO of MySQL and a good friend of mine, used to say this, and I remember distinctly when he said this. I loved it at the time, because as an open source guy, I loved this idea of sticking it to the man, and the man at that time was the company that now owns MySQL. But at any rate, he said the relational database is a $9 billion a year market. Not sure where he got that number, but let's stick with him. I want to shrink it to 3 billion and take $1 billion of that. Now, they did take $1 billion in terms of selling to Sun for $1 billion, MySQL. But his idea is sort of deflationary, that open source takes money and shrinks markets. The only problem with this view, one, it potentially means a lot less pie for everyone. And I like pie, so I don't like the idea of rinky-dink little pies. But I also think Martin, who's exceptionally smart, I think he just happened to get this wrong. Or maybe he was looking for a good soundbite. And let's face it, it is a good soundbite. He's wrong because of Jevon, who had a paradox, Jevon's paradox. Simon Wardley, who many of you will have heard of or possibly know, talks a lot about Jevon's paradox. And the basic idea of Jevons paradox is that instead of lower per unit costs leading to a reduction in overall spend or a smaller overall market, because people pocket the savings and think about it, pocket the savings. Instead, the irony or the paradox is that we actually tend to spend more. We save money, and it means we buy more things. There's a variety of reasons for this, including there's this long tail of unmet expectations or new applications. This is something that I saw when I was at MySQL or at MongoDB. There were applications being built with MongoDB, a document style database, that simply could not be built with Oracle. Not because there's anything wrong with Oracle, not because there's anything wrong with SQL Server or MySQL, but simply because it was a different kind of database that enabled new kinds of applications. So that's one reason that we see as people save money with open source, as they save money with cloud, they're not contracting their spending. They're actually spending more or getting more value for the same amount, but they're not reducing spending. It's this Jevons paradox. At the same time, think about this with respect to, and I don't have a great word for this, but these big web applications or web companies, think Google, Amazon, Facebook. None of these open source made these applications, made these companies possible. And it's not really about some punitive per unit license fee. Maybe that's part of it. Part of it also is that just keeping tabs, if you've got thousands or tens of thousands or millions of servers, keeping tabs on whether you're up to date on your licenses before the audit comes. I mean, there's part of it that's that too, but a big part of it is just the flexibility of open source that enabled all of these new kinds of applications. So, Jevon, paradox, open source and cloud didn't kill spending. Cloud has not killed open source. If anything, it's accelerated and grown it. We're looking at the opportunity to have a lot more pie. Let's talk a little bit about why. I mean, at this point, you might be saying, you know, Matt, that's fine. You work for AWS. Of course, you're going to say that. Of course, you're going to say that cloud is not cannibalizing open source, and you're an open source guy. So of course, you're going to say that open source is a net positive. And the answer is to both questions, sure. But that bias existed before I joined. It's why I joined. And that bias for open source also has existed for decades, because that's how I've chosen to spend my career. I don't think for this crowd, actually, open source is a difficult thing to embrace. But something has been on my mind since AWS reInvent last year. And that is this idea of how do we grow the pie for everyone? And it started with a conversation with a good friend from MongoDB. We had just released, AWS had just released the day before, at that time, well, it's now called Amazon Key Spaces. It's our managed Cassandra service. And I remember reading a tweet where someone said, you guys are doing this and you're just trying to take all of DataStax's revenue, which seemed a little bit odd to me. And I said this to my friend, my friend from MongoDB. I said, you know, with all due respect, I have friends at DataStax, great company, and now I have really close friends at DataStax since Sam Ramji joined. But we could take 100, at the time, AWS is at I think a $36 billion run rate. We could take 100% of the revenue and it wouldn't move the needle for us. And that's not really how we think. We really do, and this is actually true, we really do obsess over how to deliver customer value. I said, so they've got it wrong. We're not trying to carve up a little tiny pie. We need to figure out how to make this pie bigger. And talking again with this friend, it occurred to me and to us, I think both, that there's actually two phases. The first phase is, how do we make this pie? How do we make the open source pie bigger and better for everyone? Because again, the enemy is not, we're not trying to carve up a $4.6 billion database market. There's another 46 billion or another 41 billion or so. And actually it's bigger than that because there's a lot of money that's not being spent. The customers are having unmet needs that we could be driving to. So it's not about carving up the existing pie. It's how do we make the pie bigger for Kafka, for Apache Cassandra, Apache Kafka, for Redis, for MongoDB, Elastic, name your different open source project. How do we make that bigger? And the second phase is, yeah, we're going to compete like hell to win those workloads, but that's a secondary concern. And we're going to do it with cloud. And let's get into that. The first one, phase one, is let's together make open source even more awesome. And how do we do that? Well, we contribute. One thing to recognize in this, and Kyle Matthews, founder of Gatsby.js, said this really well. When I was interviewing him recently, he talked about how Gatsby is built on React and depends on GraphQL and all these other open source projects. Could not exist without them. Well, guess what? That's all of us. We are all net consumers of open source. Not one of us even remotely comes close to contributing 1/10 or 1/100th or 1/1000th of what we benefit from open source. We need to recognize that. Second is that users, especially users who figure out how to operationalize code, are actually really valuable to us. And again, I know you're saying, Matt, you're saying that because you work for AWS. Yeah, I work for AWS because I think it's true. Operations really matters. Users really matters. Rich Felker of the MuscleLibC project had this, a founder of it, had this great comment where he said, users, testers, adopters, bug reporters are so much more valuable than writing any code because it shows him what kind of code he needs to write. Now, take that with a grain of salt. We don't all want to have just net users. And Jens Axbo said this to me of the FIO project, that no, users who can contribute back are even better. They need to be using them, they need to be contributing back because that use informs the kind of things that they would contribute. Remember also Salvatore's comment that most people aren't going to be able to contribute to our projects. They just aren't because they don't have the time. They're not paid to do it. And frankly, they're using 1,000 different projects. They can't contribute to all 1,000. So maybe they choose to contribute to this one or that one. We need to be a little bit patient with each other as we grow the pie. And so that's the message here is let's make the pie bigger. Let's be patient with each other as we do it. We all have constraints that impede us from contributing. We also have different ways in which we contribute. I'm trying to remember, I think it was Jens who said to me recently that he's great at writing software. He's really crappy at writing documentation. So one of the things that probably lots of people listening on this call, to this presentation could do is contribute more documentation. That's something that every project needs. Once we've made the pie bigger, then let's compete. And let's compete in the way that customers are increasingly choosing to consume software, and that's cloud. And guess what? This isn't just AWS cloud. This is at Microsoft Azure, Google Cloud Platform, DigitalOcean, but not just that. In the database space, in this world in which we live, it's MongoDB's Atlas, for example. In fact, let me stop on Atlas for a second, because I think it's a great example. My personal belief is that license changes at MongoDB and other companies have not really helped them at all. I was at MongoDB for a few years, and licensing really didn't drive sales. That's not the way the customers were thinking. What customers are looking for is value. Once MongoDB introduced Atlas, it's amazing if you can go back and look at their earnings calls, the progress that went from 10% of their revenue, 11% of the revenue derived from Atlas to 20%. To today, it's 41%. Atlas, MongoDB's database as a service, is I think on a $400 million run rate. It's a $100 million quarter business. It's awesome. It's so cool. They're doing such a great job. they're doing a great job of delivering value to customers. Cloud is the way that customers increasingly want to consume their software. And so you look at now at whether it's Percona or MariaDB or Redis Labs or name all these different Couchbase, all of these different companies are delivering databases as a service, as a cloud service. It's exactly what they should be doing. That's exactly how we should be competing, not competing to keep value back, but competing to bring value to customers. And I think that's what cloud does. Which brings us to the conclusions. If you start with a customer and work backward, as kind of an AWS, Amazon sort of thing to say, open source and cloud are going to be key components of how we deliver value to customers. So let's do it. And let's not just do it in our individual silos. Let's do it together. Because again, there's going to be competition at the cloud level, but at the project level, at the open source level, there should be widespread, rampant collaboration. It's exactly what we should be doing. Along the way, let's be sure to remember the White Quarks, the Dreeses, the Salvatores. Let's make sure we contribute more, all of us. We all consume more than we contribute, but we can all do better in contributing. It's about abundance. It's not about scarcity. We all want more pie. And if you don't think you like pie, it's because you haven't had good pie yet. I can take care of that. Thank you very much for your time. I appreciate it.
Thank you, Matt. Appreciate your time here, and thanks for coming out and talking with us. It was really great to have you here. And
yeah,
so,
thanks, Matt.
Want to move on to our next speaker, Bruce Momjian from Enterprise DB. Bruce, are you online? I saw you here earlier.
Yes, I am.
All right, Bruce, I'm going to let you take it away.
Thank you. The old fancy screen share, and there we go. Well, it's wonderful to be with you today. I'm learning about these virtual conferences a little more now, and it's kind of nice not to be on a plane. So I do appreciate that. My name is Bruce Momjian. I'm one of the Postgres core team members. I've been working with Postgres for 24 years now, so a long, long time. I want to talk to you about a little bit about Postgres, and it's great to go after Matt because I'm going to build on what he said. These slides are online, my website right here, momjian.us. There are a couple dozen presentations there and hundreds of blog entries, mostly about Postgres, but some other things as well. So feel free to take a look. What I want to talk to you about in the next 30 minutes is a concept sort of building on what Matt said in terms of why is open source such a powerful force in the software industry and why it's fundamentally different than the traditional proprietary software that we've come from. So I want to start out talking about the concept of forever, kind of a funny way to start. And then we're going to get into exactly the point I was talking about, the concept of the software lifecycle. You don't hear about it too much, but I'm going to kind of piece that together and give you an idea of how software in the open source has a different life cycle than the proprietary examples. And I'll give you some specific examples, kind of interesting. Then we'll talk about open source adoption. There was an interesting study done a couple years ago and give you some key points there. Then we'll talk a little bit about Postgres innovation. I'm not sure how much we're going to be able to get into, but I'll highlight the big things, and then we'll talk a little bit about the community structure. So first, let's talk about forever. What does it mean for software to live forever, right? I mean, forever, that's a long time, okay? We're talking like billions of years so far. We don't really know how many more billions of years we have. But as you can see there at the bottom, the number of years that we've been digital is pretty small. So is Postgres going to live forever? Probably not. But it is, again, I've been with it for 24 years. It started out for University of California 34 years ago, and it probably has a couple more decades to go, I think. So it's not going to live forever, I would say, but it's going to be a long time. So just to give you an idea of the history of digital stuff, Jacquard Loom really being the beginning of that. But again, ENIAC actually started here in Philadelphia, which is where I'm based, in 1945, sort of the first programmable kind of computer. And then, you jump forward, 75 years or so, 85 years, and you get to where we are today. So again, databases really only in that last 50 years or 40 years or so. So again, not a whole lot of history there, but just to give you an idea. So software life cycle, what is that? This is actually a picture of a computer that I used when I was in high school. So anybody recognizes it, you're probably my age. But again, hardware has really not lasted a whole lot of time, right? I saw one of these in a museum recently. I think it was in Santa Clara. But there are not a whole lot of old hardware around. But software, that's different. It's a fungible thing. It's malleable. It can last a considerable amount of time. So let's talk about proprietary software and the typical life cycle that proprietary software goes through. And I'll kind of make some examples as I go, but effectively, almost all proprietary software starts with some kind of innovation, some kind of idea that we have a new idea for the market, we have a new solution for customers, something that doesn't exist anymore. We're going to innovate, and we're going to fund that innovation. We're going to spend 6 months, 18 months, put together a development team and develop some kind of product. Then you have your first sale. Then you go into phase 2, which is market growth, where you're basically trying to figure out, how does my product fit within the market? What kind of things can I do to increase that, and so forth. And that can last a while. It might last 6 months, it might last 6 years. But then when getting to item 3, you basically reach a point of saturation where there might be a vendor in the market who you're not able to really surmount. But you've pretty much grown as much as you're going to grow. And then you enter, excuse me, stage 4. And that's maximize profits, minimize costs. So this is the point at which, no matter how much money you sort of pour into development or innovation, you're really not going to move the needle. You've kind of saturated as far as you're going to go. So you maximize profit, you minimize costs. And usually what that means, your prices go up, development expenses go down, you have fewer developers, you spend less money on support, you're less concerned that customers are happy or talking positively about you, okay? And you may be in profit maximization mode for a while. I could list off a whole bunch of companies off the top of my head. They're in that profit maximization mode. And then you get to stage number 5. Stage number 5 is effectively where you've shut down development pretty much. You may be doing minor bug fixing. You're not adding any features, and you're not adding any innovation. And this can go on for a while, until you get to stage 6. And stage 6 is the point at which you can't make enough money to even stay in maintenance mode anymore. And the software, because it's not open source, just disappears. And if we think of a lot of really cool software we used when you were younger, typically if it was proprietary, as soon as it left maintenance mode, it's gone. You can't improve it. You can't do anything with it. It's kind of the whatever source code you had is disappeared. And that product or that game or whatever just isn't available anymore. So I know I'm talking about end of life. Maintenance mode, there's a lot of products in maintenance mode. We used to say computer associates. Associates was where software goes to die, CA effectively, because they sort of specialized in bringing in software that was in maintenance mode and effectively just maintaining it and getting revenue that way. A lot of the proprietary databases now are kind of in stage 4, right? They're really saturated in their markets. They may have competition from open source, but again, they don't see development or treating their customers better as a way to grow things. So they're just kind of riding out that stage between stage 4 and stage 5. Some software now, like maybe Informix, Sybase, are all in that stage 5 area. You know, in the 90s when I was a developer, you know, Ingress and Informix and Sybase and DB2, you know, we're all, you know, through Oracle, we're all in that market saturation, trying to compete against each other. Now they're all in that 4 to 5 stage, I would say, in terms of the proprietary software relational databases. Now, looking at open source, it's kind of a different case. You don't start off with innovation necessarily. You may start off with innovation, which is a lot of cases. You may start off just trying to gain parity with a proprietary offering. Okay. So again, it might be one of the two, but you don't have any funding. So you don't really have like time limits. You don't have requirements of trying to get to market in a certain time. It's a different dynamic, right? Then you go to market growth, and market growth can happen to a certain point or not happen to a certain point. But there's no sense that you saturate the market because, like, what do you do? Like, you know, there's a bunch of open source tools that have kind of saturated the market, but you don't have any profit maximization because typically in open source, pure open source, where it's not controlled by a company, there is no profit maximization. You just keep innovating, or you decline, or you innovate, but you don't have another target that's going to push you away from innovating or away from investing because you never invested in the beginning. You never had this sort of goal of profit maximization. Oh, we got to pay for all the investment we did during our innovation phase. None of that enters into it. And then again, if it declines, the source code is always available because it's open source, right? So it could decline and somebody else could pick it up and then it could get more popular again. Now you might think that's a silly concept, but in fact, when I started with Postgres in 1996, it was sort of in maintenance mode. There's one person maintaining it. Regular releases weren't coming out regularly. It wasn't being patched with patches applied and released. So when we started in 96, it was already 10 years old at that point. It had left the University of California, Berkeley. There was one or two people maintaining it. But again, the source code was available, so we were able to build on it. So again, the concept of the previous slide where the software, once it goes into maintenance mode, just goes away. That does not happen with open source. And again, that can be another way where software continues to live. I'm going to try and explain this slide in 30 seconds because I think it's an amazing example of a mix of open source and proprietary together. 1994, company puts out a game called Falcon 4. Anybody my age or my son even loved the game. Okay. 1998 is the final release. 1999, game development ends. 2000, somebody leaks the source code to the game. So the source code gets out of the proprietary thing. 2003, an open source community gets created to generate modifications of the game. 2005, a company takes the mods and makes a product out of it called Allied Force. Okay. 2015, a company gets the license for that and republishes it. And then in 2015, again, the open source community makes more Rhino releases to the new proprietary release. So again, great example, again, the URL there at the bottom of software going in and out of open source, basically almost seamlessly is kind of interesting. Let me give you just a visual of exactly how things are different. This is a flow of what proprietary looks like. You have on the left, developers in a company, primarily driven by sales and marketing. And then on the right, you have users, and you can see there's a very defined flow of when users see what happens in development and what what development sees from the users. And this development model is so inefficient that effectively open source is able to produce better software just by improving the model, not by having more resources necessarily, but having a better way of interfacing between developers and users. Because in open source, you have users and developers at all steps of the process. Postgres is putting out a beta for Postgres 13 this week. And again, we're in that fourth box there where we're going to have beta testing by users, talking to developers, basically fixing things in real time, 24 hours a day, getting to a final release. But again, we've had our developers, our users involved in the development process through feedback, through testing, through ideas all the way back to the feature being proposed. So again, this kind of efficiency, I think, is what makes open source just so tremendously powerful. When I started with Postgres, we were effectively down here at the bottom of the red. But what I learned from starting in 96 is that no matter how inferior we might be to features, performance, and reliability compared to closed source software, if we had a growth curve that was steeper, we would eventually overtake closed source. So even though you start lower, but if you're climbing faster, you effectively have the chance to exceed the closed source products. And there's a lot of ways in which Postgres has exceeded and is above that blue line today. You might think I'm just making this up, but effectively we already have some major operating systems that used to be best of breed, that used to be the go-to for enterprises, HPUX, AIX, Solaris. I used HPUX a lot when I was a consultant in the 90s. It was the go-to operating system for our hardware, but effectively Linux attained parity and then innovated beyond them. People are not using Linux necessarily today because it's cheaper. The ability of Linux is just so far superior to these. And of course, Solaris is now end of life, as was announced, I think, 2 years ago by Oracle. So again, you can see that end of life process kind of starting even at the operating system level. At the database level, again, same thing. The ones here in bold are currently being actively developed, the first three. The last three are in maintenance mode. As far as I know, they're not gaining market share. There's no new features coming in. And again, I think even the first three are kind of some sense struggling to understand what the new open source competitors are, what the non-relational competitors are, and they're certainly not growing market share. They're really trying to struggle. Whether they're going to end up like the HPUX Solaris, I don't know. I would probably think eventually they will, but maybe not. Yeah, it's hard to say. But again, you can see, I wouldn't have guessed that these major operating systems would be in maintenance mode today, but they are. So again, interesting parallel there, I think. Another great advantage of open source is that instead of having a company drive development in one direction, because you don't have a company, you have a whole bunch of distributed teams all over. They're innovating in every direction at once. So you're getting in every major release, performance stuff, cloud stuff, ease of use, scalability, usability, developer features, all at the same time. And that's just a tremendous opportunity for open source. So when does software die? Well, proprietary software dies when the owner of the source code no longer profit from it. Pretty clear, right? Unfortunately, it declines long before death due to profit maximization, that profit maximization stage that I talked about. Open source doesn't die in the same way. It remains active as long as it serves a purpose. It can be resurrected. As I said, in 1996, we absolutely did that. So ideas don't die as long as they're shared. Ideas are shared as long as they're useful. Proof of that, my children in college, I have 3 who finished, 1 and still in college. They're learning the same books I learned when I was in college. They're reading Plato, they're reading all the old classics because those ideas are still shared, because those ideas are still useful. And again, Postgres will live as long as it's still useful. Let me talk a little bit about an open source adoption survey. I think there's a couple big takeaways you can get from this. Again, feel free to look at the slides, but again, they did a survey. What things, once people went to open source, the Black Duck software went back and surveyed those people, and they asked them, what are the advantages of open source? And the amazing thing to me is number 5. In almost every case, people went to open source because of cost advantages. But what they realized once they were using open source is that there were 4 things that were more useful to them than the cost savings. But they didn't see those advantages until they got open source into their enterprises. Specifically, competitive advantages, innovation. Again, great, open source really focuses on innovation. It's not focused on profit maximization, obviously. So innovation is kind of it. Freedom from vendor lock-in. There's no value to locking people into open source. There is a value to locking people into proprietary. I think we had, Peter Zaitsev talked about that this morning. Quality of solutions, reliability, of course, and the ability to customize and fix were all more important than even the cost. And then there were 6, 7, 8, 4 other advantages that they found. So again, it's sort of like you go to the restaurant because of the coupon, but you end up returning to the restaurant later because the food was great. It's the same kind of thing. What drove people to open source is not necessarily the major advantage they end up getting from it. And this is one of the reasons that people keep going and going and going to open source. It seems like it is an unending trajectory of the software industry. Again, just a quote about how great it is. Databases in 2016 at least had become much more popular as a reason to use open source than previous. Again, database seems to be a little lagging in terms of adoption for open source in enterprises, but this year and certainly the past recent years, we've seen an incredible amount of adoption. This slide I love to talk about, but I'm kind of limited in time. Effectively, when you might want to study it later, when you're talking to somebody about adopting open source, there are typically 3 teams you have to address: the management team, the administrative team, and the development team. And each team sees a different advantage to open source. So the managers may see cost or vendor lock-in as an advantage. The administrators see quality and interoperability. Developers see innovation and speed of development. And when you're talking to somebody, you should probably use the language that team is interested in when you're talking about open source. Talking about cost to developers typically doesn't have as much impact as talking about how quickly they can innovate using your solution. Let me talk specifically about Postgres. Picture Joe Selko here, if anybody knows him, the big SQL guy with our Slonik mascot there. So Joe Selko, really, again, one of the founders or sort of the great teacher of SQL, but SQL goes way back before Joe. E.F. Codd in the 70s sort of designed relational theory. Michael Stonebreaker in 1986 started the Postgres development project at Berkeley. He is an advisor to Enterprise DB, where I'm an employee. And one of the innovations that Michael Stonebreaker had was the idea of extendability, the idea that a database didn't have to have fixed data types and fixed programming languages and fixed indexing methods. So it's an extendable system, and Postgres has built on that innovation in an amazing way in the 24 years that I've been with the project. For example, if you need a new data type that deals with ISBN numbers or UPC numbers, you can literally type what I put in red here, and you automatically get a new, 8 new data types that understand book numbers, magazine numbers, music numbers, and UPC codes. If you need a server-side language, you can load in any of these languages. Postgres comes by default with only a few of them, but you can get more of them. So again, if you want a server-side language that matches your application language, you can do that. If you need to do NoSQL work, or particularly something like GIS or full text search or geometry or JSON, there are flexible indexing methods that are designed specifically for non-relational workloads. GIN, GIST, SPGIST really are great when you're looking at non-linear data. B-tree is great for linear, right? But when you start to look at 2D points, or you start to look at JSON and full text search, B-tree doesn't work very well. GIN, GIST are excellent for that. Brin, great for data warehouse. Again, another extendability. Full text search, as I said before, is part of Postgres, part of the entire transaction engine, part of the whole indexing engine. It is integrated. It's not like a separate thing that sits on the side. Here's an example of a full text search query. NoSQL, we do support that. Again, integrated into Postgres, mixing non-relational and relational data, relational and non-relational queries in the same application, full transaction semantics, specialized indexing methods, operators, and functions to make that useful. All is part of Postgres. Here's an example of a JSON query. Range types, I can't even get into this, but it effectively takes a start and stop field, merges them into one field, and then allows you to do very sophisticated indexing on that. That's an example of a range query. Geometric types, points, lines, circles, very popular with GIS. There's a geometric query right there. GIS, again, an entire geometric geographical information system, which plugs into the Postgres engine, developed independently. You just type create extension PostGIS, and it loads it into your existing database. Incredibly great example of how extendability fosters innovation. That's an example of GIS query. Foreign data wrappers. Postgres has the ability to access over 100 different types of data. Uses the SQL Med standard. You can read, write data. You can do joins, sorts, aggregates. Here's an example. You can reach out to Oracle databases. You can reach out to MongoDB. You can even read Twitter feeds in Postgres. So again, the ability to interact with other data sources, a great use of extendability and innovation in the Postgres space. Data analytics, we support all of these features. So if you're used to having a separate data analytics engine, you can do all the analytics inside of Postgres, either in your primary database, or you can use streaming replication, create a separate server or multiple separate servers that do data warehousing, do your OLTP on your primary, and do all of your data warehouse on these streaming replicas, not interfering with your primary workload. So again, you can either do it on the same machine or in different machines. Works really well. But again, the same database, the same schema, no need to keep them synchronized, happens automatically. A really great way of sort of mixing OLTP and OLAP in the same system without having to bring in something that needs maintenance to keep it synchronized, old data, schema change, synchronization. None of that is necessary here. Sharding, again, a way of moving Postgres to multiple shards. That's a multi-year effort. We're still working on that. So what is the Postgres community structure? How does this all work? Postgres is a BSD licensed piece of software. That effectively means it's free for use, any use, including proprietary use, and is available effectively forever. As long as there's a copy around, that license is available. The development and the leadership team are diversified, both geographically, culturally, and also multi-company. So I could reel off all the companies that support us around the globe, but suffice it to say there are dozens of them. We are very thankful to the help that they give us, both in terms of funding some of our developers, giving us patches, helping with conferences, promoting Postgres. It's a great environment to be in. So 32 years in, we have 22 years of annual major releases. Again, I said our beta for 13 is this week. Typically 180 features every major release, quarterly minor releases. And if you're curious about what's happening in the Postgres community world, there is a PG Life website there at the bottom. which will show you all the blogs, all the most recent email, the most recent tweets. That part at the bottom is the IRC channel feed, the last 20 or 8 IRC messages, so you can get an idea of what's going on. Very vibrant community, never sleeps. So really excited to do that. Thank you so much. Really a pleasure to be able to talk to you about, will Postgres live forever? Probably for a long, long time, because of the reasons I've talked about, because of the way that the open source life cycle works, and because we are a community that continues to sort of feed innovation and run it through a lens, I would say, that focuses it on providing the best relational solutions for today's workloads, as well as those for enterprises. So thank you so much.
Thanks a lot, Bruce. And I decided to wear the cheesesteak hat in honor of your hometown of Philadelphia. So it's just for you. Just I pulled it out of storage. So thanks a bunch. Next speaker up for us is Kai Arno from MariaDB. And so Kai, welcome and thank you for attending. We appreciate having you here. And go ahead and feel free to take it away.
Thank you, Matt. So I didn't get the memo, but I managed to run in time to get my hat. This is a student's hat that you get at the University of Technology in Finland. We're all proud of this little black thing because the normal students just have that. So I hope I now conform to the specifications of how to present at Percona Live.
It's wonderful. You're great. It's great. Yep.
So I suppose I should share my screen now, just a second. So do you get my slides?
Yes, we can see that.
You can see it. Okay, so great. Hello, Percona Live Online, and good time of day. This is my first virtual keynote, and it's a bit hard to look you in the eyes and even know how many of you there are. I've seen the YouTube chat, and there's a Slack chat and lots of activities going on, but while I'm presenting, I'm not going to look at that. There are others present from the MariaDB Foundation, so you can interact with them there. I'm really excited to see how a virtual conference and virtual keynote will work out. And I consciously started by greeting you with the time agnostic good time of day greeting, because it's now 6:30 in the evening where I sit in Munich, and my colleagues in Central Europe and South Africa. It's 7:30 in the evening for my colleagues in Romania, Bosnia, and my native Finland. And I have to remind myself that the audience in the Eastern US time zone has early afternoon, and those in California just 9:30 in the morning. So thank you, Percona, for putting together Percona Live and taking it online and making then the live stream available for the poor people not being awake at this point in time. I'm thinking of Daniel Black, a frequent contributor to MariaDB in Canberra, Australia. He has 2:30 a.m. right now. Okay, so MariaDB 10.4 and the competition, that's my topic. You could say that's a fairly specific one for a keynote, but the subheader here is the more descriptive one on the process of selecting the right database. So that's what I'm going to be talking about. So how to select the database is really a basic question, but people cut corners when they answer it. In practice, they look into questions like, what do I know? What am I familiar with? What databases have I already invested in time or money or skills? And what do my friends use, or my role model, the cool guys? The client might expect something or use or even require a certain database. And we know from the development or rise of new databases that they usually go hand in hand with the development environment, and the database go hand in hand, like PHP and MySQL went together. So what's the default for your environment? Will the database choice please the boss? And if you're still in doubt and still don't know what database to choose, then what sounded cool at the conference? So this is what you will end up with if you choose the path of least resistance. That's how databases are really chosen. And obviously, the important questions are left out here. I'll get back to them. So that was how to choose a database in practice. Now, you also sometimes pretend to choose a database. So formalities sometimes put a bit of hurdles for that path of least resistance. A new project might require some kind of a formal decision process or an assessment of the right database. But how the world sadly works in practice is that you've already made up your mind, and then based on the practical questions that I listed above, and now you need to find the answer to the riddle. How can you persuade your co-decision makers that your defined answer is the right one? So where do you find the best supportive arguments for your case? And how can you dress up your suggestion in numbers, usually TCO figures? But that's not what I'm going to talk about here. I'm looking at triggers for when you really make a fresh choice of a database. So sometimes you do need to make a real choice. And I see several types of triggers for making such a choice. It can come from the application lifecycle, from the database lifecycle, and it can come from for money reasons. So the application lifecycle is fairly obvious. It's the phase of development or prototyping or minimum viable product. At the beginning of each of those, you have to either go with the flow or then make a conscious decision. And the general framework I will present towards the core of my keynote, that's where I'm going to take a look at those answers. But now, before that, I'm going to look at the other impulses, the monetary and database lifecycle impulses. So monetary impulses, it used to be something that never happened, say 10 years ago. It was the established wisdom when I was working with MySQL 10 to almost 20 years ago. But now there is something, a new concept happening, a midlife crisis of applications, where you have a smoothly running working system with no technical pain and no maintenance needed. And yet we see migrations happening in this situation. And that's a trend change. Such choices are triggered then by money, by cost reasons. Customers paying too much for the current licenses. Of course, that's not the case if you are with Postgres or MySQL or with any other open source database, but not so if you're with, say, Oracle. I'm talking Oracle, not Oracle MySQL, meaning Oracle Database 19c or some other version. So MariaDB Server has got quite a bit of traction from large users migrating their existing applications for cost reasons. So never touch a running system seems to be a wisdom from the past. Yes, if it ain't broke, why fix it? That's true, but it may not be technically broken. Still, it is often financially broken. And then you need to fix the cost, and that in turn has technical implications. So all of that said, I do think that never touch a running system still is true if and only if there are no support or maintenance costs for the product. So then coming to the life cycle, not of the application, but of the database. And we heard Bruce here talk a lot about it, and I'm not talking about individual releases here, not about the eternity of Postgres. So the most frequent need for a rational decision to choose a new database, that's triggered by this life cycle of a database major release that you're currently using. New releases come and old releases go. And Lefred here spoke about MySQL 8, and there may be users of MySQL 5.7 among you who now think about what to do now. Now, if you follow the path of least resistance, and why wouldn't you? you postpone any upgrade. And that is often wise for old working systems that don't incur any cost. But then the vendor proclaims end of life, after which you won't get any security fixes. And there are differences in these life cycles, and that's a criterion for selecting which database you want to have. So let's take a look at this. At MariaDB, on this slide, you see we just end of life MariaDB 5.5. And that's due to the maintenance policy of the MariaDB Foundation, which states that we are committed to maintaining each release for not an eternity, but for 5 years. So MariaDB 5.5 was announced for GA on 11th of April 2012. So EOL was originally 2017. And at that point, we extended it by 3 years because it was widely used, still 5.5 in Linux. In Linux distributions. And it still is the biggest one on, so 5.5 is still the biggest, most widely used release on WordPress. MySQL 5.5 had their last build in 2018. We've continued a while after that to apply security patches on a quarterly basis. So if you're willing then to take the risk of running your database without any security fixes, of course, there's nobody who will stop you from doing that. And you can even apply the security fixes yourself if you really don't want to touch anything in the application. So in the blog that I showed here, a blog on the end of life of 5.5, we noted that scientists are contemplating how to resurrect the mammoth from old DNA. Well, in the blog entry, we also point to this very GitHub page with the complete DNA of MariaDB 5.5. So we try to make it easy for everyone to have a choice, even under fairly extreme circumstances. So the message I'm trying here to gently convey between the lines is that laziness in upgrades of open source database may be a virtue. At least it should be your choice when to upgrade. And if your choice is not to touch a working system, getting security fixes for a long time is clearly a good thing. And the track record of MariaDB server here is one where we just end of life the product 8 years, not an eternity still, but 8 years after we announced it as GA. So now I'm coming to this core framework for how I think a smart database choice can and should be made. So I'm not going to give you an exact recommendation like upgrade to MariaDB 10.4 right away, regardless of whether you are on MySQL 5.7 or MySQL 8.0, on Aurora or Postgres or MongoDB or Oracle. And that's of course not credible, nor does it help you in any way. And I'm also not going to list a lot of features. Others have gone to more features here than I will do. I will not prove why MariaDB 10.4 is the best database since EF Code and CJ Date developed relational theory, or since Mark Zuckerberg launched Facebook on an early version of MySQL. If you're interested to learn more about MariaDB features during Percona Live Online, listen to Colin Charles's presentation. I believe that will be of interest to you. So what I am going to talk about is the questions that you may do well in asking yourself and your colleagues when you make a decision on databases. These questions are agnostic to your role. You might be a DBA, a developer, a sysadmin, or just a mere decision maker. And I'm like here on this picture, separating the questions in the framework to 3 areas: technology, business, and ethics. So technology would be about features, performance, stability, ease of use, scalability, high availability. Business would be about cost, direct cost or indirect cost, availability of talent, product life cycle, being future-proof, and reducing vendor lock-in. Ethics would then be about open source, business models, development models, openness, contributing to a better world, and community and governance. I'm not putting any particular weight to technical versus business versus ethical issues. That's again your choice. I'm just giving the framework to help you make a decision according to your own will and your specific situation. So technology first. Should you run your database in the cloud or on premise? Well, do whatever fits your time budget and your cost budget. Setting up services in the cloud may give you quick time to market, and we heard here from Matt Asay about how cool the cloud is. However, beware vendor lock-in in the cloud. So cloud is the new functionality trap. In the pre-cloud world, databases came with nice-to-have functionality, and they gave benefits, short-term development benefits. You could save a bit of coding here and there, but then you tie the knot with the database. And then disentangling your application from, say, Oracle is so painful that you would rather not go through that experience. Then later on, you regret yourself. So had the original developers had more discipline in not using proprietary extensions, the application may have cost 10% more to develop initially, but over the lifetime have saved that development cost many times over on license cost. Now there is a similarity. The same logic may apply to the cloud. It may be unwise to tie the knot so tightly with a cloud vendor that you cannot move to another one to run your database and app on-prem or in another cloud. So then moving to the question, should you pick a relational database or a NoSQL database? And here, the slide I have for this is a YouTube video made by MariaDB Foundation, Vincenzo Ciorbaru, where he introduces the JSON support in MariaDB just as a symbol for this topic. So my answer on whether to use a NoSQL database or not is, well, first of all, in memory, in your application, do use well-structured data objects in your development environment, and don't try to mimic database relations in your in-memory data structures. But the opposite, the reverse, also applies. Don't let your usage of JSON to structure data for your application distract you from the right choice of model for data persistence. Okay, I am partial, but I do argue that relations are easiest for storage of most well-structured data. Now, not all data is well-structured. A text document is data, but not well-structured. The borderline between a text document and a classic relational table, that might be clear, but there are entities somewhere in between, midway. A complex structured JSON object lies somewhere in between the two, and if it is both too big and too complex at the same time, I argue that it's wise to make it smaller and less complex. And then you can quite well store the smaller and less complex JSON object in a relational database. So let me put this into a bit of a perspective. I'm old enough to remember the world before relational. It was called hierarchical or network databases. The complex data structure were stored directly on disk, and the language used to manipulate that data was complex too. It really was a mess. Relations, by contrast, are simple. They rely on simple mathematics, and the language used to manipulate the data, it's just insert, update, delete. In the hierarchical days, we used to spend a lot of time cleaning up dirty data. Dirty meaning data full of exceptions and inconsistencies, which were not just allowed by these pre-relational data structures, but they were perpetuated by them. They were hard to discover and hard to fix. And now NoSQL is quite a lot the same thing. Non-relational used to be a curse word for a reason. So my suggestion, keep order. The earlier you fix a program bug, the less costly it is. And the same for inconsistent data. Discipline does help. So clean your data in memory and store the cleaned up data in a relational table. That seems to be a logical conclusion also for millennial developers. So next topic, and you'll see soon why I chose this slide. Should you pick an open source database or a closed source one? Now, in this conference, I might be preaching to the choir. I see few reasons to go for a closed source database. Of course, closed source proprietary databases still exist today, but mostly I see them as a relic from past times. The question is more, should you still allow a closed source database in production environments? And that then becomes a question of capacity to migrate and sensitivity to cost. The case in point here is the slide, DBS Bank, Development Bank of Singapore. It's one of Asia's largest banks and most profitable ones, and one of the most high-tech banks in the world. And out of over 300 Oracle applications, they migrated nearly all of Oracle because of the Oracle compatibility layer in MariaDB, which they sponsor. So instead of converting their applications of Oracle, they contributed to converting MariaDB into something that could run their Oracle apps. So if you then pick relational open source database, it says, how should you choose between MariaDB, MySQL, and Postgres? This is a sensitive topic. You all expect me to recommend MariaDB and to reverse engineer the best possible logic that speaks for MariaDB. I will disappoint you and give very little in that direction. I will not enter the battlefield of global transaction IDs for replications and which one came first and which one is better. I may have an opinion on it, but it's slightly not better than yours, and at least it's not based on using a lot of it. In the question of Postgres versus MySQL or MariaDB, I would point to the origins of the products. So Postgres is originally an academic project that turned into a product with lots of functionality. When I picked my first open source database at the end of last century, it was Postgres. It was more known and won MySQL on a feature-by-feature basis. So MySQL, by contrast, had pragmatic starting points. Performance, stability, ease of use were the kingpins, and it didn't even have full transactional support until Berkeley DB came along, which then was substituted by InnoDB. And in those early days, it won hearts over Postgres based on performance and stability and ease of use, and lost some battles based on functionality. Now, since then, the products have grown closer to each other. MySQL and now MariaDB got more functionality, and Postgres got more ease of use, performance, and stability. But you can still see the traces of history. Then in the question of MariaDB versus MySQL, they forked already quite a long time ago. So compatibility remained strong up until MySQL 5.7, but since MySQL 8 no longer is backwards compatible with itself or with MySQL 5.7, it isn't compatible with MariaDB either. So we could claim MariaDB 10.4 is more compatible with MySQL 5.7 than MySQL 8 is. So the actual questions that help here I see as the following. So what database can solve my current requirements? What is likely to satisfy my future needs? How is it to use, to upgrade? Will it scale? Is it included in the Linux distros? Does it support all many platforms? Where can I get help? And how easy is it to move between systems to the cloud or back from the cloud? My point here is I'll limit it to two items that I will highlight. It's distros and release models. So presence in the distros I see as a quality characteristic that implies answers to the earlier questions here on the slide. Even though you might not be evaluating them right now, they might come in handy later, such as multi-platform or security issues. The other key items I will stress is the release model. So it also comes from this easy upgrades scenario. I believe in the industry standard practice of a clear separation between feature releases and bug fix releases. So once a product is GA, new bugs should be a rare thing. And it won't be a rare thing if new features are introduced. So that's a reason why personally I would be reluctant to choose MySQL 8 for production use right now. Then next, business questions. So the choice of a database is not just technical, it's one about cost. And cost is more than licenses. Does the database have a base of skilled developers, DBAs and sysadmins? Is there traction for the database? Is it growing? Is it available everywhere on all the distros? What's the security policy of the vendor? What entity controls the roadmap of the database? And what's the plan of that owner and the track record? How long are the releases supported? Here again, I highlight the audit work done by Debian and other key Linux distributions, because no matter whom you ask of the vendors themselves, they will of course tout their own horn and portray themselves in the best light. So here, between the lines, I'm sure you see that I'm hinting to MariaDB already years ago, becoming a default for Debian and most other Linux distributions. This does not make us angels and everybody else the devil, but it is one non-biased way of picking between MySQL and MariaDB. So ethical questions, the third and last category after technology and business. It's a big word, ethics. It touches upon things brought up by others here. I suppose one could put it under business, but I chose to single out questions around mentality and culture under this header. Using such a big word may seem arrogant. That is not the intention. It's not a question of who are the better human beings. It's just a grouping of questions that come from the culture in which the database originated and from product ownership in a financial sense. So a good general question here, I think, is cui bono, the Latin for whom does it benefit, in whose interest is it? And one example of this are the incidents on Planet MySQL and Planet MariaDB recently, where Planet MySQL excluded blog entries just mentioning MariaDB as a character string, which upset Shlomi Noach and Jean-François Garnier and others. So we decided to do the opposite. Instead of blacklisting MySQL, we whitelisted. So we whitelisted obviously MariaDB and also MySQL and Percona and Galera, and the blog mentioning any of these magic words will pass the mechanical censors of the Planet MariaDB blog aggregator. Also, the Percona community blog is now aggregated on Planet MariaDB, which I then, of course, encourage you to follow. Now, we did not do this because we are saints. It's just our interpretation of what is right for the community from a MariaDB Foundation perspective. Oracle had another interpretation for Planet MySQL from their perspective. So don't let that overshadow my overall, I don't let that overshadow my overall picture of Oracle. And now I encourage you to listen carefully because I will now give some kudos. Hats off to Oracle for taking care of MySQL much better than I had thought they would. MySQL still exists, it's still being sold and marketed, it's still being developed 10 years after Oracle acquired Sun Microsystems. And hats off also to Percona. Percona helps MySQL keep MySQL alive, so kudos to Peter for making MySQL more usable. The question in the ethical section are about the attitude to open source. So the business model, who controls the roadmap, are there meetings where the community can air their wishes for the roadmap? What's the attitude towards code contributions? Do you accept them or do you encourage them? What is the governance model? And is the development done in the open where everything is dumped when it's ready, one time drop, or can the steps be followed in an open Jira ticket tracker? Is the release model aligned with the community expectations? Here, I believe that MariaDB fares fairly well in the comparison. So, as for governance, in the case of MariaDB, we have dual entities. I represent MariaDB Foundation, and there's also MariaDB Corporation, which is a commercial entity with 250 employees. It's venture capital owned, and from a technical standpoint, it employs most MariaDB developers. The foundation has 10 employees, and we are independent from the corporation. The corporation is one out of many members, with the others also contributing to the MariaDB server. Others on the top tiers of Platinum and Gold are Microsoft, IBM, Alibaba, Tencent, ServiceNow, as providers of IT infrastructure, and Booking.com, Visma, and DBS Bank as top-level users. And governance hence is such that there are some checks and balances. In the case of MariaDB, the interest of the user base are being looked after because we are mandated to do so. They are not at the sole mercy of one vendor. So another point here is in the comparison is backwards compatibility with data formats not changing from release to release. We're still big on making migration easy in all possible directions, including away from MariaDB. That was the trigger that in '99 got me to try out MySQL when Monty said it's super easy to get out of if you don't like it. I verified his statement and noted it was true. So I stayed for 10 years because of the path of least resistance. So I'll make a short jump into something else here. I encourage everybody, this is not databases, this is health, and this is a challenge to every database, be it a sea lion or a dolphin or an elephant. I think we can do something to promote health in these times and jointly enjoy life. This is an initiative started by a couple of colleagues from MySQL and myself. So we're going to run on the 20th of June, 2020 with social distancing wherever we are. I encourage you to take a look at this website, solstice-run.com. It's a fairly geeky thing, and we have a couple of blogs on exactly what this is about. So let's do some running. So MariaDB Telnet for and the competition was the topic. Then the process of selecting the right database, it is a complex one. How it's done in practice is different from how it's pretended to be done. My goal and the goal of MariaDB Foundation is to make your path of least resistance point towards MariaDB server. And we have some work to do to get there. And we need your help to point out to us what the most important steps that we are missing are. So I hope to have guided your thinking in how to make the right choice for your particular situation. I thank you. And this was my first virtual keynote, and I enjoyed the experience. Let's meet on Slack and other places. Thanks.
Thank you very much, Kai. That was wonderful. Appreciate you attending. So I am back to the original hat, and I am going to pass my hosting duties off to Emily Lockhart, who is here to host for the next few sessions. And I will see you all on Slack. Emily, feel free to take it away.
All right, can you hear me? Having some issues with Zoom. We're having a tropical storm here. Thanks so much, Matt. You're a tough act to follow hosting, but I'm going to do my best here. Thank you all so much for having me. I'm Emily Lockhart. I'm the manager of customer success here at Percona, and I am based in North Carolina. I'm going to be your host for the next 2 hours or so, and I'm really excited to be here with you all. I'll be checking out questions in the Percona Live online Slack channel and YouTube, so please be sure to join me there. And if we don't have time at the end of the presentation for questions, the speaker will try to answer the questions in the Slack channel. So without further ado, I'm thrilled to introduce our next speaker, Jim Tommaney from Alibaba. Jim was previously CTO and chief architect for InfinityDB, which is now part of MariaDB. He has 25 years experience delivering data solutions at scale, and he's currently working on next generation analytics architecture at Alibaba Cloud. Jim, it's a pleasure to meet you. Please take it away.
Thank you for the introduction. This is Jim Tommaney, joining you here. I'm happy and very excited to be part of the conference here. So again, my background is longtime data geek, experience delivering solutions with existing. Let me get my screen share going. Okay. So longtime data geek, basically responsible for delivering solutions with mobile analytics, health, genomics, telco, previously architect of the InfinityDB storage engine, now part of MariaDB Column Store. My team is hiring. We're looking for C++ engineers with parallel columnar vector optimizer or optimizer experience. Contact me there, and locations. Limits of the evaluation. This is just a best faith effort exploration of what's going on with the hash join functionality across the distributions. It's definitely expected that different parameter settings could have different timings. And this is like one size, one data model, one data size, and changes to those things will change timings as well. And as always, test before moving to production. Some background on the setup. Basically, the versions I use: 8.0.20, MariaDB 10.4.6, cloud environment with 64 gig memory, 8 cores. Data set involved was DBT3 at scale factor 10, which yields 1.5 million, 15 million, and 60 million rows in the customer orders and line item tables. Some parameter settings. I set the buffer pool size high, the join buffer size at 500 megabytes. Basically, all the operations would run, from memory, and so all the timings we'll see will not involve reading from storage. Additional parameter settings used on the MariaDB environment. Quick note about the adaptive hash index. For this test, I turned it off. I was getting unusual timings. I would run a query, and then I would run an identical copy of the query on another table, and I would get a different timing. I've got some notes at the back. We won't cover this, but basically the query could be either 15 seconds or 56 seconds, and it's hard to profile behaviors with that. So I've got that turned off for these test cases. Quick background on sort of just general expectations for hash join behavior. The index classic use cases, you can use an index access to identify rows in one table, join by a nested loop to another table, and join to a larger table as well. And the best behavior from a memory standpoint for that is when the large table fits cleanly in memory, and you don't have to read from storage to access that table. Because it's a nested loop access, it has the chance of random I/O happening. And then there's also another characteristic possible, that is block revisits. So you could have a couple rows within a block of data, and an index points to that, and it reads that from storage, and then later a different index lookup reads the adjacent row from storage, and those might not be at the same point in time. And so that's a place where block revisits can be a significant factor. So it works great when large table fits in memory. The classic hash join use cases is the idea that the small side fits in memory. And the extensions for that are around the Grace and hybrid hash join implementations that allow for the small side to be chunked up such that one piece fits in memory at one point in time. And so that's the classic use case for there. It works great as long as you can make that fit, but there's software allowing for larger small sides to progressively fit in memory with good performance. This is kind of the simplest possible world. It's just a simple self join of order key, order key. It's a 50 million row table joining 50 million rows. This is a little bit artificial, and we're going to get into much more detail in the rest of the analysis, but just a quick setup for what I'm doing. Some timings on nested loop behavior, some timings on hash join behaviors. And we'll start to see the syntax used to drive the hash join behavior, which is to ignore the index. And in this case, I ignored both basically the primary index as well as any potential additional index that might be used for lookup. And then just for fun, I did the same thing with a skinny table as well. These queries, I happen to reset the adaptive hash index between each query, just for additional timings, but the rest of the performance results come with AHI turned off. So quick note on this is that the join buffer size has a high impact on the performance characteristics, and especially for the MariaDB implementation. And so the blue and orange lines are the MySQL implementation that has the the ability to take the small side and, parse some of that off to disk and deal with that in a flexible manner. And so that has a very flat curve down here in terms of a wide variety of join buffer sizes have similar characteristics. The MariaDB implementation is highly dependent on the behaviors there, on the size of that. So we will come back to this as we get towards the end, but just a little quick setup. So these queries, and we'll take a look at the plans for these. And so this is just representation of the MariaDB in yellow, MySQL in blue, the syntax you see as you plan for these. So this is kind of more starting to get into real world situations. And these are what we'll spend time on today. It's basically, there's the idea of customer joining orders. So it's a smallest table to the medium table in our data set. There'll be across the top here, we'll look at an index join operation, which is no hints applied, allow the optimizer to select the path. The hash join scan, and what I do there is basically I disable all possible indexes on the table. And the reason for that is that under some circumstances, a scan feeded into a hash join can have a different performance profile than the output from an index operation feeding into a hash join. And so I've got that separated as a separate entry. And then the third one is a place where we, just a moment, where we basically just force the hash join behaviors. And on the left side, there's different use cases we'll look at. So it's basically customer joining orders. We'll have a query that filters on both tables. In this case, there'll be equal filters on both sides. So we might select, for example, 80% of the data or 20% of the data for the two filters. Then filter on the smaller side, and then filter on the larger side. And so these are different examples that we would look at under different conditions. And so we'll explore that. And just a quick note about this is that the expectations for hash joins is that it should be faster than indexes for some circumstances. I don't like the an evaluation of a hash join versus an unindexed join. That doesn't seem like something someone would want to do. And it's sort of like saying, well, it's better than nothing. And I think it's far better than that. And so that's kind of where I'm going here. Next slide here is, yeah. So the next one is orders joining line item. The structure is the same. It's just two tables that are larger in scale. Just some detail on the syntax that I use to execute this. Customer join orders, cus key equals O key, cus key. A hash join scan, where I basically force the scan by disabling all indexes. And hash join open, where I only disable or ignore the indexes involved in the join, the minimum required to force the hash join behavior. And so this is what we'll look at first is the query 1.1, 1.2, which is the filter on both sides. And we'll look at customers orders and then orders line item. Now to start to get into some of the data set here. So MariaDB on the left-hand side, MySQL on the right-hand side, customer joining orders, again, indexes on both tables. There's the idea of selectivity as a dimension down here at the bottom. So 5% of the data, 95% of the data. And in this case, the index is the clear winner in terms of performance across data conditions, across selectivity. The hash join doesn't have any places where for this query and for this scale data where the hash join is faster. There is one use case here where the gray line for MySQL is the index feeding into the hash join versus the scan feeding into the hash join, and that's slightly faster under certain selectivity. So this is the same join conditions but larger scale. And so now instead of 1.5 to 15 million, we're going to 50 million joining to 60 million. So the query's in place here. And here on the left-hand side, the MariaDB, we see something that looks very close to an ideal performance characteristics in that we would expect at low cardinality, where the selectivity restricts the results to few rows, that we have great performance for the index, and that hash joins should tend to dominate at some position. And so that shows up very clearly on the left-hand side. On the MySQL side, I see some slightly different behavior. There's sort of a similar crossover point here, as well as it's in a slightly different position. But the performance differential is actually a little smaller. And what shows up for me is that there's a step cost at certain scale of the small side. And so if the performance curve was a little flatter around here, the performance characteristics may overlap. And this is just the plans available in support of these two queries, just to see the syntax used to demonstrate the hash join. So the next one is to apply a filter only on the small side. The same three hint conditions. And this is a use case where we'd actually expect, under many circumstances, for the index operation to be more successful. And we do see that. So there's no place here where the hash join is competitive under this situation. I'll talk a little bit more towards some recommendations at the end, but currently we say we disable access to the index, we ignore index. And for this specific query, the larger table, we only need access to the OCUS key column. And if we could do a hash join to a covering index that was run with a full index scan, that would potentially be faster. But because of the way the hint is structured, we can't have both our cake and eat it too. This is the same query scenario. So there's a filter on the smaller side, joined to the larger table. And we see there's definitely a sweet spot for hash join for both engines where it has a performance characteristic. The MariaDB is here. And there's the idea that index is superior here and hash join is superior here. There's a similar trade-off here where it clearly becomes better, but I suspect there's the same step cost is showing up. And that's likely something about how the hash tables are populated or built in support of the hash join operations here. And to be fair, this is actually measuring different functionality. So the MySQL implementation has the gray/hybrid hash join that allows for saging to storage, and it could be that that's part of what's going on here. I didn't have the time to kind of profile the underlying implementation to identify what specifically was supporting that, but that's the behavior we see here. This is the third query, which is a filter on the large side only, and so it's coming in from the other side. Okay, so there's many things we're going to look at here. So certainly if you look at just the blue lines, these are the index access paths here. And there's definitely an inflection point for both engines. So there's an inflection point here and an inflection point here where something happens differently. And what happens is that the join order between the tables flips. It's indexed in all dimensions, but here, when you think about it, if we've got an O order key and we're looking for 10% of the data, then that's now, orders is 15 million, 10% of the data is 1.5 million. And now it's a coin toss on what is more effective. And because the index is on that key, that's likely to be a successful path. And so here the optimizer automatically flips the plan, flips the join order to allow for great performance under both use cases, under low cardinality and high cardinality use cases. Here, because it's sort of, there's an opportunity to drive from the using that filter. The fastest path is actually not a hash scan plus, not a scan plus a hash join, but instead to, but instead to allow access here. So that's in place here. Okay. The ideal world might be something that looks like a progressive optimizer behavior where it actually doesn't show. I didn't measure a specific use case down here. So all the way down here at 0.01 or 0.001, highly selective access to the data, the index is actually going to be faster than the hash join plus the scan plus the hash join, or index lookup plus the hash join. Sorry about that. So way down here, the index is going to dominate. In the middle, the hash join operation dominates, and then at larger scale, the index operation dominates. And so that's an opportunity for potentially progressive optimizer behavior in place. And this is the same data scenario. So there's a filter on the large side. So orders joining line item, filter on the larger side only. And so this is a place where the hash join is clearly faster across a wide variety of circumstances than the index operation. Just a minor observation, the performance curve for MariaDB looks flatter at different scale as the selectivity goes up. And we don't see in the MySQL sort of that step cost because the small side build is static in this situation. So the orders table is a fixed size, and so that's set up that way. And some quick comparison on these metrics versus the smaller join, the customer joining orders versus the larger join. The nested loop cost went up by the elapsed time for nested loop went up by a factor of 10, and the number of rows being read and used to do an index probe went up by a factor of 10. And so there's a very clear linear cost associated with the index operation. The hash join at the lowest scale, at low selectivity, is about 5x faster. I'm sorry, 5x slower with the larger data set, and about 3x slower further to the right. And so that's kind of a data point suggesting that at larger data sets, the hash join is going to tend to dominate, and this just kind of reinforces some expectations up front. I did look at something that looks like a more robust query. So those were very simple in terms of the select count. The hash join has smaller responsibility for pushing records through the hash join operation. The amount of work done and the code complexity is smaller for a count star operation. And so in this case, I had a index operation where there's no hints in place, and then basically the query itself had the filters applied, had no index applied. And so it's going to be scan operations anyway. So we're really talking about just two use cases, an index operation and a hash join operation. And we see index at the very low selectivity being at 10% of the data being superior. It works better as expected. We do see a crossover point for MariaDB. We don't see the same kind of crossover point at MySQL. And my expectation is that this is sort of an expensive query, and there's many other costs that are introduced that may hide any differences in the performance of the hash join. And so something I would have expected some performance uplift, and we see a little bit in Maria, and not yet in the MySQL implementation. Okay, so we talked earlier about the join buffer size and the impact on queries, and we're going to use this query to do some more profiling. And what I mean there is that we'll run this query under two conditions at the 20% mark right here and at the 80% mark right here. So I'll have that run that same way, and then we'll profile the performance characteristics when that happens. And so this is the query itself here. And here's the 20% query, and here's the 80% query, and the performance characteristics. And it's definitely that configuration is a sweet spot to allow for good performance with MariaDB. And it's actually, if you increase beyond that number for that query, it doesn't tend to get much different. But the join buffer size work allows for the best performance when it's large enough to support that operation, and the MariaDB will still be functional if this join buffer size is smaller. The performance will just decrease. Let's see. Yeah, so you may need to hand tune the join buffer size for large queries. The MySQL is relatively flat performance curve across the middle here. The fastest was about 8 megabyte on the size, but realistically anything above 2 megabytes had a pretty good performance characteristic. Same query, I just looked at, measured the memory utilization under concurrent workloads, 1x, 2x, 4x, 8x concurrent queries, running this 20% query, and we see the memory utilization in place here. And so there's a linear cost, more memory used for more concurrent queries. It's slightly more efficient with MariaDB. And the quick note about that is I actually set for this specific use case, I set the join buffer size up to, I think, 2 gigabytes. So it's artificially high beyond what's required for efficient usage for these queries. And the memory utilization was not a function of the parameter. It was a function of the query itself. And so it didn't use the memory that was potentially available, only used the memory that was needed in support of this query. And so the case is that if I look back at the customer orders line item table, the one where I didn't get what I expected, it's possible that I could find a join buffer size configuration that allows for better performance, but within the scope of what we're doing, that wasn't available. Sort of tuning recommendations for developers, DBAs. Try hash join out when the filter exists only on the large size. That's a clear use case. Try hash join out where the number of index calls from the smaller driving table starts to grow, right? So 10K, I'm sorry, 100K, a million or more. The actual value depends on, quite frankly, many things. Characteristics about number of distinct values in the index, characteristics about table size, the ratio of the table size. So there's many characteristics. So it's not quite that simple. And then, if there's no index, no join index available, that's fine too. When we talk about hash join and data scale, there's definitely some correlation that larger data is far more likely to benefit from a hash join operation than a smaller data set. We talked about small joining large. As the data scale went up, we saw more conditions where the hash join was able to show performance at least under somewhere in the scale. And then again, back to the hash join size, it doesn't automatically allocate space. It allows for space up to that point. And so if your queries are well behaved and have a measured amount of hash join utilization, memory utilization, it's not a problem to set the value larger. But under some circumstances, if your queries are artificially are very expensive and there's a risk there, you want to pay attention to that. And the notes on MySQL use case. This is kind of what I have some recommendations on kind of next steps on the software, and so what further enhancements could happen in this space. So certainly in my opinion, ignoring the index is problematic. First of all, it's a manual effort, and if someone changes an index name, then that changes the int. It hides an optimization from the optimizer. So the full index scan isn't available because you've told the optimizer not to use the index. And then the other part that's a little scary for me is that if you've configured the SQL to ignore the indexes and the hash join is not available because of an outside reason, the memory limit is reached or a parameter setting, then the query can run in a Cartesian join, which could be a very, very bad operation. And so that's, under some use cases that could turn, 20 seconds into 20 hours. Quick note, the optimizer did not appear to select hash join under any of the scenarios tested. Ideally, it would be able to select it when it was appropriate, and ideally, it would be able to select it for a given query based on the cardinality. And and then some possibilities around next steps for engineering around MariaDB and MySQL. Thank you, everyone. I appreciate everyone's time today and the chance to join the conference.
Thank you so much, Jim. That was great. We really appreciate that. That was awesome. I'm so excited to introduce our next presenter, Kathy Gibbs from AWS. Kathy has over 17 years experience as a production DBA with Oracle, MS SQL Server, MySQL, and PostgreSQL. PostgreSQL. You can tell I'm not on the technical side of the house. She has also worked as a product manager and as a solution architect in various business sectors, including telecom, finance, retail, and technology. And she lives in Colorado and currently works for AWS. So thank you so much for joining us, Kathy. I'll turn it over to you.
Yeah, thank you. I appreciate it. Let me go ahead and share my screen. Let me make sure. Can you see that screen, Emily?
Yes, I can.
Okay, great. Always want to make sure before I keep going and go a little bit further. So today we're going to talk about databases on containers. And really this is a 30-minute session, so we're not going to be able to dive too deep. But after this, you will be able to start from the beginning, install Docker to the end and have a container running and have a Postgres database running on that container. Okay. So we already did kind of go through my experience and what I work with. I do have experience with both Postgres and MySQL in the community versions. So we'll go ahead and move on since we've talked through that. For today's agenda, we're going to talk about a little bit about what is a container. So we kind of all start off on the same level set. We're going to create the container, and in this, I'm going to show you how to do this in Docker. We're going to talk a little bit about the network and the network that is already provided, as well as what you can do. We're going to connect to the database, obviously very important. We're going to talk a little bit about backups, and then some cloud options that you do have and that you can use. Then we'll talk about replicas, and then I added this in just to talk a little bit about some of the arguments against, or so why you may not put your database on a container. Okay. So let's go ahead and get started here. So the first thing that we need to know, right, what is a container? And I do have a picture after this slide, so may make more sense when we look at the picture. A container is really that lightweight standalone instance that you have everything with you. So you've got your code, you have your runtime, you have tools, libraries, all of that. But different than, say, a VM is you don't have your own individual OS that you have to monitor and patch and just kind of keep track of, right? The Docker, the container sits on top of that, all right? A lot of people use containers. It's synonymous now with microservices. So instead of having that old monolithic database that you used to use, or like in commercial, you can kind of split and break apart where it makes sense, right? The things that need NoSQL, then you can put that into a NoSQL database instead of trying to put everything into one engine or into one particular instance, all right? The one thing that is probably the most important when you're talking about containers and databases is that you need to have a step to have persistent storage. By default, containers don't. They have ephemeral storage, which of course means that if I bounce or I have a reboot, then my data goes away, okay? There are ways to make this work without doing persistent storage. It's just a lot of work on your point, and it depends on what you need as far as to store your data, on whether you even want to try that. My recommendation is just to use that persistent storage, okay? You do want to make sure and factor in backup and restore. That makes sense, right? We're talking about databases here. So I can do that through, hey, I can have a replica, and maybe that's how I'm doing a backup. But I would also make sure that you have a plan to do that restore, whether it's even in that ephemeral situation that I'm just recreating my container and then populating it with data from a backup, okay? And the other thing that you might want to look at is decide whether you want to do this on premise or in the cloud, right? I might want to start and play all around on my own laptop, or I may have situations where I can put that in on premise. Sorry about that. I'm noticing my curtain is fluctuating there. Or do you put this in the cloud? right? That you can have some of that replication that's already there for you. Okay, so here's that picture that I promised, right? On the left here, this is just a VM, something we're probably very familiar with, where I have my infrastructure and then I have my host that's for my infrastructure, that operating system. Then I have my hypervisor, and then I have my different VMs. Right here, I've got app 1, 2, and 3 that sit on top of the hypervisor. And each one of those VMs has its own OS. So this could be Ubuntu, this could be Windows, and this could be Red Hat, right? So I can have different operating system, but each VM has its own, right? So I have to be responsible for patching that as well. When you get to containers, I have my infrastructure and host operating system, like I did before over there. But then I have Docker, and I don't have the individual OS. Okay, so there's less that is in the way, I guess. It's easier to start, it's faster to start. And so I can have a lot of those individual applications, that microservice that can help my business perform at a faster rate. Okay, so what is the first step that we have? Well, the first thing you have to do is you have to create the container, right? So what you do then, in this particular case, I've got a link where you can go and just download the Docker software. My system is Windows. There's a Windows installer and there's a Unix installer. So very straightforward. There are some steps in between this. It's not just 3 steps, unfortunately, but so the steps are: you download your software, you install your software, right? When you get to the point of creating the database, or getting to where we've got, like in my situation, I'm going to present on Postgres, I can actually use an image that's already out there. And you can see here, there is a way to look at this in a GUI format. You can also do this through just a command line as well. But I can go in and I can create this Postgres image, okay? It'll give me line commands that I can use. So it makes things a little bit easier, especially if there's already an image there. If you're wondering, yes, you can create images too. So you can see I've got a CentOS image for Postgres 7, but there are different times I can go in and create my own images so that I can use that. Say I want to always keep dev going, right? So I can recreate my image after I've created dev and then made it an image, okay? So once I get to that point, you can see here, I can create the database with persistent storage. So 2 ways you can do this. You can actually create the storage outside of this. So I can have volumes that I've created that are persistent. But I think it's easier for me to create it as part of when I create the database. Okay. So the big thing is just the V for volume, and it will create a volume out there for persistent storage. Docker does have different, you can create storage, you can delete storage, however you want to work that, right? So you can see here, the other thing I've done is I've named it a port. I've just given it the default Postgres port, okay? And then I could create my database. When I do that, the next step is I can run Docker PS, Docker, not doctor, okay? And it will show me that it's running. It will give me the name of my instance, give me a little bit more information like the container ID, which is important when you're monitoring your containers and keeping track of your containers. We won't go into that too much today just because we have a short amount of time. Okay, the next step that we had on there is networks. So it's important to note that when you first create your Docker container, you're going to get 3 default networks, all right? So you can have the bridge network. That's actually the network that containers are running by default, right? You can set it up to automatically install rules that it behaves. You can set it up so that it can't communicate, right? There's things that you can do with that. You also automatically get a host network. So that is the host networking directly, right? And then you get a none. Really what the none is there for is it's going to disable all the networking, right? So if I don't want to delete things, I can disable it. Probably the more important to note is that you can create your own. So I can create my own network that I use and say, okay, when I've got these containers, they can only communicate with other containers that are using a particular network or that network, right? So it's, as far as commonality, it's kind of whatever you choose to do. I've definitely seen a lot of the create your own versus using just the bridge that comes with it. But when you're playing around, it's not necessary unless you just want to learn to create your own network. Okay. So I've created my database, right? I've created my network, right? First, I've created my container, then my database, and my network is up and running. So the next thing I need to do is connect to it. When you create that container, it will actually tell you the IP, but if you don't write it down there, this is how you can find out to get your IP, right? It's very common for me. I forget to write things down. So I can go in and say that Dr. Inspect, and it will tell me what my IP is for my container name. There's that ID I was talking about. So when we go back and we look at that PS, it will tell me my Docker, my container ID, right? Then I can come and put that in here. One of the ways that I use that. Okay, so now I find my IP address. I can write that down. Another way I can do this without getting the IP address is I can right here on when I'm looking at my, whether it's through the GUI or I've got host access, I can do this Docker exec IT, the name of my instance, and then in this case, I'm going to use a bash, right? So what that will do is that will give you a host access, a root access, okay? Once I have root access, I just SU to Postgres, and then I can go into PSQL, okay? Almost said the PL SQL, like for Oracle. You can go into PSQL, right? At that point, I'm in PSQL, I'm in my database. I can run whatever commands that I want to. So I can get connection info, I can get the list of my databases, right? I can create a database, I can create users, right? I can maybe change a user password or anything like that. I can do anything I can do in Postgres at this point. All right. So if I change that user or create a new user, let's say it's called monitor, right? Then I can set up a connection to pgadmin because I have my IP address, right? I have my name, I have my user, and I have my password, as well as my port. I know that I set it to the default port. So I can connect to pgadmin and then do everything that I could normally do in a Postgres database in this particular instance. Okay, great. So let's talk through backups next. So again, as a DBA mindset and former DBA, backups are very important, but restore is even more so. And that's why I take a backup, so that in case there's an issue, I can restore. All right. So if you take what would be a Docker backup, all you're doing is a physical. You're going to zip up the data files that you have and move that or copy that somewhere else. Okay. The other thing I can do is I can take a logical backup. Okay. So I can go down to my host. Remember, again, I got out to the root and I asked you to Postgres. Then I can do a PG dump, right? Or I can do a PG dump all, right? What I can do is I can schedule those to run. So I can say that I want the PG dump. In this particular case, I've got just for one table that PG bench accounts, right? And I want to put it in a particular file. Or I can put the PG dump all and run it every 24 hours, whatever time that I want to run that. There are other ways that you can do backup, but I feel like this, especially coming from a community side, these are probably the easiest ways, right? So, and things that you're familiar with that you can do that backup. Okay, restore is going to be the same thing. I don't have a slide on restore, but restore is going to be the same that I would in Postgres in this particular scenario. So if I was putting another database on there, it'd be however I restore the data. It's another reason I like that PG dump, because if I keep that in a secure location, then I can just replay that file as SQL statements if I want to restore or clone. Right. Okay, so now let's take a moment and let's talk about a couple of the cloud options that we have. So we have ECS, EKS, and Fargate. Switch those up a little bit, you'll see. But I am going to start with ECS, which is actually stands for Elastic Container Service. Okay, so you can see kind of a picture over this. This actually includes Fargate as well, which is the next slide. But you can see I've got my container image. One of the things that's really great about this is it makes it, if you're not that familiar with Docker or not that comfortable with that particular service, you can build a very fast, let me step back a second, very quickly, you can build containers within ECS. Okay, so I don't need to have all of that download or anything. I just go into ECS and then I create my first container. Okay, after that container is up and running, I can do different things like assign different task definitions to that. I can say which images that I want to run. And those images can actually come from not only within EKS, right, within AWS. I can also have those images stored someplace else, right? So if I've got images that are stored, I can pull an image from there. I don't have to move everything. It can be in one location. Okay. So you can see some of this screen here if I go in and look a little closer. Here's my task definition. I've got just my VPC, right? You can see here that this is within one region. In AWS, regions is a collection of physical data centers. And in availability zone, that AZ1, is a logical collection of data centers, or really what it is each availability zone is its own data center, okay? And so those different availability zones are on different floodplains, different insurance things that you would think about within single millisecond latency. So it's a good first place if I want to have disaster recovery, right? Because since we put those on different floodplains wherever possible, if something were to come along and knock out a data center, you'd still have another availability zone. Okay, and then within that, I have the different tasks. You can see I've got different ENIs, and then outside of those tasks, I have Fargate. Okay, well, what is Fargate? Well, let's talk about that a little bit. What Fargate does is it is for containers, and it's that kind of serverless idea. Okay, so it's on demand, it right sizes the capacity. Right? So you don't have to provision, you don't have to size, you don't have to add space to it. It's going to configure and scale the group of those containers automatically as needed, okay? So you don't need to choose a particular server type and then have to go back and change that server type, right? You don't have to decide when to scale, that it's going to scale those node groups. Each pod that's running Fargate together has its own isolation boundary, so it's more secure around that as far as if I just set it up default. It doesn't share an underlying kernel, okay? So it's kind of that serverless idea that I don't have to map out everything beforehand. I can just create it in Fargate and it'll grow with me. Okay, the last one that I want to talk here on a cloud service is we have something called Elastic Kubernetes service, all right? Kubernetes, if you're not aware, is an open source system, and it is helps with scaling and manage of the containerized applications. Okay, so a lot of people use Kubernetes to manage those containers. Okay. So you can see here what you would do is you provision that cluster, then you can deploy different worker nodes to do things, right? I can connect my tooling to EKS, and then I can run my applications. Right? So it just makes that easier to run Kubernetes. You also can run Kubernetes outside the cloud. So you can have that on premise as well. Okay, so let's talk a little bit about disaster recovery. All right, so there's a couple different ways that we can use recovery, or that we can set up recovery. Okay. First thing is so when I first create that first container, right, I created my Postgres instance, and I could create that container. I want to create an image off of that so that I have that in a YAML format, right, a particular file format that I can run in Docker. Okay, so I can create that image, and then when I need to have an example of, let's say it's called my accounting Postgres, okay, my accounting instance. So if I need to have a copy of that accounting instance anytime that I want, I can run that file and it will set it up the same way that I have set it up, right? So it's going to look just like that. One of the great things about Docker is you can create that, okay? Then I can take the backup that I took, right? So I did my PG dump or my PG dump all, and I can restore the data into that new container, right? That alone is how I can do, that's kind of my disaster situation. So if I want it in a different location or I want to make a clone, that's a good way to do that, is to have that image and then restore the data into a new container, right? But let's talk about what about replicas and creating replication. So much of the time now in production, whether you're on premise or you're in the cloud, you use replicas in a production environment, okay? So you can create replicas when you're in a container. Right? So I've put in here, this is an example code from a particular website there that shows you step-by-step how to set up a replication when you're using Postgres. Right? So what you're going to use is just that native Postgres replication, but there are third-party tools as well that you can create that replica, even if that replica isn't open, right? So maybe I just have this replica over here and I don't want anybody to hit it until I fail over, until I actually promote that to be my production instance. Okay. One of the things I would talk about, and I talk about this with everything, is to test, right? Test. Definitely in replication as well as failover. You want to, number one, make sure it works. But the second option that you want is you want timings around that, right? I want to know how long it's going to take for me to fail over to a replica if I have that. Same with just creating the image again. Okay? So using that backup that I took because everything went away and restoring that backup. I want to know how long that's going to take. So I know I can tell my customers what my SLA would be, my RTO and my RPO, right? So I want to make sure that I have that timing down so that I can publish it. Okay. The other thing to note here, we just talked about the cloud, the different options and the different services that are available in the AWS cloud. EKS, that's the Elastic Container Service. You can have replication there. So you kind of saw in that previous screen where I had the situation where I had one particular Fargate instance and then I had another one, right? I can create that replication. I can do, this is still going to be more of that native Postgres. So it isn't going to take advantage. There is no like RDS in the containers. This is community Postgres we're talking about. So you would want to use the same replication that we're talking about here. But as far as all of the containers, that's going to be replicated. So you definitely can set that up within EKS. Okay. Another thing you can do to help with that is to create like a service scheduler or use that service scheduler. So there's a couple of different types here. We've got a replica or a daemon, right? So that you can utilize that service scheduler. I'm not going to go too much more into that particular part of things. If you're really interested, I did put the link here that goes directly to that service scheduler if you want to find more information on how that works in ECS. Okay, so let's talk about, we spent all this time here talking about why I should put and how I can put databases in a container. Right? If you notice or you've looked around, there's a very widely opinion, right? So there's either a never do it, it's the most ridiculous idea I've ever heard, or I do it all the time and it works just fine, right? So it's either one or the other. There's not a lot of people in the middle. So we'll talk about some of the reasons you wouldn't. Number one, I feel like this is more for a small database or a microservice, right? So when I have that application, and I wouldn't put the application on the same container necessarily, but if I want to have those close together and I want to break up the microservices, that makes a lot of sense. If I have that database that's going for an ISV, so we talk about that down here, right? I can create individual Docker images and individual databases for each customer that I work with, right? These can be very, very small microservice size, but I need to have them separated, or my company has decided that they need to each be in separate instances. Okay, so then I can put the security around that so that I've got only particular customers that are going there, right? So that can be a reason for that. I certainly don't see anybody that says, hey, I have even a 200 gigabyte database, much less a 20 terabyte, and I want to put it on a container, right? It's not really what containers are for. When you think about overhead, I've got that lightweight container, right? I've got it to be virtualized. I can move it if I need to. It's more difficult to move the database because of the persisted storage. You have to do backup and recover for that for the database side, but that doesn't really equate to a large database, right? So in that particular case, yeah, that doesn't make a whole lot of sense to be on containers with that. But you can, if you've got a lot of these individual microservices, individual containers, it makes a lot of sense to use containers if, again, I can make it work in my environment. I have one particular customer that had in AWS, they would just get the largest size EC2 instance, and then they would put Docker on it. And so they would create their own containers and their own microservices to each individual customer that they had, or each individual area. Okay, so depending on what your company is doing, depending on your environment, it's a great way to go. It's also a really good place to put dev instances to wrap them up really quickly, right? So if I want a real quick dev instance, I just take that image and then it's empty and my developer could do what they want to with it, right? And then I can blow it away. In that particular case, maybe I don't even need persisted storage, Okay. So I would say one of the other things that comes up is that a lot of cloud discussion, sometimes people look at the cloud and manage databases as a way to work with microservices. I think that in that particular case, if you're making kind of the positives and negatives for it, it's good to have a managed database handle that microservice database, because then you can have all of the enterprise level functionality and security and recoverability that's already built in, right? So if we start talking about a little bit bigger, or maybe it is a database that needs PII compliance, so I'm a little bit more concerned about having the different security wrapped around that, then maybe that's a scenario to go to a managed database in the cloud, like RDS for AWS. But there are still scenarios that it do make sense, and I see people in production working every day having their database on the container. Okay, so it kind of depends on what you want to learn and what works best for your environment and your company. Whether I need that security that's wrapped around it, I need that two-factor authentication, I need to make sure that it's there all the time and that all of my instances look the same, like for a managed database. I need to have just the microservice that every time a new customer comes on, that I just create a new container, a new application, a new container database with that, and that I store all of their information in there. I have other security measures, maybe in my corporation, so I'm not as concerned about trying to make all of the security that I would in a managed database. Okay. All right. So what did we discover today? The first thing we talked about is what is that container, right? That easily scalable, easy, very quick to come up, very quick to actually delete at the same time. We talked about how you create a container. Again, we used Docker, that we downloaded that Docker software and then created the instance. Okay. We talked a little bit about networking, the 3 basic networks that come when you create a container, as well as that you could create your own network. Okay. We talked about connecting to the database and ultimately how I connect my tools, right? My PG admin, because I have my IP and I have my database name, I have my user, password, and port. Right? So whether it's PG admin, I could do the same thing for pSQL. I talked about how to create database backups. Some of the basic ways, just using the Postgres tools. Yeah, there are other ways that you can use that and look into that, but certainly PG dump and PG dump all will work for the database. Then we talked a little bit about the cloud options. What is AWS EKS, which is the Kubernetes service? What is AWS ECS and Fargate, right, which is the container service, and then kind of that serverless idea around containers, right? We talked about how you create replicas in Docker. And then we also went into kind of what those arguments on why we wouldn't necessarily put something in Docker. Okay, so I do have the ability to open up for questions if that is something we can do to see if anybody has any questions on the material.
It looks like actually you answered the only question that came through on the chat so far, Kathy, which was your point about whether or not to put databases on containers was a yay or nay. So there was some discussion around that.
Yeah, and I would say, just to add a little bit more into that, is that it's not as simple as a black or white answer. If you're in an enterprise and you don't have any microservices, then it may not make as much sense right now to put them on containers. Maybe for development, it's an easy way to spin up development instances without having to have an entire rigid cloning process for that. But it's more for, it's a really good fit when we're talking about microservices and splitting up that workload.
Great. I think those were the only questions besides just positive feedback for you on the channel. But
Great.
Yeah, please maybe check it out afterwards in case I missed any questions that came through.
Yeah, and if anybody has any questions, we do have that Slack channel. You can definitely ask questions after the presentation, and I'll be monitoring that for a little while to see if there's any questions that come up.
Perfect.
Okay.
Well, thank you so much for joining us today. We really appreciate your time and the presentation.
Okay, wonderful. Thank you.
Awesome. All right, take care. So we are so fortunate to have our next presenters with us. I'm really excited to introduce Antonios Giannopoulos and Jason Terpko from Rackspace. Antonios is a senior NoSQL database administrator at ObjectRocket, supporting thousands of MongoDB installations over the past 6 years. He has 18 years experience in databases and systems engineering. And Jason has over 10 years working on various database technologies, which include relational, columnar, and NoSQL platforms. He's currently focused on MongoDB at ObjectRocket by Rackspace, supporting customers with existing MongoDB implementations or those just entering the NoSQL space. So thank you so much for being with us, Jason and Antonios, and I will turn it over to you.
Thank you so much. Good evening, good afternoon, whatever, we're in multiple time zones right now. So today we're gonna discuss how to migrate from a MongoDB replica set to a sharded cluster. We got inspired by this idea because most of our customers start from a replica set, and at some point of their application lifecycle, they want to move to a sharded cluster. And this is a slide about us. I think Emily already made the introductions. We're both members of Rackspace since 2014. We work for the ObjectRocket team. We offer database as a service, and we have on our portfolio various databases like MongoDB, Elastic, Postgres, etc. We both love Mongo on our own different way. So a little bit of what we're going to discuss today. We're going to give you some definitions of what's a replica set and a sharded cluster to begin, and then we're going to present you the reasons to migrate. If you don't know why you want to migrate, there's no point going through all this process. And then we're going to talk about the actual migration, which is divided in 3 parts. It's the pre-flight, prepare, the actual migration, and the post-flight, which you're actually entering the sharding era. And in the end, we're going to talk a little bit about scaling, because this is pretty much why people are migrating from replica sets to sharded clusters. And hopefully we'll have some time for Q&A. So what is a replica set? A replica set is a group of MongoDB processes that maintain the same data set. Pretty much you're using a replica set for redundancy and high availability. So in case one of your nodes goes down, you have another 2 or 4 or 5, whatever size of your replica set. Those replica sets can scale only vertically when talking about the nodes. And obviously you can add more secondaries at some point if you want to support more reads. But your writes are going to go to the primary. So the only way to grow is vertically. A sharded cluster is a group of those replica sets that are accessible through a MongoS, one or many. The MongoS is offering an abstraction layer on top of all these replica sets, because your driver would get confused to access them all. So you need an abstraction layer that's going to unify all these MongoDB processes and present them to the driver as one entity. So this is the standard way of MongoDB to scale horizontally. So if you want to scale your writes, that's the best way to do it. So why migrate? In this section, we're going to see first, if you make the right choice, right? If you have to first think why I want to migrate from a replica set that probably works fine to a sharded cluster. And then if you take that choice, you have to convince some people on your team. So you're going to find the next slides useful to do so. So 9 out of 10 of our customers are moving from a replica set to a sharded cluster because they need to scale their cluster better. On a replica set, as we said before, we can only scale vertically. And by that, I mean for the writes. The writes are going to the primary. There's only one primary on a replica set. So if you want to support more writes, the only option that you have is to get a bigger box. At some point, those boxes might become too big, too expensive, and most probably you're going to start seeing that the more you increase in that box, the performance you're getting is not on the same scale that it was in the very beginning. For example, if you go from 2 gigs of RAM to 4 gigs of RAM, you might see 10 times better performance. But if you go from 32 gigs of RAM to 64, you might see 1.2x performance. And this is a test I want to share here that we did with a container. We ran the container with 32 gigs of RAM and 64 gigs of RAM, and you see that, okay, it performed a little bit better, but it didn't actually worth it to bump the RAM. Now, on sharded clusters, we divide our data to multiple MongoDB servers, right? Multiple replica sets. So each replica set runs a subset of our workload. So our inserts are get evenly distributed, hopefully, if you pick the right shard key. So adding more and more of these shards is going to increase the throughput of our cluster. So if you're using only operations with a shard key, that's going to be close to linear. If you're not, if you're using like kind of like a mixed workload, both shard key and non-shard key operations, it's not going to go again close to linear. It's going to get more logarithmic, but it's going to be way better the curve than the one we saw before with the replica set. And on the replica sets, all the connections go to the primary when it comes to writes. And imagine that on a big environment, the primary might get thousands of connections. So that causes some issues to the primary. It doesn't only have to manage the actual workload, but it also needs to manage all these connections, the TCP layer. On sharded cluster, we have the MongoS's, that it's the point that your driver actually connects, and they can handle the connections from your driver. So if you have 1,000 connections, you have 10 MongoS, each one will get 100. So you can scale your connections as well. Another very common scenario is if you have distributed clusters among different regions. If you're using a replica set here, you might have one primary in the US and and scatter your secondaries around the globe. So if you have a customer somewhere in Asia, it will go and request a read from the closest secondary. But when he needs to write something, he needs to go to the US. And obviously that write that he will do, it will have to go back to the region that he is in order to read it back. So that gets you some latency. Now, on a sharded cluster, you can have one shard on each region. So your customer now will write and read from the same region. So it's going to be way faster. You're going to get the latency out of that. On this slide, we present the hot-cold partition architecture, which is the same as the geographical distributed clusters. Just instead of geographic areas, just put a hot and cold storage, and you do exactly the same thing. It's a cool way to archive your data. You just change a tag on your data, and they go automatically to the cold storage. So it's the same use case. Workload isolation. If you have a replica set and you have two databases, for example, if you want to isolate them to create two different instances for that workload, you need two replica sets. And this is how your driver is going to work. You need to create a connection on both. If you have a sharded cluster, because the MongoS provides that abstraction layer that we discussed before, you can have them both under the same MongoS or MongoS's, right? So nothing changed on your driver. So you can isolate your databases and your developers won't feel a thing. Also, if you have small servers, that might decrease your costs and the manageability becomes much, much more easier. Imagine if you have 1 terabyte of data and you need to build an index, it might take a couple of hours. If you have distributed those across 50 shards and each shard holds 20 gigs of data, it's going to take a couple of minutes if you have a tool to run all these indexes at the same time. Also, initial sync will be faster. If you do initial sync on 1 terabyte, it's going to be a nightmare. And backup and restore at the same. It's the same. Now, you have decided that you're going to do the migration, right? We convinced you with all of our slides, and now you have to prepare, all right? So the first thing that you need to do is to create the additional infrastructure, and that includes config servers and MongoS's. The config servers are lightweight processes. They don't need much of CPUs or RAM or high-speed storage, I would say start with something low, like 4 gigs of RAM and 2 to 4 virtual CPUs. And they run as a replica set. So on the left, you can see the configuration file that we created for a config server. The most important, I think, is to add the role under the sharding. I have a red arrow there that says sharding cluster role configure server. If you don't do that, MongoDB won't understand that this is a replica set that's meant to be for config servers. And also use file when you getting familiar with a new service, because it's easier to increase the verbosity rather than using the system log, which is better for later on that the service is going to be more mature. And when you kick the config servers, when you do the RS initiate on these 3 services, make sure you include on the definition the config server equals true. And you can see that on the picture on the bottom. MongoDB services, again, lightweight processes. They don't need a lot of RAM or CPU. It's recommended to have at least 2. 3 is better. Try to run them on different hardware. You can run multiple MongoS's on the same hardware, that's fine. But at least have some separate hosts that they're going to keep something like zones for your MongoS's in order to have high availability. Don't put all the MongoS's in one server, even if it can handle those. They don't require disk. They require disk only for logging. They don't keep any data locally. Now, the RAM and CPU depends on the use case. If you have an application that opens and closes connections very rapidly, you might need some CPU. If you have a workload that does a lot of data fetches and has to merge them, you might need a lot of RAM. So this is something that you need to test. There is no magic recipe there. The good news is that you can have as many as you want. So you can scale them. If you see that they cannot handle the workload, you can add more. That's fine. The only thing that you need to give to the configuration, and that's the red arrow on the left, is the config server replica set, the one that you prepared from before. This is because the config servers keep your cluster metadata, and the MongoS needs to know where each piece of data resides. And using that connection string, going to read the metadata and direct your driver accordingly. You have to create a user. It's the same thing as you do on the replica set. I'm not going to stay on that slide for long. And now you have a shell. You have 2 empty databases. Congratulations. And as you can see, the admin database is similar to the one that you have on the replica set, while the config database has kind of like more collections. And Jason is going to talk about those on the next section and their mission. You have to configure networking. The cluster must be able to communicate. So the new servers that you're going to create and configure in the MongoS must communicate with the shards. So you need to have those, you have rules in place to have all these ports open. Post-transition, when you finish your migration, your driver must only have access to the MongoS. So any rules that were created to give access to the driver to the MongoDs should be removed. Authentication authorization. Everything now is going to be handled by the MongoS when it comes to authentication. So you have to copy all of your users from the replica set to the MongoS, right? You can create them from scratch if you have very few, and that's a good way to clean up. You can do a Mongo import and export of the users and role collection from the replica set to towards the MongoS, or you can use the following script that will do the same job. It will just connect and copy the users from the MongoD to the MongoS. You can manipulate those queries and do filtering, like do like per department, or do a prefix on the users, whatever. The connection string. You have to test it, right? You have your MongoS, use your driver to test that those connection strings are actually can connect, your driver can actually connect to those. The reason here is you're using multiple parameters on your replica set. All of them, I think they're compatible, but things changing between versions. So make sure that this connection string with the same parameters is compatible. Now there's a big difference between the connection string on a replica set that you only have to give one node and the driver will find the topology. Here you have to give all the MongoS's that you want the driver to access. So if you have 100 MongoS's, that might be a long connection string. And you have to do some changes on your replica set. You have to go to each node configuration and add that sharding cluster role equals to shard server. And then you have to do a rolling restart. Stop a secondary, start the secondary, then the other secondary, then all the secondaries, and then step down in the X primary. If you don't do that, when you run the add shard command, which actually initiates the cluster, you'll get the following exception. So you have to do it afterwards. Don't leave unfinished items. This is a good advice for every type of transition that you're doing. So if you had leftover items from previous upgrades or something, finish that, right? So alt schema upgrades, if you're before 4.0, we see that very frequently, or set feature compatibility version, take them to the end. Prepare your middleware. So you have to monitor that tier. You have to start taking backups. On the config servers, you have to get prepared to get the data directory and the config file. For the MongoDB, only the config file is fine. So just make sure you have that on your repo, your deployment scripts. But prepare your middleware to be able to connect. And finally, inspect your codes. If you're in 4.0 and higher, there are only two commands that are incompatible when you transition, and those are very rare to use in your code, especially the geocerts. I've never seen that in my life. There were sometimes. If you're before the 4.0, there's a long list, but most of these commands are already deprecated. So if you're following the good practice, you don't have it on your code. So always sacrifice the dev, QA, and UAT instances first. If something happens, it needs to happen with those instances. And don't be one of these guys that have its production to a sharded cluster and the QA, dev, UAT in Replica-Set. Those two are incompatible. If you do a change on a Replica-Set, you never know if it's going to be compatible in a sharded cluster.
All right. Now with all the pre-flight requirements complete, it's time to migrate. So to migrate, the first thing we need to do is add a shard. The prerequisites, as Antonios mentioned, are already complete. We have a healthy MongoDB tier. We have a healthy config tier, and we know we have a healthy shard or replica set to add because production is currently using that. So what do we do? What we need to do is add the shard. What you see here is the shard name, followed by at least one member of the replica set to add that to the MongoDB tier. If you wanted to be more thorough, you could have you could have all members listed here, but a minimum of one is required. And what does this do? The first thing it does is it should give you a resolve back confirming that the shard has been added. Next, just like your driver, it's going to open up a replica set monitor connection to the replica set to monitor for state changes, health, and also internal commands and operations. Next, you're going to see config.shards be populated with this information. Now, one thing to note here, if your replica set and now shard contained hidden members, you will not see those populated here. The MongoDB is only going to track members that are visible, that were visible and still visible. Next, when you run that command, it'll scan the shard for all databases that were present and then populate the config databases collection for the metadata. Now this command and only a write to the shard or the replica set triggers the population of this. So if you ever got into a situation where one is not present here, use that database, write to a test collection, and that will force this to be populated. But by default, the add shard command will populate that. Next, when you had initialized your shell tier, your MongoDB tier, you may have seen events about the system sessions collection. Once a shard has been added, which is the persistent data layer for your sharded cluster, the config system sessions now can be set up. So after about 60 seconds, you should see a message similar to this in your log that it was set up, sharded, and now being stored at the MongoDB layer. And now it's time to test. Before you plan to point any of your services to the MongoDB layer, you want to run sanity checks. You want to make sure that server status cluster status from the MongoOS, reports to shards, reports to databases, and all MongoOSs that you currently have present and configured. Next, you're going to want to go to your data and run finds or aggregations to confirm that you can retrieve data. And then it's also recommended to write to a test collection. All these operations would trigger exceptions or errors for intra-cluster communication if something was not configured properly. Now, for the actual migration, as Antonios mentioned, this is where you deploy a new URI, and at a minimum, you need to make these changes. First, you swap in the MongoOS nodes, multiple for redundancy. Depending on how many MongoOS nodes that you have, you could use a subset, but in this case, we're just passing all that are available. And then also removing the Replica-Set parameter from the URI. If the Replica-Set parameter is passed to a MongoOS, it will not know that parameter and result in an exception. So here we're going to go over how you would deploy your application and minimize the risk as part of that. First, we're going to identify a subset, say 25% of each of your services, and schedule them for a deploy to the MongoOS layer. You're going to want to have ready application logs because at default verbosity, the application logs will typically give you more information in a problem scenario. Next, the MongoOS logs, monitor those for potential exceptions or authentication errors or inter-cluster issues. And next, the resources, specifically CPU and connection counts when it comes to transitioning a workload to the MongoOS. These are two of the main issues we've seen when transitioning from a replica set to a MongoOS tier. Highly recommend Percona's management software and monitoring software, PMM2. And if you're an enterprise MongoDB customer, you could leverage Ops Manager. So with that 25%, you take a health check of your transition to the MongoOS tier. So if you're not receiving any exceptions from any of your services, start transitioning a little bit more work to that MongoOS tier and monitoring the previously mentioned metrics as you're doing so. And at that point, because you're doing this gracefully, you shouldn't be encountering any cursor errors or any connection errors or leftover connections to your sharding layer because you're doing it in a graceful manner. Once you've migrated 100% of your workload to the MongoOS, continue to monitor and look for any potential issues, whether it be operations, performance, throughput, or scale. In some scenarios, you may have to do a partial or full rollback. In this case, it could be a number of things. It could have been something wasn't compatible from your application to the MongoOS perspective, which should have been identified in queue error staging, or you may have run into throughput or concurrency issues at the MongoOS layer. Because your replica set is still available and exposed, you can transition partial or full rollback to that tier. In the event you encountered, say, like throughput or MongoOS scalability issues, unless it's just too few virtual CPUs or not enough RAM, the recommendation here is to scale this MongoOS tier horizontally. By scaling it horizontally, it gives you the added compute power and the redundancy that vertical scaling can't give you. And then to take that one step further, you may find that you need to do logical pooling of your MongoOS servers. You may choose to take half of them, give them to some services, and then take another half and give them to other services. By nature, the driver will be health checking all the MongoOS servers, so you need to take that in account, and it's also why the logical pooling makes sense. Next, you're going to want to test resiliency. Because you were on a replica set, you're familiar with step downs. Your driver should have been configured to handle them gracefully, auto reconnect, and continue operations as normal. But now step downs are behind a query routing layer, so you're going to want to test them again and see how your application behaves when that happens. Also, you'll want to test unplanned maintenances, OOMs or segmentation faults, anything that could just make, especially in the cloud, anything that can make a component go away, you're going to want to test. Also, now that you have a config server tier, having a config server down, or even a more extreme circumstance where you lose 2 config servers and your cluster goes into a read-only state. Everything is still operational at this point, except for sharding operations that need to modify metadata or store metadata, or store, for example, add user storing data in that configuration tier. And then to take that further, test more extreme scenarios, potentially network issues or a network blip, or what happens if you lost half of your MongoS's. You know, do you still have enough redundancy and throughput to continue with your production workload? Connection management is also important when switching to a sharded cluster. Previously, you were accustomed to just one layer of connection pools and cursor management and driver settings. Now you have to take into account another layer. This layer sometimes can require tuning to get the desired throughput or prevent things like cursor timeouts. You're going to want to do this via set parameter. And an example here is you may find that you need to keep a minimum number of connections open from your MongoS to your MongoDs, because sometimes connection creation during heavy workloads can be very costly. You won't see poor execution times at the MongoD from your queries, but all of a sudden you're getting these 1 second, 2 second latencies in the round trip, and you're not sure why. Sometimes that could come from the MongoS tier. So use set parameter as needed and tune those settings appropriately. So now we're in the sharding era. So what do we do now? Post-flight, repeatable deploys. Going forward, you may need to scale or geographically distribute your configuration tier. So be able to deploy that using your config management, as well as scaling up and down your MongoS tier. You not only have to potentially scale your MongoD tier. If you do have geographically distributed nodes that are in different sizes, make sure you have proper oplog length, for consistent backups if you're not using some type of streaming backup service. This allows you to get a consistent state across all shards, as well as your configuration data. Upgrading and downgrading. You're no longer binary swapping just the MongoD process during upgrades or downgrades. You now have to upgrade other components in the sharded cluster, and order matters. So at times, from version to version, the order can change. So it's highly recommended to make sure that you upgrade in proper order and check the documentation for that order for each major version upgrade. And lastly, feature compatibility version. Setting feature compatibility version in a replica set was just a command to the primary. Now when you do that, the command is actually issued against the MongoS, and you need to then restart the MongoS tier as that propagates to all replica sets in the cluster, including the config layer. And lastly, the metrics for your MongoS tier are not shared. You still want to monitor and gather metrics individually, but at least through PMM2 or any other Datadog utilities, anything like that, make sure you're aggregating these metrics across your whole tier so you get a complete view of your throughput. You're going to want to remove anything that may be legacy. And an example here was monitoring the op log for operations. With a replica set, if you hadn't transitioned to change streams already and you had some legacy code monitoring the op log, switch that to change streams, especially since that's a supported feature from MongoDB. And the reason for that is one, it gives you target flexibility. You can monitor a collection, a database, or even a deployment. They're resumable, and then since they're based on the aggregation framework, you can also do manipulation using the aggregation framework and not having that overhead of doing that in your app or somewhere in your code base or downstream somewhere. Again, it's a supported feature, and most importantly, it changes with topology. As your cluster grows and you're adding and removing shards, you don't have to take that into consideration anymore. The change streams will automatically detect any topology changes. And as Antonios mentioned previously, a single authentication source. If you were still tailing the op log, you would have had to maintain authentication at the MongoS and at the MongoD layer. Now you can just keep authentication and authorization at the MongoS. And they are transaction compliant. Change streams will only give you data that's been majority committed versus tailing the op log where you may have ingested some data that has been rolled back. So what is it to shard a collection? So a namespace, which is a database and a collection of MongoDB, you choose a key for it, and based on that key, and in this case, UUID, sharding splits that collection up into logical chunks with a min and max range, and then those chunks are then distributed across multiple shards. So to shard properly, the most important thing you can do is understanding your workload. And here, we are enabling profiling to gather 100% of our operations so that we can then analyze them. Here in this example, we don't have rate limiting. If you need to do rate limiting due to a degradation of performance, you can pass that with set profiling and then profile for a longer period to make sure you capture all operations. And then with that data, whether you're going to use the aggregation framework or a custom script, start generating reports for the namespaces that you want to shard. Most importantly, get a count of the operations to understand the scale at which you can distribute them, and then the patterns for those. One, that's going to be your shard key candidates, and two, if you, for updates and find and modifies, they could potentially break your application. So considerations for candidates, to scale out long-term, you want high cardinality, something that's going to give you targeted operations for both read and writes. So when you add shards in the future, those operations get scaled out near linearly. And again, high percentage of the operations from your reports. The closer you can get to 100%, the better scale that you'll have long-term. Typically, there is a compromise though, that you can scale sometimes just only 90%, and the remaining 10% will have to be broadcasted to all shards. Keep in mind, look for potential hotspots or issues with tiny documents and mediocre cardinality where it could affect data distribution among various shards. Monotonically increasing fields can impact throughput. For example, if one of the more recent ranges is on a single shard, that single shard will receive the new data, impacting throughput. Low cardinality and data pruning are also potential issues, not blockers that will affect data distribution and operation distribution. But with the asterisk there next to low cardinality in MongoDB 4.4, you will have the ability to extend a shard key to improve cardinality if you didn't choose right the first time. Some blockers, multiple unique indexes to maintain unique constraints across the cluster. The unique key constraint must be in your shard key. You do not want null values in your shard keys. Up until 4.2, you couldn't modify the value for a shard key. But if you are running 4.2, you now have that ability. And again, find and modify, it's a must-have to have the shard key in your filter pattern. And for updates, there is one workaround by passing multi-true. In the event you need to revert a shard key, you do have some choices. If you're still in a phase where you recently deployed to the MongoS tier and sharded, but you can still easily cut back to the Replica-Set away from the MongoS's, you can do so just by redeploying the previous URI and then removing the sharding rules by connecting to the Replica-Set directly. And then at that point, you would reinit your MongoS and your config servers and then start over again. Next, you can use the MongoDB supported method of Mongo dumping and Mongo restoring the data. By passing the drop command to Mongo restore, drop will remove all cluster metadata related to that namespace. And then lastly, if your workload tolerates a brief or no downtime, you do have the option of identifying metadata associated to that namespace. And then, combined with removing that metadata, and then MongoOS restarts in a step down, remove sharding for that collection. That's a little bit too complex and too much to go into detail at this time.
Okay, so as I said in the beginning, 9 out of 10 our customers, they do the sharded clusters in order to get scalability, in order to increase their throughput. So let's see what happens when we are in the state that we have defined our shard keys, like Jason described before. So all of our collections, or some of our collections, the busiest ones, are sharded. So as you can see, we're still with one shard. That's your initial replica set. And those green boxes that I have put there are your chunks. The chunks are nothing but logical pieces of your collections, right? So partitions, but logical, not physical. So what you do next, you have to add the shard to scale horizontally, right? It's pretty obvious. So you add the new shard, and automatically the cluster will detect that there is an imbalance. There is a process called balancer, which if it started, which by default I think it is, if it doesn't, just run sh start balancer, it will detect that imbalance and will start moving those chunks from the one shard to the other. The balancer is aiming to create a perfect distribution of the chunks. So in this case, we have 6 chunks. The balancer will aim to move 3 chunks from the source shard to the destination shard. And that will eventually happen. It will move those chunks over. And the next step for the balancer, not exactly for the balancer, for the cluster, is to remove the leftover data. So I move those logical pieces of data. They're not physical, so I cannot just go and wipe a file. Now I have to run a remove command. So I know that I moved from key 1 to key 10. Now those are live on the new shard, and then I have to go and remove them. So there's another process that's called rage deleter that go there and delete those documents. It's going to do them one at a time, one chunk at a time. And voila, you're having half of your data in one shard, half of your data on the other shard. Or if you wanted that rephrased, half of your chunks in one shard, half of your other chunks in the other shard. Now, since this is a fresh sharded collection, most probably having the same amount of data is applicable here. If it was something that was after a few days or weeks, most probably those chunks wouldn't have the same size. But since you did it like a few hours ago, most probably you're going to have the same data on both nodes. Now, next steps, you want to add more shards. Now, you can take advantage of what we call parallel migrations. If you have, your cluster now has 2 shards, you can see them on the left, they have 3 chunks each. If you add 1 shard, you can utilize only 1 move of a chunk at a time. So you can have 1 source and 1 destination for 1 chunk. So you're gonna get the same speed as you got before, that you scale from 1 to 2. But if you add 2, Mongo has the ability to run parallel migrations. It can choose different source and destination each time, different pairs, and run those migrations in parallel. Everything we said before applies to those parallel migrations. It has to do the range deleter and everything. But imagine that if you're doubling the size of your cluster, it's going to scale faster. And that's a type, I don't know if the Percona logo is there. That's a type that it actually can tell you how many parallel migrations you're going to get based on the number of shards that you have and the number of shards you're going to add. So if the number of shards you have is bigger than the number of shards you add, then you're going to get parallel migration equals to the number of the new shards. Else, it's the number of the shards you already have in your cluster. And there are some balancing considerations, right? When you're balancing your data, that doesn't come for free. We said you have to read the data, move them over the network, write them to the other shard, and then delete them. Those are MongoDB operations. They're not something that happens on a file that you just transfer it instantly and you just wipe it after that. Only takes a few milliseconds. So there are ways to make that more graceful, less impactful for your application. I think the most popular one is to define a balancing window. So you say, I want my cluster to balance between midnight and 2 a.m. that I know that the traffic is not significant, right? I don't get any traffic at that time. So let it balance. I don't care if I get a performance penalty. Although you can control the balancing window, you cannot control the range delimiter window, right? So range delimiter tasks might kick after the balancing window finishes. You have another option which is called secondary throttle. When the balancer does those moves, it uses read concern of 1. It has to only commit it by the primary. That makes it fast, but at the same time, it can move a lot of documents at the same time. So the number of inserts that the primary would get might not be able to handle them. So you can use secondary throttle. So for its write, now the source is waiting for majority. So it waits for 1 secondary at least to acknowledge that. So that makes it a little bit slower, more robust maybe, but slower. So you get less impact. And finally, the wait for delete. Now, as we said, range delimiter runs asynchronously, right? So you do migrations and at some point the range delimiter will kick and do those removes. Now, with wait for delete, you can say, I want to do a migration and then I want to wait for the range delimiter to do the cleanup before I start a new one. Usually the range delimiter starts within 10 minutes, but if they're open cursors, it might take more than that. But in this way, you do deletes and migrations in a serial fashion. So it's going to produce less impact for your cluster. Now, be aware that the documents that are in transit might be visible from the secondaries if you use certain read concerns. Also, if something happens during those migrations or before the cleanup happens or in the middle of a cleanup, those documents, it's going to stay there. We call them orphaned documents. Actually, Mongo called them orphaned documents. So the cluster does not log those documents somewhere, so they just stay there. And they just take in space from your cluster. And if you're using that read concern that we mentioned above, your driver, if it's reading from the secondaries, will access those documents as well. And finally, one of the problems that you might face on when you are on a sharded cluster, that's a very common one, is called unsharded collections, right? There are some restrictions around sharding. Jason mentioned them. So some collections you might not be able to shard because they might have 2 primary indexes, because they might be very small. So you think it's not worth it. So all these unsharded collections, they're going to stay on what we call a primary database and primary shard, right? So they're going to stick with one shard. And since you are started from one shard environment, right, on a replica set, and I assume you haven't created new databases after the migration, all these unsharded collections will hook to your initial shard. So if you run a MongoStat or if you have monitoring system, you'll see that potentially that shard takes more operations. And obviously it occupies more space on disk. So what you can do for those unsharded collections and potentially the databases, the one solution is shard them all, right? If you cannot do that, you can distribute them using a command which is called move primary. So when you run that move primary command, you say, I want this database to move from the shard that actually ran the command to the shard that I'm defining on the move primary command. So from A to B. Now, that is going to move the unsharded collections only. It's not going to move the sharded collections. And it's pretty similar of doing a Mongo dump and a Mongo restore. And during that operation, while this operation is running, there's no way to take a lock and guarantee the consistency. So you must take a write downtime. Else, until this command concludes and makes the transition, everything that your driver tries to write on those collections, it's going to go to the old primary. And since that's a Mongo dump method, you might miss some writes. And at the end of this process, it's a good idea to flash your Mongo SS. There is a command that's called flash router config. you have to run it in order to make sure that all the MongoS's have the same configuration. And here we try to summarize everything that we discussed on this presentation. There are a couple of phases when you want to migrate from a replica set to sharded cluster. The first one is you have to wonder yourself why I want to migrate, and most probably you need to arrange a proof of concept with your teams to see that if the sharded cluster is actually the solution or just I'm missing an index. And obviously you have to get ready that you're going to dive in a more complex environment. We discuss about that. You need more components, there are restrictions, but at the same time, I think you're going to jump into a more performant environment. And then you have to prepare. The most important steps is here are to build the extra infrastructure. And I think the actions here is go to the development environment first and do the actual migration there, get ready, get familiar, and then prepare and do the same for the production. And when you execute, you have to get, I think the most important here is to get familiar with the rollback scenario. If something goes wrong, how you're gonna fast redeploy your old connection string and go back to your replica set. When it comes to sharding, here we talk a little bit about the profiling. That's most probably a separate presentation of how you're gonna choose the shard keys. I think the most important here is that if you pick a bad shard key in the fashion that's gonna break your driver, if you're still on a single shard, which is the case, this is what we said, do all the sharding first and then add shards. You can just change the connection string and point it back to your replica set. And then just, if you want, wipe the entire infrastructure, go back to your replica set and start fresh. You want to delete the metadata, that's also acceptable. The best is to just delete that sharded infrastructure, the configs of the MongoS, and start over. Create new shard keys. While you are on a single shard, there is absolutely no risk, only redeploy away. And in the end, we discussed a little bit about scale, how obviously if you shard your collections, you want to add more shards to take advantage of the horizontal scaling. And we discussed a little bit the considerations around the balancing and the unsharded collections. With that, we want to thank you. We want to for attending. We want to thank Percona for having us here. And we are open to questions if there are any. Obviously, we are on Slack, so you can hit us anytime there.
Thank you.
Thank you so much, Antonios and Jason. Let's see, I don't see any questions in the Slack channel yet. You can give it a few minutes. Let's see. But yeah, that was great. Thank you guys so much. Let's see, I think we have some, hang on one second, I've got a little, okay. So I think if we have, it looks like we have no questions at this time, but feel free to put them in the Slack channel, and Antonios and Jason will monitor that for the next few minutes or so, and then we'll have Matt Yonkovit, our Chief Experience Officer, has prepared a presentation for you all to see before the next speaker presents at the top of the hour. So stay with us or take a quick break, and thank you all again, and we'll talk soon.
Thank you.
Matt?
Hi, Matt Yonkovit here, CXO at Percona, with another Yonk quick hit. Wanted to take a moment to let people know a little bit about Percona, who we are, what we stand for, and how we came to be. Many of you may not have heard of Percona before. Maybe you came to this conference because you saw an advertisement, you might have heard about it, you were interested in open source databases, maybe a friend referred you. So let me take a few minutes to talk to you about Percona. Percona was founded in 2006 by ex-MySQL employees Peter Zaitsev and Vadim Tichenko. Peter and Vadim were actually on the performance engineering team at MySQL and responsible for making MySQL scale, making sure that it was available and it could meet customers' needs. Over their time at MySQL, they felt MySQL got a little too corporate and more focused on shareholder value and sales than what really mattered for their customers. And so they started Percona as an alternative to the big enterprises, somebody to keep those enterprises honest and call BS on them if need be. Percona has over 14 years of experience focused on open source databases, making open source databases faster, more scalable, and more secure. While Percona was founded starting to look just at MySQL, they evolved not only from MySQL, but also to Postgres, MongoDB, and MariaDB. We're not only experts in performance, though. We're also experts in open source database in general. But Peter and Vadim did write a book on performance, the MySQL High Performance book. Now, Percona is really committed to making sure that open source software has the features and the functionality that you need to make sure that it can run optimally on any environment, on the most popular platforms in the most popular ways, right? So we are committed to bringing the best of what's out there in the open source space, making it accessible, making it easy to deploy, and enabling users to avoid vendor lock-in. We then take that software and those services and continually adapt it based on what the ever-evolving needs of the community are. Now, we've been trusted by not only startups and web companies, but also large Fortune 500 firms as well. And so a lot of companies trust us to help them navigate the complexity that is the modern open source database world. Now, I like to call us modern day influencers. Currently, our blog has actually over 300,000 readers per month. Our tools have been used billions of times. Our conferences, like the one you're attending here, have been attended by thousands of attendees. And some of the world's largest companies and most respected companies present at these conferences. We've been doing this for a really long time. Percona software has also been downloaded hundreds of thousands of times a month, and Percona software is installed on millions of servers. Now, when we talk about Percona software and Percona's products, let me differentiate those a little bit. Our goal is to run the best open source database software on the most popular platforms and make sure that customers get all the features and functionality they need. And this includes MySQL, Postgres, MariaDB, and MongoDB, and enabling people to run not only on-prem, but on the cloud in a multi-cloud environment or hybrid. Whether you're using Docker, OpenShift, Kubernetes, Pivotal, we help companies achieve more with their tech stacks when they're surrounded by the open source databases. Now, how we build it, and this is important, whether it is MySQL, Mongo, Postgres, or any of our software, we start with what's already great out in the community space. And for MySQL, for instance, in this example, that's MySQL Community Server. We have customers who find issues that occur that they haven't been able to get fixed, or maybe only occur in their environment under certain workloads. We fix those critical bug fixes and we push them back upstream to the upstream vendor, but we also include them in our Percona server releases. We then find issues that prevent scalability and prevent performance, and we include those to make a more performant version of MySQL. Then we take enterprise versions, a lot around security, a lot around things that would normally be behind a paywall, and we make MySQL more secure, more available, have more features, more visibility, observability. And then we find the best out there in the open source space, and we include that as well. We take all those components, we mix them all together, and then we test it with an enterprise level of QA, and we release that as Percona software. So not only do you get what is great about MySQL, but you get an enhanced version. What's more is the enhanced version is 100% in the free space, and there is no vendor lock-in. If you decide not to engage with us in a paid relationship, you can still use it. You don't have to change out your software. Now, we have the distribution for MongoDB, which we talked about in my keynote. We've also got our Percona distribution for Postgres. These are where we take the best of what's out in the open source space and make it easier to use and bundle them together to work together. We also have Percona server for MySQL. Percona Server of MySQL is just what I described, a better, more enhanced version of MySQL. It's actually the most advanced MySQL that you can get in the pure open source space. You have to pay for something that has more features and functionality. We also distribute Percona ExtraDB Cluster, which is our high availability solution for MySQL. It's the oldest and most respected and most widely deployed clustering solution for MySQL. It's trusted by thousands of customers worldwide. We also produce tools to help people manage their environments better. Percona Toolkit has been used billions of times. It's like your DBA Swiss Army knife. Extra Backup helps back up MySQL. And of course, Percona Monitoring and Management. And I'll talk a little bit more about that in a second. All of these are 100% open and free and can be downloaded and used without any sort of licensing from us. Now, these services, or these are backed, the software is backed by our services, right? They're backed by experts. So if you do want, a little bit more help, you can pay us for support, professional services, managed services. However you need or want to engage with us, you have that. Or you just use the software on your own. And if you need help, there's lots of people in the community who can help as well. Now, I mentioned we were going to talk a little bit about Percona Monitoring and Management. Now, we just launched version 2.6. Now, what we found was that many companies are running multiple database engines, multiple platforms and providers. They're trying to go cross data center. They've got thousands of databases to manage. And of course, there's always higher performance and scalability expectations. And the complexity is really becoming the new normal in this environment. So we built Percona Monitoring and Management to help with this, to not only optimize database performance across all those different platforms, but improve data security and reduce the complexity and simplify management of these complex environments. So whether you're trying to optimize performance, we have query analytics and metrics to help monitor that, or you're trying to ensure data security, we have things to help find those bottlenecks and those issues. And if you're trying to reduce the complexity, we also have this tool that helps pull all of this information, all of these disparate systems into one environment and one view. And in 2.6, as I mentioned earlier, right, we've given you the ability to enhance your annotations, advise on your Docker or your cloud native deployments, visualize your database deployments across the globe, provide more functionality around both Postgres and MongoDB. And we've also included our new security enhancement tool. Thank you for listening, and we hope you're enjoying the show. And hopefully now you know a little bit more about Percona.
Thank you so much, Matt. I think we have another short bit prepared.
Well, so Emily, before we jump to the next short bit, I don't know if people noticed. Here, I'll go off. Hello, everyone. It's me again. And so I don't know if everybody noticed, but Fred mentioned that not all of our audience is engaged. So his cat is actually watching in his sleep. So I've decided to maybe spend 30 seconds to try and get that oh so critical of feline audience engaged in Percona Live. So Fred, move your cat over to the window. Let's see if we can get the Fred. Hopefully that worked. But I'll let you go again, Emily. Sorry.
Oh, thank you. I trust that worked well. And I think we have another little bit here before the top of the hour.
Hello, we hope everybody is enjoying Percona Live online so far. We're sticking to a tight schedule and the previous presenter has finished slightly early. Please bear with us while we get the next talk on schedule. Have you joined Percona Live Slack yet? Slack is the official chat channel of the conference and we recommend you join to engage with the speakers and other conference attendees. Please also take a moment to provide feedback on the previous talks. The links can also be found in chat. We have some social games running too. follow the hashtag Percona Live and join in. You'll have a chance to collect the exclusive conference t-shirt posted to you shortly. Please consider taking part in the Open Source Data Management Survey. This survey provides critical help with shaping and understanding the current state of the open source software market. Visit percona.com/survey. Our next speaker will be with you shortly. Thank you for your patience. Okay, Emily, I think we're ready to change over our hosts. If you want to introduce the next host, we can get started a minute early.
Sure. All right. Well, thank you guys so much. It's been wonderful being here with you for the past 2 hours. And thanks again to all our speakers. I'm going to pass it over now to my colleague, Matthew Bowen. Hey, Matt.
Hello. Thanks a lot for handling us the last couple hours, and I will take it from here. All right, how is everybody doing today? In my time zone, it's about 2 o'clock, so I just finished lunch and I'm ready to keep this ball rolling. If you don't know me, my name is Matthew Boehm. I've been with Percona for coming up on 8 years. I'm currently holding a dual role of senior architect in our consulting department and senior instructor in our training department. So if you're interested in anything training related with MySQL, be sure to give us a ring and we will be happy to come and educate you guys in all things MySQL, replication, topologies, backups, recovery, advanced query tuning, performance analysis. We even just released a Kubernetes tutorial as well. We have our MongoDB cluster tutorial, proxy SQL tutorials. All of these are full day, completely engaged, hands-on labs. That would be awesome for you and your team to get a little bit more involved in. I had a minute to fill and I just filled it, so great. So we just finished a little bit of NoSQL with our MongoDB talk. From the guys over at Rackspace. So we're just going to shift a little bit over to the side and we're going to start talking about Cassandra and our friend over here at Yelp. My apologies, I'm going to call Raghavendra. You can correct me if I spelled that, if I said that wrong, which I probably did. Raghavendra is a senior software engineer at the reliability engineering team over at Yelp in their London office. So he's the one who deals with all of their MySQL and all of their Cassandra. And so he is going to be taking us through all of the cool stuff that he's got going on over there. So if you want to take it away, it's all yours. Yep, there we go.
All right. Hopefully everyone can see me and hear me. All right. Okay. Please shout if you can't see me or hear me or otherwise. Okay, good evening or good morning in some parts of the world, since this is a 24-hour online conference. And Matt, thanks for waking up the feline audience as well. So hello to both feline and non-feline audience from me. So today I'm going to be speaking about orchestrating Cassandra with Kubernetes operator and PaaSTA. And so sit back, relax, and enjoy. Before I move forward, I want to give a special kudos to Percona for pivoting so quickly and organizing this online event. So quick clap there. So having said that, okay, so this is about me. I'm Raghavendra Prabhu. As Matthew mentioned, I work at Yelp and I work in London, UK, where it is a nice summer. So you can see my face better, hopefully. And I work in the database reliability engineering team here. And our team is distributed in London, UK, and San Francisco, CA. So we are a team dealing with distributed databases, and we are ourselves distributed, which is cool, right? And on the right-hand side, that's not me. That's our team logo, which is the otter. So the databases we deal are Cassandra, MySQL, Zookeeper, etc. Okay, so the next thing is Yelp's mission. So Yelp's mission is to connect people with great local businesses. As the picture shows there, on the left-hand side, you have a person, and on the right-hand side, you have great local business, and we connect you. Okay, so this is the overview of the talk today. So I'm going to do a brief introduction to like some tidbits here and there from distributed systems, and then I'm going to talk about Cassandra and Cassandra at Yelp, then briefly talk about orchestration, and then spend a bit more time on Cassandra operator itself, and then what are the opportunities and challenges that we observe with this, and then I'm going to conclude. Cool. So let's start with the introduction. So often I start many of my talks with a quote. So I thought I decided to start this talk with a quote from Leslie Lamport, who's a guru in distributed systems. And he said that a distributed system is one in which failure of a computer you didn't even know existed can render your own computer unusable, right? This is often true even when if you have dealt with like production systems and so on, where cascading failures can happen. And yeah, this is something to keep in mind always when dealing with distributed systems. After the quote, I want to briefly mention what are the desired traits of distributed systems. And I want to give a special credit to the book Designing Data-Intensive Applications, where these traits are mentioned as traits of a system. But since most of the systems are distributed these days, so I'm going to call it that way. So they go like reliability, scalability, and maintainability. So reliability is wherein your system should work correctly even in the presence of faults, some level of faults, human or technical. Human being the stress word. Scalability, it should be able to scale as its model proves, either horizontally, vertically, or both. And finally, which I consider to be personally consider to be quite underrated, is maintainability, right? It's often underrated, but it's very much important to scale the system with organization. This deals with things like operability, simplicity, evolvability, and extensibility. A lot of ability is there, but those are very important, I feel, in my lexicon. So having spoken about the desired traits, I want to do a brief tangent to the distributed system fallacies, because I feel like these are very important to keep in mind when designing an orchestrator for a distributed database like Cassandra, for instance. So it goes like, I'm not going to read the whole thing, but it goes like network is reliable, latency 0, one administrator. Some of these are pretty self-obvious, like latency is never 0, but some of them are not that self-evident, like one administrator or topology doesn't change, for instance, or homogeneous network. So when you are trying to orchestrate a distributed system, these are some of the things which will be useful to keep in mind, and something that I'll be mentioning throughout the talk as well. Okay, so with this brief introduction to distributed systems, let's talk about Cassandra and Cassandra at Yelp. So this is the Cassandra. I'm talking about not the Cassandra from Trojan Wars, but the Cassandra which is a distributed database. Okay, so usually, in a normal talk, I ask who here has heard of Cassandra, but I presume everyone has heard it by now because you're one tab away from a Google search. So I'm going to skip that. So let me mention that Cassandra is a distributed wide column NoSQL data store. It's also a leaderless or a multi-master, which means you can write to any node and read from any node, even on a multi-region level. So which is pretty cool. It has multi-region support, which means you can deploy it both on a local area network and a wide area network. So you can have one cluster, which is, let's say, New York and California, in both the regions, but a single cluster. It also has tunable consistency, which is pretty cool. What that means is the client can say at what level of consistency its queries needs to be answered. Like if it needs the write or read to be served by all the replicas or a quorum of replicas, that is the majority of replicas, or one, things like that. And also, unlike say MySQL's InnoDB, which uses B-tree and is very well read optimized for point reads and so on, Cassandra uses log structured merge storage, and it's write optimized. And not only that, it's also cloud aware. So what that means is it has ways to propagate information among the cluster through mechanisms such as gossip. It has a very good failure detection mechanism called fee accrual detection. And it's also quite topology aware. So it understands data center racks and so on. And it also has things like hinted handoffs, which are useful when nodes are not available. So these characteristics kind of, and the reason why I'm mentioning these characteristics is because it makes Cassandra more amenable to be deployed on something like Kubernetes. Okay, so Cassandra at Yelp specifically, we use Cassandra for both primary and derived data. Derived data being one wherein you store it in another database, say MySQL, and then you stream it to Cassandra for a use case specific to Cassandra. Primary is one where you directly write to Cassandra. What this also means is we use Cassandra for both OLTP and OLAP needs, which is online transaction processing and online analytical processing use cases, basically. Which means we use it for like a lot of batch jobs. We use it in a lot of batch jobs, interactive applications, behind microservices, serving the web traffic, analytical use cases, metrics, caches, even in the tracing pipeline as well. So. Which makes Cassandra an important component of our stream processing pipeline as well. So there are a lot of these pipes, some feeding into Cassandra, some leaving Cassandra, and so on. We are also completely deployed on Amazon Web Services, and we use EBS for storage of the Cassandra data. And we use SmartStack, which is a service discovery mechanism for Cassandra. We use it mainly for discovery of IP addresses, and not for routing specifically, because Cassandra client driver is quite intelligent in that regard. And finally, we use Zookeeper-based cluster coordination for pre-Kubernetes Cassandra clusters. And there was a talk I gave in a previous Percona Live. It's called Taskerman. That's what we use there. So at 100,000 feet, let me see if I got those zeros right. Okay, yeah, at 100,000 feet, the Yelp EC2 Cassandra, the pre-Kubernetes Cassandra looks something like this. So you have a cluster, multi-region cluster. And this is not like complete, it's not a facsimile of what's deployed in production. This is just for, for the purpose of this talk, this is how a cluster looks, a typical cluster basically. So it's deployed in East and West. So as you can see, speaking about the distributed system fallacies, you can see that we have deployed one cluster, both, as one cluster, which is over a wide area network, as well as, inside a region as well. And so a lot of things come into play: latency, bandwidth, heterogeneous network, and so on. Now, if you zoom into one of these regions, right? So let me zoom into US East 1 or US West 2. So this is how it looks. So you'll see that this one cluster is striped across, if I can put it that way, across multiple AZs, right? And each of these are like M5 instances, but that's just like an example. Then we have like elastic block devices attached to them, and also like they are in autoscaling group. And note that this is pre-Kubernetes, so that's why I mentioned like EC2 autoscaling group. And this is, of course, as the text below indicates, it's a multi-AZ, multi-region Cassandra cluster. And we use EBS for snapshots. We use EBS snapshots provided by AWS for backups. Okay, so now we know what's the state of Cassandra and Cassandra at Yelp. So let's talk about orchestration. So orchestration is what we use to manage our Cassandra cluster now on Kubernetes. But before going into the definition of orchestration and minutiae there, let me mention like what this figure is indicating. So this is how I would sum up the goal of an infrastructure team. So on one hand, so the person in middle, let's assume it's me or our team. So we have to balance between velocity, which is to be able to roll out new features and whatnot, from up stack to churn or scale or features. And on the right-hand side, you need to ensure that your database is reliable, available, and maintainable. So it's a tight rope to walk. So that's what I would, to summarize the goal, I would say that it's to deploy new features, infrastructure, and scale the cluster while ensuring the infrastructure is always available. So I would sum up that as the goal of a typical infrastructure team in general, at least. So having said that, I would define orchestration in this way. So orchestration can be defined like a formal definition from Wikipedia or otherwise. It goes like automated configuration, coordination, and management of computer systems and software, which is completely true, but it's kind of slightly dry, right? So let me add one more thing on top of it, which is that I would say that orchestration, in addition to automation and whatnot, it's also about operationalizing principles and learnings which are gleaned from managing an infrastructure. What that means is, let's say you're managing some infrastructure and you realize something which can be potentially automated, but something which is not, but something that is very well documented in documentations and runbooks, and that's something you should always try to add to orchestration mechanism, so that you can focus on other things. An example would be like deploying a fix for broken deployment. So like when a deployment gets broken and you deploy a fix for it, that's something you can also do through say Kubernetes, which we actually do, which rollbacks the deployment and deploys the new one, deploys the fix. Anyway, so why orchestrate? I mentioned, I want to mention those desired traits again, but highlight specifically the maintainability aspect, because that's where I believe the orchestration pays significant dividends. It's also required for sustainable management of constantly growing infrastructure and automation of best practices and learnings, as I said. Now, the next bit is, when you are picking up an orchestration system, it's always good if an orchestration system is kind of like is well coupled with the control plane. Control plane is nothing but the plane of a distributed system dealing with configuration and so on. And if these two, if the orchestration and the control plane are very well dovetailed, right? If they are in very well congruent with each other, it is very good. So in our case, that is something we are achieving by having the Cassandra operator, which is the main orchestrator, sitting on top of our platform as a service, which I'll come to shortly, and Kubernetes. So this is how our orchestration stack looks like. So on the bottom, we have PaaSTA, which is our platform as a service. And unsurprisingly, the logo for that is a PaaSTA, actual food, PaaSTA balls and so on. The second layer is the Kubernetes itself, and top of that is finally the Kubernetes Cassandra operator. So let's talk about Kubernetes first. I guess by now everyone knows what Kubernetes is, so I'll probably breeze through this. It's very popular open source container-based orchestration system. There are so many talks in this conference about Kubernetes, for instance. It's very well actively developed with several cloud contributors. It has very good support for stateful and stateless applications, which is very important. And it has well-defined building blocks for building distributed systems, things like stateful sets, which implement, let's say, a rolling restart, as a default design, for instance. And more importantly, it integrates very well into our platform as a service. Now, Kubernetes is quite generic, and but at the same time, it's quite extensible. This is important because several organizations, whose infrastructure has matured over time, often have their own platform as a service. So whenever a new orchestration system comes into play, it's very important that you can integrate it well into your platform as a service. That's very important, especially because infrastructure tends to be quite opinionated and idiosyncratic in nature. So this is where it's helping us, because by the quality of extensibility in Kubernetes, we have been able to integrate it well into a platform as a service, and transitively into our operator as well. Next is the PaaSTA, which is a platform as a service at Yelp. So it's a highly available distributed system for deploying, building, deploying, and running microservices that we have been using at Yelp. Before this, we have been deploying this on Mesos with Mesos, Marathon, Kronos, etc. But now we are doing this with Kubernetes. And this has been used for stateless services, microservices at Yelp for a very long time. And now we are deploying the stateful workload as well. So we have like thousands of, just to give a rough scale, we have like thousands of microservices deployed and growing. Sorry, we don't stop anyone from deploying any microservice. We don't have any strong checks and balances, though we have some monitoring on cost actually. But as a result of that, we have hundreds of deployments every day. And this platform as a service, unsurprisingly, handles both handles our compute, storage, and network abstractions. So basically CPU and device provisionings and fleet resizing and networking related abstractions. Now this comes into this question sometimes comes up. So I've just added there, which is why PaaSTA? Why do we need a platform as a service, right? So what this provides us is not only like few other very good features, which I'll mention shortly, but also a uniform interface. So when you have like it's always useful when you have like a single interface to manage your services and anything that you have deployed, or stateful workload you're deploying on Kubernetes. for things like deployments, so you can use it in your CI/CD pipeline, or for doing rolling restarts, or for rollbacks, canarying, etc., etc. So that's very useful there. And then PaaSTA also provides us things like ClusterMan, which we recently open sourced. It's our homegrown autoscaler of underlying nodes, of the fleet itself, which understands signals pertaining to like CPU and pending resources. And PaaSTA also provides us a way to deploy on Spot and statically reserved fleet. So Spot fleet, for those of you who have not heard of it, is a time shared instances, you can call them, which can be revoked by AWS at any point. So we use these Spot instances mainly for deployment of Cassandra on like instances wherein we can sacrifice availability for cost savings. Things like non-production instances or test instances, or even in production for certain use cases such as tracing related or metrics related use cases. But note that since we have a clear separation of stateful and stateless workload, because we are deployed on EBS, even with Spot fleet, even when the instance goes away, it's only our availability which may get affected. Actually, we have some measures to not, so that is also not impacted, but but we have a clear separation of state in Cassandra, which ensures that we do not face any issues with the Spot fleet either. So, so we spoke about Cassandra at Yelp, orchestration, and specifically about Kubernetes and PaaSTA. Let's talk about Cassandra operator itself. So Cassandra operator. As you can see, the operator is always doing something, looking around and fixing things, which is what we want. So this is what basically I'm going to talk about in the operator. Brief introduction there, mention specifications of the operator and Cassandra container, how the reconciliation works, what the hell reconciliation is, first of all, and then I'll put it all together. So Cassandra operator intro. So this was developed by the DRET, and we use in Golang, and we use on top of operator SDK and container runtime. It's also deployed in Kubernetes itself. And what it does have is the controller loop. Wow, that's quite a tongue twister for reconciliation. And I'll show that loop shortly. And it also defines what is known as a custom resource for Kubernetes. So custom resource is basically a whole pie, wherein you define what all you need. Oh, you need storage, you need secrets, you need container specification, like how much CPU, and finally, the stateful set, which manages, the state of multiple nodes. And one more thing I want to add here is this Cassandra operator that we have comes with a big red button, because I was reading this paper recently, and there they mentioned this specific thing, which basically is nothing but, let's say this operator is doing something and we want to do something, we have this way wherein we can pause this operator or stop this operator of functionality provided by a platform as a service, PaaSTA, so that, we can stop it, we can do whatever we want, and then we can resume the operator, and, we don't step on each other's toes. This is very important, trust me. In terms of responsibilities of the operator, as I said, it creates cluster from specs. You can scale cluster up and down based on, Git specifications. And it's also very useful and very important, very key, very pivotal for safe and reliable change deployments. I cannot stress this enough. It also handles lifecycle management, multi-region coordination, credential management for TLS, and so on. And it also has some heuristics for balancing resource utilization with availability. Things like how do you spread the pods of the same cluster across multiple nodes, things like that. I'll not go into detail here. Anyway, so with this introduction to Cassandra operator, let's speak about specifications. Basically, like, the first bit is, how does the cluster specification look like? So in our case, it looks like something like this. So you provide things like in your Git, repository, you provide details such as how many replicas you want, CPUs, memory, disk. Disk here is the EBS, by the way. And what kind of pool that you want it to be in. Basically, like it's like where you can say whether what kind of instance pool you need. And you can provide Cassandra configuration overrides, any extra options you need, monitoring options, etc., etc. One thing I would like to stress here is by the get-go, one of our design principles has been is a batteries included approach, which is that most of these options are, most of these parameters are optional, which means that if you just provide cluster name, you can spin up a cluster with some good defaults. The good defaults is very important in my opinion. Okay, so we know what the specification looks like. So let's see what the pod looks like. So in Kubernetes world, a pod is nothing but a collection of containers which share, namespace and have lifetimes linked to each other. And basically, in a pod, you'll have like one, main pod. Let's call it as a mothership, which in this case is the Cassandra container. And then you will have a bunch of sidecars, which are there to help Cassandra. So in our case, we have sidecars such as HHX for Smart Stack, for high availability discovery. Then we have one for cron jobs, one we have for Sensu-based alerting, and then we have another for change data capture, which is like for any changes that come from the cluster, it's exported to Kafka. So this is like a publisher which runs there. And then we also have one for metrics exporters and so on. Not all of these sidecars are required in every cluster, but we have made it so that it's also configurable. You don't have to run all these sidecars. Only some of them are mandatory ones. And as this picture shows, all these sidecars share the same network interface. So they have one IP address. They can be addressed with single IP address. And but internally inside a pod, they all talk to each other through localhost. And they also come with the specific IAM, which is just for them. This is very important from security point of view, which I'll mention in a later slide. And they can share the EBS storage, though that storage need not be mounted in all the sidecars. It can be mounted wherever we need. Okay, so the next bit in the specification, so in the specification is the state, the storage, right? That's where the main thing lies. So EBS for Cassandra, I guess I mentioned the clear separation of stateful and stateless components, which helps us orchestrate better. And but in this, I also want to insert a very favorite quote of mine by Guy Steele, who was behind the Scheme language, very popular guy in computer science, and he came up with some things. He came up to describe a clear separation of stateful and stateless components. He referred to it as separation of church and state. So for those of you who don't know, Church, Alfonso Church was the founder of Lambda calculus, which deals with just compute. So he referred to it as separation of church and state. Anyway, moving on. So the next thing is by using EBS, we have a quick healing upon node failure. As you can see in the picture there in an AZ, when the node dies, the container gets evicted and respawned on the other node, and the storage gets attached very easily. And AWS makes this quite frictionless, which is very good. And we also use dynamic provisioning with Kubernetes, which means in this slide where it said 2000 GI, right, 2 terabytes. We don't provision any of that storage. That storage gets auto-provisioned by the AWS EBS driver that we are using for Kubernetes specifically. Okay, so now we know the Cassandra operator introduction. We know some of the specifications and how the storage looks like. Let's talk about reconciliation. So before that, let me define what reconciliation is. Without going into formal definitions, I would say that let's say you have state A and state B. State A is what you have on disk, like the config. State B is what what is running in the cloud, right? So reconciliation is nothing but making sure that both these two states agree with each other somehow, by making changes to the runtime state. They don't have to be identical, but they need to be congruent with each other. So what I mean by that is, so this is how a reconciliation loop looks like for the operator. So you have configuration on the Git, on the left-hand side, which it keeps observing all the time in the loop, roughly speaking. There are some triggers that we use, some event-based mechanisms, but for simplicity, let's call it as a loop. So it observes the configuration in Git. Then it also listens to all the cluster events, the Cassandra cluster events, nodes dying and whatnot, nodes joining. So based on that, it takes these two things, and then it updates the cluster state so that they're all in harmony with each other. So this is the basic gist of the reconciliation. So this is kind of like a OODA loop, if you heard of it, which is like a observe, orient, detect, and act, something like that. But I don't think that's used in the automation systems, but yeah, nevertheless. So this is how a loop looks like in detail. If you zoom in into this loop, right, this is how it looks. So you don't have to read through all of this. I'll just mention it. The purple version, the purple bit is what is important. So basically the operator checks for things like, does the stateful set exist? If the stateful set does not exist, that's the easiest bit. It just creates it. But if it does exist, it needs to check if the specification of the cluster has changed. Like did somebody increase the CPUs, stuff like that. And in that case, it also updates the stateful set. Updates the stateful set, and then it goes to this loop thing. Okay, nobody changed CPUs, but somebody increased the number of replicas. This is something we deal with differently. So if somebody is trying to scale up the cluster, right, this is where we check if the cluster is ready. The cluster being ready means if all the nodes are up, if your cluster is a 6-node cluster and all 6 nodes are up, things like that, roughly speaking. So it tries to scale the cluster up and down, but it does not do it if the cluster is not happy, which is very important. And this is kind of like related to a precautionary principle, one can say, which is that don't do anything which is not critical when when something is broken, for instance. So before scaling, it checks that. But note that when it needs to do this cluster spec change, it doesn't do that check because it doesn't need to. Because let's say something is broken and you pushed a fix, this goes in this part. Yeah. So then it tries to scale it up and down. For scaling up, again, it's easy. You just add a node, and Cassandra handles it beautifully. But when scaling down, that's where it gets kind of tricky, because you need to decommission it. You need to tell Cassandra also, oh, this node is going and we are scaling down the cluster. So this involves one extra step, not a problem. So we scale down the stateful set by 1, and then we go back to reconciliation. Note that you may be seeing some locks here and there. I'll explain that in the subsequent slide. We use the etcd for locking between the operators. So now we know the specifications, we know the loop, and we know what the operator is about. So let's put it all together. So this is how the big picture looks. So from the earlier EC2 picture, this is the Kubernetes picture. So we have the operator, the Kubernetes, then we have PaaSTA, which is like the glue between them, which manages Cassandra containers, in availability, multiple availability zones. And but other things are more or less the same. Like we use EBS snapshots, etc., etc. So this is like the region level picture. And this is like, if you zoom up, right, this is how it will look. So this is where I want to mention the etcd bit. So our Kubernetes is what is known as a non-federated Kubernetes, which means every Kubernetes in each region is independent. They don't share any state. What that leads to a situation is that if you deploy a cluster which spans multiple regions, you need to coordinate it, because you'll have one operator in each region. And if both of them are operating on the same cluster at the same time, bad things can result. And we can get woken up in the middle of night, and we don't want to be. So we use this etcd leases so that these operators can coordinate and serialize their work. And so yeah, so that's where the etcd comes into play, and that's where all these logs that you see in this flowchart come into play as well. And so this is the pre-K8s picture, wherein we use Terraform, Puppet, and whatnot for creating the cluster, for the Cassandra cluster itself. And this is the this is the Kubernetes approach that we're using, wherein we use Git, and the operator reads all the Git and tries to reconcile the state. Okay, so we discussed Cassandra operator. Let's speak about a few opportunities and challenges. There are, just to preface it, there are like a whole lot of opportunities and challenges. This is not exhaustive, but I picked like 3 out of each, and mentioning them here. So in terms of opportunities, cost accounting is something that we found to be a very good opportunity, because not only like we can think in terms of spot and non-spot instances, but also it means that we can think in more granular terms. We can think in terms of cost per request. We can think in terms of requests per CPU, in those terms, and we can make better cost accounting and forecasting, for instance. Instead of saying like we need X instances, we can say X CPUs, which is pretty cool. And we can change the disk, CPU, and memory independent of each other again. I like that. So the next thing is auto-scaling. I'm very excited about auto-scaling. And this is because any web service load tends to be cyclical in nature, or in non-production, during the weekends, unless there is someone working, which I hope no one. So it tends to be cyclical in nature. So what this allows us to do is do auto-scaling both on the fleet level, like on the underlying nodes, and also on the container level. So we can do what is known as a horizontal auto-scaling, wherein we add more nodes, more pods of the same cluster, or vertical auto-scaling, which is wherein we increase the CPU or memory dynamically. Now, This may be obvious, but the horizontal autoscaling is very painful because data needs to get distributed and laws of physics. So that's something you do on a capacity planning level, like on a more long-term level. Whereas the vertical autoscaling is something you do on a very short-term level, for spikes and so on, or for something which, as that picture shows, if there's a holiday, everyone is trying to book something. After autoscaling, the next one I want to mention is security. If I could do a Ballmer dance, Steve Ballmer did a dance once about developers. I want to do a similar one for security maybe someday. Yeah, let's see. So security, reduction of surface area, right, is very important in my opinion. By reducing the surface area, you can save your databases. And this is where, things like what we are doing is we have like per container or per pod IAMs. So we can assign IAM tokens, which are identity and access management tokens from AWS on a per pod basis. And we are using KIAM for this. And this means that only that container or only that pod can access certain AWS resources, which is very important for us. And we also run Cassandra with the reduced capabilities and so on, so that for security reasons. Okay, so we spoke about opportunities. Let's speak about challenges. So first, glass half full. The next is not glass half empty, actually. The next half is actually drinking it, I would say, because these challenges are not like blockers, I would say. These are the things which kind of challenge our assumptions maybe, and made us rethink our made us come up with some creative solutions. So this is how I would put the challenges rather than something which are impediments, but things which provoke our creativity, let's say. And again, in challenges, there may be like so many. So this is not exhaustive, but I picked like 3. So the first one is sidecar. Sidecar, if you remember, was something I mentioned. These are all these helper containers. Now, these are very useful, but also like humans, we can end up overdoing it. And what happens is when you add like a sidecar, that resource gets multiplied in all the cluster pods, right? So if you have a choice between adding it on the host level or as a remote agent versus adding it as a sidecar, the resource allocation is something that is very important to keep in mind. Because let's say you add a sidecar which uses 1 CPU, and then you deploy it, right? It means that your CPU allocation has gone up suddenly by 100 CPUs if you have 100 pods, right? So that kind of thing. So that's something to keep in mind when doing the sidecars. And another thing is, since sidecar lifetime is tied to that of the container itself, you cannot do independent deployments, for the sidecar. So this is something to keep in mind when you have to decide whether something needs to be a sidecar or not. For instance, in our case, for repairs, we decided to run the repair as a remote agent, a remote agent which uses JMX rather than as a sidecar for this reason. The next is isolation. I guess any discussion of containers and databases is not complete without discussion of isolation. And there's a lot which can be said here, but what I would say here is that we have like some mechanisms to detect if there is throttling happening on a with like Docker CPU throttling and so on. But also we also look at few other metrics pertaining to like C group metrics and so on for CPU and memory, that it does not happen. But also we also use EBS optimized instances, which ensures that the path for EBS and network traffic is not getting mixed up. And the AWS Nitro in 5th generation AWS instances has also helped here. And we also try to do some intelligent scheduling and bin packing so that so that there is no noisy neighbor issues with these containers. Next is deployment strategies. This is an actual screenshot, by the way. I thought instead of putting some picture, why not a screenshot? Yeah, so this is how the CI/CD pipeline looks. So with respect to deployment strategies, few things. One is that since this is since I've added it there, it says dealing with immutability. What I mean by this is when you're dealing with Kubernetes, something like stateful set has few things which are mutable, but few things which are immutable. But let's say we want to increase the disk size, you have to do it somehow, right? And this is something which causes us a few problems initially, but then we realized that we can do deployments in a certain way to get around this. and not be hit with the stateful sets blocker with respect to the immutable objects. And because we keep doing these deployments day in and day out, so that it needs to happen seamlessly without anyone's intervention. And yeah, so on these deployment strategies, if I can think of a few more things, one is that of the rolling restart itself. Like, we also needed to ensure that when it goes from one stage to next, let's say from stage to dev, or dev from dev to stage to prod, we need to ensure that it has completely be deployed in one environment before going to the next. This is easier said than done for stateful services. For microservices, it's much easier to do, but for stateful services, stateful clusters like like Cassandra, this is much easier said than done. So this has been something which has been very interesting for us. Okay, so we discussed some opportunities and challenges. So let's jump to the conclusion. So just to reiterate, I wanted to mention these distributed systems fallacies and how any orchestration mechanism needs to take into consideration things like one administrator, for instance, because all the whole stack that I showed you of the orchestration stack that we had, like PaaSTA, that's managed by a separate team. So things like that are something to keep in mind when you're designing an orchestration system, so that we have like a very well-defined interfaces, uniform abstractions, things like that. Okay, so I started with the code, and I want to end with the code. Why not, right? So this is how I would put it. Orchestration, if I have to sum up in a Twitter-worthy headline, I guess, would be stating that it's like building a reliable system, like building a reliable system. In this case, is probably a cluster, or a even higher abstraction, like the data storage stack, you can say. So building a reliable system out of unreliable components. And note that the components in this case includes both human beings and and systems. So that's what I would call as the goal of orchestration. And again, I want to give a special credit to the designing data intensive applications book for this particular quote. Though in that book it has been noted as a subsection heading, but here I'm quoting it as a definition for orchestration. Okay, that's it. Thank you. And I presume there is not going to be a Q&A on the video, but if you have any questions, feel free to ping me on Slack or otherwise.
Yeah, what we're going to do is any Q&A will be done in the Slack channel. So if there's any questions right now, which I haven't been kind of watching and no one's been asking any questions or talking about it. So if you have any questions, feel free to type them into chat. You can certainly tag Raghu in the chat in the Percona Live online Slack chat, and he'll be happy to answer those questions for you. So thanks a lot, Raghu. I don't think anybody else has any questions. Very informative presentation, so it's very good.
Thank you. And thanks again for this online format of the conference.
Yeah, it seems to be working out really well. I'm glad everybody's enjoying it.
Thanks. I'll stop sharing now.
Yeah, go ahead. And I think we're going to have a little bit of another short by Matt Yonkovit. Matt, are you up?
Well, so I have nothing prepared. We've got some more videos recorded, but I wanted to take a few moments to maybe sit down and chat with a few folks and see how things are going. I'm watching the Slack. We knew that we were going to have some breaks, so we recorded a few videos. We watched one of them. We've got a few more. I think it's really cool to see how many people have participated. We've been getting a lot of feedback on Twitter, a lot of feedback on the channel about how this is going really well. So, if there are things out there that you want to ask, feel free. We can have a bit of an open QA for the next 10 minutes or so. If not, I can always pull slides. I've got lots of slides. I've got so many slides, you probably don't know what to do with them. I'm Mr. Slide Guy. Right. Interested to know, are there some topics that are on people's minds so far? We've heard some great content thus far. And, I know for me, listening to some of the Cassandra side of things from Raghu, that's something that I typically don't get involved with. I mean, I know Cassandra a little bit, but that is not a deep thing. And that's really interesting. And I really do appreciate, him taking the time, especially as it's getting a little later in the day in London for him. And we're starting to get into the the late hours for a lot of people. So yeah, I'm excited about that. And, you know, I also think that it's important to take a second and thank, you know, those who have helped put this on. So if everyone could, you know, maybe in the general Slack there, just do a tag of Bronwyn and thank Bronwyn for all of her hard work. It would be really, really appreciated, right? I mean, I think that would be really cool. And, you know, so maybe everybody just jump onto that Percona Online Slack and just give Bronwyn a good wave and, you know, say thank you so much for putting this on. Now, we've been talking about, evolving this type of conference and seeing what we want to do, you know, online. You know, obviously we've got Percona Live online in Europe. It's still scheduled, and we're excited and we're hopeful that, you know, maybe we'll be able to attend that and do that live. But in the meantime, we're thinking about potentially doing some technology days. And so maybe doing like a mini one of these where we have 4 to 6 hours just focused on MySQL content, and then another one just focused on Postgres, then another one just focused on Mongo. So that way it's a little bit more specific to the audience. Interested in your feedback on that. So that's, you know, something that, you know, we're super interested in hearing about. By the way, Bronwyn says she's doing some speaker checks right now, and she's like, why is she getting flooded with all these good wishes and best wishes? And I'm like, you know, it's because we all, you know, like think you're doing an awesome job, Bronwyn, right? And so that's always a positive thing. So if you haven't, you know, gone out and gotten your, you know, Red Bull and your soda, you know, now's a good time to break. We've got about 15 minutes before the next topic. And so I'm going to go in and I'm going to pull out some slide decks while we're talking here. This is what's called live, kind of like, you know, jamming. Right? We're gonna jam out some stuff. So if anybody has any questions or things they want, you know, to come up and want us to talk about, feel free to throw them up there. You know, we're more than happy to keep this train rolling with, you know, some live Q&A. So let me see what I got. So I don't know how many people here, you might have not seen our slides on the state of open source databases. And so we did a webinar recently on the state of open source databases, and we actually did a walkthrough of the various database technologies. And you know, some of these databases we've talked about before, but you know, we're curious as to, you know, what, you know, you see. And so we all know that open source is insanely popular. And so let me go ahead and I'm going to show some slides on the popularity of open source and how it's growing. So it would help if I did this correctly. And this is what happens during a live show, everybody. You never know, you know, like what's going to happen. So there is that. All right. So if you didn't get a chance to take a look at that and you want some more details, that's great. But let me go ahead and spend a few minutes while we wait for our next speaker to talk about, you know, some of the things in the open source space. Specifically, you know, let's talk about, you know, the popularity of open source, because this is important. Now, I don't know how many people, you know, have read the Red Hat open source survey, but Red Hat does this awesome job every year of identifying, you know, the trends in open source. And according to Red Hat, you know, 95% of the respondents in their survey, and this is across all enterprises and all different, you know, global spaces, identified open source as strategically important. Right. And so it's really interesting because we've got 39% say it's extremely important, you know, 36 vary. But, you know, more and more, it's common to see this as, you know, like the open source movement as winning the hearts and minds of enterprises everywhere. It was interesting. Some of the comments in our open source survey this year kind of, you know, pointed to some of this, but there was a few people who said, we're not allowed to use open source still, or open source is the toy that is used before you buy a real database, right? So there is still some of that mentality out there, but we are starting to win it. So that 5% we still need to help with, and maybe that's the 5% that need the cat toy, right? That could be the that we need to start, getting the hearts and minds through alternative measures. But when we talk about, when they were looking at the number of people who think that open source in their industry or in their company is going to grow, 77% say that open source will continue to grow in their company. So this isn't a one and done thing. And this is actually is reiterative of what Bruce was saying earlier and what Matt Asay was saying earlier. And this is a over and over thing. Open source is growing. And if you haven't seen, there's a whole bunch of different places you can go to track this, right? So DB Engines is a great resource if you've never gone there to track, the growth of open source. And so, they track the commercial versus the open source, changes. And you can see that open source databases have almost overtaken commercial databases according to their ranks. And when we asked our participants in our survey last year, whether open source database usage was growing, about 50% had it increasing, and probably the other 50% had it as staying the same. The enterprises, the larger companies, it's interesting that they had a lot more in the I don't know phase. So that's an interesting. But we talked about the multi-database is king. But I like to show this slide. And so this slide needs to be updated a little bit, but this is an eyesore for all of you. And you're probably all squinting and you're all going to take screenshots to ask me, like, what are all of these things? But, part of, that change in open source is now we're starting to get a lot of forks. And this is the MySQL kind of fork tree that I've started, and, how you run it and where you run it and why these different versions may or may not be, compatible with one another. And the ecosystem starts to get more and more complex as you start to enter into more and more providers. So it's interesting to note that, while open source is increasing and the usage is increasing, it's also fracturing a little bit. And that's something that is causing some complexity in the industry. But if you wanted to know who the most popular, database engines are right now, and where that growth is happening, and, I hate to make this a popularity contest because it really isn't, because all of these technologies are used very, very widely, and the margin between these is very small. But when we talk about, the most used databases, MySQL, everybody that we talk to in the industry, whether you're talking to cloud providers, when you're talking to, industry insiders, it has the largest install base right now, which is great. It has massive reach, and it's been around for a while, and it's been battle tested, and that's wonderful. And so according to the Stack Overflow survey, DB Engines, our own survey, the usage of MySQL is tops. And I talk to a lot of cloud partners, and they tell me the same thing. MySQL has a huge install base. There's a huge opportunity for people who are looking to migrate to the cloud in MySQL, and that's where they see their future as well. But Postgres is the fastest growing. And so Postgres, is the #2 in terms of popularity. But it is the fastest growing, and it is definitely the #1 target for enterprise migrations. And Postgres SQL's great feature set, and very their work on trying to replicate some of the features at Oracle or SQL Server, some of the proprietary databases, have made that a target of choice for many migrations. And then, it's interesting from our survey, we had Mongo, Redis, Maria, and Elasticsearch kind of like all bunched in between this 3 to 6 space. And then, DB Engines and Stack Overflow had MongoDB as #3. So, I mean, we had ours kind of bunched there. But you can see that all of these databases, they all are popular. I mean, you're talking about a percentage point difference because everyone is running multiples of these. And that's important to note. And so when you do a quick deep dive on the 4 that we support currently, and we were looking at this, you can kind of see that trend where MySQL has that big, install base, Postgres, second, Mongo, and then MariaDB. But where we see the growth, Postgres and Maria are growing. Mongo's about the same, statistically speaking, down 4% in the Stack Overflow survey from year to year. So it's kind of flat. MySQL has shrunk a little bit, but I think that's more just the maturity of it. You're going to see a few of those applications start to dwindle or to move to other systems, but they have such a large install base. That's a small move. So before I go further, let me go ahead and let me stop my screen share. Again, I wanted to, maybe show a couple slides you didn't see. I went through these. We have a webinar that we did, which is recorded, which you can walk through if you're interested in seeing some of this and getting a little bit more deep dive and understanding where the use cases for MySQL, Mongo, or Maria are. We've done some of that work for it. So Andy Moore has asked, I post a lot about data leaks. His personal favorite was the GDPR leaks, for irony. What's my personal favorite leak and why? Okay, so it's interesting because today there was a leak, okay? And today's leak that was talked about was a company that tracks database leaks, and they have a database that has all of the information that, on the leaks that was leaked itself. How ironic is that, right? I think, the quote that I gave, and I put this in my keynote slides, okay? The quote that I gave was just, it was mind-boggling because it seems like every day we one-up ourselves, right, when it comes, to the data leak side. And so, the quote is, there have been multiple Elasticsearch database breaches reported earlier, and the most recent one, around 5 billion, were exposed after a UK-based security firm inadvertently exposed its data breach database, which stored a huge information related to security incidents from 2012 to 2019 without password protection, right? Now, the GDPR one is, funny enough, but when we talk about hey, I'm going to go do security analysis, I would expect that those guys to understand how, to secure and keep their data, my data protected, right? I don't want more credit monitoring services. So it is really, good there. So, oh wow, look, so Akshay, hi Akshay, haven't talked in a while. So he wants to do kudos for the slides because I have so many slides just ready to pull up, which is always fun. And Veronica thanked the entire Percona team. So yes, thank you. So let's see. I think that's it. We're about 4 minutes away. 4 minutes away from our next topic. So if there are any more questions, I am happy to answer them. Otherwise, you can all go around. I can pull out the cat toy again if you really want me to entertain your cats. If people want that, just go ahead and throw it in Slack. Happy to put the cat toy back on. We can give some cat love. That's fine. I'm gonna go check. Where does ClickHouse fit in? So a couple things. So where does ClickHouse fit in? That is a great question. And do you know what? We've got a couple of sessions coming up specifically on ClickHouse and where it fits in. I believe Vadim is scheduled a little later on today. And we also have, the fine folks at Altinity who are going to be talking about ClickHouse as well. So, ClickHouse has, a really good broad spectrum of use cases. I'm going to let the experts talk about that. And there are going to be some talks that are going to be specific to ClickHouse. So I'm super excited about that as well. Somebody also asked, where can you find a schedule with the topics? Percona.com/live. You can go to the website and you can take a look at the schedule and you can see everything that's there. And so somebody asked for a time zone converter. So we tried to break them up into, time zones on our website so you can click on the tab. So it's something that, you can, say like, what's the local time zone that is appreciated as well. So, Matthew, we've got about 2 minutes to go, and I have, done my witty banter to fill in the time here for you. So who do we got coming up next? I think, we're a couple minutes early, so maybe we can do a little preview of what's coming up on the slate for the next session.
Yeah, we can certainly, I can certainly do that. I definitely have a lot of verbiage here that I'm not going to bore everybody with, but the two next speakers are, oops, and that's what I get for moving my page around, are Yoav and Yav. Wow, that's one letter away, those two guys. Yoav Eilat and Yahav Biran. It's actually Dr. Brian. These two guys work over at AWS on an anti-cheating tool for multiplayer video games, for online video games. What they're going to talk about is a combination of machine learning to, in a way, pre-detect or try and get a better jump on when cheaters actually cheat, and then how they use SQL to process that information, store it, and then retrieve it so that they can basically build different algorithms for all this different type of detection. And they're going to be talking about all the different AWS systems that they integrate in order to do this with various games. I don't know which game specifically they're going to be talking about. I'm not a big gamer myself, so I definitely don't play any of the shoot 'em up games. So because I have horrible, what I think they call it twitch reflex. So like when I need to move my whatever blaster I'm using, I'm horrible at that. But if I was playing a game and I continuously got destroyed or whatever by somebody who is cheating, there's a good chance I would no longer be playing that game. So if it was a subscription-based game, that company's probably going to lose out on my money. And I'm sure the same can be said. Actually, they had it in here that there was a survey by Irdeto that said 77% of players said they would stop playing a multiplayer game if they think the opponents are cheating. So it's out of that, the estimated game industry is $174 billion in 2019. So that can definitely represent a big chunk of change for your gaming company if you've got cheaters giving a sour experience to the other players. So Yoav is a senior product manager over at Amazon in their RDS department. He's been there for a couple years and managing a whole bunch of different sections and departments within AWS, Aurora, serverless, PostgreSQL, and MySQL. Dr. Yoav Biran, he's been games designs reliance systems, cloud-based infrastructure, got his PhD from Colorado State University. Previously at Microsoft Azure and helped build their Azure compute services, but now apparently is over at AWS. So I'm going to let these guys take it away because they're going to do a much better job talking about what they're doing and cheating, stopping cheating video games. So take it away, guys.
Okay. Hi, everyone, and welcome to our session, Anti-Cheating Tool for Massive Multiplayer Games using Amazon Aurora and Amazon ML Services. That's a mouthful, I know. My name is Yoav Eilat. I'm a product manager at AWS, and with me is Yahav Biran, who is a solution architect who has worked for a long time on the gaming industry. And together, we're going to show you some techniques that you can use to detect cheating in games based on data that you have in your relational database. So let's look at the agenda for today. So first of all, we'll talk a little bit about machine learning and relational databases in general. So not just the gaming example, but just in general, what kind of data do you use for machine learning and what happens if it's located in a relational database? How do you run ML models on that type of data? We'll talk more specifically about our example, which is cheating in video games. So think of people who are writing a program that will play on their behalf, or two players that are coordinating with each other, some kind of cheating behavior. And at a very high scale, you need to have some kind of automated way to detect those kinds of situations and deal with them. We'll look at the cloud services that we're using. Obviously, we work for AWS, so we're using AWS examples, but I think the same type of ideas you could probably use using other databases or other clouds if they have similar capabilities. We'll do a walkthrough of our solution using a game that was developed here at Amazon, and we'll show some algorithms that can detect specific types of cheating, and we're going to look at 3 types today. And then some next steps for how you can add machine learning to your application, whether it's a game or whether it's other types of applications. So when we think about machine learning, obviously that's become a huge topic in the software industry in recent years, and especially, we see it a lot at Amazon, a lot of things, both at AWS in terms of the cloud and Amazon's other businesses. And usually when people think about machine learning, the more instinctive way or the more highly visible way that people think about it is for things like text, when it analyzes what you're saying or translates it to another language, or images. There's services where you can send a JPEG and it tells you if it's a dog or a cat or a horse. I have a friend who actually worked on horses and on bicycles for a long time. So, looking at examples and, training a model to identify these things. So these are things, or self-driving cars or all these other machine learning examples. But what is actually much more common is that you have very traditional, relational, tabular type of data, and there's a huge percentage of the world's information that is sitting in relational databases. And the question is, what do you do in that scenario? You have lots of data and you want to be able to take the data from your relational database, use it in a machine learning service, and get results and make predictions, and put that inside of your application. So your application would be able, the one that's sitting on top of your database should be able to go select some data, run a machine learning model on it, and get some prediction. And there's many different cases where you might want to do that, and we'll look at some examples. So traditionally, it used to take a lot of work and a lot of machine learning expertise in order to add machine learning to an application. And we've counted at least 6 steps that you would traditionally have to do. And you, meaning both you as an application developer or database user, and with some help from a machine learning, data scientist or someone who's an expert in those things. So first of all, you would need to select in the plain language sense, to select a model that would work on your data, and usually through trial and error, you would find an algorithm that works on your data, and you would have to train it. You would then write an application, some code in your application that would do select in the other sense, to read the data from your database. Then you would need to format it, and formatting is often really a pain in the machine learning world, because different algorithms expect data in different formats. And even if it's a format that it's a CSV file, what order are the columns, all kinds of problems like that. So you have to do a lot of work to format the data for the machine learning model. Then you need to run the model in a machine learning service, probably in the cloud these days. Then the service needs to format the output back and then feed it back to your application in the original format, so that your application can go and do something with the results. So that's a lot of work, and the result that at least we've seen is that most machine learning is really done offline. We don't see a lot of cases where people are actually making calls from from an application to a machine learning service. It usually happens, usually the data scientist will just take, like we're showing in this diagram, that will go and read some data from the database in some desktop tool, and then go do some experimentation, or maybe the model is already there. They'll run the model, call the service, run the model, and then load the data into the database, or forward it to the application owner. So the whole thing often happens offline, and sometimes people are running scheduled jobs, but even that's less common. What we would really like to do is to just be able to add some code to your application, to your game, or whatever the application is, and then use the models directly from there. So that's what we want to show today. And these problems would be even bad enough if you only had a single data source. So if you have an application like a customer service application that has a database, where all your customer service records are located, or an order management system, or IT management that looks at events happening in your data center, all of these things, and you just need to pull from one data source, that would be bad enough, and somebody would need to sit with a desktop tool and do that. But it gets even worse where you have multiple data sources. And the gaming example is definitely a situation where you have multiple databases to look at. There's different things that happen in the game, including the moves that people are making in the game, plus the data about the players and all kinds of other things like that. So if you have multiple databases, you need to go and get all that data, combine it, load it, and then run it. Then you would have to, you'd be sitting and calling multiple algorithms, and you would have to go and combine all the results and reconcile them. So that would be a lot of work to do manually. So we want to see how we can do that in an easier and automated way. Okay, so like I said, gaming is an example where you have multiple data sources. Today we're going to look at three things. One is authentication, so the information for the players that logged into the system, and to see if there's anything fishy about what some player did when they authenticated themselves. There's transaction data, which is what players do, what they buy inside the game. These are good examples of supervised learning because it's a pretty structured type of data, and it's tagged properly. You know exactly when somebody logged in, logged out. The fields are pretty well known in advance. And then for player moves, that's a little bit more difficult to classify because they're moving in all directions, and you're not exactly sure like what is a valid move and what is not. So that's more of an unsupervised learning example, and we'll look at both of these cases. Okay, so a few things about the cheating problem. So from what we've seen from research firms like IDC, it's a really serious problem. So think of two players that are, moving together and Yahav was telling me about these examples where two people are coordinating, where one of them is walking in front of the other and acting like a sort of human shield. So people shoot at the other player, that player dies, and the other player can continue to move, and then they switch roles later. So, when you do things like that, or when you write automated software to play on your behalf, where you have a player that's walking in one direction, shooting in the other direction, and doing 5 other things at the same time, then it's probably a bot that's been written. And it kind of takes the fun out of the game. And like you can see in these surveys, people are kind of losing the fun in the game. And I think, similar issues exist in other industries. So even in video conferencing, like we're doing now, and we're using Zoom to speak, there are problems where you see bad behavior from participants. And if you could automate some of the obvious cases where somebody is disrupting a conference or any other type of software that you have, then it can make it much more playable and usable. Okay, so a few words about the technology that we're using, and then we'll jump straight into how we develop these algorithms and how they work. So we're using Amazon Aura, which is a relational database that's offered by AWS, for those of you who are not familiar. It's compatible with MySQL and PostgreSQL, and both of these editions support these machine learning capabilities that we're talking about, and they were released at the end of last year at our reInvent event in 2019. And it's basically this is a database that's based on the MySQL and Postgres databases with a bunch of optimizations and performance improvements, plus a few additional features. And it has pay-as-you-go pricing, which is like a cloud service. You pay for what you use. The machine learning capabilities specifically, which we added in 2019, what they basically do is allow you to do a query in your Aura database and then transfer it to a machine learning service for making a prediction. The two services that we support currently are SageMaker and Comprehend, which are two machine learning services that are offered by AWS. And the nice thing about it is that the whole thing is done using SQL queries. So you don't need to call APIs, you don't need to write additional code. You're basically doing you can just write a statement where you're selecting from the results of the machine learning call, and it's a function, and you can just use the results just like you would use any other type of data that you get back from your database. So if we look back at the 6 steps that we had before, using this feature, you basically get it down to 3 steps. So you still might want to select and configure the machine learning model using SageMaker or whatever tool you want to use. Now you would just run a query that calls the SageMaker, in this case, service, and you would get the results and you would use them in the application. A lot of the things that I mentioned earlier around formatting and all of that are done automatically behind the scenes. Okay, so before we go into the gaming example, just wanted to show a few other examples of what the select statement might look like, or what the SQL statements might look like in different examples. So the first example is when you're looking for fraudulent transactions. That's obviously a very common use case where you might want to use machine learning. So in this example, we've made some we've committed some transactions, and we have a function that we wrote which is called is transaction fraudulent, and it takes a few columns of data from your table, and if it returns true, then you want to roll back that transaction, and it was fraudulent. So that would be something that you would check when you actually insert it into whatever final table is where the transactions are officially approved. Second example is using the other service, Comprehend, to do sentiment analysis. So this is an example where we're looking at text, and you're passing a text that somebody wrote. For example, it might be that somebody said about your product on your website. So, this product is excellent, this product is terrible, or whatever, and you want to look at the sentiment of what they said, and if it says positive or negative, you can go and you can take action. So for example, in a customer service example, you would maybe run sentiment analysis on the comments that people are making, or the reviews, or the customer service requests that they're making, and if somebody makes a negative statement, maybe you want to go and follow up and do something about that. And then the third example is a classification example, where you have customers that, a database full of customer orders, and you want to look at what they bought, and you want to look at other data that you have about those customers, where they live, age, gender, whatever it is, and then you can predict what kind of customer are they and what they're likely to buy in the future. So you might discover, your ML algorithm might discover that you have 5 types of customers. One of them is big spenders, the other ones are occasional spenders, or whatever. You want to classify them into different groups. And once you find the customers who are likely to spend a lot in the future, maybe you go and you market something to those guys. So different things you can do. And in all of these examples, it's very likely to be relational data that's in a relational database, whether it's numbers or whether it's text. Okay, so I think with that, let's hand it over to Yahav, and let's look more specifically at what the gaming scenario looks like and what we built here.
Right. Hi, everyone. So as you have mentioned specifically about the gaming scenario that we're gonna take a look at this presentation, is that we already got we decided as the business problem about the dimension of the problem. So we looked at the game and we saw that the game enable you to do all kinds of stuff, such as moves, or such as buying loot or other transaction that you could do, and obviously in order to get into the game, you will have to authenticate. So that's the three transactions, the 3 dimension that we are going to take a look at now. What we did behind the scene, like a cooking show style, is that we already built the model. We could take. I'm gonna mention it a bit on the process of that, but just for the sake of this demo, we're going to assume that we have models that are deployed in our machine learning tool called SageMaker, and those models are exposed as an API, and they send you something, right? They send you, most of the time they send you a number that will basically be the prediction with some sort of efficacy, which will be represented in another number. So in our example, we're going to have an authentication cheat score. This is and this, as you can see in the function, how we are integrating with this with the model. It is basically a standard create function statement that defines the dimensions that the model accepts. In this case, it's the user agent, and I'm talking about the authentication, the user agent, that the device that the customer came and performed the authentication, the day, the month, the hour, and the minute, and the source IP that was used. Now, all these parameters will be sent to the SageMaker endpoint that it's called auth cheat, and in return, it will give you the score. It will return the score that we wanted, right? As we could see on the right side with the select statement. Now, in order to filter that, what we did basically, we created a classification that the results of this request will be in a new column called classification, CLS, and we are basically filtering all the classification that are greater than 0. Now, this is a private case, right? Because we are using a regression, a logistic regression, which is basically a binary results. But you will see in another example, when we use anomaly detection, it's going to be something else. And we're going to talk about how do we determine what will be the classification score that is interesting for us to review. Now, this is the game. This is a game that was that we developed in reInvent 2018, where we wanted to talk about completely other things, but just to give you an idea of what is this game ought to do. This is an MMO, a massive multiplayer game, and it's basically enable you to go on this surface and execute all kinds of stuff, right? And the execution can be literally executing people, but also performing other transactions. As you can see, this is all kinds of events that are happening. Ideally, we would like if we would have this this presentation with you in a conference. We would let you play it and actually sense it and emulate the cheat, but unfortunately this is not the case. But I'm sure we're going to have another chance in the future. But to our point, we simulated some sort of a cheating activity that is done across the 3 dimensions that we mentioned before, and let's see what's going on. So we're going to start with the authentication. As I said, player authenticated with a supported client, can be PC, game consoles, anything basically that your game supports. And then you have the emulants that are defined in 5 personality traits and game events. They can move, forge, dodge, etc. And also, finally, they can transact virtual goods. So what does cheating look like in the data? Now, Yahav mentioned that before, that the cheating can manifest in various ways. And the beauty of this feature is that it allows you to decide on what this cheating means. And then it allows you also to respond or to react to how cheaters become reacting to your measures. So and maybe this is a good point to make, that the machine learning based solutions works very well with problems that are evolving and they're not static. And so in our case, player can cheat as they make illegal trades and run bots. And we will try to understand what does it mean with respect to the data that we have. And also cheating can manifest in consecutive failed login, right? So let's say that I have this bot and I want to log in from another client on another even source IP or Cedar IP. I'm sorry, subnets, and that can be posed as an anomaly or non-legit behavior. In the case of microtransaction, it is very similar to any fraud that you might have in other venue, even like a credit card cheating fraud. And the player move anomalies, players walk and shoot in the opposite direction while performing other tasks. You have mentioned that as well. So how can we stop cheating in the game? So usually if you are a game publisher, you would, and this is going to be a business problem, a business risk for you, you're going to form an anti-cheat team. And the anti-cheat team will comprise of at least 3 types of personas, right? The first one who are the people that are actually the marketing team that are very involved, or designers that are very involved with the storyline of the game. On the other hand, you will have people that knows how to pull the data from all the sources that you have, including the relational database. And finally, you will have the data scientist that's going to make a decision what, given the data that you have, what will be the best model or algorithm you should use in order to get those cheaters with good efficacy. The reason that it's important to have a multidisciplinary team is because that anti-cheating, a false positive, can be frustrating in the same way, right? You don't want to have a situation where legit users will go and have to go through all kinds of horrible captchas, verification, and also like just going back and forth with customer care. That's going to create the opposite effect of the whole motivation, right? So I guess that what we wanted to enable by forming this anti-cheat team is to stop those cheaters and continuously refine the algorithm. So now we're going to go over to review the data structure, and again we try to keep it as light as easy as possible without getting too much into the weeds, but hopefully the level of details with the schema that we're going to show you now will give you a sense of how you do stuff. And by the way, before I continue, all these things all this presentation and the code is going to be open source and be available for you to try after that. So you don't have to take notes and read those small prints. So in the first data set, we have the player authentication. This is the authentication transaction. As I said, there is a timestamp that the player came, and in this case, it started to the authentication method was the Xbox Live Token. It means that it logged through the Xbox authentication service, even if you offer other players to log in from another places to the same game. This is the player GUID, the user agent, which in this case it's an Xbox device. This was the source IP and the Cedar and the geolocation, the geographic location of the players. the transaction is the timestamp, the player GUID, and the type. In our case, it's a loot box. The user agent again, and as you could sense from the transaction and the authentication, you could also see how these two data sources can relate can be joined on the player GUID and the user agent as well. And finally, we have the player moves. The player moves in this case is the X and Z coordination, include the timestamp and the player GUID, of course. But we also have three properties. One is the quadrant, as you saw in the video clip that I shared. The game is divided into quadrant and in sectors and subsectors in each quadrant, and the events can be user traversing from one place to another, or forging or dodging or other events that can that the game allowed. So we used 3 models for this game data. The first one is the authentication. Now, for authentication, we use the algorithm called IP Insight, and again, it's an unsupervised learning algorithm for detecting anomalies for specifically patterns of IP. This algorithm does a really good job by looking at patterns in the source IP and the seeder of the subnets of the IP that the player come from. For transaction, we looked at supervised linear regression, specifically a logistic regression that basically takes the classified data and produce a number between 0 and 1 with respect to the transaction that was made. And again, this is a very similar problem to fraud detection with credit cards. The reason that we use supervised, it's because the data that we have for authentication is already resides on Aurora database in our case, because it serves the customer care. And if someone if someone complains about some transaction that was made on his account, or something that was done by other players, this information is already resides in Aurora. So supervised and supervised classified algorithm is optimal here. And finally, for the player moves, we use the random cut for us, just because that we have lots of information, and this information is not classified. We don't even know if it's how to even start with classifying those events. And so the player moves fits very well to the business problem that we have, because we assume that most players are good and they are playing nicely according to the rules, and so the anomalous behavior will be suspicious, will be considered as suspicious for us. So the data preparation. So just to give you an idea of the amount of data that that was included in this experiment, this simulation, we have 700,000 authentication event and 1,400,000 transaction, and roughly 65 million player moves. Right, and this is between 0.1 and what we did, for the supervised data, we classified data between 0.1 to 3% to allow the model to distinguish between legit transaction, move, authentication, and non-legit. I'm sorry. So we build our models, as I said, using Jupyter notebooks hosted on by SageMaker. We used all the data to store. We stored all the data on S3, and then once that we have the training, once that we were able to distill the data and train the model, we deploy the model as with a hosted inference endpoint using the SageMaker service, and we, as Yoav showed before, we used Aurora to invoke the endpoints. And we're going to talk about how we did it and all the optimization that include with that. Now, and now we get into the meat of how this this journey on training the data and massaging the data using the high level language SQL that we use make it easy and I guess more cost effective in some way with respect to the personas and of the people that are participating in the anti-cheat team. So the example, and again, I'm not a data scientist. I feel very comfortable with writing SQLs, and so the ML models like numbers, and I mean integers. And in the data that I got from all the sources that we mentioned, there was, as you saw, some of them were presented as characters. Some of them was presented as numbers, but those numbers also needed some processing. So what we wanted to do, we wanted to encode the string attributes into a number that the models can understand better. So for that, you want to run all kinds of transformation and encoding processes. For example, we transform the move event. So in the example that we showed before, we have an event called traverse sector or travel explore. We needed to encode this to an integer. In the sector case, we have a sector 0-2. In this case, we wanted to encode it into a string, and the same thing for the quadrant that the player play. Now, if you do it, and this is how I did it, I'm going to share I'm going to open source the notebook so you can actually see this code sample. But in this example, this code sample is taken from the notebook that I authored. But as you could see here, I took the quadrant encoded, the sector encoded, and the event, and encoded it using the pandas and the what hot encoder. Now, it's not a rocket science, and and if you have a good understanding of Python, you could get along with that. But if you're not a data scientist and you're not comfortable by jumping between all kinds of platforms, if we take this thing and use this example, this example does the same thing. It's basically, if you look at that, it starts with select distinct all the event name, and this is just for the event encoding, and basically go through all the encounters table and just assign an integer to each event. So this is fairly simple, as it is, I think, the simplest SQL that you can come up, and you didn't have to do all this exotic libraries that I respect very much. But for the personas, again, bringing back the business problem that we have, the personas that are dealing with this anti-cheat team are not necessarily comfortable with that. So that's another value proposition. Okay, so let's try and see these things in action. So the way that we do it, we created materialized view for the 3 dimension, the authentication, transaction, and the encounters, the player moves. And based on the characteristics of the cheating that we discussed, we're going to start by looking at suspicious transaction, then looking at suspicious authentication by the player who executed the transaction, some sort of like a join, and then we're going to try to make sense of this suspicious activity by looking at the 3rd dimension, which is the player moves. Now, the order that we decided on is completely arbitrary. It's because of how Yoav and I looked at the business problem, but it does not preclude you from applying any flexibility to your anti-cheating strategy. Materialized view. So we agree that we are going to, on a hourly basis, weekly basis, daily basis, whatever the frequency that we want to apply in the online processing of this anti-cheating, we created this this materialized view, and this materialized view is triggered by a trigger, the same sample that Yoav showed before. But if you look at this example, you could see that we are querying all in the authentication case. We're querying the entire authentication. We're querying the parameters that are the input for the authentication model. In this case, it's the day, month, hour, minute, and the source IP. And we basically filtering only the suspicious one, the one that are mentioned as a CLS that is greater than 0, classified as fraudulent. For the move, it's fairly the same thing, but as you could see here, we query the model for the move cheat squad, the player Z, quadrant, sector, and event. But in this case, we chose to get only the transaction that was classified above 2. Why 2? Is because that we used the data and we looked at, and we created like a simple histogram, and we saw that an anomaly with that its score is greater than 2 is suspicious. So as you could see, it's very flexible and very fluid, and really depends on your game and your data. And this is and the tools basically exemplify the flexibility of this model. Okay, so let's run this thing. So I'm going to share my other screen. Okay, let's see. Okay, so I'm going to log in. And so the first query that I'm going to execute is going to basically, hey, can you give me all the timestamp and the player GUIDs that are basically suspicious? So I'm going to go through all I'm going to call into the transaction cheat score, right? And I'm going to query the materialized view that created just an hour ago, okay? And between the time that I specified. And so, as you could see, we could. I mean, if you could see here that the syntax that I'm using here, I'm basically querying the materialized view and going back into and looking and filter only the suspicious one. In the last slides, we're going to see how the optimization, how the the Aurora ML feature is optimizing the back and forth between the machine, between the database and the endpoint, because obviously there is a lot of optimization opportunity with respect to the network and the network latency between the two. Now, if we looked at the 13 rows that we got here, we have, it doesn't mean so much for us at this point, but what we could do is we can, oops, we can, come on, sorry. We're going to look at another query that's going to basically look at the authentication, transaction, and going to join it with the suspicious transaction that we have, okay? And as you can see here, one second, I'm going to do the same thing, and we're going to talk about those things. As you can see here, these are the authentication sheet, right, joined with the transaction sheet, right? So what we basically did, we were able to filter these 13 cases, okay, suspicious cases, to 3.1. And if what we could see here is that we have a really interesting player here that is doing something. So let's try to understand what's going on here. The first timestamp is describing the timestamp of the authentication. As you can see here, this guy logged in in 6:37 in the morning, and the suspicious transaction, which is denoted in the second timestamp, the suspicious transaction happened roughly 20 minutes after he logged in. Let's look at another transaction. The same thing, 6:37. That's probably the same authentication that was made, but here we see that another transaction, another suspicious transaction, happened in 11 p.m. The same thing happened at 4 p.m. and sorry, he has another authentication transaction at 4 p.m. and then another authentication, suspicious authentication, happened in the same time, right? So that looks a little bit suspicious. So what we want to do here, we want to basically go and try to see, to cross-reference it with other dimension. And the other dimension that we have here is the player moves. So in the player moves, we are going to execute this transaction. And this transaction, if you could see here, it's returning all the distinct timestamp and player GUIDs of the suspicious moves. And how this suspicious move manifests, you could see here, I'm basically querying the move cheat score, right? And I'm asking to filter the move cheat score from the materialized view that are greater, that the classification is greater than 2. And again, I'm classifying it, I'm limiting it between the timestamp that I was able to get here. Okay, so what did we get? We got here, we got that this player, right? We can see him here. He did some suspicious move, and this suspicious move happened in 7 a.m., which is like something like 6 minutes after the transaction, the suspicious transaction that was made that day. So you could see that, you could get an idea that this is something that is an interesting player to explore. And we, as an anti-cheat team, going to take these details and go and explore more. We might want to look at the log of all his all his movements and try to assess whether there are other suspicious behavior, or maybe look at patterns. So what we wanted to show you here is that the game that we presented includes lots of movements, lots of transactions that are coming at you from all kinds of direction. And what we were able to do, we were able to show you with 3 select statement. We were able to get a good idea of what's going on with respect to the cheating in the game. So let's go back to the slide and see. I'm going to new share. I'm going to PowerPoint. I'm going to share this thing back. Okay, so this is what we did. We query first the authentication. We found these 13 cases, and then we joined these cases with a transaction, and we found this case, and then later on we were able to look at some anomalies that in his moves, right? And as you could see also that there are cases that are anomalous that are legit, right? And we didn't necessarily wanted to take action upon them. And that's allude to the point that I was making before about false positive. Now, and this is something that I didn't do, so I can jump back to the command line. But basically, the things that we wanted to do as a next step is to look at what's going on with their moves, why the moves were suspicious. And here we double click basically into the transaction that this guy did, regardless to the models, right? We basically queried the movements that the player did, and we found, and this is how it looks like, just to give you an idea. It's I'm basically looking at the timestamp, the player GUID, the quadrant, and the sector of all the cases that was suspicious, right? Where classified is greater than 2, and we found that the suspicious behavior happened in quadrant 3, sector 35. So what we will do is that we will go to our encoding mechanism. We're going to find out what's going on in this thing, and we're going to start monitoring other activities in these areas. So now, it's all good. It's great. We were able to find those cheater, hopefully, with not so many false positive. But I also want to spend some time to understand, to show you how we optimize the calls. Because if you think about it, the calls between SageMaker and Aurora can be very chatty, right? And this chattiness can create several problems. First of all, the first problem can be latency, right? You don't want to sit in front of the in front of the screen and wait for long hours and long seconds or minutes. But also this back and forth, this chattiness can manifest in cost of data transfer, right? Think about the cost that because you have 2 separate endpoints that are talking to each other, and that can also cause can incur cost. And finally, if you think about the ease of use that you gain by the seamless integration between these 2 endpoints. For example, you might want to apply a asynchronous mechanism when you are interacting with the API at scales by partitioning the data and sending those chunks in a batch fashion. And we're going to show you how this done in our specific example. But in this case, what we wanted to show here is that we're going to look at how many fetches was made between the Aurora database that was originating the call to the model and to the SageMaker. So we're going to start by flashing the status of flashing the buffers of the statuses. And now, if you look at the command that we executed here, we are going to get lots of data, which is basically roughly 1,750 rows, right? And if we looked at the number that we made to the Aurora, to the SageMaker, you could see here that when the transaction table that we query was 1.3 million records, and the 1.2 million of them hit the cache, right? So what we were able to do, we were basically optimize the number of back and forth between the SageMaker, between Aurora and SageMaker, and basically only 1,351 actual request was made. And this is actually a really cool optimization that if you would have to do it yourself, you will have to apply those mechanism and caching yourself, which is will not contribute to your business as an anti-cheat team. Now, I also want to point out for another another optimization when we were that we demonstrated here. We were making a request, right? In this case, it's the Aurora integrating with Amazon Comprehend, but it follows the same pattern when it interacts with the SageMaker. The application, you make a call to the application returns 50 features, for example, right? And now you need to communicate that to the other API, again, the Comprehend case. And Comprehend as an API has a limitation of 25 rows in each batch, right? So what you will have to do in this case, you will have to break to batch those requests, those 50 requests into two chunks, right? So you're gonna get a response, send another request, and get another response and aggregate that. Okay, so that's something that you will end up doing if you would do it to yourself. What we get from here is you want to have both scalability of requests from the Comprehend. You don't want to implement asynchronous query as I just demonstrated. You as a user want to basically make a request and get the results and wait hopefully until these things finish, but you don't want to deal with this asynchronous, but the asynchronous fashion is required to get a scalable query mechanism. All right, so that's what we had for today. We have we published our example on GitHub that basically talks about those all the things that we demonstrated today. We have other interesting links for you about Amazon Aurora and the machine learning, other features that you could use and best practices, and the Amazon SageMaker. I really hope that that was a good use of your time. I enjoyed it very much. This is Yoav and my contacts. we are happy to answer questions. Yeah, thank you very much.
Yeah, thank you very much, Yahav. This was great. And yeah, looking forward to hearing from people in the Percona community. And if you're doing gaming or if you're doing other types of applications, I hope you can use similar techniques. So would love to hear from you. Thanks very much.
All right, thanks guys. That was a very interesting presentation on the gaming and the cheating. I would have never put that together with MySQL and the SQL language. So it's pretty neat. Lots of comments on the Slack channel about the presentation, an interesting topic, and people are looking forward to reviewing that and watching it actually again. So the question was asked, just in case somebody saw it, about whether or not these recordings are going to be available, and they certainly will be. So look for that announcement coming later. If you do have any questions for the AWS guys, I know that they had to run, so they're not going to be able to answer any questions live, but certainly type them into the Slack chat. We'll make sure that they get out to them and that they can respond as appropriately also back to you in the Slack channel. I've got 2 minutes before the next presentation comes up. I'm actually done for the day. I'm going to hand it over to Michael Coburn, who, if I recall correctly from yesterday's meeting, is going to play the guitar for us.
Well, I brought the guitars, but I'm not sure I'm going to play.
So you can trust him. He's an expert. And so, because he's got the shirt that proves it, and if it's on your shirt, then that's gold. So he's going to take it over from me. So everybody have a good day, and I'll see y'all later.
Thank you, Matthew. I appreciate that. For those of you that don't recognize me, haven't seen me before, I'm Michael Coburn. I've been at Percona for about 8 years, and I'm in the role of a principal architect. I work on the same team as Matt, so we are both strong consultants here at Percona and specialize in the MySQL side of work. I did want to say that I am quite proud actually to be presenting or to be speaking in front of the next few speakers here. I've had the distinct pleasure of working alongside a few of them. I've also met many of the others at conferences. And the first talk I'd like to bring to your attention is going to be done by Shopify. It's by Akshay and Jeremy Cole, who are both legends in the MySQL space. Their topic is based on MySQL on Google Cloud, War and Peace. I hope it isn't as long as the novel by a similar name, but I expect it'll be within the 30 minutes. And in terms of who these people are, Akshay is an experienced MySQL database reliability engineer who's been working with MySQL for about 8 years. He's worked previously at Percona, he's worked at Tumblr, and now he's a senior production engineer on the data stores team at Shopify. And the other legend on this call is Jeremy Cole. He's a pioneer of MySQL scalability. He's been working with MySQL for over 2 years. He started at MySQL AB, he was at Yahoo, proven scaling as a consultant. He's worked at Twitter, Google, and now he's the senior staff production engineer at the data stores team at Shopify. So with that, I'd like to open it up to Akshay and Jeremy.
Okay, welcome everyone to Percona Live Online. Before we start, hope everyone is safe and at home. Today we are presenting about MySQL on Google platform, and yeah, let's start with it. So the agenda for today basically is a small introduction to us, speakers, and our company, Shopify, and then we go on to some important concepts in Google Cloud. Then we listen to some peacetime stories, and then wartime stories, and then we conclude our talk. So something about us. I'm Akshay Suryavanshi. I'm a senior production engineer in the data stores team managing the MySQL databases. And I've started working here since September 2018. With me, I have Jeremy Cole today. He's a senior staff production engineer in the data stores team. And he has been working here since August 2018. And of course, he's a MySQL legend. Shopify, our company, is an online and on-premise commerce platform founded in 2006. now used by more than 1 million merchants. Hundreds of billions of dollars of sales has happened on the platform since its inception. We are a large user of MySQL, and throughout the Black Friday and Cyber Monday weekend, which is our peak time, we handled hundreds of billions of queries with MySQL. So that is a little introduction to us. Let's move on to our next section.
Yeah, so first we'll talk a little bit about some important concepts just so that the terminology is explained. But Google Cloud, if you're familiar with Amazon, AWS, some of the terms are very similar. Regions are just a geographic region where Google Cloud operates, usually sort of considered like a data center or a couple of buildings of data centers that are very near each other. And zones are a subdivision of those regions. Typically there are 3 within each region, but it varies a bit by region. GCE is the Compute Engine Platform, which is the system that provides virtual machines to run as servers, and most of our MySQL infrastructure is on GCE run on VMs. So we have the virtual machine instances within GCE. They're scheduled in a particular zone, and we use the next item, persistent disks, which are a network-attached block storage system based in a single zone in GCE. GKE is the Google's Kubernetes engine, so it's the Kubernetes solution that is managed within, it's actually running on top of GCE and managed within Google Cloud, and we'll talk a little bit about that as well. That is the solution that we're using for some of our up-and-coming MySQL work. So at the moment right now, most of our big MySQL installation is on GCE in VMs, and we have a lot of work happening within GKE.
Okay, so yeah, after warming up to some Google Cloud concepts, let's talk about some peacetime stories and events that has happened over the last 1 year after Jeremy's talk about MySQL on Google Cloud Platform. So let's start with persistent disks. So PDs, as Jeremy mentioned, they are network-attached distributed log storage. This is a place where you basically save most of your data, especially when you're running MySQL data or any sort of databases. So except their performance, which is usually latency of a network-attached storage, they provide incredible features, especially fast snapshotting of volumes. We have utilized the snapshotting behavior to revamp our backup and restore infrastructure, and like brought down our recovery time to less than 1 hour for even a multi-terabyte disk. And this is so incredibly fast that we actually restore each and every snapshot that we preserve or retain as a backup every single day. And it's happening in both regions where we run our MySQL fleet, most of our MySQL fleet. So these are like really useful features. They provide us really good resiliency against testing our backups and our restore procedures. Configurable VMs. So VMs, virtual machines, expose an extensive API, which is very useful in programmatically doing things with them. The API is very helpful. It is well documented, and yeah, we are using it in a bunch of places. Scaling VMs up and down are seamless operations. Of course, all of them require a restart, or most of them require a restart, but those are manageable cases with the MySQL databases and a good failover stack. Provisioning new VMs in an appropriate region and zone is very easy, again, because of the extensive API which is provided. Something required to build resiliency against zone failures. So we spread our VMs across multiple zones, and that helps us tremendously when a particular zone goes down, which you'll learn about more in our wartime stories as well. So all of this basically has allowed us to build self-healing tooling to automatically replace failed VMs easily. And then we see a lot of failures happening throughout throughout a certain period, and we were able to accomplish building these toolings pretty easily. Again, thanks to the API which GCE provides. So GCP is truly multi-regional. Google Cloud has the most extensively spread out availability region. From what I heard last, I think they are spread across 23 regions and 70 zones, which is really good. So this is definitely helping us in building robust regional failover capability. We can failover from one region to another pretty nicely, and Shopify is able to just move all the traffic from one region to another with the use of that, and it happens within few minutes, and we can do this multiple times in a day now. We also have the ability to expand to a distant geographical region without a lot of work, yet keep the same stability that we see in our previous regions. Isolating PII data is quite achievable and has been a big win for Shopify in the past 1 year, where we launched a certain product where PII data needed to be preserved in a particular region, and GCP provides really good support for that. Google Kubernetes Engine. So GKE is feature-rich on top of already cutting-edge Kubernetes, which is really nice. Kubernetes is an open-source project for container orchestration. We are, as Jeremy mentioned, most of our future work is happening towards containerizing MySQL and running them or scheduling them inside Kubernetes. So one of the aspects which is helpful for us is automatic storage and file system expansion, which is really easy and almost automatic, and it solves a very important problem for database administration at such a scale. Zone-aware cluster node scheduling helps schedule the Kubernetes pod, which are in fact MySQL pods, in a way that they are fault tolerant towards zone failure. So just as we built our resiliency with using VMs in particular zone, Kubernetes also automatically, or GKE also automatically provisions pods in such a way that they are spread across zones. Networking. GCP networking is pretty simple to set up, and it's really great. Again, kudos to Google's networking. It's top-notch, as always. Inter-region latencies are pretty low and helps us perform region failovers for databases in the event of a disaster. So as I mentioned in my previous slides, we are able to do a complete region evac within a few minutes, and all of that is possible because we can keep our databases in both regions up to date and due to these low latencies. VPC, virtual private clouds, are a great way to segment the workloads. So we segment our production workload, our staging workload separate from each other, and VPCs are a great way of doing that. And isolating the networking at VPC level has helped us achieve that, which means your staging workload basically doesn't interfere with your production workload.
All right, so it's not always peacetime, and it's worth talking about what it looks like at wartime and some of the things that can go wrong in the cloud and in Google Cloud specifically. Starting with, stockouts are a real thing that actually happens. We may not be able to allocate the resources that we want to allocate at all times. So the concept of a stockout basically is that a resource that you requested, whether that's a VM or a disk or something else, is not available at that time. What that looks like is that you attempt to allocate it using some API, and it just takes a very long time to show up, or you get an error saying that it's out of stock, basically. In one particular instance, in one region, we had consistent PD and VM stockouts occurring regularly for several weeks, where creation of VMs or creation of the underlying PD volumes for them would take several minutes or tens of minutes. All you can really do in that case is just keep trying until you succeed. The cloud does have some resources available generally, they just aren't always immediately available. So you just keep trying and trying and trying. But one of the things that does mean is that you need to make sure that you do not, for instance, have a requirement in your disaster recovery plan that you immediately spin up a replacement instance for something to avoid downtime. You need to make sure those instances are already running and the resources are already allocated if there's a time critical component to that resource availability. One of the bigger challenges and problems that we've had in general is persistent disk. And one of the instances of this is we had a recent outage that was caused by a change in persistent disk's backend, which caused a regression for us, which caused anywhere from minor latency impacts to full stalls for several seconds of the underlying PD volume, which of course pretends to be a disk, so that means the disk is fully stalled for several seconds. There's a term, increased P100 latency came from that, which is, well, technically a true term, a bit unhelpful in describing how that looks to the user. In this particular case, it actually took several weeks for us to diagnose and pin the blame of these stalls on PD completely and properly and get Google to start working on it. So during that time, we had many small incidents, many big incidents that were caused by that, and we just have to kind of work through those and figure out what's going on. Once the problem's identified, of course, there were some mitigations we put in place. And there was a long-term solution for it, but the fun part of that story is that the mitigation for this particular problem involved attaching a very large PD volume to every one of our VMs in order to work around a problem that was happening in PD. And in order to do that, since we had so many VMs, in aggregate, we had to allocate petabytes of persistent disk and leave them attached for a few months. And probably the major outcome of that is you've got to work with your vendor. You've got to, so work through some of the technical issues with this, and sometimes you have to get pretty creative to make things work right now and get yourself back in action. Live migration is still a problem since the last time I gave a talk like this, which was a year ago. We're still seeing problems caused by live migration. Live migration is intended to avoid downtime in instances, which it does pretty well, but it is itself not perfect, and it means that we constantly have machines being live migrated and the VMs being moved around between different physical machines. The frequency of that occurring and the number of times it causes us problems directly related to the frequency of Linux kernel or Intel CVEs. The more of those there are, the more pain we have because Google has to go fix those and get the fixes rolled out generally pretty quick, and that causes us a lot of trouble. So the errors that we see right now, we see stalls related to live migrations. We're still getting host errors where live migrations fail sometimes and then it just kills the host, or kills the VM rather. Some live migrations are still breaking NTP and causing the machines to have the time be out of sync. And we are still getting multiple migrations per VM. As I mentioned in the last version of this talk, we had seen 11 live migrations for the same VM within a day or so. And that still continues, that occasionally we see some outliers like that where the same VM just gets migrated over and over when they're aggressively rolling out a change. We also had in the last year, a regional outage where Google had made a change to their traffic routing in one region, causing basically an overload of their networking stack. And we went down pretty hard because of that. The unfortunate part of that was that there was nothing really that we could do about it while we were down. We kind of had to wait for the network to start working again before we could even fail over to get out of the region. In order to avoid data loss and to avoid even bigger problems potentially, because of the way that the region went down, we had to wait more or less for many things to recover before we could fail them over. So the downtime was several hours until recovery. So in this case, sometimes you're kind of at the mercy of your allies. We are multi-zone, we're multi-region, but that doesn't always work in exactly the way that you think it should. And sometimes that causes you extra problems. In conclusion, running MySQL in the cloud is not magic. It can be a really brilliant solution, but it can also be a real challenge. And there are some unique challenges to Google Cloud, unique challenges to running MySQL in cloud infrastructure, and unique challenges with the cloud itself. So we've learned a lot. We've had some pretty big wins. There's a blog post that Akshay wrote all about how we do backup and restore. That's pretty awesome. Using Google's persistent disk snapshots, those something like that wouldn't be easily possible outside of infrastructure like Google Cloud. So we're very happy and very appreciative of that. But sometimes running databases in the cloud can feel like you are constantly at war. And there's always something broken. There's always something burning. There's always something that you have to be working on to keep yourself running. So it's a bit of a peacetime, wartime situation. When things are good, they're really good. When things are bad, they can be pretty bad. Thanks for coming today. And we will be happy to take questions and hope that you will stay safe.
Thank you very much, Jeremy and Akshay, for that presentation. Now, it looks like that was pre-recorded. So I do want to take an opportunity, maybe see if we can put you guys on the spot with a few questions here. I'm waiting for a couple to roll in still on the Slack channel, so please definitely keep them coming in, and I'm also watching the YouTube chat. But before we have any listed from public sources, I've got one. I was curious as we went through the presentation on what you're doing about the PII, the personally identifiable information, and how you keep it constrained to a region. So things like backups and whatnot. How do you address that?
I can take that. So yeah, first of all, thank you for having us over here at Percona Live. So yeah, related to the PII data, we fortunately Google Cloud provides us a way to keep that data in a particular region. That is currently our need. We need to contain some sort of data related to our products in a certain region, and Google sort of added that functionality for us. But again, you can keep the active data or online data inside a particular region, but for backups, since we use snapshot, they could be stored anywhere across a Google region. So we were helped on this by Google. They added a support for keeping the backups also stored in a particular region. So now we are 100% compliant on where that particular data stores and moves. So that has worked really nice for us in one of our projects last year. And you can certainly limit the data and its backups as well to a certain region.
Thank you, Akshay. Thank you. We've had a couple questions come in. One of them is from Alexander Kuzminski. He's asking, what's your intra-region latency?
I was just answering that question by just answering directly here. It looks like 32 milliseconds east to central. So US East 1 to US Central 1. This is not specific to Shopify at all, though. It's just Google Cloud's inter-region latency. It depends which specific regions you're actually using. But that's the the case that we see right now, somewhere right around 32 milliseconds. I think that's pretty typical for this particular set of or pair of regions.
Thank you very much. We've got a question from Javier Son. He's asking, are you dealing with any cloud NAT issues in GCP?
I don't know anything about that, actually.
I don't know if that, at least I haven't seen any problems like that, especially with NATing related to the cloud. But is there any specific thing related to NATing, any particular weird issue? And there are always weird issues in the cloud.
Javier writes, maybe it's better we didn't hear about it. So we'll take another question.
Yes, Javier. That's absolutely right.
Mr. Kuzminski comes back with another question: how you handle, or sorry, how do you avoid split brain?
That is a good question. So we use Orchestrator for automatic failovers, but only in a particular region. And we use a different tooling for our cross-regional failovers that we talked about. For an automatic failover, we obviously want to avoid that split brain scenario. We are again active-passive over here, not active-active or hot-hot. So whenever like a failover happens, one of our pre-hooks for Orchestrator is killing that VM, which was a writer before. And Google provides us the ability to kill a VM which is not prone, that particular API request is not prone to a network partition and can be done safely. So we rely on Google Compute and its API to reset a VM and then move on to do our production automatic failover, and then again come back to that VM and destroy it completely.
Very good, thank you. We've got a number of other questions. Simon Mudd asks us, how challenging or easy was the move to GKE from VMs from what you've seen so far?
Well, it hasn't happened yet, so challenges are mostly ahead. But I mean, at that point, it's just how challenging is it to move from one MySQL instance to another? There's definitely challenges. So the one sort of savior of a lot of this in some cases is that the storage system that underlies Google Cloud is the same. So you could run a Kubernetes job which talks to the same PD volume as the VM could talk to. And so there's no reason you couldn't actually restore a snapshot of a PD volume or attach an actual PD volume as you migrated a job. How exactly we do that for instances that we might want to migrate there, we don't have a specific plan for that yet, because a lot of the GKE work that's being mentioned is actually migrating from Cloud SQL, not from our MySQL and VMs. So,
okay, thank you. And we have a question here from Steven Zydek. He's asking around backups. Do you have processes for testing snapshot backups, and how do you ensure consistency?
We do have a very strict process around backup. As Jeremy mentioned, I did write a blog post about it, which had some details. For now, yes, we back up every 15 minutes. Basically, we snapshot every 15 minutes. We have tooling running which deletes the backups which are not needed and maintains our retention of backups up to like past 6 months. And we restore each and every backup every day in each region. And we check each and every page of InnoDB page of that backup to verify the page corruption as well. So we run InnoDB checksum, InnoChecksum in parallel on all of our data, which is into multi-terabytes at this moment. And we do that every day with again, as Jeremy mentioned, all of these are happenings and are scheduled inside Kubernetes. And these are jobs which run daily. We also ensure that MySQL can be started correctly on those backups, and also that replication can be resumed correctly on those backups as well. So it's a pretty complicated process, but has been happening for the past many months. it's running smoothly.
Thank you. We've had a couple questions recently around stockouts. I'm looking at the most recent one from Jeffrey Anderson. He's asking, how do you deal with the stockout issues? And another question asked, how do you proactively deal with stockout?
It's a multifaceted question, I would say. Proactively, I think it comes to what I mentioned in that section of making sure that, for instance, your failover strategy doesn't involve spinning up another instance. And that, I think, is probably good practice for most cloud environments anyway, in that nothing exists until it exists. So depending on its existence, for you to move forward is probably the best way to guarantee that you have problems. So if you have, for instance, a failover replica that you need to exist to accomplish your failover, you need to have it pre-exist. So then most of the stockout issues have to do with like node replacements when things fail, and adding additional capacity potentially. And those are, it's just something we have to deal with, and it's based somewhat on the regions that we've chosen and the size of machines. Frequently, it could be that actually, so maybe one real constructive answer to that is make sure that you don't unnecessarily limit exactly what type of machines you can run on. And that's, the broader set of machines that are available for allocation, the better. And the smaller instances, the better, because they're bin packed onto physical machines. So the larger machine size, larger VM size you choose, the less schedulable it is. And that's something that we don't follow very carefully right now, as actually could chuckle about. We have pretty big VMs right now. That's something that we'd like to see be smaller in the future. But it's definitely something, if you're building from scratch, if you're migrating, whatever, you'd be better, allocating a machine with 32 gigs of RAM rather than 200 gigs of RAM, because the 200 gigs can only be bin packed onto machines with 200 gigs free. So the more schedulable those are, the better.
Thank you. That's a great takeaway. And then I'm looking in the YouTube chat. I see a number of questions around SSD storage. There's reference that at some point it looked like local SSDs were slow. Do you have any experience? Can you talk to the performance of the SSD drives?
Yeah.
We use much slower disks.
It all depends on what you compare it to, right? So the persistent disk SSD is network attached storage. So it has network latency built into it. It's within a single zone, and Google's networking is really, really good. So it's not that high, but it is still a network request fundamentally. Local SSD is very, very fast in general, and looks like an okay solution, but it has other limitations, right? It's only allocatable in very large blocks. It actually really exacerbates your potential stockout issues, because your VM then needs to be scheduled on a physical machine with enough local SSD available. And that actually is probably the biggest way to ensure that you have stockout issues, is using local SSD. But it also isn't network attached if you use the local SSD. So things like the snapshot-based backups that we use right now just don't work in that model. So even if you can deal with all the other limitations there, our fundamental architecture at the moment is based on persistent disk and taking advantage of some of the advantages of persistent disk, which we lose by not using persistent disk. So that's probably the biggest answer there.
Very comprehensive. Thank you. A time check. We are at the end of our talk. So I want to say a big thank you to you both, Jeremy and Akshay, for your time today and for your informative discussion on Google Cloud. Thank you.
Yeah, thanks. And thanks for everyone watching.
Okay, as we move to the top of the half hour here, our next talk comes to us from Box. Priyanka Reddy is going to talk to us about a survey of strategies that they use at Box to protect MySQL. And today's the first time that Priyanka and I have met each other, and she shared with me that she's an engineering manager at Box, where she leads the teams responsible for building and maintaining the relational data access layer that is at the heart of Box.com. In addition to providing developers performant access to relational data, her teams also build services to improve the stability, availability, and manageability of the sharded MySQL infrastructure. Prior to Box, Priyanka was the founder and CTO of WeMakeItSafer.com, which was acquired by Bellamy Research. And before that, she interned at the now infamous Theranos, where she had a singular face-to-face conversation with Miss Holmes and is disappointed she wasn't asked about it for the Bad Blood book. So with that, Priyanka, welcome.
All right, thanks, Michael. Thanks for that introduction. I'm very excited to be here, part of our first Percona Live Online. Let's get started on strategies that we use at Box to protect MySQL from being degraded due to scale. So I'd like to start with the mission of Box. So over the past 13 years, we've heard from many companies, and they've all said the same thing, that they want to move faster, be more efficient, but technology gets in the way. And that's why our mission is to power how the world works together. And we do that through cloud content management, one platform born in the cloud that enables seamless collaboration, both internally and externally, single source of truth across all of your apps, automations, AI, ML, and a lot more. And we're the only platform that offers all of those capabilities. That's why Box has over 97,000 business customers, representing 68% of the Fortune 500, including some in the most security, privacy, and compliance-minded industries. And they challenge us every day with new and interesting use cases and constantly increasing scale. And so to support those use cases, we have an application, and underlying that application is the data access infrastructure. And I support the teams that are responsible for this infrastructure, which provides access to the metadata about all of the entities that are stored within Box. The data access infrastructure holds hundreds of billions of records, spans thousands of machines, and serves millions of requests per second. It's a critical part of the Box application, and so we have some stringent guarantees that we have to achieve simultaneously. First up, we have strict data consistency. Given the type of information that we're providing to our customers who are very compliance, security, and privacy-minded, partial or stale data isn't acceptable. So for example, permissions calculations can't be delayed. We provide a pretty high throughput. We continue to support whatever scale is being thrown at us by our applications that's serving those 97,000 customers. We currently serve millions of requests, but that actually turns into tens of millions of database records that are being retrieved or modified per second. We achieve a pretty low latency. Most of our APIs complete in a few milliseconds, and most of those actually in under a millisecond. And a single customer request requires tens of requests to the database layer. And so any small increase in latency at our layer gets amplified to the customer. And finally, high availability. Any outage in the data access infrastructure is an outage for Box, plain and simple, making this one of our P0s. So here's what the data access architecture at Box looked like a decade ago. I don't know if you're allowed to refer to one machine as an architecture, but that's what we had. All we knew about our traffic at this point was that we had queries, tens of thousands of them accessing hundreds of millions of records, all located on a single DB server. Fast forward to today, and this is what we have. And today we know a lot more about our traffic patterns. Things like how much of our traffic is repeated reads, how much of it needs to be immediately served, and how much of it can be delayed. Understanding this traffic is critical when deciding which strategies will or won't work for us, and they're key to getting the best utilization out of our infrastructure. And it's what allowed us to scale 100x over the past decade while maintaining the guarantees that I mentioned. And while I'd like to talk through all of the changes that we made over the last decade, I'm not going to have the time, so I'll focus on a few and discuss those in detail. So going back to our initial architecture, we started out, as most web applications do, with a single web server and a single database, which in our case was MySQL. And our full infrastructure is housed in our own in-house data centers. As we started to get more traffic, we scaled up by adding more web servers, replicas, cache, and sharding the database. We had also built up a pretty substantial data access layer in the web servers, and it included all of the logic that's required in order to read from the replicas, caches on the sharded database. And then our next step was to add a data access service. So the immediate problem that motivated adding this new data access service was exhaustion of our database connections. So whenever we had spikes in traffic, all of the web servers would attempt to grab connections to our databases at the same time. And then since connection management was decentralized amongst the web servers, we didn't have a global mechanism to throttle the requests, leading to connection exhaustion. And so we introduced a data access service layer between our clients and our data access stores. The layer contained all of the logic that previously resided in the web servers, so we could remove it from there. And then at the same time, we were adding another set of clients that were in a different language. If we didn't have the data access service, then we would have had to rewrite all of the logic that was in PHP, bugs and all, and replicate that in Scala. And so thanks to that data access layer, we were able to, we were prevented from having to do that. So that data access layer, first and foremost, protects our critical resources. Preventing connection exhaustion is one example. It also provides a uniform language independent way to interact with the relational data, allowing us to add even more clients in other languages later on. The service encourages good client behavior by restricting the set of possible queries that clients can do by providing a limited API. And it simplifies operational management of our relational data resources. And this is key in enabling the team to rapidly build out more sophisticated strategies, including the ones I'm about to share. So next, I'll talk through how we were able to increase the utilization of our replicas. So as the demands on the data access layer started to grow, we were seeing the load on the masters increasing at an alarming rate. And we knew that the single masters couldn't handle the load for very long. But while the masters were holding on for dear life, the replicas were living a life of leisure, hardly doing anything. At Box, we use asynchronous replication for our replicas. And so our replicas can be lagged at any point, and they're not guaranteed to contain fresh data. And so the only requests that we were sending to them at this point were those that could tolerate stale or inconsistent data. But given how important consistency is to our application, you can imagine that we didn't have a lot of traffic that fit the bill. And so our goal at this point was to get better utilization out of our replicas. So we started out by trying to get strictly consistent reads from replicas. And any algorithm that we would implement for doing this would start with asking the question to the replica, are you caught up? If yes, then the answer's easy, you read from the replica. If not, then we need to do something else. And so we have a couple options for what that might be. So first option, if the replica isn't caught up, you just fail the request. Now that might work most of the time when you're rarely lagged, but during periods of sustained lag, you'd be failing most, if not all of your replica bound requests, making this not really a viable solution. Now, second option is to fall back to the master. Now that sounds like a really good compromise, right? The best of both worlds. We'd get increased usage from our replicas for the majority of the time, but then don't have to resort to failing requests whenever lag is high. But it's a really bad idea. Why? Because in times of sustained replica lag, there's a good chance it's because the master is getting inundated with writes and struggling to keep up with those. And in that moment, if you flood it with all of the requests that were supposed to go to the replica, well, there's a pretty good chance you'll take the master down as well. So if we can't trust that the replica will be immediately caught up, which both options 1 and 2 do, the other option is to wait for the replica to catch up and then keep retrying until it is. And this seemed pretty promising for us because we had identified quite a bit of traffic for which it was acceptable to sacrifice a little bit of latency for consistent data. But the problem with this strategy is that there isn't any guarantee that the replica will catch up to the master in a reasonable amount of time, basically before the request times out. But it actually doesn't have to catch up fully. And that's the key insight to this next strategy. So the reason we wait for a replica to catch up to the master is so that we can achieve read after write consistency. So this diagram here represents writes that happen on the master and when they are replicated on the replica. So in this case, you can see that the replica is lagged by a couple writes. And so say the client did a write at T0 here, represented by the blue box, and they want to observe that write on the replica when they go to read from it. If they try to do that at T1, it still won't have that write, so they won't observe it. Same thing at T2, until at T3, they will observe the write, and that's what they need in order to achieve read after write consistency. However, at T3, the replica still isn't caught up to the master. And if we continue to use that check of using basically replica lag as a way to see if we've achieved read after write consistency, then we're missing an opportunity at this point to do the read that were actually safe to do. And so we've come up with an algorithm that takes advantage of this insight, basically that we only need to wait until the replica observes our write, the one we care about, and not all writes. And so we do this by having the client keep track of the master position after the write that they care about. So the write that happens, or the position that after the write that's represented by the blue box. And then when the client goes to read, they pass in that master position, and the server knows that they need to wait for that and not for the replica to be fully caught up. So there's a lot more details and complexity to this. And if you're interested in learning more, please take a look at our blog post on this strategy. And by implementing this, we were able to offload 50% of our master reads onto replicas. So to summarize, the strategy that I just outlined exploits a couple properties of our traffic. It takes advantage of the fact that we have many reads that require read after write consistency, but can tolerate some latency. And many of our reads are actually occurring minutes or even hours after the relevant record was mutated. And so those reads don't even have to wait on replicas to catch up in order to get the read after write consistency. So one unfortunate side effect of moving more traffic to replicas is that the number of objects that we were able to cache decreased. And so let's talk about why and how we counteracted that. So at Box, we use look-aside caches. So our caches are populated during a read. So when a read comes in, we try to grab the object from cache. If it doesn't exist, we read it from the database and then set it back into cache. On a write, though, all we do is once we do the write on the database, then all we do on the cache is delete it. And so because of this caching policy, where we read from, whether it's the master or the replica, directly impacts what value can be cached. And so one invariant that we maintain in our caches is that we only cache the freshest values. And so caching what you read from a master is always safe to do, but caching from a replica is sometimes safe to do. And then you have the logic for figuring out whether or not it's safe to cache is pretty complex. And so at that time, we opted not to do it. And that's why when we moved our queries to replicas, the less content we ended up caching. And so we wanted to counteract that. And so we employed the following strategies to increase cache utilization. So first, we cached values that were read from caught up replicas. And so as I mentioned before, when we were reading from replicas, we're focused on finding out, is the replica caught up to the client's desired position in order to know if we should do the read? And we continue doing that. But while we're there, we also check if the replica is caught up to the master. And if that's also true, then we're able to cache the value that we read. So even though I talk a lot about what happens when a replica isn't caught up, the fact of the matter, at least for us, is that a replica is often caught up. And so even though none of the algorithms that we have can rely on a replica being caught up most of that time, we can still take advantage of that fact in order to cache what we read. So the next one is one of my favorites due to its simplicity. So we cache the fact that an object doesn't exist. And usually when you think about cache, it contains a value that we read from a data store, and we expect that it'll be asked for multiple times. You don't think of it as caching the answer to a question, and the question in this case being, does this object exist? But that's what we did. So when a read comes in for an object that doesn't exist in the database, we place a sentinel value in cache for that key, meaning it doesn't exist, don't bother going to the database. Once we did this, about 10% of our cache hits go to these non-existent values. And that's a pretty significant number of queries that we were able to offload from our databases. And finally, can't do a section on caching strategies without mentioning leases, which is a concept originally described by the Facebook paper in 2013. It's most useful for records that have lots of read and write activity within a short period of time, which can result in thundering herd of requests on the database. So if you're not familiar with a lease is a temporary value that you can place in cache, and you can think of it as a lock that only allows only the leaseholder to read the record from the database in order to replace the value in cache. The remaining requests that also want to read that value end up waiting until the lease is fulfilled rather than going to the database to fetch the value themselves. So we implemented the algorithm that's described in the paper and found it to be incredibly valuable in protecting our databases. One side effect, though, of leases is that it can occasionally result in a bad client experience. So if a client request is waiting on a lease, it's possible that the record associated with that lease is getting so many writes that the lease is continuously invalidated. And so the request, when it sees that the lease is invalidated, the algorithm is that it tries to become the new leaseholder. But if there are many different requests that are all waiting on that lease, then they'll all try to become the leaseholder. Only one of them will win, and it's pretty unlikely that a particular request will win. And so this can keep happening until basically the request times out. And so this was a problem that we had, and we extended the leasing algorithm to fix this problem by employing some of the same read after write consistency tricks that we did with replicas. It's pretty complicated, and we're in progress writing a blog post, which should come out pretty soon. So look out for that on our tech blog. So let's summarize the traffic properties you should look for if you want to use these caching strategies. So we have many reads that require read after write consistency are repeatedly read. Records that don't exist are repeatedly read. And finally, records undergo heavy read and write activity within a short period of time. So switching gears, let's talk about how we rate limit at the data access layer. So the next biggest issue that we faced were occasional spikes in traffic from some users that would result in degradation of a database. The spikes were pretty sporadic, usually sudden, and they were short-lived, but they left a spike of errors in its wake. At that time, we did have other methods of throttling users within Box, but they were all at higher levels, at the application level or above. And the problem with that is that they couldn't accurately assess what the impact of a particular request would be at the database level. And so we decided that we wanted to implement rate limiting dynamically at the database level based on actually how much of a database resource a request is taking up. And so our data access service is distributed. And so there isn't any one actor that has a full picture of which users are, say, using the most of database resources. And so often the first instinct when trying to throttle in such an environment is to create that single actor where the information can be aggregated and used to make a decision. Usually you use some sort of external shared storage. But that doesn't work too well when we're talking about low latency, high throughput service. First, you have the additional round trips that are adding significant latency to your already low latency requests. And then more importantly, the new resource adds a single point of failure that during a spike of requests, which is when you most need that rate limiter, the shared resource is likely to become overloaded and fail itself, rendering it not very useful. And so we decided instead to look for an approach that would satisfy these set of requirements. So we wanted decentralized information propagation, no shared storage, but instead the hosts have the information themselves. Needed it to be fault tolerant. We have hosts often going in and out of the cluster, and we need the rate limiter to be able to recover on its own without having any manual intervention when that happens. And fast convergence, because this information is decentralized and needs to be, make its way across the cluster. It's important that the information do so quickly following a spike in traffic so that all of the hosts are ready to rate limit before the spike in traffic can result in serious database degradation. So what we ended up using was largely based on this paper that describes how to compute sums across a distributed cluster. And the idea is that each node has its own local value, and we want to reach a state where every node is able to accurately arrive at the sum of all of those values. And the paper proposes an algorithm called push sum protocol to do that. The protocol is made up of many diffusion rounds. In each round, each node chooses a random other node in the cluster and sends out its local information. The receiving node takes that information, adds it to their own local info using a formula that's described in the protocol, and it comes up with a new local usage. And then next round begins and it sends out that information to another random node. And so we keep repeating that. And after a certain number of rounds, which is based on the size of the cluster, the paper proves that there's a high probability that all nodes will have the same and correct sum, or at least very close to that. So the protocol I just described is defined as defined in the paper only works when you're talking about a single moment in time. Traffic, on the other hand, is continuous, and we need to keep calculating usage on an ongoing basis. And so we took that, that protocol and then made a streaming variation that would work for us. So instead of having just one point in time, we break time up into intervals, and the nodes are accumulating information about multiple intervals at the same time. And so here, this node knows about time interval T0, T1, all the way to T4. And T0 is the oldest time interval, and so it's been through the most rounds of gossip. And then T4 is the most recent, and so it's been through the least rounds of gossip. And every node is doing the same thing. They have their own view of all of the different time intervals. And when we gossip between the different nodes, it sends, you know, everything that it has. When a host receives that information, it aggregates the information using push sum between the same time interval, right? So the T0 values are aggregating using the same push sum. And then once a time interval has been gossiped about for a target number of rounds, so here, if we say we need 40 rounds, then this one has been through the target number of rounds, and so we can stop gossiping about it because we've decided that consensus has been reached, and so that information can be removed and instead used to make rate limiting decisions. So at Box, we have 40 diffusion rounds, and we get convergence within 4 seconds. And the traffic property that makes this particular rate limiting work is that we were getting occasional bursts of traffic, and they could all be identified being sent from the same entity. So either the same user or a lot of users all within the same enterprise. Cool. So far, we've talked about replicas, cache, and rate limiting. And those, for the most part, are all designed to scale reads. And it makes sense that those were the priority for a significant part of Box's history, since the vast majority of our traffic is reads. But it finally came time to focus on writes and how we would optimize them. So for a majority of our history, most of our writes needed to be immediately committed as they were part of a customer request. And it was only more recently that we were getting more and more writes that could be delayed and done asynchronously. And some of those asynchronous writes were a result of a customer action, but many of them were kicked off internally. So things like data migrations. And these tended to be larger in volume and would result in significant replication lag, putting our high availability at risk and rendering some of those replica read strategies that I mentioned less effective. But we had no mechanism to dynamically put back pressure on these writes to slow them down. And so we decided to build that. And we started by tagging our writes with the quality of service that they required. So we have high QoS for those in the customer request path that couldn't be done asynchronously, and then low QoS for everything else. And the high QoS would always succeed, while low QoS requests would only succeed if none of the replicas were significantly lagged. And this framework not only prevented these lower priority requests from causing degradation to our databases, it also provided a pretty nice client experience because it gave clients a feedback loop and allowing them to dynamically regulate their rate rather than having to guess at a safe request rate. And then the other big win was that we were able to get better utilization of our master database because we shifted more requests to off-peak times, essentially allowing us to flatten the curve of database traffic. So once we rolled it out, we realized one problem is that we had bucketed all of our async traffic together into like low QoS, but actually they required different qualities of service. So the traffic that was triggered due to a customer action, it could be delayed and retried, but it was important that it eventually commit. And then we had traffic that was kicked off internally of lower priority, and it could actually be abandoned if absolutely necessary. And so we decided, rather than bucketing those together and treating them the same, we added a level in between, medium QoS, for the customer triggered traffic, and the medium QoS would go through if the lag was, say, below 5 seconds, while the low QoS would only go through if lag was below 1 second. And that worked really great. It made it so that low QoS traffic could never succeed while the medium was failing. And after we built out this framework, we've had 20% of writes able to move on to this new framework. So that's been really good. And finally, the traffic property that we took advantage of here is that many of our asynchronous writes could be delayed or dropped if necessary during times of degradation. And so there you go, an abridged story of how Box's data access infrastructure changed and grew over the last decade. We, as the data access infra team, know so much more about the breakdown of our traffic compared to when we started on this journey. And if there's one lesson that I've learned, it's that it's really important to understand the properties that your traffic possesses. In fact, it's key to building the optimal data tier for your company. You saw that by identifying the properties of our traffic, we were able to exploit that traffic to get better utilization of our existing data access tier, our replicas, our caches, our master databases. And after putting this presentation together, I'm even more motivated to go back to our own traffic and see what else I can dig up. And hopefully I've inspired you to do the same with your own applications and given you some ideas of strategies that you can use if they apply. And I'd love to hear what has worked for you and your applications. Cool, thank you very much. Thanks for your time.
Thank you very much, Priyanka, for that talk.
Sure.
I'm just watching. I don't see anything in the Slack channel, but we are pretty tight on time. I figured maybe I could toss out a real quick question for you right now.
Sure.
You went through a variety of different strategies, and I wondered, did you come across any strategies that didn't end up working out as well as you'd expected?
Sure. Actually, one of the strategies that I mentioned, which is to cache the fact that an object doesn't exist in the database. So we have multiple caching tiers, and we're caching different types of traffic. And while it did work out really well for one of our caching tiers, we also implemented it for a different caching tier. It didn't work as well for that. And so it's very traffic dependent. And even these strategies, even for every particular use case, sometimes it works, sometimes it doesn't.
Thank you very much. Thank you. Okay. Well, with that, thank you for delivering your talk. And we're going to move on with the next segment. We're going to move a little bit away from MySQL. And it's with great pleasure that we've got Kyle Davis here from Redis Labs. And his talk is titled Declarative Caching with PostgreSQL and Redis. Kyle is the head of developer advocacy at Redis Labs. Before he joined Redis Labs, he worked as an independent full stack architect and code quality consultant. Kyle's authored a book which is titled Redis Microservices for Dummies, published by Wiley, and has written extensively about developing with Redis. Kyle holds a Bachelor of Science from the University of Southern Indiana and a Master's of Science from the University of Central Missouri. Kyle lives in Edmonton, Alberta, Canada, with his wife and 8-pound dog named Mr. Button. And I hope at the end of this talk, he can show us how to properly pronounce the word about. So with that, I welcome Kyle to the stage. Thank you.
Hi, everybody. My name is Kyle, and today I'll be talking about declarative caching. It's an interesting little way of doing things, and so let's go ahead and just get started with this. This is me. If you can't see, that's a great picture of me. You can find me at these different places at the bottom of the screen there. Now, one thing is, I've been using databases for a long time, and really, it's a misspent youth that I had on databases. My first database was DBase 3, and then I graduated DBase 3+, and I thought there couldn't be anything better than this. And that was in the 80s. I wish I'd rode my bike more, but now I'm using those skills that I earned as a small child interested in databases. But I want to talk today about Redis more specifically. Redis is an in-memory database, right? And it's really interesting because it's really grown up over the years, and it's used for a variety of different use cases, operational, analytical, or hybrid types of use cases. But what is it actually? I can say that spiel over and over again, but what is it actually? Now, the first thing I want to talk about is what Redis stands for. And nominally, it's Remote Dictionary Server. Now, that's a little bit of a misnomer. In fact, Redis is about 10 years old. It was created by a guy named Salvatore Sanfilippo. He's in Sicily in Italy. And I was interviewing him at our 10th anniversary and I asked, expecting to get Remote Dictionary Server, what is Redis, right? What does it stand for? And he actually told me that it's a bit of a backronym. And in fact, we started with the domain name, Redis. He wanted a 5-letter domain name and it was available. And then he figured out how to fit it in. So that's the story behind the name. But the great thing about Redis is that it's very transparent. It's really easy to figure out what's going on with it. This website that kind of birthed the name of it, Redis.io, is the great documentation website where you can find out the entire computational complexity for every single command we have in the engine. If you don't know or can't find whatever you want on the documentation site, you can actually go and take a look at the source code. The source code of Redis is written in super clean C. I was of the era of developers that I thought it was impossible to write clean C code, but this changed my mind. And in fact, I use it as a reference all the time because it's so easy to kind of figure out what's going on inside of Redis. So it's right there on the screen if you want to go take a look at it. Now, I work for Redis Labs, and Redis Labs also produces Redis Enterprise. Redis Enterprise is an multi-model database built on top of Redis. And really, it's great for, enhances the operational characteristics of Redis. And so if you're a small company that uses, just a ton of Redis because your product is such that it needs to be real time or it needs to have things straight up incredibly fast, then Redis Enterprise is for you. Or if you're a large organization and by nature of that size, you use a lot of Redis, then Redis Enterprise is for you. But today I want to talk about something that's maybe not the biggest use of Redis. I mean, it's huge, but it doesn't require you to be running at giant scales, is caching. Now, caching is a pretty simple concept for the most part, and it starts out in a very, simple world. And that becomes where you have a database and application server, whether that be on a VM or a container or whatever. But the reason it starts out kind of simple and then it starts to go a little bit sideways is because databases are pretty complex things generally, and your application servers are probably a pretty simple thing. And then when you start using your application server, you can easily go to a situation where you overwhelm your database server, and so it kind of causes some problems. You start pushing more and more traffic to the database, and the database starts to suffer a little bit. And what you do at that point is you implement caching. And caching is a very simple concept. Basically, for the most part, and the simplest form of caching, which we'll look at today, you're doing your writes into the database and your reads are coming from a cache, in our case, Redis, right? So this enables you to do things and like having a cache that performs at a much higher rate than the database does just by nature of it doing kind of simpler operations. Now, it saves the day with performance, and this is something that happens. The classic scenario is you have a situation where you have your database, and it takes 100 milliseconds, say, to populate the cache, but 9 times out of 100, you're pulling it from the cache, and that takes 1 millisecond, right? So you're saving huge amounts of time for the majority of things that you're going through. Now, the other thing is when you're looking at scale, and scale is a little bit of a different problem with load and scale compared to performance, but it solves it in a very similar way. So let's say that you have a database that's doing, these are just made up numbers, this for whatever size this is that could scale up or down, depending on how big your instances are and what your database can handle. Let's say you're doing 10,000 queries per second, and that leads to a 95% CPU utilization. And what do you do at that point? Do you scale out your database? And if you scale out your database, sometimes that's very difficult or very expensive, or it can be something that would be, just impossible because you painted yourself into a corner, which some people have done in the past, and including myself. And so you're kind of stuck. Well, caching comes in and really saves you there. So let's say that you have a situation where you're only pushing about 1,000 queries per second, and then the other remaining ones are being pulled from the cache. So now your CPU utilization is lower, right? These are pretty simple concepts to grasp for the most part. However, things can get a little weird. Basically, you think, that's great, I'm going to cache everything. And then that's where it gets weird, right? You might think, okay, well, I've already got a fast database. Everything's running well. The database is pulling things at 1 millisecond. It's got 2% CPU utilization. I need to add caching to it. Well, that doesn't really help you any, right? Because it's already fast. Now, when we take a look at that, you got to think, like, it's not rational to cache anything that's already fast, right? You kind of have to have a performance budget and figure out how your database fits into that performance budget. Now, what happens if you already have a fast query and you try to cache it? Well, actually, the opposite tends to happen. It doesn't increase your performance. So you still have to do your repopulation, and that takes some time because there is latency between the database and the cache. There always is. There's always latency between everything. And then you have to pull things from the database as well, right? So you have potentially what you think was going to be a less amount of time ends up being more, because latency can add extra, or caching can add extra latency to your overall application end-to-end response time. So that's one scenario where maybe you don't want to do it. Another scenario is where you're actually what you're doing probably doesn't make a lot of sense to cache. In this case, let's say you're going through a user flow, for example. So a user, this is very simplified by the way. Let's be honest, when you're doing user flow, you're doing all sorts of authentication and things like that that are in the way, but you'll get the concept here. But you're going to a cache and you're asking if a password is there and be hashed and be refreshed every 60 seconds. So that 60 seconds is important. You know, the user goes in to change their password, right? That is written to the database. But notice we haven't updated the cache yet, because a lot of times you don't update the cache synchronously. And then 15 seconds later, they log out and say, I want to log back in. And what happens is the database hasn't caught up, right? It's something that is showing you a previous view of the data. And then it says the passwords don't match. You have a very dissatisfied user because they just changed their password. And I'm sure I have run into this scenario before where you changed your password and then it says it's not right. Everybody has been there. And I think that's probably bad caching. But you know, these sort of things are not just caching related to caching passwords, but other things as well in your application. You post something on a forum or something and it doesn't show up for a few seconds. It seems weird to users. And you don't want to do that. Another thing you don't really want to cache is when you have a scenario where you're doing something sequentially or you're doing a lot of queries over and over and over again, and you're caching everything. What this does is make the cache go crazy. And at that point, the cache is basically just saying, I'm just going to cache everything, and the important stuff isn't cached, but the unimportant stuff is, because your cache is full. This is a function of the fact that caches are generally smaller than the primary database, which they are being referred to. So there's a lot of things where you want to have logic in your caching. You want to be thoughtful about what you're caching. Now, shifting gears a bit, let's talk about how you know, caching might look. I'm going to give you some examples of pseudocode here. So this is a very simplified, non-language specific. It looks a little bit like JavaScript, but because that's one of the things we'll be looking at today. But let's say you have a query here, a very simple dumb query from you know, that you do the first day of learning SQL. You basically hash that query and you'll return a key. The key is then used to see if it exists in Redis. The key is how Redis accesses data. If it doesn't, then what you're going to do is you're going to actually do the query on the database, store that data in your application, then set it at a key in Redis, and then set an expiry on it. So every 60 seconds, it'll kind of go away, right? If it isn't refreshed in any way. So after that, then you take and you send that data back to the user, right? Very simplified flow. And this is something you'll be doing all the time. But think about this. When I was talking about it before, you're going to be going in and testing if things are working the way you want them to do, and you'll probably be adding and removing caching depending on the need of your application. And the way most people handle this, unfortunately, is they just comment some stuff out, right? I don't like that. I think it's pretty bad from a code quality standpoint, especially. So why? Well, one thing is it creates boilerplate. Two, you have hard to understand code. You introduce a subtle surface for bugs to crop up. You tightly couple all sorts of things together. And when you go into the real world, it gets way more complex than the pseudocode I just gave out. So let's see here. How does it work? When you're talking about hard to understand, what's going on here? You've commented a bunch of stuff out. Well, you've just added 6 useless lines of code into your software because you're not really using it, right? So your code is longer. Longer is hard to understand. But comments have a tendency to be sticky. If you've ever worked with a large code base for a while, you know it's just full of comments and commented out code, and that doesn't lead to anything really beneficial. Even though that might not be up to our standards, this is life, right? And then a junior staff member on your team might go up and look at it and say, why is this here? Does it not work? Or was it not performant? Or was this something we're trying out for a future version? What's going on here, right? So, you know, having just kind of useless lines of code is never a good idea, right? It's just not sanitary. But the surface area for bugs is where you get into some real problems. So in this case, you probably looked at this and said, this is basically the same. You know, I did a little trick here where I kind of took the code away, and it's hard to point out the bug here. Well, the bug here actually is where you're taking the key that you're generating that you would be using for Redis, and you didn't actually comment that out properly, and you're trying to query that in with your query with SQL, right? And it's just going to be a bunch of junk characters, and SQL is going to return an error. And you might think, why? That looks like a perfectly normal query. More insidiously, the bug looks like this. In this case, you're thinking, what's going on here? This will work for a few seconds, and then it will stop working, which is the worst kind of bug. In this bug, for example, this looks almost identical to the last one. Basically, what we're doing is we're going and getting the key, and the key might be somewhere else, and it might be something that you already have in the cache. We're never actually running that query, so potentially what can happen here is you're getting the value out of it, and then it's just the cache value, it expires out, and then 60 seconds later, it doesn't work. That's the worst type of thing. It's kind of like, you know, if your car makes a clunking noise only when the mechanic's not around. So the other thing I like to talk about is kind of how you're coupling everything together. This is going to create a lot of boilerplate. It's going to be tightly coupled between your cache, your data layer, and the query itself. So where do I come from with this? Well, first thing, you're tightly coupling to your database or to your caching layer, Redis in this case, and you're not providing a lot of abstraction layer here. So if you want to change something, what happens if the client changes? And in our case, this is happening. Redis is introducing a new protocol just in this last version, and the next version will be mandatory. So you're probably gonna have to change your actual application. So you know, this is something you have to do, but maybe you are also going to change your database client library. And these are all things together, but you've also coupled everything together. And think about if you have, you know, hundreds of thousands of lines of code and you have to change every time you make a database call, that's going to be painful, right? So what's the solution? And the solution really lies with the two concepts that are probably something you hear all the time, but I just want to go over them: imperative versus declarative. You know, imperative is about what and how. So as an example, if you want to tie your shoes and you tell somebody an imperative instructions on how to do that, you're going to have very specific instructions, taking each lace in each hand and moving them one over another. That's an imperative instruction set. Declarative is what, but not how. And that means just tie your shoes, right? Like that's how the instruction that you're giving instead of doing each individual step. Now, going back to imperative, some markers of this are basic logic statements, for loops, these sorts of things. And recipes, I'll get to that in a moment. I do want to go over what declarative is, and then I'll talk about the contrast here that I see. Declarative, actually SQL is declarative, and Redis is declarative, HTML is declarative. These are all declarative operations that you do in your day-to-day life. So in HTML, for example, you wouldn't say, you know, here's how to draw each line on the button. You can define that in CSS, which is also declarative. But you don't say, you know, go up 10 pixels and down 10 pixels, and you don't tell the database engine how to operate on every single bit. And you don't even do that in Redis that often. But the contrast here is like if you're ordering food for the drive-through window, that's declarative. Basically, you're saying, give me a cheeseburger, right? Imperative would be going up to the window of the fast food restaurant and saying, hey, take a bread and then some meat on top of that and then some cheese, and I want lettuce, tomato, and onions, and put another piece of bread on top of it. Of course, that's not how the world works. So really, when you want to do something relatively complex that's repeatable, declarative is the way to go. So here's our imperative example. We've seen this over and over again. And of course, we've talked about the problems of it. But what we want to do is take this caching that we're doing here and then move it into the declarative world. How this looks is basically the history behind it more specifically, and we'll get into how it looks in just a moment. Basically, the idea is SQL's declarative, but if you actually integrate the caching control within the query itself, while still having an external cache, you can actually gain a lot of elegance to your code. Gaius was one of the original idea. He wrote the Postgres client called Slovnik for Node.js. And basically he has this concept of interceptors. And interceptors are this middleware layer that sits between the client application, the client library, and then the remote database. And so you can set these up to modify them or do whatever you want to. And it's kind of an interesting use of it. He wrote a blog post about it, I think in November of last year, and saying this is possible. And I thought, this is a great idea. I do give him credit for it. The Redis implementation is something that I wrote. It's not very long. It's pretty easy. I think it's less than 60 lines. And you can get it at this GitHub a link here, and I'll have this at the end as well. But when you start looking at this, let's contrasts the two pieces, right? So you have imperative on this side, and then on this side, you have a declarative, and it looks a lot nicer and a lot cleaner. We'll break it down, but basically you have so much less, there's no logic statements, it's smaller, and it's really easy to maintain. And that's important to be able to maintain everything. So let's break it down a little bit. First things first, I've been using Node.js for years and years and years, and I had actually never seen basically tagged strings that come before the backticks if you're doing interpolation type of syntax for strings. I'd never seen this before, the Slonik client. That looks a little foreign to me, but it's easy to get used to, just 3 characters. And then you have at the end, you have a SQL comment that's actually being interpreted by the client library interceptor. And then that's actually controlling caching. So here you're just adding a few extra things to it in something that's kind of safely contained in that. And then you're just saying, cache it for a time to live, a TTL of 60 seconds. And this will be passed into the plugin and through Slonik. And then it'll eventually get to your database, but it'll be ignored because it's a comment. What's really cool about this is it's very easy to remove this and not really change the flow of your application, right? This is just deleting things back and forth and playing with that makes it very maintainable. So what's actually happening as far as Redis is concerned? Now, basically with Redis, when we see this here, we're going to actually do the setex command, which is a little bit of an obscure command in Redis. It's supported all the way back to, I believe, version 2, and we're on version 6 now. But basically, this says set with an expiry built in. So we're optimizing already. The key name is being made up of a prefix, which we'll use for namespacing, and then we'll hash using various hashing functions. You can choose those, I believe. But the hash will actually take and encapsulate the whole query, so you get a very regular type of key in Redis. And Redis is based on this idea of a key value type of database. It's a little bit of an extension of one, in fact. But so everything is accessed by key. And then the first argument here, the 60, is where we're saying cache it for 60 seconds. And of course, if I change that 60 to 120, we cache for 120 seconds, so on and so forth. And then we're taking the results from the database and storing those as the value in Redis. When we're fetching data out of the cache, we're just going to use a plain old get, which is one of the basic commands of Redis. And we'll be able to reverse it out because we're supplying that same query. And of course, this works with all the extensions and where you're inserting values into queries and everything like that. It's quite easy. Now, one thing I will tell you that was counterintuitive to me is when you think about this, if you have the same query and you cache it with a TTL of 70, and then you cache it also with a TTL of 60, that will actually duplicate twice, or duplicate, you don't have to duplicate twice, but duplicate the value in the cache. So you're not only having one value here, but it will, it's fine because it'll reason itself out and will be able to retrieve those and have 2 different types of expiry, because maybe you'll have 2 different contexts in which you'll call them. But if you had different TTL values, different expiries, you could actually fill your cache up quickly by changing that TTL value. So it's a little bit counterintuitive. Now, I want to run a demo, and I'll tell you, this demo is pre-recorded. I did find out that my demo did not run very well when it was being recorded with Zoom. As soon as I turned that on, my underpowered laptop, which is getting replaced in 2 weeks, decides to make everything run to a crawl. That's life, right? But basically, we're running a load generator. The load generator is going into a table that's pretty straightforward. We have a user ID, a username, an email, and a created app. And it's being filled with fake data. So this data is being randomly generated. It's doing it every 50 milliseconds, right? Then the query side, we're running two things at once. We're doing kind of a hard query. It is basically where we're using regular expressions, which is kind of a nightmare. And sometimes you have to run these, but the reason I chose this one was that the longer I run it, the harder the query has to run, right? Because we're not really indexing regex, and this is probably less than ideal, but we all have those queries that run less than ideal. But I'm putting a cache TTL a comment in it, just saying, hey, let's keep that around for 10 seconds, right? So that's being interpreted by Slonik, which is actually doing the caching for us. And it will run also at the same frequency, but not at the same time. So let's go ahead and run my demo. First off, what's happening here is I'm going to go ahead and get my demo ready. I'm going to run the population step here, which will start pushing in the data. And then I'm going to go ahead and do this. Now, right now, on the top part of the screen here, it's running without any type of caching. So it's running 16 milliseconds. It'll probably trend upwards in time the longer we run it. Now I'm going to simply add in the caching, and that will just be that one little line I copy and pasted in. Save that. We'll start it up. And so now we were running at 16 milliseconds. Now we're back down to 4 milliseconds. And you can also see the email count's not going up regularly because it's being cached. You saw here where it went up, and we're still pushing data into it. So it can really save you. I mean, we're almost 4x here of time just on this kind of local host demo that we're running. And it will kind of stay stable at around that 4 millisecond mark. And this is all running just locally, and of course you could scale it up or down depending on not running on a slow laptop. So what's going on here, and maybe where do you stop, where do you go next, that sort of thing. Well, first things first, this is a cache aside. There's various caching patterns: read through, write behind. Cache aside is probably the simplest, and it's exactly what I explained before. So the cache is kind of off to the side. Redis supports many of these. In fact, as of last week at our developer conference, we now support write behind. Where you write to Redis, and then that is then put into a query after the fact. So Redis is your first stop for your data. Then you can read from that too. So Redis manages everything from there, and that would work for a variety of queries, but it wouldn't work for every query. So there's two different use cases. It's always good to kind of think about your caching patterns. This is using Redis as a blob storage engine, which is kind of the most basic and kind of dumb use of Redis. Redis has a lot of power to it. There's 200 commands built in, and then those have various data structures. You can, if you really want to be optimized with your caching, you can actually do more optimized things with it by using those data structures in those data types. And in fact, Redis has a module system where you can plug things in and do even more things. So for example, there's a write behind system with Redis that it doesn't use declarative caching, but it allows you to take a relational database, MySQL, Postgres, or whatever, and then take that data and also write it into a graph engine, for example. We have a graph engine built into Redis as one of our modules, so you can write it in multiple places and do some very sophisticated things. It's sensitive to a number of things. Of course, that's similar queries where if you saw the slide where I was writing a bunch of stuff sequentially, it will not save you there, right? It will not save you from doing something really limited in understanding, let's put it that way. And then the whole cache TTL differences, those are very serious limitations on it. So if you're not careful, those two things can fill your cache up, and your performance will not be any better because you're constantly refilling your cache, and it's not really logically there. This is Postgres in Node.js only. I am currently writing the MySQL version of this, and that's something I'll be doing on my stream. So hopefully we'll get that, and we'll start knocking out other things. We have some plans for Python as well. And these are just, this is not my #1 job priority, but it is certainly one that I find very interesting, and it's kind of the thing I always wanted. So it's always great when you're writing things that you want to use yourself. And if you use ORMs, this is not going to provide you any value. Of course, an ORM can provide their own caching engines, and sometimes they often work with Redis as well, and it's just a matter of plugging those in. Now, I want to get to one other section since we have a little bit of time, geolocal caching. If you're looking at the map of the US, if you're going to the best case scenario, the latency from East Coast to West Coast is about 40 milliseconds, and that's limited by the speed of light. You can't go any faster than that. So it doesn't matter if it's an electron or a laser beam, 40 milliseconds from East to the East Coast. Of course, the curvature of the Earth comes into play, and if you're a flat earther, then you don't believe in that, but you're probably not doing a whole lot if you're a flat earther. Now, realistically, data transfer is probably going to be along the lines of 85 milliseconds. 85 milliseconds is because you're routing, you're not going in a straight line, and all sorts of things like that. Now, at Redis Labs, we talk a lot about things being needing under 100 milliseconds. And that's the instant threshold. If something happens end to end in less than 100 milliseconds, then basically you have something that is instant. It feels without delay. Anything above that, you can sense that as a human. That's our human perception threshold. Now, so let's get into a little bit more of a specific example. So you have a primary database on the West Coast, and you have a cache on the West Coast, and then on the East Coast, you have somebody in Boston making a request. Now, that's going to be bad, right? Even though you're caching, it's not helping you because of geolocal or geo distance, right? The time it takes to traverse that. Now, you might say, well, I'm going to add a caching layer on the East Coast. Well, what happens there, right? It's still bad when you're having to, when you're getting from the cache, it's good, but when you're just getting repopulated, it's going to be bad. And you can end up with caches that are different at this point, because when one side's updated and the other side's not, and it really does kind of cause some problems for users. Redis Enterprise has something built in called active-active distributions, where you have two clusters, and those are peer clusters, and they actually replicate from one to the other, and you have to have your one primary database. And what's really cool about that is if somebody on the West Coast updates a given cached value, it will automatically synchronize that with the one on the East Coast. And in fact, if there's conflicts, it will resolve those conflicts automatically. So in that way, you can then have kind of this worry-free geolocal caching where you're not going to get into situations where you're going to be out of date. So what's next? Grab the module. You can get it on npm or the GitHub link on screen here. Play with the demo. That's also available on GitHub. With the and microphone with the other one, and then subscribe to my newsletter, and it's available here. It's about once. So if anybody has any questions, I'd be glad to talk about those now.
Kyle, thank you very much for that very informative talk on PostgreSQL and Redis. I'm just taking a look in the general chat. I don't see any questions as of yet, but like with other speakers, I've got a couple ready. So I'll put one out there right now. You spoke of Node.js and PostgreSQL. Is it possible to do this with other languages or databases?
Sure. Yeah. We're working on Python for sure. I'm working on MySQL, and I think that this is a very simple thing to implement for us. We just have to have a little bit of way to patch it into the library, and it's very effective.
Okay, thank you very much. And maybe time for just one more. Redis is an in-memory data store. Or do you need to rebuild your data from scratch after you have an outage?
I'm sorry, the audio cut out and I can't hear you.
Oh, I'm sorry. Redis is in memory. Do you need to rebuild your data from scratch after an outage?
I'm sorry, the audio is it's like a robot.
Is it just me? I'm sorry. Okay. I hope it clears. If need be, I suppose one of our other moderators will take over from me now.
I can hear you loud and clear, Michael.
Okay, thank you. Okay, Kyle. Well, thank you very much for your time. I appreciate the talk. Okay. And so this is the last talk of my little section here. I've been so grateful to be the one to be able to present so many of these speakers. The next speaker, I've known for quite some time. This is Alexander Rubin. He is an ex-Perconian. He's now working in an organization called Virtual Health, and his talk is based on creating an open source MySQL firewall. So I want to say first, privyet to Alex. Alexander has over 10 years industry experience with the MySQL database and related technologies. His specialties are performance tuning, full text search, high availability, database infrastructure architecture, and data warehouses. Pretty much everything. He's helped many MySQL customers design extremely high performance databases with optimized schema and queries. And before I hand it over to Alexander, I just wanted to highlight maybe an experience I'd had with Alexander going back a couple years at one of our conferences. The two of us had some heavy talks that day. And Alexander, I'm sure you remember this. It was a long day, and we decided towards the end of the day that we wanted to go out and see if we could find some beers and whatnot. And you mentioned to me that there was a great bar that you'd heard of. And in fact, having been at a database conference, you said to me, Michael, you're going to love it. It's a NoSQL bar. So I said, sure, I'm up for anything. So we go together, we walk down to this bar, and we're very excited to roll in there and have a little sit down. But do you remember what happened? We didn't stay very long.
Yeah, sure, I remember.
Yeah. And the reason we didn't stay long is in this NoSQL bar, we couldn't find a table.
Exactly. No table to join.
No tables to join.
Exactly.
No tables. So without further ado, I present to you Alexander Rubin.
Thank you very much. Thank you very much, Michael. Let me share the screen. All right. Michael, is it visible?
Yeah, we can see your screen.
Okay, good, excellent. So today I will be talking about creating an open source MySQL firewall. And I will start with this problem and solution. So what's the problem? The problem is SQL injection. And no SQL injection talk will be complete without this classic XKCD comic about little Bobby, who is actually doing an SQL injection. Bobby drop tables. So I will be going to demonstrate a really horror case of SQL injection. And one of the solutions that we will talk about is SQL firewall. It's pretty much the way how we can protect MySQL. So let's start with this. Let's create a simple app. I want to create a bookshop. And I will use the modern approach for this bookshop. Python for our language, MySQL is a database, API, JavaScript. So in this bookshop, I will use JavaScript for the front end, which will call API, which will in turn use Python to access MySQL. I have been searching in internet for a sample of the code, and I have created this purposely vulnerable API to demonstrate it. So what is bad here? Well, this is really bad. So what happens here is that we're taking the input from our user and place it directly into MySQL. So that is really bad. What will happen then is we can use SQL injection. Now, the worst part about this SQL injection is that it's so easy and so easy to execute. We don't need any tools. We can just use the URL to put anything we want there. So in this example, I just do 1 or 1, which will basically omit any other filters that I may have and dump everything from the MySQL. Well, you may say, well, this is a public API anyway. So what's the problem? Well, the problem is that our old Bobby drop tables will actually be able to drop table. And this is not good. But sometimes even worse is that a hacker can actually take over the whole MySQL. And we can actually do this union trick to dump all the users and passwords and basically do whatever we want. We can download the whole database. And if this contains PII information or PHI information, that's very bad. Now, this whole thing is because SQL is so flexible. And this is very good, but it's also dangerous in this case. So how do we actually download and crack MySQL passwords? Well, there is a tool for that, and the tool is called SQL Map. That's a very powerful tool for penetration testing, for security penetration testing, and it is very easy to use. So let's give it a try. What I want to do here is I want to download all users, download passwords, crack the passwords. The only thing I need to do is to pass those parameters to SQL Map, specify my endpoint. This is my test private network, and then specify the URL. Okay, so now what happens is that you can see that this is actually injectable. So it found the way to inject, to do the SQL injection. So what is next? The next is it will show us what the type of SQL injection I can use. And now the scary part. It actually was able to download the MySQL passwords and crack it. So these hashes are crackable. So we have figured out that this website was using a root user with a password MySQL. So this is also bad. So let's take a look. Summary, what went wrong? First is non-sanitized input. We trust our users too much. We take whatever we're getting from the user and put it directly to MySQL. That's bad. Second is we are using a root user with all privileges, including the system MySQL database. The whole reason why we could have executed this SQL injection and downloaded the users and password is because we're using the root user. And simple password, which were cracked easily without the need of any expensive hardware or whatever. Finally, I think that this case is basically relying too much on MySQL network protection. Keep in mind that MySQL network was not exposed at all, right? MySQL is protected. We are using the public endpoint to download everything. How do we protect? And my suggestion here is we need to use all. First of all, we definitely need to sanitize our input, and it is a good idea to use prepared statements. To sanitize input, we can use whatever available in your language. For PHP, for example, there's a MySQL real escape string, which will do some job to remove escape characters and sanitize the input. The second important thing is grant only needed permissions. If you have a database, a customer database, then it's much better to grant all on that database only rather than grant everything on star.star. And finally, it's a good idea as a secondary protection to use a firewall. And you can use the application, the wide area firewall, or you can use an SQL firewall. And after this long introduction, I will present the case of building an open source MySQL firewall based on ProxySQL. I have also created this very simple website, which I put some information there, and the slides will be available there as well. So what is ProxySQL? If you're not familiar with ProxySQL, ProxySQL is a proxy, a man in the middle, pretty much, which sits behind your application and MySQL. Because of that, ProxySQL can do things like rules, routing, and filtering. We are interested now in the security features of ProxySQL. So starting with ProxySQL 2.09, there are two interesting security features available. The first is SQL injection engine, which is supposed to catch the SQL injection automatically. And the second is firewall whitelist. So the firewall was inspired, the implementation of firewall was inspired by MySQL Enterprise Firewall, which is available in 8.0. And ProxySQL has created the open source version of that pretty much. So ProxySQL has a way to configure by both config file and SQL layer. If we want to enable those two security features from the beginning, from the start, we will use those two MySQL variables. It's called MySQL variables, but it's really ProxySQL variables. The first is automatic detect SQLi, and the second is firewall whitelist enabled. If you are not familiar with ProxySQL, the main way to configure proxy is to use MySQL command line and connect to the admin interface. Here we are using the local host, and we are using the specific admin port 6032. We use username, password. And here's a quick example of what we can do to display some information and to configure ProxySQL. I will not talk about how you actually configure ProxySQL, how you display the information apart from the security. There are lots of information how to do the routing with ProxySQL, but again, we are interested in protecting MySQL and creating a firewall. So let's start with the SQLi, SQL injection detection. Well, the good news is that it is automatic or even automagic, and it's easy to enable. But there is a big disadvantage, false positives. Unfortunately, the SQLi detection is blocking normal queries like select star from user or something like that. So there are so many false positives that it is really almost not usable. It is possible to remove those false positives, some of them, but I was not satisfied with the way how automatic SQLi detection works. And in reality, it is really hard problem to solve. We are trying to detect something that we don't know about. We don't know anything about the application. We're trying to detect it automatically. So if automatic SQLi detection doesn't work, what does? So let's take a look and let's try out and test firewall. We will use ProxySQL for that firewall. So let's change our app. So we will connect to ProxySQL. Again, ProxySQL is man in the middle. We will connect, we will change our database host from MySQL master, where I was connecting before, to ProxySQL. And then the ProxySQL use its own port, and this is MySQL port, pretty much, as opposed to admin port. Now, what's our course of action with a whitelist, with a firewall which will use the whitelist? We will have three things to do. First is train. We'll need to create this whitelist pretty much. So the first thing that we will need to do is to collect all good SQL queries. We will collect the digests of the queries because ProxySQL actually can generate the digest. And then out of that digest, we will create a whitelist. It's basically a rules. Then the second thing, the second phase is to test. So we'll set the mode to detecting and we'll check the error log. At the second phase, we are expecting to see some warnings. So at the detecting phase, what happens is that we say, okay, this is the set of the whitelist queries. Everything else is not good. But we are not ready to just block them yet. We just want to see what happens. And then after we are satisfied with our test phase, we can actually use the protect mode. We will disallow everything except for our whitelist. And we will do that by just setting the mode to protecting. Here are some examples. If we want to enable the firewall, again, we're using ProxySQL admin interface. We will just set that. We can set the mode to detecting or to protecting for all users or to specific users. And this load to runtime is a way how we'll save configuration in ProxySQL. So let's take a look. Again, this is our endpoints, our API endpoints, and we are training. So I'm visiting this website pretty much, and then I see the results. Then what I can see here is the queries. Here's the probably better slide to display the SQLs. So we are looking into this table called stats MySQL query digest, and we are seeing digest text and generated digest. So after we trained it, what we will need to do is we need to load. We will need to create the firewall whitelist rules. So what we're doing here is we are loading our generated digests to the whitelist rules. And then we can select from the whitelist rules and see that those are loaded. Okay, that looks good. So let's see what happens next. So then we will want to set the mode to detecting. Again, this is horrible practice, but we're still using user root, but we will be protecting this user. So now we'll do this load MySQL firewall to runtime, load MySQL variables to runtime to enable the whitelist, the firewall whitelist. So now we will be going to the website and try to do the SQL injection. The injection actually succeeded, but we will see in the ProxySQL log, in the error log, that it has identified the digest that is not in the list. So that's our detecting phase. That's good. Now, finally, we're protecting. Now, the real thing. We have set the mode to protecting, and now we are blocking injection. We are blocking SQL injection. And here's my API is in debugging mode. So that will show me the actual error. So we can see that ProxySQL will return an error, and the error text say firewall blocked this query. We can actually change that error description to anything else. So this is good. This is big success. And we can also test out our normal queries that we have trained. So this is okay. This is blocked. So now we can also test the SQL map again. And running SQL map will show this critical error, which is actually good for us. It means that this parameter, published parameter that we are trying to inject is not vulnerable. So we have created a firewall which protects us. Now, this is good, but it's not. There are things that we'll need to look for. We need to be careful. Whitelist-based firewalls by design are not smart. Pretty much everything that's not allowed will be blocked, even the valid queries. So if we will, for example, will request this website, this API, and specify published and author, that will cause the false positive. This is not the query that we have trained for, right? So this is a new field. It's also a combination of the fields. So whitelist-based firewall needs to be trained and needs to be retrained. The big potential issue with that is that if we have a release, a new version of the site, or the new version of the API, whatever, then we will need to pretty much retrain everything. So now what I will try to do is to give you a quick demo. I have created a very simple web interface for proxy SQL as a proof of concept. And I have recorded this session. We'll see if it will work. So this is the web interface that actually allows you to see the status of proxy SQL and to do some basic stuff. The reason why I have created it is that I found that it's pretty tedious to do the train phase and load phase and stuff like that. So instead, I will try to use this interface to do it by clicking the button. Basically, what I want to do is I want to collect the queries first, then I want to load them, and then I want to switch to protection. So let's go further. What I'm going here is I go to the firewall section, and then I change the mode to detecting. This is our train phase pretty much. So then I will go and visit all my APIs. We'll use the different endpoints just in case. And then I will reload this page, and I will see that the query digest has been loaded. Now I want to load that to the firewall rules. So I will change this mode to protecting. And then this interface actually loaded the firewall rules to the, it created the firewall. So now this works, but now let's create an injection. Let's see if it will actually work. Yeah. It is working. So now we try to do the injection and firewall blocked us. So this simple interface will simplify the work with a proxy SQL firewall. So here's the conclusion. Always sanitize user input. That's a must, right? We don't want to trust our users too much. Use prepared statements if possible. It's a great idea to use prepared statements in any language. And then finally, use an SQL firewall or network firewall as an additional level of protection that can actually save you from something unexpected. If you want more information, then I have created this simple website, and we'll upload the slide deck there. So that's all I have, and we'll be very happy to answer any questions.
As always, Alexander, thank you very much for your time and your talk.
Thank you.
There is one question going back and forth from Mr. Rick Harris, and he's asking about queries that don't digest well. After a bit of chatter, it seems that we're talking about where we might see some hash collisions. Have you observed this?
No, I haven't, but I can expect that that can potentially happen, though. But I haven't seen that when I was testing it, and I haven't seen that in the MySQL query digest as well. So, but it's possible.
Just watching for other questions to come in. But in the meantime, Alexander, I actually had something a little different planned for you.
All right.
Not some straight questions from the audience until I see some more, but I was thinking around the development of MySQL and the introduction of some features, and I wanted to put you on the spot and see if you could maybe answer some of these.
Oh, wow.
So, for example, do you remember which version the MySQL query cache was first released in?
Query cache. I think 4.0.
Ding,
maybe
ding.
4. No?
4.0, that's right.
0, okay, yeah. So I still have memory. That's good.
Okay, another one for you. Do you remember when row-based replication was introduced into MySQL?
Row-based. I think that was either 5051. I remember actually that because the whole thing about row-based replication was needed to work with NDB cluster. And NDB cluster at that time was, suffering from the problem where there's a SQL nodes, and they all write, but they will have the independent statements if there's a statement-based replication. So, but I don't remember if it's 5051.
My quick research says it was in 5.1.
5.1.
I'll give it to you. You're very close. Okay, one more for you. Do you remember which version, and I want to take this back a little bit, that the help statement was introduced?
Help statement in I never used help statement. So it's probably been in the first version, I think, but I don't know. 223 just to answer. Oh, 323, sorry.
323 is what I could find as well.
Right. Yeah, because you cannot find the 322, right? It's not available anymore.
No, that's right. All
Yeah,
of the documentation pages are cached on other people's servers, not on MySQL anymore.
Right. But we can call Monty and ask him about the help statement. Cool.
Yeah. Okay. Well, thank you very much for delivering your talk on MySQL Firewall. It was very informative as ever.
Thank you very much.
Okay.
All right.
We've got a couple minutes here before our next talk. I didn't see any questions come in. And I don't see anything on the YouTube chat either. And so I wanted to just say one other time that Alex and I had gotten together. We were also at a bar, and a query walked in and walked up to two tables and said, "Can I join you?" And without further ado, I hand it over to our next speaker, Tim Sharp from Percona. Tim?
Hey, Michael, thank you very much for the introduction. And hi, everyone, and thank you for joining Percona Live 2020. My name is Tim Sharp, and I'll be your host for the next couple of hours. Our next presentation is Unbounded Scale, using Vitess for scaling write-intensive workloads. Our speakers are Morgan Talker and Daniel Guzman. Morgan currently works for PlanetScale as a community development manager, and he is an active contributor to Vitess and sits on the maintainers team. Throughout his career, Morgan has worked on both MySQL and TIDB in various roles. Our other speaker, Daniel Guzman, originally studied electrical engineering, but quickly became interested in all things data. Since 2007, he has worked for numerous companies as a DBA, and for the past 7 years, Daniel has worked for Percona, where he currently enjoys the role as MySQL tech lead for the managed services team. So I'd like to pass this on to Daniel and Morgan.
Thank you, Tim. All right, so let's start by sharing our presentation.
Awesome, and I'm just going to do a quick audio check at the same time, Daniel. Can you hear me fine?
Yeah,
awesome.
We're good. All right. Okay, so thank you guys for joining this very novel way to do the Percona Live, which apparently is going very good. So we're going to talk about unbounded scale for write-intensive workloads. So this is our agenda for today. We're going to do an introduction to the problem, to the solution through Vitess. We're going to also talk about operational issues that appear only at scale or that are more visible at scale. And finally, Morgan is going to show some advanced features of Vitess. Okay, so let's start. So it's a null thing that using a single MySQL instance it simply won't scale. historically, the scaling problem that has been easily solved has been for read, right? By adding slaves, read replicas, that's kind of fix it. But the scaling problem for writing, it's still a problem. It's still, let's say it's more complicated to achieve. For some people, it's still a weird beast. So we're going to talk about the problem and how Betas provides a solution for it. So before going into depth, I always use this analogy that it's available on the MySQL high performance book about scaling. So we can be sure that everyone's it's on the same page about what it's scalability and capacity, because usually there's some confusion of those words, of those concepts, with what is performance, which is like a more popular word or concept. So performance, in this analogy with cars on the highway, it's how fast the car can go. That's independently of where the car is running. It's pure on where the car is. In this case, for MySQL, how well tuned it is, right? That will be performance. Capacity, it's the number of lanes times the maximum safe speed. So your car can go this fast, and you have this amount of lanes to go as fast as you can. And the scalability is how much more cars you can add with the lanes that you have without slowing the traffic, right? And probably there's always a limit on that, and there's always jamming on the highway. And solution for that, it's costly and it's adding more lanes. So going back to more abstract concept, the first step on scaling is usually buying some time with vertical scaling. Vertical scaling is adding more powerful hardware, bigger hardware capacity, but that first only works for some type of workloads, and also it's costly. So these are the two bounds for that type of scaling: financial limitation and computer limits. So with what is related with vertical scaling on respect of query volume, is that you start to have long and complex queries, and you start to have contention issues with which is pretty much because you have high concurrency situations, right? And that means that there's increased latency because queries need to wait on a queue for be served by MongoDB or some sort of mechanism. So you have to add that time waiting there for the actual execution time. Typically, when you saw benchmarks around MongoDB, those benchmarks show you millions of queries per second that can achieve with this high amount of threads, all the stuff. But that is in general. For the specific of writes, it's more of 10 of 10,000. It's a more accurate number. Single MySQL installations are limited by hardware profile, but also by software limitations. MySQL needs to handle sharded resources. For that shared resources to be used, it requires some mutex or share structures. So everything is used by everyone at the same time, virtually. But also for write specifically, the binary log, it's a performance bottleneck because you have this multi-thread writing, high concurrency, but then you end up with a single thread applying everything. Things that have helped are multi-thread replication, available since 5.7. But there are still issues with workloads that modify the same subset of rows of the same tables. That's still a competing issue when you want to scale writes. Also, what it's worth related with data volumes. As soon as the data volume it starts to increase, the workload shift from CPU bound to IO bound start to become a problem. You cannot always add hardware forever, and you start to having operational complexity around this. For backups, time to get backups, all the stuff, it starts to get very slow. Also, it will affect the actual performance of your MySQL instance, because more and more that data is not going to fit on the buffer pool, so more reads or more operations will hit the disk. That not also affects writes, but also reads, because everything goes through the buffer pool on InnoDB. And when you have large servers, bigger hardware, all the operational issues will have this larger blast radius, which is basically error propagation. Like one thing that it's probably, if it fails or if there's a mistake, it's not going to affect big amount of the operation. It will come bigger and more noticeable. This is also an issue inside of managing InnoDB and doing debug inside the database, doing query optimization, because there are more things that you need to look at. Not only the single execution of the query and how it works on a small operation. You have to take care of more things that are probably that were an issue, like the history list length. You have to be more careful with transactions that you keep open for way too long time, with linger transaction, which is a very common situation, which is basically transactions that are never commit or roll back it. And of course, all the things that come from contention. Failovers are also an issue. It will take more time to have a warm buffer that will work as the best performance. It will have more problems with noisy neighbors if you have and agents running for monitoring, stuff like that. It's going to also become a problem. And mistakes are just probably going to affect bigger things. Okay, so what are some approaches to write scaling? There are three approaches that are popular for solving this issue. The first one is functional partitioning. Functional partitioning it's pretty much finding independent, isolated functions from the same app that can be, of course, isolated and working independently, which is what we know as microservice now. Like, for example, you have this application for e-commerce, and then you can isolate the checkout process on its own containers, with its own database, with its own data set. That will reduce sharing operations. That will make it easier for the database, but still it's a lot of problem, because you have more things to take care, to orchestrate. It comes with its own problems. The second approach is manual sharding, which it's basically making the app the responsible for managing the logic of the sharding, of splitting the operations. What's the problem with this approach is that usually apps are not made for are not made thinking on sharding. I'm going to shard this someday when I grow up as an operation. That hardly happens. So that means that you have to make a huge change on your app, probably refactoring the code. that's costly. And also, you'll add a new layer to maintain, which is all the logic for the sharding, for splitting the traffic, for making the queries make sense. That will be just more operational responsibilities for your team. And then there is the automatic or new SQL options, which is the category where details fall, and it's pretty much making details responsible for this, taking care of the complexity, taking care of the logic, solving the shard problem for you. So Morgan is going to take it from here on what is details.
Yeah, I like what you said about the manual sharding. I'll just add maybe one point, which is that often your application is not the only consumer of the data. So it makes it very hard to add extra layers on top, like an analytics tool or something like that, if you do manual sharding. So being able to have something solve this for you makes it much easier to have many consumers of the data. It also helps you in another point, in the case that maybe you sharded it wrong or your usage changes, to be able to reshard it. It's hard to do that in a very abstract way. And I think if you use the technology to do this for you, it makes it easier to be able to do that. So I'm going to talk about Vitess specifically fitting in this category. It was created at YouTube. The birth of it traces back to 2010, when they were undergoing just massive exponential growth. And they were using MySQL as their database, and they weren't going to be able to solve this with a single server. So the way they solve this is, rather than putting sharding in their application, they put a layer in between their application and their database, and that was Vitess. So they solved it in a generic way. It proved to be useful, and as it grew after YouTube open sourced it, it eventually became a CNCF project. So it's under the same home as projects like Kubernetes that you may be familiar with, and it's at use at many of these fine companies. So I'm not actually sure with our Zoom call if they are a Vitess user, but I know that Slack is, that you're on the Slack chat answering and asking questions. There's a commercial provider for Vitess as well, and that's PlanetScale. We also provide a database as a service offering so that you can get a managed Vitess. So that was the origins. Let me click to next slide. It doesn't seem to be working. Daniel, do you mind advancing the next slide for me? And then I'll try on the next one. Let me describe the architecture of Vitess as sort of a high level. One thing that's interesting about Vitess that I briefly alluded to when I described how YouTube built it is that it's a new SQL database, but it's based on MySQL. So you get the same nice properties that MySQL has, where it has very good consistent query response time, and it has very good single server read and write performance, but it allows you to add many of those servers. And it does this by adding this layer in between. So you can see your application at the top here. Your application speaks to a component of Vitess that's called VTGate. VTGate speaks the MySQL protocol, and it looks like MySQL to your applications. Under the hood, it's speaking to its tablets, which are its data nodes that have a MySQL server associated with them. So it's routing application requests, giving a single view of all of these sharded tablets to your applications. And the VTGate component in the middle here is stateless. So it's very easy to be adding more of these VTGates as you need to be able to scale. There's some other components here. The metadata for the sharding information is stored in a topology server. Vitess can use your preferred choice of etcd or Zookeeper or Console. This is a common deployment technology that many companies at scale are already using. And it has, outside of the query serving path, some components to be able to manage Vitess. But the basic stuff that I want to point out is this VTGate server, which is a proxy that your application connects to. So I'm going to get you to skip to the next slide. Let's talk about how we can deploy Vitess. So Vitess layers on top of your favorite choice of MySQL database. The tablets that I was speaking of, they actually have two ways of operating. One is that they can fully manage MySQL, and they can handle any sorts of failovers that they need to, and sort of change the replication topology. And if you use that mode, you must use MySQL 5.6 and above, or MariaDB 10.0 to 10.3. It also has the ability to have an externally managed tablet, in which case, if you want to, you could use Cloud SQL, Amazon, or RDS, and have that responsible for doing the failover. It supports the ability to deploy locally. So Kubernetes is not strictly a requirement, but it's the most common path that people do choose to deploy Vitess on. And we have options for Helm and a new operator that PlanetScale created and actually launched today. So operator is just a little bit more sophisticated, in Helm's basically like a templating language, and operator can handle some of the active failover conditions much better. And I'd say that Kubernetes is not a requirement, but because Vitess sort of approaches things in a very cloud-like way, where it wants you to think of databases as ephemeral, and that failovers will happen, and that typically you do run with slightly smaller instances of Vitess, and many of them, than you would in maybe a traditional scenario. Vitess encourages you to have 250 gig shards. It probably does make sense for you to consider deploying in Kubernetes if you're looking at Vitess at the same time. So next slide, please. So just 2 slides on essential terminology. The first one is key space. So when Vitess is using MySQL under the hood and it's storing things in MySQL databases or schemas and has the ability to shard, to sort of disambiguate this term, what you see as a database inside of Vitess, it calls it key space. And a key space has 2 varieties. Key spaces can be sharded or they can be unsharded. If you choose to shard your key space, there are a few more restrictions on what queries are completely possible. And another piece of terminology to throw in, the scheme of how you shard your table is called a V-schema. We won't go into too much detail on that one today, but it does help to know that term. And next slide, please. The other essential terminology I did describe when I was on my slide, but it's this terminology of tablet, to say that this is the data node component of Vitess. So each copy of MySQL plus a VT tablet process is what Vitess calls a tablet. And this is the basic unit of being able to scale your Vitess cluster. So as we add additional tablets, we can expand our write capacity, which is really the theme of what we're getting to today. Next slide. So Vitess is MySQL-like and does use MySQL. A few interesting things to point out, and we'll go into more details. We talk about the operational issues in our next section. Daniel will describe the MySQL way, and I'll describe the Vitess way. But Vitess does integrate very nicely with extra backup to do backups, integrates with Orchestrated to do failover detection. And as I said on that architecture slide, it doesn't store the metadata. It allows you to store this in external service and can use some of the most popular technologies to be able to do that. One interesting thing when we were building this talk, Daniel and I, he was saying, does it have integrations for Ansible, Chef, or Puppet? And my answer was, you could build your own. There's nothing sort of restricting that, because you can build that and orchestrate that on top of the local deployment. But I would really encourage you to use Kubernetes as the deployment target. It's much better suited to be able to do that. Next slide, okay. So some other sort of basic questions to kind of predict them before we get into things. Where does Vitess fit in the scheme of data consistency? Vitess is an ACID database, so it's a lot more close to the traditional relational databases than a NoSQL store that might not provide some of those guarantees. I will say it's just a little bit weaker than MySQL in that it only guarantees a read committed isolation. So you'll be reading data that's committed on other various nodes if you're doing a cross-shard query, but it will see kind of newer elements of data that have been committed, not giving you like an older version of the data that MySQL might by default. But it does also have some semantics that you can opt into that will give you more of an eventually consistent representation of the data. So it does support read replicas, and you can explicitly select them. So instead of saying use my database or my key space, essentially in Vitess terms, you can say use my key space at replica, and you can get a copy of an instance that might have some slight delay in when that data represents in time. As you're modeling or designing how to shard systems, Vitess does support the ability to do an update in multiple shards consistently with what's called like a two-phase commit. It discourages you from doing this. So it can two-phase commit internally. It has the ability to do that. It doesn't rely on MySQL's two-phase commit functionality, but you have to turn that on, and most users in production do not do that. They kind of model their design so that their updates are sort of self-contained for one PC, which is much faster and more efficient. Okay, next slide. And yeah, a couple more clarifications. Vitess does help you improve your throughput or the write scalability, which is the theme of today, i.e. the number of queries per second. But I think this is true of a lot of distributed systems. If you're evaluating Vitess or others, it's unlikely to help your query latency. So if you take a very naive case and you have a while loop that's single threaded and you update one row, it's going to take 1 to 2 milliseconds extra per one of those queries to go through VT-gate and to go through VT-tablet. And not shown in my architecture diagram, but because VT-gate is stateless, some users put a load balance in front of that. It improves the overall throughput or the overall capacity of the system. It doesn't make the individual queries necessarily faster. Although in actually some edge cases it could. As Daniel described, as your system gets bigger, it gets slower because it becomes more IO bound instead of CPU bound. So in those cases, it could, but I think careful planning will help mitigate any regressions that you could get here. Next slide. And I think this is my last one, these initial Vitess clarifications. There are a few more things that you have to deploy to get Vitess started. So versus MySQL, you have to deploy that topology service. Maybe you have one running already, and typically you want that to be highly available. So 3 copies of topology service. The management service, the VT-gate, often you'll run 2 so that you have high availability. And then a typical deployment of the data nodes, the tablets, is to have 3 copies of each shard to make sure that you can handle failures. So this sort of, there's some guides at this link to sort of say, how much CPU each one of these will need, but this sort of stresses this point that it does help to use a Kubernetes deployment to be able to lessen some of the impact on you to set this up. Okay, Daniel, I think it's back over to you.
Okay, Morgan, thanks. So now that we have the introduction completely, let's talk about the operational issues at scale and how Vitess provides a solution for each of them. So let's start with backups. Backups, it's the most obvious in terms of when data volume increase. You will require to have more disk space for store the backup. It will also take more time to take the backup, to encrypt it with your encrypting, to compress it, and to move it to a third-party location like S3 or whatever external location you define. It will also impact on the time on restore. That probably doesn't sound like a problem, but if you're in a disaster recovery mode, it's going to be critical. Another thing that we also see is that retention policy are like the first victim. Why? Because backups are taking longer. That means that you cannot probably take daily backups anymore because you don't have enough time to take it. So you will start to say, okay, instead of daily, let's take it every 2 days, every 3 days, every week. It's going to become a problem eventually. The solution of Vitess.
Sure. So in Vitess, I'll start by saying it's similar technologies as MySQL because it is MySQL, and you'll hear me repeat that many times. But I think the impact is less because typically Vitess recommends that you pick a 250 gig shard size. And it does this very specifically because 250 gig seems to be about the size where you should be able to restore this from something like S3 within 15 minutes on most networks. So architecturally, Vitess uses plugins for backup. Sort of the legacy backup engine is to shut down one of the replicas and then copy it, but it also supports extra backup. And it has another sort of plugin for where to store the data. And S3 is a common deployment for that. I will clarify and say that each of the shards independently are performing backups. So it's not strictly a fully consistent backup. It's consistent on a per shard basis. Some other things to note about this backup, being 250 gig, you can restore it in parallel, which typically is what you need from S3 to be able to get all of that performance efficiency as well. So really designed to make sure that restore is efficient.
Okay, another issue is the ones related with schema changes. Big tables, it means very painful schema changes, or also the same for large amount of tables. Why? Operations on MySQL are single-threaded, although there are some alternatives of becoming multi-thread PTON schema change, but those are not common. Some of the operations are not online, native as the online DDL from MySQL. Some approaches require failover when you have big tables, foreign keys, several restrictions, and being the failover cost operation, sometimes that's the best option. And it's very common to use PT online schema change or GAUS as tools to try to reduce the impact and the overhead of the alters or any DDL that you're trying to do. But this also comes with a cost of disk space. For example, for PT online schema change, you require to have at least the same amount of disk space available for the table size that is using. Sometimes you don't have that. So there are the nuances of using this that it helps from one things, the lack of online, but it comes with a cost.
Okay, so the Vitess answer to this is very similar again. There's nothing special to Vitess that solves this problem in a different way. I mean, you can make the schema change to VTGate and then it'll propagate it to each of the underlying tablets, but then it would be blocking just like MySQL DDL is blocking. So typically on large tables, users will use Ghost or PTOSC much the same. But because your data is now split across hopefully tens or hundreds of shards, if it's a large table, then it's applying each of those in parallel, as you can run Ghost independently, and Ghost is single-threaded for each of those, but it's a much smaller amount of data that needs to be processed. So seems like a small difference, but I think it might save you a lot of problems with that.
Okay, so with failover, what are the problems with failovers? A single eventually operation that it could be something that you do every day, every week, wherever, and you think everything is controlled, it potentially becomes a daily task if you need to do this for changing, executing DDLs, like with the example. It's going to become half of your day, of your workday. So it's very problematic in terms of time users and resource users as a DBA, more moving parts. That means that more things that could fail, more servers to perform the pre-flight checks or post checks. These failover tags are not trivial. There are a lot of things that you need to guarantee they are met with some pre-flight checks. And you have to do that for every single server that you have. It's going also to become time-consuming task. And probably the biggest problem is that you have more data that needs to be checked for consistency. As everyone knows, before executing a failover, you have to be sure that the candidate master has the data that the master actually have. That's a task that it's let's say trivial, but it takes a lot of time, and fixing it's sometimes problematic. So the bigger the things get, the more delicate they become.
Yeah, so one thing not mentioned on my slide, but I'll throw in, since you were mentioning it, is that not knowing who has the data, most deployments of Vitess use semi-sync replication. So they guarantee that at least someone else has the data, and that does make some of your automation and your failover much easier. But Vitess, it was designed to fail, and no pun intended, but it categorizes failover as either planned or unplanned. And planned is just completely plumbed through as an API call to be able to transfer the leadership and say this is now the master for this particular shard. Unplanned can be done via the Vitess operator, or it can be done by integrating with Orchestrator. And so Orchestrator can allow, can be plugged in to basically call the Vitess API and say, this is the new leader, I've discovered a failure. And this is a common deployment option.
All right, so upgrades and updates. There are two approaches of doing that. One is in place and the other is logical. In place, it requires that you change by the binary files. It could be faster in terms that you don't have to take a backup and restore, and this backup, it needs to be a logical one. The binary one, the one that you take with extra backup, don't work. But you also have to perform a system upgrade of table with MySQL upgrade script. And that could take time or not, but it's still something that you need to do. And on the other hand is the logical, the one that you require to take the logical backup and restore. That could potentially be less problematic because you're doing it not in your actual server but in a new one, but that means additional costs. You need an additional server. You need to sort it out, the networking issue. Everything needs to be somehow connected, and also requires a failover on a instance that you have never used. So both approaches have pros and cons, but it's mostly the same thing as with everything. When you're scaling, it becomes problematic because more things can fail and more time you need to invest on doing these operations.
Right, so the Vitess answer to that is that typically upgrades and updates are not done in place. They're done by deploying new resources, and this is really the cloud way of doing things. But the other thing that I'd add is they're often done physical, in that we'll use that backup provider, extra backup, and then after we restored it, we'll run MySQL upgrade to make sure that it's consistent. There are a couple of other considerations to be aware of. There are multiple Vitess components, and there is a specified way of which way you should be upgrading them, and it's bottom up. So upgrade your MySQL and your VT tablet, then upgrade the management server, and then upgrade the proxy, the VT gate that your application speaks to. And the last thing is, upgrade your application client, which many of us even skip this step. I think that's the least required part to do, but that would be the part that you would do last. And this is just an easy way to remember it.
Okay, so that's that's for the operational task. So let's go back to what we're talking about in general, which is scaling MySQL. Remember that there are two options: scaling up, which is putting some money on it, but buy more hardware, which for many applications, this is all you need. There are applications that you just need to give some more air on CPU power or on CPU cores for concurrency, and that will work, right? But for the ones that it doesn't, there's the scaling out, which is replication for reads, and for writes in scaling is partitioning and sharding. This is where Vitess excels.
Yeah, so in Vitess, I didn't explicitly point it out, but it's MySQL that's handling the state, and it's the topology server that's handling the other metadata. Everything that Vitess writes is actually stateless. And when things are stateless, it makes them very easy to scale because you can just keep adding more of them. So, well, to start with the VT gates, if you want to add more VT gates, there's no cache in them, there's no state, you just add more VT gates. And if you want to add more capacity, you add more tablets to be able to do that. Eventually, you might get hotspots in a particular tablet as your load distribution is not equal. And then you can kind of split that tablet in half. And that's how you can make sure that you scale that individual tablet. And then you can split that one further if you need to. And then maybe eventually after that, you might have scaling issues with the topology service. But it's possible to scale that as well because you can have a local cell topology service. A cell is Vitess's name for a data center. And then you can have a global cell for the topology service. And it doesn't actually access this very frequently. It's never part of the query serving path. So it is very easy to be able to scale Vitess to thousands of nodes. And we do know of multiple clusters in that sort of size.
Okay, so everything related with configuration changes. There are two options also, dynamic and static. Dynamic are the ones that you can change through the client. That has the problem that if you do not persist those changes on the configuration file, you lost it after a restart. When doing that, typos are easy to spot because just the client will say there's an error on syntax or whatever, and you can fix it. But think about doing that for increasing the amount of instance each one. For the static, it's the actual one that requires to modify the CNF file. If you don't do it properly, if you have typos, you won't be able to restart it. Here in this with this particular approach, it's not that problematic if you have several instances because most likely you will have a configuration change to being through Ansible, Puppet, Jeff, whatever. So it's let's say that part it's fixed, but you still need to restart the server for those changes to apply. That will probably mean some failover with all the things that we mentioned that it's a problematic around failovers when scaling. So in those cases, even if you have solved the orchestrator of those changes through a configuration management is still the exact step of doing the restart. It can be problematic.
So in Vitess, I want to clarify that there's a couple of different types of configuration. You have the configuration, which is how you route to various shards. And that's stored in the topology service. So your favorite choice of etcd, Zookeeper, etc. And then for MySQL configuration, this is how Vitess handles it. So when you essentially launch a tablet, Vitess runs MySQL d -- help or dash version, and then it finds out which version it is and then applies a minimal configuration file that Vitess needs to operate. So Vitess wants to use GTIDs, which are not on by default, and wants to turn the binary log. You can specify an additional file when you launch a tablet, as well as the minimal file that it launches. This is something that would be applied globally. And if you wanted to make a instance level change, so you wanted to do an experiment with the set global step that Daniel was talking about, you can actually make that change because you can connect to an individual tablet through the MySQL local socket to do that. But if you try and run a set global through VTGate, that's disabled. So, some options there. I will point out that Vitess sort of philosophically, it wants to manage your MySQL. So it doesn't sort of believe in using the MySQL protocol and using set persist to be able to do that. It would prefer that you manage this in the Vitess way by having it sort of run and start your MySQL service for you.
Okay, so what it's related with monitoring and visibility, you can have visibility. It's through MySQL client, MySQL shell, with commands that get you storage status through the error log, or you can use PMM, the Percona monitoring and management. Remember that visibility and monitoring is not just grabs, it's just informations. MySQL client and the log and all that stuff provides you black and white visibility, PMN, add colors and add history to that. This is how you can solve it. This is actually something that works even if you escalate, right? So this is one of the few things that are kind of the same if you are a small operation or a large operation, but also Vitess has a solution for it.
Yeah, so Vitess has a solution, but it's really the same solution in that Vitess being cloud native uses the same stack. It uses Prometheus and Grafana, and you can keep using PMM. But I'd add a caveat, and which is I think that some DBAs take a very my database server centric view of the world. And I think because you've got a VT tablet and you've got a VT gate on top of that, and these actually have connection pools, which is a useful feature. It can add latency by queuing there. And I think that's the wrong view of the world to look at the database server by itself. It really helps you to have a more holistic view of the application, maybe using something like New Relic or something to be able to see the actual query times that you're getting from the apps. You get a more accurate representation of time. You can also grab the times from VTGate. That's a bit higher up in the stack, so that's a better place to see them than just looking at the individual database. And also because some queries might be a scatter gather, that would also be misleading, I think, to look at the query on an individual MySQL server to do that. Okay, so the last section is mine. So today we wanted to focus on one specific issue that we know hurts a lot of people, which is write scalability. That it's less answered than read scalability, where I think we all know the answer. But in doing so, I described really some of the more obvious features of Vitess, and I think there are some other ones that are useful. So I just have a couple of slides to share with you on that, and then we'll open it up for questions. So there's some features that are not related to sharding that Vitess has, and one of them that I just described was connection pooling. So if you have a typical web server, it might have 100 Apache always defaulted historically to 150 requests, and if you have 10 of these web servers, then you're going to have that pile on your database server. So having a connection pool is useful. You could also use a thread pool inside of MySQL. There's some other features on top of this that Vitess does that are really intelligent. But if you don't use transactions explicitly, but you're just in auto commit mode for your reads or your writes, Vitess will essentially merge those those queries in those connections together and sort of fan them in as it sends them to the underlying shard server. To add on that, what it'll also do is that if you're on auto commit mode and you have, let's say in the previous session, we're talking about caching, you have this really repetitive query that appears on a homepage, and maybe it takes some time to generate that. When the VT gate first sees that query, it'll kind of keep record of what that query is. And if any new requests come in for that same query and they're in auto commit, it'll basically just tag them onto the end of that original request. And then when the results come back for that original request, it'll just broadcast that out to all of the clients. And so this can really help in some naive cases that are very easy to introduce in your application. And honestly, it can be hard to catch in QA because they could be very simple queries and you might not generate that traffic. A lot of people don't do any load testing. It's hard to be able to simulate that. Also, Vitess, by default, it operates in an OLTP mode or transactional mode, where it will make sure that queries are not excessively expensive. So typically they're not table scanning by default, where SQL is a great language, but because it's declarative, it's very easy to write things that you don't realize are very complex, and you can't site check to tell that's problematic. So Vitess will add a limit 10,001 to all queries in its default OLTP mode that it sends to the underlying tablets. And if it gets back 10,001 rows, it'll give you an error and say basically this query was malformed. But if it gets 10,000 or less, then that query is okay, and it's basically allowed to proceed. And while the MySQL server has statement timeout in, I think, MySQL 5.7 or 8.0 plus, Vitess has them on by default and has it with a very strict 10 seconds to make sure that if that query takes longer than that, you get an error. You can change this, of course. All you have to do is do set workload equals OLAP, and then you'll be able to act in an unrestricted way in how you query this data, and it'll make sure that it routes you to a replica rather than the master to be able to perform those queries. So some very nice, like, productionalized thoughts in how to operate a database. And when I was saying that Vitess is sort of an ACID database and it fits in that category of strong consistency, it does have a feature called vReplication, which allows you to create caches of tables or caches of queries. So if you can imagine that, the way that you've sharded this system, some of the data is on this shard and some of the data is on some other shard and so forth in some other key space. You can get into some cases where scatter gather could take more time in a distributed system. So what Vitess allows you to do is basically save and keep refreshing summaries of tables on each of the shards so that it can basically push down larger fragments of the query to the tablets, to the edges, to be able to execute it. And then in the VT gate, what you can do is you can set query equivalents. So you can say, if you want to access this table, then it's okay to access the original, or it's okay to access the materialized view that might be slightly delayed. And this can really help you kind of from an operator perspective and not from a query in the application perspective, make changes in a very nice, neutral way. Okay, next slide. These are kind of a couple of interesting emerging spaces. So also in the last talk, we were talking about caching in like a geo distribution scenario. I think that the whole geo-distributed setup is going to become interesting for another reason, which is things like GDPR, and in California there's an equivalent at CC something or other, where governments are instituting laws mandating where the citizens' data must be located. So because in Vitess, it allows you to shard your data and allows you to specify the function on how you shard your data in that V schema that I said we won't get into, you can actually customize that, and you can set some policies for how to distribute the user's data so that you can make sure that if someone is in Europe, their data stays in Europe, and then you basically stay in compliance of these laws. It's also very complicated to implement because GDPR spans to things like backups and how many copies of the backups and how long time-wise they may last. So I think this is an emerging space that Vitess is particularly well primed for. But that's just like a little bit of a teaser that was outside of the context of this talk. I want to open it up for questions, and if you have questions for Daniel and I, we're happy to answer.
Okay, we have one question coming in. Can you run Vitess with DBASes, like, for example, RDS?
Yes. Yes, we would call that an external tablet, and it works fine.
Another question coming in. In the case of MySQL version downgrade, does Vitess also handle it?
Yeah, so Vitess has many of the same restrictions as MySQL does there. Downgrades between major versions is not something I've attempted. Downgrades between 8.0 versions is actually at the moment also problematic with some restrictions. If the restrictions are in MySQL, they're going to unfortunately be in Vitess as well.
And let's see, looks like one's coming in. Okay, what are the differences between Vitess Helm charts and the planet scale Kubernetes operator? Does it matter in terms of deployment?
So I think long-term view, operators is certainly the way to go. So for me, Helm is kind of like a template, and a template allows you to kind of specify, I want so many of these and so many of that. But to actively kind of manage and handle the failovers, operator is a piece of code that runs and can make decisions. So there's a lot more functionality that's available in both operators in general and the planet scale Vitess operator than in Helm charts.
Okay, very good. Well, I think that's all the questions I'm seeing coming in. Thank you very much, Morgan and Daniel, for your time. We very much appreciate it.
Awesome. You're welcome.
You're welcome. Yeah, thanks.
Thanks, Tim. We have a quick update that we can share from Matt. So we'll just get that started now. Okay, it looks like we're having an issue with audio, so just give us one moment. And we'll try that again. Sorry, we have a bit of time until the next speakers come on, so just not to keep the stream dead, we have some pre-recorded content available, so we'll just get that started now.
Choice, Hi, Matt Yonkovit, CXO at Percona, with another quick hit war story for you. Again, a lot of times I'll sit around, after, Percona Live with a lot of folks. I'll tell some stories. We'll swap war stories. We don't get that when we're on the online version. So wanted to give you a few of my choice stories from, behind the scenes of what's going on at MySQL AB when I worked there, at Percona when I worked here, at various companies that I've worked with, because we all have these war stories and sometimes they're really interesting to listen to and there's lessons to be learned. So today I'm going to talk to you about probably the most unusual consulting engagement that I ever had. And so this consulting engagement was a consulting engagement for a particular company that serviced and was focused on vampire dating, which was an unusual, place. It was like for goths and for people who like to, dress up as vampires to find one another and, potentially make matches and hang out. It was, think of it as almost a social network for vampires. And this was a company that I didn't know much about. But my first experience was when my boss at the time called me up, and said, "Hey, I got a gig for you." And I said, oh, great, where is it? And well, that's the thing. They want you to come to their house. They're a bunch of vampires. They want you to come to the basement and work it out of their basement. And I don't know about you, but like that just sounds weird. I don't want to go to a vampire's house and work out of their basement. It just sounds a little weird. But at the time, MySQL had gotten acquired by Sun. So he said, well, alternatively, we can have you go to the Sun office and we can meet there and, you know, we can get together in one location. So it's more neutral ground. And we've never done this before. So why not, you know, try the Sun location? So we decided on the Sun offices, and we chose the Sun office in downtown Chicago. Now, I don't know if you've ever been to the Sun office. It's been a while, so they haven't been around for years and years and years. But the Sun Microsystems office at the time was in the Chicago Board of Trade, which is like the stock market for Chicago, right? So big place, everybody's there dressed, you know, in their suits. You've got, you know, people who sell mutual funds and commodities, and you've got, you know, brokerage houses, and you've got like, it is a fancy business location, right? And so that is one of the, you know, places that lots of dollars are transacted. So I went to this office, was able to go up and, you know, get myself situated, and very polite people. And, you know, the receptionist set me down, showed me where to go, got me the conference room. You know, I was able to give them the names of the people who were coming. And so about 9 o'clock, I get a call, you know, from the receptionist, you know, Mr. Yonkovit, your guests are downstairs. And I go, oh, well, okay, well, are they coming up? Well, sir, they want you to come down and sign for them and vouch for them. And it's like, why do you want me to sign for these? Why do you want me to vouch for the, you know, like what's going on? Like they're on the list. They should be able to be allowed up. No, you need to go downstairs. All right. So I go downstairs to the front office of the Chicago Board of Trade. And guess what? Here's these guys, and they're dressed in like full on like Matrix garb type, you know, flowing black, you know, like stuff. I mean, they were totally, you know, leather and stuff. And it was really interesting because, you know, you see like all of these, you know, business people, they're like, what's this? You know, and they're kind of freaked out by this. And so we, you know, brought them upstairs. We got them through security, and we were able to help them. You know, this was one of those issues where, you know, their system was experiencing tremendous amounts of growth and they couldn't handle it. So it was all about scaling their systems, and we were able to do that. It took, you know, a few days to do that, you know, and we got done a little early. And so, you know, we want to go on and we want to help find value to, you know, the folks who are there. You know, this is, you know, hey, they spent money on having me come help fix their systems, and we fix them. So we typically say, you know, hey, you know, is there something else I can help you with? Do you want us to look at your replication, your HA, you know, anything else? And the guy who we're working with, who's the CEO of this company, says, yeah, there's one thing. I just want one thing. You know, you're familiar with the Chicago area. I'm not from here, but I've come here enough where I know the area. And he looks at me and he goes, I understand there's a Lego store in downtown Chicago. Do you know where it is? And I'm like, yeah, I think I do. I want you to take me to the Lego store. And literally, we spent the last day while he shopped, and I helped him shop for Legos. And he was really excited about the Harry Potter Legos, which were the new Legos out on the market then. And so he got really excited. He got to buy his kids, you know, like, you know, Harry Potter Legos. It was like a kid in the candy store. He was super happy. One of the more unusual cases, but not only did we save, and, you know, like, you know, back in the day at MySQL, save his, you know, scalability issue, solve them and make them better. But I was also able to make sure, you know, his wife and kid were happy by getting, you know, Harry Potter Legos. So not something you would generally do, but it is something that I will always remember.
All right. Thanks, Tim. Back to you.
Thank you for that, Matt. So hi, everyone. Again, thank you for joining Percona Live 2020. And my name is still Tim Sharp, and I'll still be your host. Our next presentation is Percona Monitoring and Management 2.6, the Security Threat Tool. Our speakers are Daniel Guzman again. And briefly, Daniel originally started electrical engineering and quickly became interested in all things data. He has been a DBA for the past since 2007. And for the past 7 years, Daniel has worked for Percona, where he currently enjoys the role of MySQL tech lead for the managed services team. Our other speaker is Stephen Hoffman, a lifelong technologist. Steve got his start in high performance and high availability computing while in college. As his career in technology progressed through programming and systems engineering, he made the transition to leadership and has since never looked back. His successes include leading several companies through high growth phases, as well as multiple mergers and acquisitions. He is currently leads the platform team at Percona. So handing this off to you guys.
Thank you, Tim.
All right, thanks. I'm going to put the screen share up. And Daniel, let me throw control over to you too. Here we go.
All right, so hello again. I'm Daniel. This is the talk, Percona Monitoring Management, PMM 2.6. Focus on security threat tool, which is a new pretty cool feature. Introduction has been made. My partner in crime is Steve. I'm Daniel. So let's get in business. So we're talking the security threat tool. What's that? Security. Security, it's like one of the most important things and probably one of the most ignored things. Which I shouldn't say that, but it is what it is. So what is the problem that we're trying to solve around security and databases and and all this stuff? Well, several things we're trying to solve. The first one is lack of visibility. Some of the problems of security are just because they're not visible. They're buried under noise. With more big, complex infrastructure topologies, deployments, it's more easier to lose visibility on security problems. That's one thing. Other thing that we're trying to solve is everything that comes around security issues because of operational mistakes. For example, lack of hardening protocols. It's pretty common that a DBA or DevOps or whatever deploys a database and nobody does a hardening. What's the hardening? Checking for anonymous users, users with a password, that the ports that needs to be open, nothing else. All the stuff usually forgotten. What else? Excessive confidence. Excessive confidence is believing that the database that you're using, the product that you're using, it's secure by default and it's secure out of the box. And that's not the reality. The reality is different. The reality is that the databases, probably the focus is more on usability, and usability and security are a complex balance, and sometimes usability wins, especially when you're using things out of the box. That's excessive confidence on the database. The distraction of unlikely scenarios. What that means? Focusing on complex solutions or complex or specific layers for security, like focusing only on firewalls, IP tables, security on load balancer, or things that are more complicated than and forgetting the basic stuff, the user password, the plugin authentication plugin and stuff like that. That's something else that we want to bring focus on when trying to solve this problem. Finally, is raising awareness. Like I say, things that are just buried under noise or under complexity or whatever, we want that to go to the front again. We want that to be the things that are going to be solved and have some love from a security perspective. So that's the why we need to fix how we are trying to solve that issue. First thing, and I think the baseline of this approach is start simple. The majority of the database breach security problems are because someone forgot to just put a password on a new user, or someone just left a user open to the world instead of specific IPs or specific hosts. That is problems that are super simple to fix, but probably someone forgot to do it, or it wasn't visible. So we want to start simple. We want to be consistent. We want that the security check, it's applied and it happens on every single machine, on every time at the same time. It's not something that is only for the master or for a couple of nodes. No, it's something that will work for every database that you have. Even if you have multiple databases, like PMM, you can monitor not only MySQL, you can monitor MySQL, proxy, Postgres, Mongo, DBAS. For all of those, if you have a mix of that, you will have the same check every time. Another thing is that it has to be continuously adaptable. New threats coming. The way to figure out that threat is you're being a victim of a threat or not change. We need to provide a solution that can adapt to that. Next is that you don't have to be an expert on the DB, on the database. You don't have to be like this super senior DBA or a manager of the database to have access to security report, right? So that's something else that we want to put as a requirement. Things just need to work. Also, this needs to be useful. It has to be something that it's easy to highlight. The security threat tool needs to be something reliable that I go and it actually saying to me what is the problem. It's not the info is not buried on noise or whatever. That's something that needs to have. It has to be actionable. You not only need to know that you have a problem and you have a security issue, but it also provide to you means to fix that problem, right? Information how to actually change the password or links to more complete documentation on how to fix it. It has to be actionable. It's just not only an alert and then you have to figure out how to fix it. No, it will help you how to fix it. And finally, it has to support bring your own scripts. What that means? It needs to be customizable. There are particular situations on every single deployment. It's not the same your deployment than mine, and there are things that are more a security issue for you. You need to be able to create custom checks and for that using our tool. So that's our approach to solving now. What's the result? How we solve it is the security threat tool. So Steve.
Yeah, thanks, Daniel. Well, I mean, as anybody in development knows, always the list of things that you want is greater than we could ever hope to do in a lifetime. So we had to dial it back a little bit, and we set out sort of a series of development goals for the team on what were the things that we must do in this first release. So those things are drawing attention to issues immediately. Again, that goes back to the requirement to be actionable. Maintaining a consistent view so that you can gather all your information in one spot. I think that's one of the beauties of PMM has been putting all this information in one dashboard or in one spot that you can get all your information. We needed to have the out-of-the-box functionality that can check for and alert on the most common issues. We also wanted to get some more like virus definition style updates so that the security checks as they were developed didn't require a separate action of you installing and upgrading your PMM system. Once you have the basic engine, we can add checks in our cloud service and you pull them down on a nightly basis. For making these checks, we wanted to be a simple language. We chose something that was Python based. And the whole goal for that is being able to open this up to allow you to create your own custom checks. And ultimately, our number one goal is really, helping you stay off the front page of the internet. So, we set those out as the initial wave of goals. There's plenty more to come and we'll get into that. But right now, I think we're gonna hop out of this presentation and we're gonna go over to demo mode. So Daniel, just kind of give me a nod if that's showing all right.
Yeah, it is. Go ahead.
Excellent, excellent. So what you're looking at here is the home page of the PMM tool. If you've never seen it before, there's an awful lot going on, but for those of you who already have it, this is probably the first thing that you notice. So this is an upgraded system. Obviously, it's a demo system. I guess you could log into the IP if you're really so inclined, but the point being, when you first install the latest version, you're going to see the failed security checks panel, but you're going to notice that it is disabled. We did this intentionally. We wanted you to have to proactively go to our PMM settings page, either through the PMM dropdown or the convenient link provided right here. And what that's going to let you do is actually toggle the security threat tool on. Now, there's a reason for this. One of the things Percona holds highest regard is your data, your privacy, and being able to control that information. One of the things that we do is telemetry is enabled by default in PMM. What this does is sends us very basic information about the PMM server that you're running, simply the version, what type, is it a Docker image, is it an AMI, is it an OVF file, and how long that's been up, and that's it. You can get more information on that if you go to check.percona.com, which is the endpoint that the telemetry service hits. But when you enable security threat tool, you're going to notice that you can no longer disable telemetry. And the reason for that is eventually, and we'll be very transparent about this, but eventually we'll need more information so that we can go from simply informing you to actually helping you make better decisions, more qualified decisions. And I'll show what I mean after we apply this. So I've turned this on. This is a demo environment. I'm actually running this instance in debug mode. For the end user, when you enable security threat tool, you're going to kick off a whole bunch of behind the scenes processes, one of which being going out to our cloud service, pulling down the latest checks. That's going to run once every 24 hours. So depending on when you last started your PMM instance, that's what starts the 24-hour timer. You may not see anything for literally the next day, but when you come back to the system, you'll notice that some checks have run against your infrastructure. And obviously I've staged a few here, so we had something interesting to look at. What we try to do, again, using a consistent color theme that you'll notice throughout PMM, red is bad, orange says pay attention to, and blue is, hey, FYI. So we put this right here in front of you so that you've got immediately actionable information. There's at least two things that I have got to pay attention to. And by clicking on that panel, that's going to take you right to that centralized dashboard of checks. And again, giving you that information consistently, we see that we've got one critical, one trivial item here, one trivial item for the RDS at MySQL, and then the same 1-in-1 for our Percona Server 8 instance. What we wanted to do is start off small. You are looking at some development checks, so these are not what's all the way in production. In production, this is as much as you would see. I know the first thing that draws people attention is, oh my gosh, you're exposing the username of who has a blank password. This is something that I've been playing with on my own. When I installed it on my home lab, I just for the heck of it decided to run against my system, and it came back with a blank password, and I wasn't expecting that. And so when I went and debugged it, I realized that there was an account I had created for a service I was tinkering with years ago, wasn't working, and I gave up on it, and I never actually removed the database instance. So it worked. At that point, I wanted to know what that user was. But again, that's not what's in production right now. While we're at it, if you want to leave a comment, it would be great to hear your input on whether or not you think seeing this in the live system is worthwhile. especially if I tell you that access to this information is limited to PMM admins only. So if your account was created in Grafana as an editor or a viewer, you will not be able to access this information, only your PMM admins. So the other thing that you're going to notice is we call this trivial. So I mentioned earlier about the telemetry service. Well, at this point, this is sort of a dumb compare. We look at the version of MySQL that you're currently running, and the security check actually downloads whatever the latest available version of your minor release is. We honestly don't know if there's anything noteworthy that would require you to upgrade or not. So at this point, this check is merely trivial. It's informational. Hey, you might want to investigate this. But as we continue to enhance the service, we'll be able to take your MySQL version, compare it to the CVE database, and actually make a recommendation based on the level of risk that you're at given the version that you're running. If we find that you have a CVE with a very high index on it, or that maybe upgrading to the most current version would resolve 20 or 30 CVEs, obviously the importance of that check we would elevate to draw your attention to it and get you to take action. So while we're at it, Daniel, did you want to go ahead and add those systems for me?
Yeah, that's done.
Awesome. So what Daniel's gone ahead and done is he went and added 3 more systems. And I only wanted to show this so that you can see the additional checks that we're creating. And again, a lot of these are in development. What you saw on the last screen is really all that's in production right now. But you'll notice we've got a lot more stuff going on here. Let's go back into our dashboard and take a peek at what's going on behind the scenes. So some of the checks that are in development right now is for our Postgres servers. We want to call out that you might have users you did not intend to have the super user role for Postgres. I think I heard Daniel mention this earlier in his talk about MySQL anonymous user checks, basically users with a blank username. We're trying to make this as proactive as we can. And again, putting the information in front of the end user so that they resolve issues with that goal of keeping you off the front page of the internet because your system was hacked. So that's basically the nickel tour of the PMM tool. We've got a lot of stuff still to come. This is our first release. We wanted to get it out there. We want to start getting feedback, show it off to the world. As you can see, there's probably a dozen checks. Some of them are actually not showing up because the systems aren't vulnerable to them. But we'll be releasing more and more of these over time. So hopefully there's a steady stream of it. But let's flip back over to our presentation here so that we can talk a little bit about where we go from here. The biggest thing for us is we want smarter checks and more of them. Right now, like I said, it's very informational. And again, it's going off the lowest level of information. So we don't actually know if there's a problem with your version of Postgres. All we know is it's not the current version. We also realize that alerting isn't enough. One of our goals for the Percona monitoring and management tool is to actually allow you to resolve some of this stuff. Now, obviously, we're still working out exactly how we want to do that. If I skip, it's not on this side, I thought it was on this slide. One of the things that we're taking very seriously is not resolving security issues by creating bigger ones. So a big piece of what we've done is lay the foundation for a secure environment. Meaning, we don't want to create an environment where you're subject to man-in-the-middle attacks or SQL injection or things like that. So a lot of our energy is going into hardening that aspect of it. But over time, the goal is to allow you to resolve those blank passwords, disable those anonymous users, perhaps remove super user account. And obviously, we're going to do this the right way. It's not proxied credentials. The person who's actually carrying out the action would have to know the credentials to perform that. We're not just going to let any PMM admin start making changes to your systems. But the other thing is usability improvements. This is high on our list. So the table that you saw is a very basic table layout, but we've got sorting of items, making sure that you've got all listings, that you can go back in time, turning checks on and off, snoozing alerts, just a whole myriad of user-friendly enhancements that we want to make. I mentioned that right now the checks only run on a 24-hour basis. Customizable frequency is very high on our priority list. It's actually one of the next items we'll be working on. And that's going to allow you to increase the frequency of checks, as well as we want you to be able to customize individual checks to run more often than not. Maybe you only want a version check done once a day with a CVE scan once a day or once a week, but you want the blank user password to fire every hour on the hour. The custom checks in the developer guide, again, we're putting a lot of energy into making sure we do this correctly. We don't want to create another hole and close one hole and open 2 more. So allowing you to create your own checks without exposing your systems to increased vulnerability is something that we take very, very seriously. But once we get the basic engine and details worked out around creating custom checks and finalize the developer guide, it's a Python-based language. I was able to pick it up in just a matter of moments, and I'm not very smart. So we think we've made this pretty easy for everybody. Lastly, you'll notice third-party integrations is something big on our list, and that's allowing you to integrate this with Alert Manager, Slack, PagerDuty, so that, again, we want this information to be actionable immediately. We don't want you to find out that a system was, has a blank password, and you find out about it 24 hours later. That's something that you probably want to close immediately. So that's sort of the short list. I mean, there's a lot more we can do. Like I said, the sky's the limit. We've got a lot of aspirations, but just so that you know that there will be continued development in this, and we'd love to hear your feedback.
Yeah, I would like to add that there's one thing that will be beneficial for both the users and Percona, and is that new checks are independently of the PMM version that you're running. That's the whole intention in the future. So if you have PMM 2.6 and beyond, you always have the available the latest checks. And why is this beneficial for both parties? Because for the users, they don't have to perform an upgrade. That's probably not a task that are planning to do often. And also it's beneficial for Percona because we can push new checks ASAP as soon as possible, and it will be available for everyone that it has a PMM version that has the security threat tool and it's enabled. It will be available without the need of upgrading the PMM server version.
Yeah, great point. That was one of the first issues that we set out to tackle, was making sure that to get one new check, you didn't have to do a full PMM server upgrade and a PMM client upgrade. We'll be versioning that as we go forward. So if you're running an older version of PMM server, we will have checks that will check their compatibility with that version, because obviously as we enhance the actions that we can take, we need to keep some sort of synchronization between the two. But yeah, great point, Daniel. Thanks for bringing that up. So at this point, I guess we have open it up for questions. Tim, did any come in on the line?
Yeah, we have one question coming in. Are the checks going to be extended to the operating system as well?
Yeah, that's a great question. I mean, the short answer is yes. We will open this up so that you can do some basic checking against your operating system. The complexity gets wild, right? So I just want to temper expectations and say that for right now, we're focused on SQL-based checks. Basically, we're limiting it to select and show verbs, or the Mongo equivalent, check version, so that we don't overshoot and do something silly. But then ultimately, we do plan on adding basic system level checks, so that you might be able to even extend our CVE system not just to the database server, but also the system that it's running on, but down the road.
Okay, I have a question here. I'm not sure I understand. Is it what additional privileges will you need for PMM?
So we didn't have to grant any privileges beyond what the normal PMM user gets for using the exporters as it is. So I have a very generic user for our RDS instance. Obviously, it was able to pull the version information, and it was allowed to do a basic select against the MySQL users table. That's basically it. It's just select at this point. We're not making any change. We don't intend to make change. So the PMM user that's polling for information is not going to be the same one that would actually change it. So when it comes time to carrying out actions, you're going to have to provide your own credentials. That way we know the person carrying out the action has permission to do it. We don't want to mediate that as Percona.
Very good. And one final question, how often can people expect new checks to be available?
Well, the beauty part about doing this as a cloud service is we are pushing our team to go to more of a continuous deploy model. Now, we haven't gotten there yet. So, it's not going to be every hour on the hour. But right now we're targeting bi-weekly releases. So every other Sunday night or Monday night, we'll push out checks. We'll be updating the cloud service. So we should be able to get them out fairly quickly. We've got a pretty healthy list of them right now that are in the development process, making sure they go through their QA paces. We've got a great security guy overseas in England who loves to break things. So everything passes through him. Make sure that we don't do select stars or things like that would get us in trouble. We're typing it down or scoping it down to as little information as humanly possible to answer the question we're trying to answer. So, let's say bi-weekly for right now. But again, with an objective of getting to continuous deploy, we may be releasing them daily.
Very good. That's all the questions I see coming in. Thank you very much for your time, guys. I really appreciate it. Good talk.
Thank you.
Thank you, Tim. Bye.
Bye-bye.
Hi, Matt Yonkovit, CXO at Percona, with another Yonk Quick Hits. More war stories from the ranks of the MySQL consulting world that I came from in the background. And so you might have heard these stories before. You might have heard them over drinks or beer or at the bar at Percona Live, but since we're not at Percona Live, I'm going to give them to you here live online. So a few years ago, we were working with an internet unicorn startup that had been valued at a tremendous amount of money. Very popular company used by lots of folks. And they had actually migrated their data centers. And that data center migration went perfectly. They didn't have any issues. It was working just flawlessly. And the problem was, one of their developers decided to run a database migration. Part of that database migration dropped the tables and was going to recreate them. They accidentally ran it in production, dropped all their tables, lost all their data. That's a bad day, right? So nobody wants that day. It's horrible. So they go to restore their backups. And their backups weren't running. Why? They migrated their data center a few months ago, and they didn't turn on the backups in the new data center. It was a problem that really, impacted their business because now they have, number one, no data. Number two, no backups to restore from. So they called us up to help with forensic data migration. It's something that we don't do very often, and it's a very unique skill set. But we actually had to go into the binary files and we had to restore data by hand. It took about 4 or 5 days. So imagine a giant unicorn of a company having an outage that lasts 4 or 5 days. That is a massive outage. And in fact, within 6 months of that outage, that company was actually out of business and assets were sold and they went on to, another company. So, little things like that, again, it's these little tiny configurations, it's these little things that are missed. Sometimes they're super easy to overlook, but they can really impact the performance and, the revenue of a company. So you just got to be careful. Thanks so much.
Thank you for that, Matt.
Hello, we hope everybody is enjoying Percona Live online so far. We're sticking to a tight schedule and the previous presenter has finished slightly early. Please bear with us while we get the next talk on schedule. Have you joined Percona Live Slack yet? Slack is the official chat channel of the conference and we recommend you join to engage with the speakers and other conference attendees. Please also take a moment to provide feedback on the previous talks. The links can also be found in chat. We have some social games running too. Follow the hashtag Percona Live and join in. You'll have a chance to collect the exclusive conference t-shirt posted to you shortly. Please consider taking part in the Open Source Data Management Survey. This survey provides critical help with shaping and understanding the current state of the open source software market. Visit percona.com/survey. Our next speaker will be with you shortly. Thank you for your patience.
Over to you, Tim.
All right. Thank you very much, Bronwyn. I appreciate that. So our next speaker is Alexander Zaitsev, and he will be presenting open source cost efficiency in action, analyzing 500 billion rows in a single ClickHouse server. Alexander is the co-founder of Altinity, and he has 20 years of experience in engineering and engineering management over several companies. Alexander is an expert in high-scale analytics and design and implementation. He designed and deployed petabyte scale data warehouses, including one of the earliest ClickHouse deployments outside of Yandex. So thank you very much. And I'll now pass on to Alexander.
Thank you. Thank you. Let me start sharing. Can you see my screen?
Yes.
Okay, perfect. Hello, everybody. Good time of day. It's 3:30 a.m. in Moscow, where I'm located. So I have already birds singing on the street. So it's perfect timing for a good talk. And who am I? I'm a software engineer, as Tim just presented, with many years of background and experience. And I started to work with databases right from the very beginning. My first database was FoxPro, if I recall correctly. And now it is ClickHouse. And by the way, I'm not Peter's brother. So everybody asks. We know each other for years, but I'm not his brother. And I want to tell you a story which actually started from Peter's email that he sent me in December about a very interesting article published by ScyllaDB guys who analyzed huge data set with 500 billion rows on some beefy cluster, and they got some very interesting performance results. Actually, the article was very good, and the results are interesting, but for us, for ClickHouse folks, it was kind of strange that for such a huge data set, for such a relatively small data set, they used a huge cluster. So I decided to play a bit with the hardware that I have in-house and try to do something similar on a single host. And I will tell you how it went. So let me introduce the problem a bit. So the problem that we consider here is Internet of Things. When we have, say, 1 million temperature sensors, probably in some homes, households, or just at streets, and they collect temperature data every minute and keep data for at least a year. This amount of data results in 1.4 billion measurements per day, or if you take the full year, it's 500 billion measurements, or 500 billion events. And the goal of the experiment is first to report on every sensor. We should be able to get the data for every particular sensor. Also, we need to be able to quickly detect broken sensors across all the farm. And it would be interesting also to build some temperature maps across all sensors and do some visualization maybe. So how much hardware is required for that? ScyllaDB guys, they kind of think that the beefy cluster is a good solution, and they used a cluster which had almost 3,000 CPU cores, 32 terabytes of RAM, and tremendous storage on solid state. This is all good and interesting, but with ClickHouse, we can actually do almost the same with very different hardware. So I took my Intel NUC, which we often use at conferences for some demos. It has only 4 cores and 32 gigabytes of RAM and 1 terabyte of pretty good storage. But the most unique thing about this Intel NUC is that it's powered by ClickHouse, which is an analytical database. If you're new to ClickHouse, these are main features. It's column store from ground up, so it keeps data in columns. It's optimized bottom up in C++, so it has a lot of low-level optimization, CIMD optimizations for modern CPUs, vectorization, and stuff like that. It's SQL database, so if you know SQL, if you know MySQL, then there is no problem to write queries for ClickHouse. It's very portable, almost like MySQL. You can run it on a laptop, on Intel NUC, in cloud, or everywhere. It's scalable, both vertically and horizontally. So you can build clusters, or you can set up big machines. And it's certainly open source by Apache 2.0 license. And last but not least, it's very fast. Originally, it has been developed by Yandex, but it's currently it's still being contributed by Yandex a lot. But as you can see, there is a separate domain, and it's moving as a community project quite a lot. So what are main challenges when we're trying to solve this huge data problem? First, we need to manage volumes. Because if we're doing math, and then in order to keep all this amount of data, we have to have several terabytes of storage. But on Intel NUC, we only have 1 terabyte, and we need some space for operational system, for some other stuff. So in reality, we only have 700 or 800 gigabytes of storage, and we need to store data feed data in the storage. Then we certainly want to have a good query performance, and this is our goal. And we want to do it on a single mini PC. So rule number 1, when you approach such kind of problems, is to know your data. You need to understand what kind of data you want to store, how it's organized, and how you can store it in the most efficient way. So in this particular case, if we are talking about temperature sensors, the data first is time ordered, because we measure every minute, and every minute we have a new value. Second, the temperature actually changes smoothly. So every new measurement, it shouldn't be far apart from the previous one. So you can see it on a graph that it is continuous changes, right? Also, we may think that during the day there is some oscillation, and there is some seasonal changes, etc. And all sensors are also different, because they are set up in different places, and those different places also has different temperature profiles. But probably the most important is that the data is time ordered, so we have time series, and the changes are smooth. We can use it in order to make an efficient schema, and this is what our table looks like. Note several important things. First, we have encodings that we use in order to store data in most compact and efficient way. We have double delta encoding and a T64 encoding coupled with LZ4 compression. And I will explain in a minute what it means internally. Also, I used alias column here in order to extract date. And alias, it doesn't store data at all. So it's just an expression that can be evaluated by ClickHouse very efficiently. And last but not least is our ordering. We order data by sensor ID and time. And order in ClickHouse is very, very important. This is how the data is physically sorted on the disk, on the storage. And this is also a hook to ClickHouse primary key. So when ClickHouse queries the data, it uses both the primary key, which is a sparse index, and it relies on physical order on the disk. Once we have the schema, this is our rule number 2. We need to reduce I/O by all means. And this is where encodings help a lot. For example, what delta encoding does, it tries to encode deltas of deltas. This is why it's called the double delta. If we have the sequence of events, or sequence of some numbers like 5, 10, 15, 20, or 25 in this example, we can calculate the delta, which is 5 for all those events. And double delta is just 0. And if we are going to encode it in most efficient way, we can only use 1 bit per per value, 1 bit per measurement. On top of that, since we have all bits quite the same, for this particular example, it might be different for different data distribution, it also can be very efficient, compressed afterwards using LZ4. As you remember, we use double delta for time dimension and for sensor ID, and we have ordering by time and sensor ID as well. That means that we have a very good data for double delta encoding. So it should compress very efficiently. T64 codec is kind of unique. It doesn't exist in other databases at all. It has been inspired by some academic article and implemented by Yandex folks. The idea is that if we have the data that doesn't use the full data type, then we can do a matrix transposition and convert it to the form that it's very easy to compress. So here on the left side, we have 8 words of data. Every word is 8 bytes, and we only change the minor byte, right? So every word is different, so it's kind of hard to compress efficiently. But when we transpose the matrix, we have a lot of zeros, which are just consecutive bytes, and 1 meaningful byte at the very end. So it can be very efficiently compressed. It works well for the data which is slowly changing, and this is unique for ClickHouse. Next, we need to generate the data. I don't want you to dig into logic of this fancy SQL script, but it generates the distribution with oscillations. You can see several sinus functions in there. And what we also do, we inject an outage, which is exactly the same outage that ScyllaDB guys had in the article for particular sensor ID and time period. This is outage, and we will be detecting it later using our data. If you run this query, then you will have to wait. Yes, it takes time to insert the data. In my particular case, it was 13 hours. But once it's done, we have 500 billion rows inserted to a single machine at a rate of 1 million rows per second. This is not extremely fast, but good enough. So ClickHouse can actually do faster if you give it better hardware. And now let's look at our data. At the top, we can see how individual columns has been compressed. You see that sensor ID and time has been very aggressively compressed thanks to sorting and double delta. For temperature, it wasn't so good, but still we have at least 3 times compression. And overall, at a table level, this level of compression allowed us to feed our 6 terabytes of uncompressed data in only 700 gigabytes, slightly less of compressed data. So we feed the data in a single box. So the first part is done. What's next? Next, we can try to query the data. And surprisingly, if you query for a single sensor, then it's very fast. It's only 24 milliseconds to get some data for the sensor. We want to visualize it. I didn't have time to plug Grafana to that, but ClickHouse has internal visualization tool, which is called bar function, which can resemble you some old times, DOS times, and we can use it in order to visualize distribution for one particular day. So we have the data, we can query it. That's good. But what if we want to query for for all sensors, not just for one sensor, for the full data set? ClickHouse tries hard, and as you can see, it tries at a speed of 600 million rows per second, but still laws of physics exist, and this query will take several minutes or 10 minutes or 20 minutes. So we need to think of something else, how to do it more efficiently. And this is our rule number 3. We need to understand how to use the database in the most effective or efficient way. And for this scenario, what I try to do is a materialized view with aggregation. Look here. So this is actually a complex construction which has both materialized view and materialized view in ClickHouse. It works as an insert trigger. In fact, I created this materialized view at the very beginning just to avoid the population, and it has been automatically populated once I inserted the data into the main table with raw data. And the logic of aggregating merge tree, which is again uniquely ClickHouse feature, is to aggregate data using certain rules. In this case, I want only to aggregate min and max, and there is a special functional data type in ClickHouse which is called simple aggregate function, which does the job. I could actually calculate average almost the same way, or on any other aggregate function that exists in ClickHouse, and ClickHouse has got quite a lot of them. So what it does for us is data reduction. If we look into row counts and size statistics one more time, we can see that we have 1,000 times row count reduction when we move to materialized view, and 300 times storage size reduction. Why? Because we actually calculated, aggregated by days, and this is sufficient for the use case and that ScyllaDB suggested. And here it is. So what we want to do, we want to find a sensor which is anomaly, which shows some anomaly. Anomaly means the temperature is very low, and this is not my definition. This is how those guys did. So in fact, I would probably use some different algorithm, looking at neighbors or using some probabilistic methods. But this is exactly the query that was used in StillDB article, and I used exactly the same. So in 2 seconds and for 2 and 4 seconds, we've got an answer which sensor is an outlier, and that's almost it. We can query it, checking that this is in fact defected sensor. We can see the drop in the distribution for this particular time and day. Problem solved. Since we have all the data now aggregated, we can also quickly generate data to be used in maps or in map applications. And this is just 5 rows, but the query for all million sensors, for all 1 million sensors, would probably take almost the same time. So in 3 seconds, we could generate data and to be used for the map like this one. I didn't draw this map, I found it on the internet, but if you use some map tools like Tableau or Carto, you can display the data efficiently from our 500 billion rows data sets. So what is the result of this exercise? And it's very simple. So ClickHouse can handle 5 billion data set even on a mini PC, which is, I can't say that it's a junk hardware. It's a good hardware, but it's very small compared to servers that we typically use. And the main technique in order to get a decent performance is I/O reduction. So we decreased I/O using smart codecs and encodings, and that allows us to store data in most efficient way. And second, when instead of doing brute force search for raw data, we pre-built an aggregation that helps us to detect anomaly. We still can go to detailed data anytime when we need, But for analysis like anomaly detection or some mapping and stuff, we don't need the detailed data with meaning granularity. It's sufficient to have the daily aggregate. And this is just a little piece of what ClickHouse can do. And it's not necessary only about 500 billion rows data set. ClickHouse can work on small data sets or any data set of your choice or desire. That's all. Any questions?
Hi, Alexander. Thank you for that. That was a great talk. Some questions are coming in right now. Let's see. Aren't you cheating aggregating the data? Is this a fair approach?
Yes, certainly it's a fair approach because you need to be smart about your data and about what you're doing. If you can do something more efficiently, then you have to do it. Sometimes you have to use brute force and you cannot aggregate. But if you can, this is a way to go. And ClickHouse is very good in aggregating and providing partial aggregates and things like that. In particular, ClickHouse has a unique feature of aggregating uniques. So typically you cannot aggregate unique. But since ClickHouse is built for cluster environment, and in cluster you always have to do some partial aggregations of unique, ClickHouse has a built-in feature to do that very efficiently.
Very good. Another question is, does ClickHouse work on Raspberry Pi?
Yes, somebody tried to build it for Raspberry Pi. Unfortunately, I don't have a Raspberry Pi in my lab. Probably for the next talk, I will try something on Raspberry Pi as well. So ClickHouse can be built for ARM, and Raspberry Pi is not an exception. But probably you have to spend some time turning off some modern C++ functions that are used.
Very good. You showed a colored map. What map visualizations are available for ClickHouse?
So I mentioned that Tableau has a map tool or something like that, and Tableau works very well with ClickHouse over ODBC. Not very well, but reasonably well with ClickHouse over ODBC. And also I know that Carto, which is a company who develops map visualization software, they also use ClickHouse or have adapter for ClickHouse. Not sure about Grafana. If there is somebody who knows Grafana better than me, probably there's something for Grafana that can be used as well.
Let's see here. You mentioned linear regression. Can you tell more how it can be done with ClickHouse?
Yeah, this is, so if you want to do anomaly detection, so ClickHouse has several tools to do that. Probably the easiest thing is just to check the neighbors and see if the value is outside of neighbors, and or if there is a significant drop in measurement. And also ClickHouse has several built-in machine learning features, including linear regression. So you can build a regression model on your data and then compare particular value against the model. So, and if there's outlier, you will immediately see that it doesn't fit the model.
And finally, are you Peter's missing brother?
I'm not.
Okay, very good. Okay, well, thank you very much for your time, Alexander. We really appreciate it. I'll turn this over temporarily to Bronwyn now.
Thank you. Have a good rest of the day. Bye-bye.
Thank you. You too.
Hi, Matt Yonkovit, CXO at Percona, with another Yonk Quick Hits. More war stories from the ranks of the MySQL consulting world that I came from in the background. And so you might have heard these stories before. You might have heard them over drinks or beer or at the bar at Percona Live, but since we're not at Percona Live, I'm going to give them to you here live online. So a few years ago, we were working with an internet unicorn startup that had been valued at a tremendous amount of money. Very popular company used by lots of folks. And they had actually migrated their data centers. And that data center migration went perfectly. They didn't have any issues. It was, working just flawlessly. And the problem was, one of their developers decided to run a database migration. Part of that database migration dropped the tables and was going to recreate them. They accidentally ran it in production, dropped all their tables, lost all their data. That's a bad day, right? So nobody wants that day. It's horrible. So they go to restore their backups. And their backups weren't running. Why? They migrated their data center a few months ago, and they didn't turn on the backups in the new data center. It was a problem that really, impacted their business, because now they have, number one, no data, number two, no backups to restore from. So they called us up to help with forensic data migration. It's something that we don't do very often, and it's a very unique skill set. But we actually had to go into the binary files, and we had to restore data by hand. It took about 4 or 5 days. So imagine a giant unicorn of a company having an outage that lasts 4 or 5 days. That is a massive outage. And in fact, within 6 months of that outage, that company was actually out of business and assets were sold, and they went on to, another company. So, little things like that, again, it's these little tiny configurations, it's these little things that are missed. Sometimes they're super easy to overlook, but they can really impact the performance and, the revenue of a company. So you just got to be careful. Thanks so much.
Okay, sorry, I accidentally shared the pre-recorded video again, the same one. Okay, so we still have a couple of minutes, so if we could just hang tight, our next speaker will be with you very shortly.
Thank you, Bronwyn.
Hello, we hope everybody is enjoying Percona Live online so far. We're sticking to a tight schedule and the previous presenter has finished slightly early. Please bear with us while we get the next talk on schedule. Have you joined Percona Live Slack yet? Slack is the official chat channel of the conference, and we recommend you join to engage with the speakers and other conference attendees. Please also take a moment to provide feedback on the previous talks. The links can also be found in chat. We have some social games running too. Follow the hashtag Percona Live and join in. You'll have a chance to collect the exclusive conference t-shirt posted to you shortly. Please consider taking part in the Open Source Data Management Survey. This survey provides critical help with shaping and understanding the current state of the open source software market. Visit percona.com/survey. Our next speaker will be with you shortly. Thank you for your patience.
Okay, Tim, over to you.
And so thank you very much, everyone, for joining us. My name is Tim Sharp, and I'm your host for Percona Live at this point. Our next presentation is Dark Corners of the MySQL Codebase, and our presenter is Daniel Black. Daniel Black is a serial micropatcher of open source projects working at IBM. He currently does performance and port encoding for power systems, and he was formerly a DBA consultant where he started writing code for far too many patches for MariaDB, a tradition which he continues today. So I'd like to now introduce Daniel Black.
Thanks, Tim. Yep. Slightly behind. I think my browser with the slides crashed. So anyway, thanks for the introduction. We'll go from there. Just loading that up again now. F11. Now, I thought I'd actually make this a little bit different. I'd actually, rather than doing it on my chair, I thought I'd actually, go outside and see what that's like. Except cancel that technology.
That's okay. It happens. Take
Yeah.
your time, and we'll get started as soon as you're back up.
I'm just there now. Just that one. Sure. Cool.
There we go.
So, thought, so while at IBM, I'm spending actually a lot of my time working on the power systems and improving the performance of those. And that's sort of, I guess, what Tim sort of said in the introduction, that sort of started doing SQL and then sort of ended up doing far too much coding. So I had to find an employer that would actually support that. So where I come from at the moment is in sunny Canberra, and I say sunny loosely speaking because, it's probably just about to rain. So if I run inside, you'll know why. Had to pull off the deck soon. As Peter sort of covered in the keynote, that we're at the 25-year mark for MySQL, and presenting Daniel Van Eden's graph here on how it progressed over the years. So from a dark corners of MySQL perspective, we can see that a lot of the code was sort of written around 2001 as the foundation basis, and obviously there's been significantly forks and replacements a bit, but some of the code from like 2001 is still around. So if we look at like what computing was like in 2001, there was this supercomputer, the IBM SQ-White at Lawrence Livermore National Labs. It weighed a lot. It had 8K processors and 6 terabytes of RAM. Incidentally, back last year, the Lawrence Livermore again has got an IBM computer on Power 9 systems called Sierra. That's sort of the fastest in the world, helping out with Corona. On the, not one of things, there's the IBM E-Series was launched in that year. It also weighed a lot. 2,500 pounds. It was an entire rack, and it had 8 to 512 gig and up to 4 processor modules. However, just to be not totally IBM specific, in that year, HP and Intel released the Itanium, which had like 4 CPUs in like a more user-based market. They didn't sell many of them. However, it advanced the computing to that whole 64 bits. If what was more likely a machine actually used by laptops is in the range of like a G4, it had like half a gig of processor, singular. It had 1 megabyte cache and 256 meg of RAM. 2001 was also the year that the Linux 2.4.0 kernel was released. Was also the same year that Windows XP came out. So you see some of those artifacts in the code base too. And if we do an ultra short version of how the performance has improved over the years, in 2010 we got NODB, we got the ability to do multiple updates on a table at the same time, and not just inserts. Percona put a lot of work into improving the NODB to get extra DB as a enhanced product. MariaDB in 2013 realized the replication on a single stream can't actually keep up, so got parallel replication. And joyfully in MySQL 8, the query cache got removed. which I see as the great removal of a feature as a performance gain. So where I actually started on code bases and using a technique known as a look for the code that MariaDB, MySQL, and Percona all put out their source code, all on GitHub, and all provide documentation on how to build it. So there's really nothing stopping you from actually going deep into it. One of the functions I came across while just doing a peruse through trying to solve something different was this bit. And it kind of struck to me as like, wow, that's just an odd way of doing it. If you look like closely at the function, you can see that if the two inputs are the same, you're returning the same number. So it would have been just simpler to write that. If we use Matt Goldbold's compiler explorer, we see what the code actually translates to, byte for byte. Well, instruction for instruction on Intel. And see that, we go through a series of branches, and while it'd be really quick if both of the inputs are string results, or both the int results, it's a bit long. So if we do the simplification, replace the first lines 9 and 10 with and if A equals B, return A, and look at the code side by side, we can see we've actually just reduced the size of the code. Now, this is in itself, if you can reduce the size of the code for the same benefit, you allow the CPU cache to cache more of the instruction code in its caches. And for a hot function like this, it's important to keep in because, it gets executed multiple times per query. We also see from the output on the green on the top right-hand side that the instruction path is similar. We take the first two arguments, we compare them, and we jump to the .l1 label at the bottom, which is return. So what a really simple path does for CPU processors, the processors have a concept called branch prediction. It's very complicated, but the more predictable a branch means the more things like pre-fetching and pre-processing within the processor itself can occur. And, while it's got, a bad rap in sort of Spectre Meltdown as like exposing things, for the most part, the pipelining and pre-calculating results is actually a gain. Another corner of the code I came across was this myRegister file name. This is called whenever MySQL opens a file. It's mainly there to keep track of the file name associated with a file descriptor. And so it can print errors easily. Probably it's a bit of extra overhead for what's typically needed, but it works. However, what noticed around that, there is this mutex lock around the thread open when you're actually putting the data in this structure. Now, within a Unix process, the file descriptor, FD, is actually unique for the process. So there's actually no need to put locking around this structure because you're not going to register the file name from 2 bits of the code base at the same time. So the simple fix is actually just in the red to remove the mutex lock. At the same time, I replace those the increments with a statistics increment. That actually in the production build of MySQL doesn't actually use that thread lock. It uses a statistic lock and it's not actually using that lock, so it's optimized out in that way. So this is in MariaDB 10.3.7, MySQL still got a bug out for it, though I checked the other day and the code base underneath has significantly changed. However, they still do use a thread lock there. Which brings to, another mechanism, another fault I came across by just looking at the code. There's this thing called large pages as a setting. There's a whole big MySQL manual page on it there. As Alexei opened up and confessed to, he wrote it back at like 2004. The 2.4 was the latest kernel. That shared memory was the only way to actually do it at the time. If you look at the manual, the things to get large pages to work, you've got to do a bunch of sys controls, you've got to change a bunch of memory groups, you've got to set up some mount options, you've got to change some memory lock limits, and it's not surprising no one uses it. It's just too hard. And what's, I guess, also a consequence of it, being too hard is it disappears out of the code base. It gets broken by other features, and no one really cares. I mean, the MySQL bugs here are actually still open. So because, that was a really old feature, that what happened in like the 2.6.32 kernel was, in addition to the processors at the time starting to push out, well, there's actually more than one large page size. It's not just 2 meg, you can have 1 gig as well. They also made it available as a huge TLBFS. And what huge TLBFS does is it actually is a lot simpler than shared memory pages. It doesn't have the extensive permission controls. It's accessed by fairly standard mmap calls. And in the 3.8 kernel there, what we see is that there's a number of different TLB sizes that you can actually use. So by using all this knowledge, you could actually rip out a huge amount of complexity and sort multiple large page sizes at the same time. And yeah, this is what's just got merged last week in 10.5.3, and there's a MySQL bug still open on that with a similar implementation. It's important to note here that it's not just Linux that's doing innovation. In this time, Windows actually added a bunch of calls around large pages as well. And so I was actually able to write an implementation there and get MySQL compiled on Windows for the first time and get that going. Another option where Linux has sort of come and started to provide the interfaces that were once previously restricted to more complicated implementation is temp files. So here was the implementation of how MySQL created temporary files. We did make temp to get a unique file on the file system, which is the right way to do it. And then immediately after, we deleted it. Now, in since like Spectre and Meltdown, every syscall is getting extra overhead on flushing caches, flushing pipelines, and various else. So the more we can actually remove the number of syscalls, especially like 2 in immediate sequence, the better our performance is going to be. If we look at the open manual page on how things do syscalls, there was a temp file flag added in the Linux kernel in 3.11. So we should be able to use this instead of an open and a delete. And also note here that just because it's created as a temp file doesn't mean we can't actually link it to a location on the file system. And as far as I know, that hasn't been done. That sort of saves, if you're doing a big alter table and it suddenly crashes, that you don't actually need to clean out files out of the file system. So there's that opportunity still to go. So to correct, the temp files, we can just add a bit of code that makes sure that it does temporaries and uses the otemp file flag onto open and sort of falls back to the previous mechanisms otherwise. And so for those of you seen the otemp file not supported on blah in your logs, that's my fault. What happens is that TempFS for some reason doesn't support temporary files, which seems like a bit of an oxymoron, but it just doesn't. It might later, but we preserve a state here to make sure you're not flooded those every time a file doesn't work. Now that we've looked at a bunch of just looking at the code and sort of thinking about what can be changed, whether it's ugly or whether there's new kernel features available, sometimes you need to show there's an impact, and for that there's Sysbench. So Sysbench is maintained by Alexander, wrote the large pages and been around for a long time. And if I could spell empty right, that this is a simple test on how you'd modify a test to just create files. And so this is mainly a test, not so much of the temp files, but of the locking one previously, where we had a global lock. So in the source code for Sysbench, that empty test.lua contains you need to do a populator of what to do when the thread begins, an event, what happens every time, and what to do when it's done. So in this case, make a connection, run a query, create a different file, not only for the thread ID, but for every time through the loop. So in this, when we run it like this, by just pointing it at the host, specifying run 600 threads, because that's a good number, for 60 seconds, we see that it was able to create 500,000 events in that 60 seconds, which isn't too bad for creating files. But if we've got the code base, what we can do is, compare a modified version with the locks taken out and that one. So now that we know how to look at the code base to write a test case, what we need to do is point to where in the problem the code actually is. And we use perf for that as a mechanism, and Valerie will talk about eBEF in a different talk if he hasn't already. So perf is a standard Linux tool. It's as a package to get meaningful information on the reports you generated. You need the debug info from MariaDB or MySQL or Percona that corresponds to the compiled version. If you're using a distro version, it's normally in a separate repository. If you're using straight from the upstream bundled packages, they've normally got it as a separate package in the same repository. So it's pretty easy just to install those. And that doesn't actually interfere with the current executables. It just provides information when we do the perf report later. So before we do a report, we've actually got to record what the MySQL process is doing. So we just use perf record. We use -G to record the stack traces. And so why this is important, because seeing a lot of time in a mutex code isn't that important if you don't know which mutex it is. We specify an out file, we specify the process, and we use an arbitrary process like sleep here to record the amount of time. 3 seconds may not seem a lot, but it's recording at 4,000 samples a second. If you want to record something longer, you can reduce the frequency down and put the increase the length of time. Another alternative just using sleep is to do your MySQL statement that you want to test. So for example, if you want to see what MySQL does with a particular select statement, by all means put that at the end of the perf recording. When doing recording, your aim is to actually keep the number of samples reasonable. So finding out something that occurs every 1 in a million times isn't that useful. We want a kind of sampling enough. So probably engineer it around to get 1,000 samples. If you go too much, it will actually need to stall a little bit to get through it, to get enough recording. So start small, see what that generates, and if you need to go bigger or longer, you can. If we look at what perf report actually generates, use -G again for the stack. We specify an input file, and this is generally what we get. So by default, it includes the children of a function when it does the recording. So this is what we get. You know, MySQL is a multi-threaded program. It starts with a clone, a spawn thread. The workload I've got is a lot around a lot of connections. So we've got a lot of handling connections, processing command, and as we go down, we see a prepared statement. So overall, this, I guess, is a basic sanity check to see if it's, you know, within the processing of the commands. Other threads include like NoDB purge threads that might occur. So if you see those high in the performance profile, it might indicate more likely a lack of tuning rather than a database problem, but you never know. If we add the -no children option to perf report, what we see is the base level functions where the CPU spends most of its time. So we're obviously running this on a power system, and believe it or not, MySQL and MariaDB spend a lot of time copying around memory, and whether that's into buffers or not, need to find out. If we hit plus on any one of those functions, we can see the stack all the way down as to how it generates. Got to that. So now it's back into the top-down view. We go from the handle connection on the left all the way down to the memory copy down the bottom. We see along the way that the percentage CPU is kind of dropping down, and that indicates possibly a small bit of memory copy use in that function. But what we can see from this is there's no major block where it's actually doing memory copy. It's just a lot of small memory copies at various places around the stack. If we hit like annotate on perf, what we get here is a mixture of the C code and the assembly code it generates. The percentage on the left is within that function. So in this function, we've got like a 26% doing something related to the while loop condition. Takes a bit of thinking and knowing what the assembly does to work out which bit of that while instruction is actually causing the problem. But sometimes this is enough to actually put in a bug report and saying, this is taking a lot of time, maybe it shouldn't, and let someone else deal with it. With perf recordings and Brendan Gregg's flame graphs, by running the same perf recording through two scripts, you all of a sudden get a SVG flame graph. So this shows a similar sort of thing in a different form, that of the MySQL process, a lot of time is actually spent in the handle connection, and the width of the bar indicates how much time of the entire thing is within that function, and also shows the call stack from bottom to top. And I'm sure there's a stack order bug pun there I could throw in, but no, I'm not quick enough. We can also see from this flame graph, there's actually on the top sections of the flame graph, there's a lot of time spent in handling UTF-8 and UCA and other kind of character set related things. And this might be, if you're looking at how to actually improve the performance, is like something you might want to actually tackle. Because if you tackle those, you might get an extra 10% of CPU back in a ideal case. The other thing you'll see about the code base, remember it was written in like 2000, well, bits were quite old, is it doesn't quite account to NUMA. And what NUMA is rather than all processes having equal access to memory, is the computer is actually divided into a number of nodes. Processes can access their local memory quick enough. However, to access the memory of the other side has to go through an interconnect for that. And this is something that's easily forgotten when you're looking like a cloud service and you go, oh, okay, I just need a big service, so many CPUs. Yeah, sometimes those CPUs aren't actually on the same node as the other CPUs. So getting MySQL to be intelligent about these interconnects is going to be a challenge. I've seen numerous MySQL engineers and MariaDB engineers sort of screaming that, at the aspect, and I'm sure users have too, that I added more processes to this thing and it goes slower. And so part of that is because, the caches on one node aren't actually shared with the other node. And when the other node accesses them, the first node can't cache them anymore. So because of that internodal effects, you can actually get this case where more processes drops performance as this example goes. So for instance, this is a old IBM Power 8. I mean, old like 3 years. It's not huge, old. But yeah, it has 80 processors on 80 CPUs on each node. There's 2 nodes, each is 128 gig. And those are like 8 threads per core. There's 20 cores on them. And there's a cache hierarchy, which I haven't shown there. But in this NUMA control information, you see that the distance between different nodes is greater by a factor. And while this is just an operating system hint, it isn't exceptionally accurate, it does translate that there is an effect of the nodes. However, when you can run a workload on it that sort of fills up like a HTOP graph full of so many processes, it's a good thing. However, what we need to actually make sure is that each thread is actually doing useful work and not just thrashing around a lock from one place to another. And as you throw, more hardware at systems, whether that, be an entire system here or on the cloud, it starts to show up some of the bottlenecks that weren't perhaps totally accounted for in the code base. So when I came across late last year in a perf recording, if we narrowed down to it, there's this place where buffer pool stats end page gets ++ happens. This is the variable within MySQL that corresponds to inid buffer pool read requests. For those who've looked at show global status, you'll notice that that is a big number, incredibly big. You wouldn't believe how incredibly big it is. However, what we see there from the statement that it is basically in each buffer pool, there is a statistic structure and that gets incremented. We see in the instructions there, it is the LD or the load instruction that is slow to retrieve a value from memory. In terms of retrieving a value from memory, a load isn't usually slow. However, because this is a value that is written to so often, that means if it was in one CPU and one cache and it was written to a lot, that would be actually fine. However, when multiple CPU caches and more so multiple CPU caches across nodes start realizing, oh, okay, I need to grab that memory location. That means I need to invalidate the CPU cache in a different node. And then once that's invalidated, need to actually fetch the value from memory. Now, while there may be some ways in the process to actually speed this up, it's fundamentally a bottleneck from a simple counter. And one that actually has been fixed in the latest MySQL 8.0.20 release. Hello, dog. Excuse me. So we see the load is slow, and that's why the load is slow. It needed to invalidate the cache. The store, on the other hand, is quite quick because once you've done the load, you've got the reservation of that memory location, and you can write back to it quicker. However, that doesn't actually prevent another process in those few intermediate instructions from trying to grab it back. The other thing that you can see by looking at perf profiles that was a bit slow, and I indicated this in the frame graphs, some of the character set functions are slow. And if we look at like an example of my str in simple whatever that is, what we see that in this function, there's a lot of byte by byte access through a mapping function to convert it. We saw in the history in the beginning of the talk that in 2001, there was this thing called 64-bit. When we're processing characters, we're still doing it byte at a time. I don't have a solution for this, but it probably would involve either seeing what someone else has done clever and faster, or B, actually just using a bit more memory, and rather than doing a byte at a time, do a block at a time and use a bit more memory in the translation table. Now that we've got more than 256 meg of RAM. Usually. So in the examples we've covered, some code is just a little bit ugly. I've written some bad code. I will continue to write a little bit of bad code every now and then, and that just needs to be cleaned up. There's kernel-supported features that happen that allow blocks of code to be simplified. As the C++ language comes across, we get things like atomics and thread local variables that enable performance to be increased. So one I didn't cover here, in MySQL 5.7, if you get a contended mutex, what it'll do is it will spin on itself a few times doing nothing for a random amount of time. That random amount of time was determined by just a simple mathematical add multiply function that has some significant random characteristics. However, those are two variables that are in a global context. So remember when we saw with the statistics counter, that same thing is actually happening while you're spinning for a mutex on MySQL 5.7. It's creating a lot of work on the CPU cache and the bus to wait, which is quite ironic. So yes, the other aspect we covered was like hardware, that we've got huge amounts of threads that are starting to come available. If we look at what Postgres has done, we've seen them start to implement using multiple threads to do things like sort and join and fetch data from multiple sources. The MySQL codebase and the MariaDB codebase are still largely single-threaded. To process query does one thing at a time through the threads, which means, threads can be used for, multiple concurrent queries, but it would be good to actually start to utilize those to help out with the same query and fetching locations from multiple things. And NUMA will, continue to form a challenge for the coders of the MySQL codebase, because it's all pooled. We've got this big thing called a buffer pool, and everything is stored in there, and there's no fragmentation. And while we can go on a higher level and start to do, multiple instances and have like an instance per this kind of table, there's also an aspect that might be able to improve by taking into account that, memory and CPU aren't always co-located. And to finish off by saying, there are dark corners. Dark corners is easily fixed by shining the light on them, to write a test case, to point at this bit of code and going, that's ugly, to throw some test cases and say, here, this shows that this bit of code could be better. And so dark corners can be fixed, but all it takes is a little bit of sunlight. So thank you.
Okay, Tim, are you there?
I am.
Just a little bit of a technical problem there, Campbell, Brodwin. So just waiting for some questions to come in here.
I see I'm drastically early too, so okay.
Do I need to compile the MySQL server from scratch to do a performance trace, to record a performance trace?
No, you don't. You just need to actually download the debug symbols from the repo, and that should have it all there. And yeah, those don't actually impact with the system as it is.
Another question is any database data stored in the perf traces?
In theory, no. The perf man page or online documentation has a couple of quick warnings. However, for the most part, it's actually just taking the instruction trace and what's on the stack. While in theory, there might be the ability to infer something about the data from those. Normally, it's not very much. I mean, the things like a table name, you probably couldn't infer anything beyond, maybe the length of the string used in a table name. So if you have perf recordings and you want to share them, and I encourage you to do so, to actually try to get some of these bottlenecks fixed, it's really safe to do so. It's even safer once you look at like the perf report output, because there you can actually see that there's no data, that it's just a bunch of statistics and a bunch about the MySQL code base and where it was running at the time. There's no user data there.
Very good. And finally, one person asked, if I wanted to start with small patches to the server, what should I look at?
Okay. There's some existing shallow MySQL bugs and MariaDB bugs that are around like a simple, date time function not returning the right result. Those are, remarkably self-contained as far as going through, and they normally only take, 1 or 2 lines of code to actually fix. You just got to find out which ones and write the test case for them.
Okay. Someone is typing in a question right now, and I'm just waiting for it to come in. Let's just see here. The joys of modern technology.
After that, since I've got a bit of time, I might actually share one of my own, war stories unless, there's booing on the channel. But anyway, we'll see.
So somebody says, Daniel mentioned at the beginning a C compiler he was using, but I missed it. What do you mind telling us again?
Sorry, advantages of a C compiler?
No, Daniel mentioned at the beginning a C compiler he was using. So you mentioned that you're using a specific C compiler.
Oh, sorry, that online one. It's Compiler Explorer by Matthew Godbolt. And what you can do is you can just throw a little bit of code up there and watch it generate the output.
Okay.
And what you can also do with that one is play around with the optimization options, see how the code is different. And you can also switch between MySQL versions and watch how compilers have actually changed in the way they generate their output. And there's also, different architectures. You can throw out a power output and throw out an ARM output and a MIPS, and for the same bit of code and compare and contrast. So yeah, fun tool that way.
And let's see, one person is typing here. Let's just wait for Chris to finish up. In the meantime, if you do have any more stories, I'm sure we would be happy to hear them.
Okay.
This one person asked, are there some tagged beginner friendly? I'm assuming he's referring to patches.
Yep. In MariaDB code base, there's a beginner friendly. I think there's a trivial one in the MySQL bugs. doesn't seem to be consistently applied. So yeah, look at the problem. If it seems easy, give it a go. Also, I guess other places to ask for help. MariaDB's got a Zulip channel. The MySQL community's got a Slack channel. If you want to actually take on one of these tasks or want some guidance on where in the code base to actually start looking on a problem, yeah, that's a great place to start and a great place to ask questions if you're stuck.
One person mentions the MariaDB Foundation probably has small tasks for developers wanting to get into the MySQL MariaDB code base. So.
Yep, yeah, and those are a lot of the beginner-friendly ones. The ones that are, never quite get enough developer attention to fix, but aren't actually too hard. But hey, it's always good to have them available.
Very good.
It's one of that. Okay, so war story of mine. I was working for a shared hosting company at the same time I was doing DBA work, and had this was my other job as like a system admin there, and had this like downtime. We needed to upgrade a few things and shut a few servers down. And I thought, okay, they've got enough time. We've got a 4-hour window. Let's see what it'll take to do a distro upgrade. I'm not going to actually do it, this system, but we'll see it anyway. Looked in the documentation, and this was like a Debian system. It had a 2632 kernel. I thought, oh yeah, good. There's like this LVM support. It's got these LVM snapshots, and yeah, there's this function of restore to checkpoint of that. So I'll just take a checkpoint, do the upgrade, take a note of what breaks, analyze that a bit later, then just roll back to the snapshot. So yeah, in the window, take the server down was just a VM running on that. So ran a snapshot on the underlying system, tried it, recorded what I want, and got to the point where returning to the checkpoint and went, that kernel support isn't there. The kernel support was in the LVM tools. It wasn't actually in the kernel. So, it was like, oh shit, what now? So I started panicking, and I ended up grabbing the source code for the kernel, taking a patch for what was applied a couple of releases later that says actually implement the restore to snapshot point. And yes, in a outage window, I was compiling kernel, merging a patch in that didn't cleanly go, and then crossing fingers and booting up the kernel there so I could actually restore back to the checkpoint where I thought it was going to go actually smoothly. So oops. Yeah, I mean, share hosting aren't the kind of places to have multiple copies of things, but yes, importance of trying it out and perhaps not on a production system next time. Fun.
Very good.
But these are the mistakes we learn from. And hey, and the outage window might have got slightly longer than actually scheduled, but the customers kept their data. Phew, and I kept my job.
Very good. So I'm going to pass this back on to Bronwyn. Bronwyn, the control is for you.
Thanks, Tim. Okay, everybody. So we are going to do a quick restart of Zoom in the hope that, one, the watermark goes away, and just to prevent us from being kicked off the live stream. So we will be on the same link that you're viewing it on YouTube and Twitch right now. So if you give us about 60 seconds, and we will be back online with you shortly.